Hey, this is Andrew Brown over here on FreeCodeCamp, bringing you another free cloud certification study course. And this time we are looking at the AWS Cloud Practitioner, also known as the CLF-C02. And the way we're going to achieve AWS certification is through lecture content, hands-on labs, and as always, I provide you a full free practice exam. The best way to support more free study courses like this one is to purchase the optional paid additional materials. It's going to help you on your exam, and it's going to allow me to produce more of these great cloud certification study courses. If you don't know me, I'm Andrew Brown, and this is the fourth time I've taught this certification, so it's really refined at this point, and I've taught a bit of everything in the cloud. So we've looked at AWS, Azure, GCP, Terraform, Kubernetes, you name it, I've taught it. But that's about it, and I will see you in class in the next video. Ciao. Hey, this is Andy Brown, and we are at the start of our journey asking the most important question first, which is, what is the AWS Cloud Practitioner? Well, it's AWS's entry-level certification that's going to teach you things like the cloud fundamentals. So we're talking cloud concepts, architectures, deployment models. It's a close look at AWS core services, which would be our compute, our storage, our network, our databases. And it's a quick look at the vast amount of AWS services and functionality around AWS. So we're looking at identity, security, billing, pricing, support, and a lot more stuff. And we'll get into that in the course, and we'll even look at the exam guide outline. But yeah, there is a lot of stuff. The course code for this certification is now the CLF-C02. The old one was the C01. The way to know if there is a new course is if this becomes the C03. If you see that, then this course may be out of date. Yeah, right now it's the C02. Often people refer to this certification as the CCP to stand for the Certified Cloud Practitioner. How you want to refer to it is up to you, but there are a few ways of describing this certification. I want to point out that AWS is the leading cloud service provider in the world, and the Cloud Practitioner is the most common starting point for people breaking into the cloud. So even if you're going to utilize another cloud service provider, I'm just going to say that you're going to get a really good foundation with this certification, even if it's not the same provider. So who is the certification for? Well, consider the Cloud Practitioner if you are new to cloud and you're learning the fundamentals, you are at the executive management or sales level, and you need to acquire strategic information about cloud for adoption or migration, or you are a senior cloud engineer or solutions architect who needs to reset or refresh their AWS knowledge after working with cloud services or AWS for multiple years. It's always a surprise that when I come back and I refresh this course, the things that have changed, and it's very easy to miss those things. So yeah, this certification is for everybody. So what is the value of the certification? Well, this certification provides the most expansive view possible of cloud architecture and AWS. I would describe this as having a bird's eye view, or the 50,000 foot view. So with that in mind, the idea here is to promote big picture thinking. We're zooming out and assessing the cloud or AWS landscape for things like changes, trends, opportunities. And it's important to understand about being strategic about the approach and process for your journey. And that's why I like the certification so much, and I strongly recommend it for everybody's journey. So what is the value of the certification? Well, it's not a difficult exam. It's not going to validate that you can build cloud workloads. So if you are trying to obtain a technical implementation role like cloud developer, cloud engineer, DevOps engineer, it's not going to be enough to attain those technical cloud roles, but it could help shortlist your resume for interviews. The exam covers content not found in other certifications, so it is recommended as an essential study guide for your AWS journey. Do not skip this one. Some people like to go straight to the solution architect, and then they realize that they didn't set a good foundation, or they just have gaps in their knowledge, which could really help them out in their careers. So really do not skip this one. I like to make these roadmaps to give you an idea in terms of where you can go after this certification. So here is all the certifications currently that AWS has. Notice that I have the data engineer. It's a really small one. It just it came out as a beta exam. It's not as hard as the professionals. It's just where I place it on this diagram. But the idea is that we have a lot of different ways that we can navigate or work through these certifications, and these can generally map to particular roles in the cloud. So very often people go right to the solutions architect. I'm just getting my pen out here, but very often this is the approach. They'll go straight to here right after the solution architect because they're very similar in terms of scope and challenge and difficulty, where the solution architect is a broad certification, just like the cloud practitioner, but it's more focused on the technical knowledge, whereas this one, of course, is much more broad, the cloud practitioner. And then after that, people will generally go for the developer or the SysOps administrator. In my personal opinion, I really do think that people should study all three associates and do all three associates at the same time, because really I don't find that it makes sense to leave out the SysOps admin or developer knowledge. It's just the way that AWS engineers their certifications. But when you go to other ones, like let's say Google, they only have one associate and they have all the, they call it cloud engineer, and it has everything in it. And so, again, I just feel like you should take all three, but you decide what works for you. And, you know, you can see that there are various routes, but I want to just make it very clear that certifications do not validate programming. They do not make you do technical diagramming. They don't necessarily make you do code management. And there's many other technical skills that are required for obtaining technical roles, like these roles. And that is not the purpose of certification. Certification is supposed to give you knowledge specifically on AWS. And so just understand that you need to make sure you get those skills somewhere else. I do try to slot in a lot of these technical skills where I can. And so if we're doing something in the course and you're wondering, why are we doing this when it's not on the certification? It's because I'm trying to give you those adjacent skills so that you are successful in the future, okay? So how long does it take to study to pass this exam? Well, it depends, right? It depends. But if you're a beginner, we're probably looking at 30 hours. So this is someone who's never used AWS or a cloud provider before. You've never written code or had a technical role. If you're experienced, your study time is going to be very low, like as low as 6 hours, even lower if possible, especially if you've already taken the certification. I sat it blind, right? I didn't look up anything, and I passed it no problem. So it says here, you know, if we've practiced or we have experience working with AWS, if we have an equivalent experience in another cloud service provider, some people are coming over from Azure or GCP, so they can kind of map their knowledge over to AWS. Or if they have a strong background in technology, you might really be already familiar with these kind of offerings from another discipline, and so your study time can be really low. But I would say that you know, the average study time is probably 24 hours. So yes, it's closer to the beginner level, but that's the average study time that we found. And so it's basically a split between 50 lectures and labs. So labs are hands-on skills, and 50% with practice exams. A lot of people forget that practice exams are part of the study process, so make sure that you do that. We do recommend a study time of 1 to 2 hours a day for 14 days. What does it take to pass the exam? We're still going on with this here, but you know, you have to watch those lecture videos and memorize key information. This is a knowledge-based exam. It's not it does not test your skills, so knowledge is key here. You should do hands-on labs. We call those follow-alongs within your own account. This is just going to help cement the knowledge in your head. It really makes a huge difference. So really do those hands-on labs and get practice exams to simulate the real exam. You absolutely need to do this, because if you don't, you're going to find that you did all the study materials, and then the exam is its own beast. So make sure that you go get some practice exams. There's a lot of places that you can get them from. We offer a full free practice exam. I think we're the only provider that does this, but we give you like a full free practice exam, and we also have some paid ones. So the best way to support this content that we produce is to purchase our additional paid materials. If you don't have the money, that's okay. We still have at least one full free practice exam to help you out. You can find that over at exampro.co/CLF-C02. It looks like an O, but it's a 0. Let's talk about the content outline. So there are 4 domains, and you have to understand that each domain has its own weighting. This is going to determine how many questions in that domain will show up on your exam. The first one is cloud concepts. So that's for 24%. So we're looking at between 15 to 16 questions. Domain 2 is about security and compliance. So that's 30%. It's quite high up there. So we have about 19, 20 questions. For cloud technologies and services, it's 34%. So understanding the offerings of AWS is the most important thing in the exam. It's the highest percentage here. So we're going to definitely get 22 questions. And then we have domain 4, so billing, pricing, and support, where it's at 12%. So we have 8 questions. Not a lot for billing, pricing, support. Definitely important because it's very easy to get overbilled in this stuff. But just, point out that you need to know a wide range of AWS services. You need to know about core services more in depth. So where do you take this exam? Well, you can take it at the at in-person test center or online from the convenience of your own home. I personally like to take it in a test center if there's one near me. I used to live in Toronto. Now I don't. So there's no test centers near me. And so I have to do it online. It's just so much less stressful walking into a building and everything is controlled, whereas at home, you might have a lot of things going on and that can cause a lot of stress, but do what makes sense for you. So AWS delivers the exams via Pearson VUE. And so there's Pearson VUE. They have the online system, which you install on your computer. And then they also have a network of test centers they're partnered with. Previously, AWS also offered it via PSI. They don't do this anymore. I'm not sure why they changed this. Before it was only PSI, then they added Pearson, and now they've dropped PSI. So your only option is Pearson VUE. I just want to point out what a proctored exam means. It means that it's someone is supervising your exam while you're taking it, so you're not cheating. So it's very common that when you check in, they're going to ask to look around your room. You might even have to talk to them, and it's just again to make sure that what you do is your exam was legit. So when they issue your badge, it's for real. Anyway, let's talk about grading here. So the passing grade here is 700 out of 1,000 points. And so you need to get around 70% to pass. AWS, like many other cloud providers, use scaled scoring. So that doesn't mean that if you get exactly 70% that you'll pass. But more or less it works out to be that. Okay, so the response types we have here, well, first of all, we have 65 questions, and there are 50 questions that are scored, and then there's 15 that are unscored. And if that sounds bizarre, I agree with you. I think it's odd that they give you 15 unscored questions, but the reason AWS will do this is that they want to introduce new questions to help test against the difficulty of the exam, because, maybe some people know more than what they're expecting, so they can adjust the difficulty of the exam. I think that they use it as an anti-cheat mechanism as well. But from the test taker, it can get a bit stressful because you can get 15 really crazy, wild questions that were not in your course studies. And it's just AWS testing things out. And so I just want to point out, don't get stressed out when you take this exam and you get a really funny question. It's probably one of those unscored questions. But on top of that, there are 15 scored questions you can get wrong. So you can get a total of 30 questions wrong on this exam and pass. I just want to make that really clear there. There is no penalty for wrong questions, so absolutely always submit an answer and take your best guess. The format of the questions are multiple choice and multiple answer. So, it's not too stressful in terms of the formatting of questions. There are, again, 15 unscored questions of the exam. They will not count towards your final score. Why are there unscored questions? They're there to evaluate the introduction of new questions. They're there to determine if the exam is too easy and the passing score of the question difficulty needs to be increased, to discover users who are attempting to cheat the exam or steal dump exam questions. If you encounter questions you've never studied for that seem really hard, keep your cool and remember that they may be unscored questions. Just really want to emphasize that there. In terms of the duration, you get 1.5 hours, so you have about 1.5 minutes per question. Your exam time is 90 minutes. Your seat time is 120 minutes. What are we saying when we say seat time? This is the time it takes, or that you should allocate for the full exam. That includes things like reviewing the instructions, showing the online proctor your workspace, reading, accepting the NDA, completing the exam, provide the feedback at the exam. So a lot of people go, okay, my exam's starting, or I have 90 minutes of exam, but really you want to show up 30 minutes prior because that check-in process can be really, really stressful. So, just consider that the full scope of time you need to dedicate for these exams. This certification is valid for 36 months, so that's 3 years before recertification. Some other providers, like Azure, if you do the fundamentals, it's forever. Other ones require you to refresh every year. Other ones, you don't have to take the full exam. You have a reassessment that is free. AWS likes to do it this way. The nice thing, though, is that when you do pass a certification, somewhere AWS allows you to get the next exam half off. So at least there are cost-saving mechanisms if you do pass an exam for the next follow-up certification. But yeah, that is pretty much a breakdown of the exam guide. We will go and take a look at the actual exam guide so we can understand the full scope of what's in there. But yeah, we'll see you in the next one, okay? Ciao. Hey everybody, it's Andrew Brown, and we are here on the training and certification page on the AWS website. And what I want to do here is I want to pull up the exam guide so that we can make sure that we know exactly what it is that we're getting ourselves into. We did cover this in summary in the previous video, but I think it's always useful for you to know exactly where these things are. AWS is always changing their marketing pages, and I've already noticed a few changes here, so just understand that's the nature of cloud. Notice here that it's talking about the beta exam certification. So even earlier, we talked about the data engineer, or we at least showed it on our journey map, and it's not even 100% out beta. So you can see we're kind of prepping for the future here. I also want to point out that they have this like certifications path thing, and I don't really like it because I don't think it's very accurate. So the first thing they show is solutions architect, and they don't even say you need to get the other two associate certifications, which you absolutely should do before you go for your solutions architect professional. The data analytics is no longer a certification that AWS is producing, so this is an out-of-date document. So I just want you to understand that these are marketing pages. They're here to maximize the amount of certifications you need to obtain. My goal is not to make you take every certification. My goal is to make sure that you are prepared to do the job, and I just want to help you avoid going down the certification route and getting too many certifications that aren't going to benefit you. So just take these with a grain of salt when you're reading them, okay? So anyway, what I want to do is drop this down and go to Cloud Practitioner. And here on the Cloud Practitioner page, if we scroll on down, we got Prepare for the Exam. And here we'll click the exam guide, and it'll open up a PDF, and it'll give us all the information we need to know. This is what AWS has been doing for a long time, is making these exam guide PDFs, which I really like. But anyway, the first thing we should do is confirm the course code. So this one says CLF-C02, so we know we are on the right track. And then down below here it says, this exam validates the candidate's ability to complete the following tasks. I want to highlight some keywords: explain, understand, describe, and identify. So understand that this certification is not checking whether you know how to do cloud. It's more if you understand cloud. And the majority of AWS certifications, in fact, all of them, are multiple choice and multiple answers. So they can't really check if you were able to do something in cloud. So just understand the limits of certifications, at least AWS certifications, based on their testing mechanisms. So when it says target candidate, it's saying where you should be in order to pass this exam. And so they're suggesting that if you had 6 months of exposure to AWS with cloud design, implementation, operation, then you should be able to pass it. It's just worded strangely because it makes it sound like you should have this experience before you even start studying, which is not true. They just mean like if you want to pass it, you don't need 6 months to pass this exam. That's crazy. You just need what we recommended, which was the amount of hours. We said the average hours is 24 hours. So I'm not sure why they put 6 months. I guess it's just for those who are really having a hard time with cloud, they give you a lot of scope or room there. But you can see they're pointing out from non-IT backgrounds, recommended AWS knowledge, cloud concepts, security, core services, economics, AWS. That's just a repeating of the domains. Notice it says job tasks that are out of scope is coding, cloud architecture design, load performance and testing. I'm highlighting these three because I just want to point out that in associate level, professional and specialty, they actually do ask questions around troubleshooting implementation. And I suppose they do architectural design, but they never, ever, no certification in AWS is going to test your coding skills, architectural diagram skills, and they're not really good about load and performance testing. They have like use case scenarios, but just understand, again, the limits of these certifications. Coming down below to the response types, we've got our multiple choice, our multiple response. So that's pretty clear there. There is 50 scored questions. There's 15 unscored questions, so that is very clear. The point system is based out of 1,000 to 1,000 points. The lowest you can get is 100 points. I don't know how that works. Why can't you get 0 points? I don't know. The passing score is 700, so that's what we need to score there. Then down below here, it's just talking about the course outline, and it actually has a comparison of the old CLF-C01, so we can take a look there and see what actually has changed. So down below here, we have our cloud concepts, our security compliance, our cloud technology services, our billing, pricing, support, and then it comes in and it starts describing all this stuff. Now, I need to make it very clear how AWS makes their exams. They give you a huge list of things you need to learn, but if you learn each one of these things, you can end up overstudying, or you'll find that the exam guide outline is not one-to-one. I'll give you an example. We'll look at something else. I'm going to go to HashiCorp here for a second. HashiCorp Terraform certification as an example of how different AWS certifications are. So for HashiCorp, this is their exam guide. They'll give you each of these items, and you can be 100% sure that every single thing, every one of these things will show up on the exam, one-to-one. So it's very easy to know exactly what you need to study for. If you know all these things, you will pass. In AWS, they list all these things, but they won't all show up. They're pulling from a very large pool. So to kind of narrow down what you need to study, you need to have a good sense of overall everything, and you're just going to get some things wrong. But anyway, coming back here, the first cloud concepts, they're talking about the benefits of cloud. So we have a section on benefits of cloud. And so they talk about the value proposition. So there's like 6 or 9 of them, I forget. We have multiple slides on that. And so we're talking about economics of scale, benefits of global infrastructure, advantages of high availability, elasticity, and agility. I think we call these cloud architecture terminologies because they're not really benefits. I mean, they are benefits of cloud, but I like to group them a little bit differently. Then we have identified design principles for AWS Cloud. So we have the well-architected framework. This was, for the most part, never in the CLF-C01 for 90% of its history, and then they decided maybe like last year or something to add it in. Before, we even wasn't even the Solution Architect Associate, but now it's even at this level, and that's totally fine. You only need to know it at a very high level, so it's not too difficult to learn, but it's a white paper. It's a PDF that just describes how AWS thinks that you should design your architecture. Then we have understand the benefits of strategies and migration to the cloud. So we have cloud adoption strategies, cloud adoption framework. So this was not in the last exam, but luckily I included it because I thought it was something that was very important, and so I already have it in the certification course, even from the last one. They actually do ask quite a few questions around the cloud adoption framework, but when you look at, and again, this one's like a white paper, just like this one above here, and we'll talk about what white papers are. If you've never heard that term, it'll make sense in the course. But the cloud adoption framework, there's not a lot to it, but on the exam, they'll ask you a lot of questions around it. So you just have to have good common sense about choosing those answers, if that makes sense. Identifying appropriate migration strategies. Sure, I guess so. I never got any snowball questions. They say snowball here. We'll go down below here. Understand concepts of cloud economics. So cost savings of moving to cloud, aspects of cloud economics, fixed costs compared with variable costs. They're talking about OPEX and CapEx. Understanding the associate of on-premise environments. Understand the difference between licensing strategies. And AWS never, ever, really ever mentioned bring your own licenses ever in their certification courses. And I never got this on the exam. And other people I sat for the new exam never encountered this. Still good to know, but I'm just saying that I don't know why it's listed in here because it's definitely not on the exam, but it is a good thing to know at the basic level. Understand the concept of right sizing. And maybe I'll go back and make a slide on that because I don't think I actually make a deliberate slide on that. But I think what they mean there is understanding like how horizontal scaling and stuff like that works. But again, no questions on the exam for right sizing, at least not from its technical definition like that. Identify benefits of automation. I think there might have been one question of saying like, hey, which one lets you automate stuff, and you just chose CloudFormation, but they really don't talk they don't ask a lot of questions on the exam about IAC, infrastructure as a code. Identifying managed AWS services. This is something they do a lot in exams, like describe a service, you pick it. We have security and compliance. So we have the AWS shared responsibility model. You absolutely need to know that. That for sure always appears on the exam. Customers' responsibility. They'll do this a lot. They'll say like they'll give you a scenario of like a typical workload or resource, and then you have to determine if it's the customer's responsibility or AWS's responsibility. Describing the responsibility the customer and AWS share. So again, this is just all the shared responsibility model still here. Describing how the AWS responsibilities and customer responsibilities can shift depending on the service used. So yeah, this is basically the shared responsibility model. Understand the AWS cloud security governance compliance. So AWS compliance, governance concepts. Benefits of cloud security, they don't really talk about that. They don't really directly ask that in the exam, but yes, we do cover that. Where to capture and locate logs that are associated with cloud security. They absolutely do not ask that on the exam. I'm not sure why that's here. Identify where to find AWS compliance information. That will absolutely be on the exam. Understanding compliance needs among geographic locations and industries. Sure. I mean, they're talking about, we have a slide in this in the global infrastructure, but it's like data sovereignty and like GovCloud and things like that. Describing how customers secure resources for AWS. So just generally knowing the security services. Yep, that absolutely is on the exam. Identifying different encryption options. I never got this on my exam. I never heard of anyone else getting this, but if they are going to talk about this, they're probably going to talk about it around S3. Recognizing services that aid in governance and compliance. Absolutely for sure that you will get questions around things like FIPS or HIPAA or like common compliance certifications, not specific to AWS, but just in general. Here they're just talking about specific security services. This is kind of a repeat of what they're talking about up here. But they're just saying there's identity service, governance service, it's all the same thing here. Recognizing compliance requirements that vary among AWS services, sure. Identify AWS management capabilities. So they're talking about IAM, the AWS root account. We got a separate slide on that. Principle of least privilege, absolutely they will ask that there. A single sign-on, also known as AWS IAM Identity Center. I don't know anyone who's gotten this as a question on their exam, but we got a slide for it. Understanding access keys, yep, we cover that. Password policies, credential storage, secrets manager, systems manager, just a bunch of stuff. Identify components and resources of security, describing AWS security features. So ACLs, AWS WAF, security groups, they really don't ask these on the exam. So I'm just trying to make a point that they're asking for all this stuff and they don't even it doesn't even show up in the exam. So, and you know, we can just keep going and going through this and I could keep telling you what is and isn't. But if you go down below, it gets even crazier because they go, any of this stuff could show up in the exam. It's just like a big list. It's crazy. So, you know, I know that seems stressful, but, you know, just follow me in this course, and you'll absolutely pass if you go through my content. You'll have no issue there, and we'll avoid all the stuff that doesn't show up, and don't stress out about this exam guide. Now, let's go take a look here and see where the rebalance has changed. So notice here that this went from 26% to 24%. They never used to do this, so I really appreciate this is now in the exam guide. But we got 25 to 30%, 33 to 34%, 16 to 12%. Why they would reduce this one, I don't know. But it is a shuffle, whatever. They, of course, increased the technology section more and did some basic rewording. Support should have always been in there, so it was always under that section, but it's nice that they labeled it as such. So notice here it says no content was deleted from the exam. And this was the largest struggle for me for the certification because I already made all the content for the last one. My old one is not expired, and I was struggling because I already had this as well. This is the only thing that they added that was new to the certification, and then they just reworked these numbers here. And so, you know, I did add more. I added more labs. I added more other stuff there. But I'm just going to say, like, I don't know why they did an update from CO1 to CO2 because barely anything changed. Now, I shouldn't say that. The exam questions did change. I noticed that the exam questions, the quality of them kind of have dropped. I'm wondering if they're using generative AI to generate out questions or something, but there's something, the quality of questions are definitely different. And I would say that they're more, they're not worded as clearly as they used to be for whatever reason. But anyway, you'll still be okay. It's totally fine. Recategorization of CLF-C02, and so they just did a shuffle of these points. And I really don't think that the new one is better. How useful is this exam guide? I should probably give them survey feedback. But anyway, just give you an idea how much stuff there is in here. Do not stress out. Just stick with the course. You'll absolutely pass. Hopefully that gives you some better confidence there. But we'll see you in the next one. Ciao, ciao. Hey, this is Andrew Brown from ExamPro, and what we're looking at here is a free practice exam that I provide with you for this course, and all you have to do is sign up on ExamPro. You don't even need a credit card, and you can redeem the free available content here, and this is really up to date and very well simulates what you'll see on the actual exam, and it's a full set, full 65 questions, so you're getting a real simulation here. But what I'm going to do is just start it off here. We're not going to do the whole thing. I'm just going to click through and show you a couple of them so you have an idea the level of difficulty these questions are. So the first question we got presented with here is, which AWS support plans provide access to the 7 core trusted advisor checks? And so that is a question that you might need to answer. I don't want to spoil this for you, so I'm not going to tell you the answer. We'll go to the next one. So a large accounting firm wants to utilize AWS to store customer accounting information in archive storage and must store this information for 7 years due to regulatory compliance. Which AWS service meets this requirement? So the first one you'll notice, this one is multiple answers. So you have to select multiples before you can submit your answer. And the next one here is just a single choice. So those are the two types of questions you will see on the exam. They're not going to ask you anything about coding. You're not going to see any kind of code. In terms of length, that's pretty much what we'll see in terms of the questions. I think in many cases I wrote a little bit more like in the style of the Solutions Architect Associate to make it slightly more difficult just so that you're a little bit over-prepared. So if you do well on these practice exams, you're going to do well on the real exam, okay? So I just wanted to kind of get you that exposure there, okay? Hey everyone, it's Andrew Brown, and I have opened our exam simulator. This is on the ExamPro platform, and this is the free set that I promised folks in the course, so no cost to go get this one. You just have to sign up and access it. But the reason I have it open is because I really want to talk about a very specific type of question that we've included in here that will not appear on your exam. So for those who are familiar with Azure certifications at the associate level or higher, there's this question type called a case study. And what a case study is, I'll just pull it up here, but I believe in this randomization of this practice exam set, I think it's this one here, but what a case study is, it gives you a scenario that you have to read through, or a case study about a company. So you read about the company, you look at the objective, its requirements, constraints. This stuff can all be different. There could be diagrams, all sorts of stuff in here. But the idea is that you are contextualizing a business use case, and they're going to be asked a series of questions, multiple choice, multiple select, and it all ties back to that case study. So the reason we included this is that we believe that this is going to give you better comprehension and a higher chance of passing. So it's not going to appear in your exam, but we include it as an extra challenge to you so that you have a higher chance of passing. Now, if you don't like this, we do have other practice exams. They, of course, are paid that are just the normal style, which is all multiple choice, multiple select for this course, the Cloud Practitioner. But, we do have them in half of the practice exam sets because again, I think that it's going to be good for you. So hopefully you see that as a bonus. But I just wanted to give you a heads up about this because you'll counter me like, what the heck is this? The other thing I want to point out is that when you enter a case study, it's like having a mini exam within your exam. So once you've answered all these questions, you can't go back and you can while you're within the case study. But if you get to the end of this and submit the case study, you can't go back and update it. So just be aware of that. And again, hopefully you like this. we love feedback to hear what people like, but it's just they always appeared in Azure exams, and we want to see them in AWS ones as well because I think they're just really good for testing your knowledge. But anyway, we'll see you in the next one, okay? Ciao. Hey everyone, it's Andrew Brown, your favorite cloud instructor, and what I want to do in this video is to show you a unique feature that is in our platform, just in case you come across it while you're doing the materials. I can't remember if it's in the free or paid tier. I believe it's in the paid tier, so I'm not trying to upsell anyone, but I just want to make sure people are aware of that while they are taking this course. But sometimes what you'll see in the follow along, so like for example, we have S3 down here, which is for Cloud Simple Storage. And I don't have them always included in the videos, but at some point I might do that. But the idea is that we have these validators, and validators, what they can do is they can verify whether you actually have the resources deployed in your cloud account. So it's like an additional check to make sure that you did it right. So for example, we have this one for S3. So it says set up an S3 bucket. It is account validation. So this tool performs an automated check on your personal cloud infrastructure to confirm its alignment with the build project requirements. Make sure you input precise values for your infrastructure components. So let's go through that and show you this. I'm showing this as an example, but you'll see them in other follow-alongs, and look out for that stuff. I believe in the to-do, it'll even show it here. So if you watch the video and you watched it to the end, or you press that button there, but you'll get your star for that. But the way it works, let's go through it. So the first thing is I want to click on this new run button. And then what we'll do is we'll have an agreement. So this agreement is confirming that you understand that you are using your own cloud account, and we are going to need to get read-only access to it, and just understand that you are using you're providing us access to an account that is your own account and is not your company's account, because obviously we don't want to get in trouble for accessing data that we're not supposed to have, and you don't want to get in trouble for that. So that's just a friendly reminder. So I'm going to click the I agree and the accept. The next thing it's going to ask for is your AWS account ID, the region that you're deploying in, and then there might be additional parameters that it wants to know so that we can test against it. So what I'm going to do is just log into my AWS account. It'll just take me a moment, and we'll fill this out for real, okay? Now, of course, I'm filling out this example here, but I just want to point out that you're just going to have to follow this procedure, and it'll be slightly different for each one for that, okay? Be back in just a second. All right, so I'm logged into one of my AWS accounts. I have a lot of them. And I think this one is my developer's one. So for this particular follow along, you would have created an S3 bucket, right? And so what I'm going to do here is go to S3, and I already know what to do, so it's not too hard for me, but I'm going to go ahead and create myself a new bucket. I'm going to make note of the region that I'm deploying in. So S3 is a bit unique because it shows global, but you are still deploying to a specific region. So we'll go ahead and create that bucket. I'm just going to say my validator bucket as a test. Notice where it's deploying, US East 1. I could change that to anything else, like CA Central. I am in Canada, so it doesn't hurt to deploy where I am. And we'll go here and go all the way down, and I'm going to go and create this bucket. Okay, so that bucket name was, I forget, it was like something like validator. And so what I need to do is copy that name. We'll go back over here, and so it's asking for the bucket name. So there's the bucket name. We need the AWS account ID. That always appears in the top right corner, and they have a nice clipboard button there to get that in there. And the region, so we deploy that in CA Central 1. So it says there, CA Central 1. You're always using this programmer's name, not the full name, but this fun handle. You can see them all here on the right-hand side if you're not sure about that. But what we'll do is go back over here. We'll paste in that user region. And so what this is going to do is create a CloudFormation template that's going to give access to us to your account. So we'll go ahead and hit save and continue. And so now we've inputted our parameters. Those have been saved. And now it's saying we need to access your cloud resources. So we want you to generate this CloudFormation template. We're going to press the button. We'll wait a moment. And we can either download this template or use the AWS CLI to run it. The CLI command is a lot easier to use, and I'm going to recommend that you always do that. And so what we're going to do is generate out this CLI command, and we're going to get this one-line command. And I'm going to go back over to AWS. Sorry, I know I'm going really fast, but it's just how it is. And at the top left corner, we have this little button here. That's for Cloud Shell. We're going to open it up. I know coding's scary, but it's really important to get as much coding experience or scripting as you can. So strongly recommend you follow along here. But it's going to open up, and once it's open, we can paste that in. Now, sometimes this wants to have some kind of EBS storage, so you might have to say yes and wait a little bit. That's just the norm for cloud storage. But I'm going to go back here. I'm going to copy this command, okay? And we're going to go back over here. I'm going to right-click and paste. And this always happens when there's a multi-text line. We're going to pop up here, and we're just going to review it. Looks good. So notice it has a template URL, so that's the template it's pulling in. There's temporary credentials to allow that. It's going to create a stack name called ExamPro validation, and it's going to say capability named IAM. Now this might fail because I've done it before, but we'll go ahead and paste it in. I'm going to hit enter, and it looks like it's creating the stack. So we'll go over to CloudFormation, and we'll go here, and I'll just get this out of the way. I don't want that open right now. And so I'm just going to give this a refresh. And did that create that right now? That was the name of the stack, right? ExamPro validation, that is correct. And if I go over here, what's the date today? I don't even know, because that might be an older date. I mean, it's November, so I don't think that one worked because I already had it working there before. So what I'm going to do here, I'm going to go ahead and delete this one, okay? So I just want to point out, like, if you're doing multiple validators in the system, you always have to roll it back, tear it down, okay? Like the old one. So I'll delete that one again, because I just don't have strong confidence that it was actually deployed. So I'll be back here in just a moment as it tears down. All right, it actually did finish tearing down, so that is there. But I'm going to go back here. I'm going to attempt to run this command again. So go ahead and copy this, and I will paste it in again. We'll say paste. And I'll hit enter. And it says already existed in the stack. Well, what are you talking about? It's definitely not there. That's what I thought I would get as an error the first time around. So this is CA Central 1. Oh, you know what it is? I'm in North Virginia. So you got to be very careful with your regions. So I go over here. So I did delete one that was from another one. That's why I was confused, because I thought it already existed. I have to delete it out. This is normal in cloud, right? So just understand that when I do follow-alongs, I don't edit out the tricky parts, because I know it makes it a little bit confusing, but it really does help to demonstrate how confusing cloud can be and how to work through those problems. But over here, CA Central, so this is deployed. 11/15, that's the date that I've deployed this on, so that makes sense here. So we just got to be very aware of that. So this is in CA Central 1, but we'll go back over here. And so this is done. So we know that it's done because it's here. It's in the region that we expect it to be in. So now the permissions are done. We can run the poller. So what the poller is going to do is it's now going to pull data from your account. And that way we're going to be able to then validate whether things are correct. So we'll go ahead and run the poller. And notice it says S3 API list buckets. It flashed it really quickly, but the way this tool works is it's actually using the AWS CLI underneath. So I'm just going to go ahead and just show you what this is, or just show you a quick reference here. So the AWS CLI is a pragmatic way to access information for AWS. We probably show that somewhere in this course. And so the command it was running, I believe, was... I should know, I coded this. It was S3 API, and then it was like list buckets. List buckets. So that's the command it ran. So really, what the validator did, it did AWS S3 API list buckets. Okay, and if you notice this, it returns back JSON. So we get back the payload. That's what we are storing in our own AWS account, which, by the way, we delete after a period of time. I don't remember how much time, but we don't hold on to your data for long because we don't really want it. But yeah, so here it's returning back that data. And so somewhere in here, that the bucket's in here, right? So we've pulled that data and it's there. And so now we can run the validator. We'll click Run Validator. And it's super fast because we already have the data downloaded. And it's doing one check here. So it says should have bucket matching name. So you can see it's loading from a JSON file that's called S3 API list buckets. We always name the JSON files after the commands. And it's looking through buckets. So if we go over here, go all the way to the top here for a moment, you can see buckets. So it's looking within this array, and it's trying to match a name called my validator bucket, which you provided to us. So somewhere in here, I have a lot of buckets in this account. Somewhere in here, there it is. It's there. And so that's how that works. But yeah, just look out for those validators and try to run them and validate that you are able to do this stuff, okay? But we'll see you in the next one, okay? Ciao. Oh, wait. I didn't show you how to clean up. I'm just running off screen here. So once you're done, what you can do is you can go over to CloudFormation here, and you should do this, is go ahead and delete the stack, okay? Because that's going to tear down the permissions so that we no longer have access to your account. So that's kind of an important thing to do. But we'll go ahead. And the other thing about these permissions is that we're only asking for exactly what we need access to. So in this permissions, it only generates out to get access to the S3 bucket, specifically what we're accessing for. So even if you left it up, it's usually okay, it's safe, but you know, if there's no reason for us to have access anymore, you should obviously delete it. But yeah, that one is now gone. And so now we are absolutely done. I'm gonna go ahead and just close this out here. But yeah, hopefully that makes it pretty clear how validators work in our system, and you see the benefit to getting that check in your real account. Ciao. Hey, this is Andrew Brown from ExamPro, and we are at the start of our journey asking the most important question first, which is, what is cloud computing? So cloud computing is the practice of using a network of remote servers hosted on the internet to store, manage, and process data rather than a local server or personal computer. And so when we're talking about on-premise, you own the servers, you hire the IT people, you pay or rent the real estate, you take all the risks. But with a cloud provider, someone else owns the servers, someone else hires the IT people, someone else pays or rents the real estate, and you are responsible for configuring cloud services and code, and someone takes care of the rest of it for you, okay? So to understand cloud computing, we need to look at the evolution of cloud hosting going all the way back to 1995, where if you wanted to host your website or web app, you'd have to get a dedicated server. So that would be one physical machine dedicated to a single business running a single project, a site or an app. And as you can imagine, these are expensive because you have to buy outright the hardware, have a place to store it, the network connection, having a person to maintain it. But it did give you a guarantee of high security, and they still do as of today. So this model hasn't gone away, but it's been specialized for a particular use case. Then came along the virtual private server. So the idea is we still had one physical machine, but now we were able to subdivide our machine into sub-machines via virtualization. And so essentially you're running a machine within a machine. And so you had better utilization of that machine running multiple web apps as opposed to having a physical machine per project. So you got better utilization and isolation of resources. And so these two options still required you to purchase a machine, a dedicated machine. And so that was still kind of expensive, but then came along shared hosting. And so if you remember the mid-2000s, like with GoDaddy or HostGator or any of those sites where you had really cheap hosting, the idea is that you had this one physical machine shared by hundreds of businesses. And the way this worked, it relied on tenants underutilizing their resources. So, you know, you wouldn't have a sub-machine in there, but you'd have a folder with permissions that you could use. And so you would really share the cost. And this was very, very cheap. But you were limited to whatever that machine could do, and you were very restricted in terms of the functionality you had. And there was just poor isolation, meaning that, you know, if one person decided to utilize the server more, they could hang up all the websites on that single server. Then came along cloud hosting, and the idea is that you have multiple physical machines that act as one system. So this is distributed computing, and so the system is abstracted into multiple cloud services. And the idea is that you basically get the advantages of a lot of the things above. So it's flexible, you can just add more servers, it's scalable, it's very secure because you get that virtual isolation. You get it extremely at a low cost because you're sharing that cost with the users, where in the shared hosting, it might be hundreds of businesses. We're looking at thousands of businesses. And it was also highly configurable because it was a full virtual machine. Now, cloud actually still includes all of these types of hosting. They haven't gone away, but it's just the idea that you now have more of a selection for your use case. But hopefully that gives you an idea what cloud hosting looks like, and it really has to come down to distributed computing, okay? Hey, this is Andrew Brown from ExamPro, and before we talk about AWS, we need to know what is Amazon. So Amazon is an American multinational computer technology corporation headquartered in Seattle, Washington, and so this is the Seattle skyline with the Space Needle. And Amazon was founded in 1994 by Jeff Bezos, and the company started as an online store for books and expanded to other products. So as you can see, this is Jeff Bezos a long time ago, and he has this interesting spray painted sign, and his desk is held up by cinder blocks, and it looks like his desk is like an old table or something, and he's working really late. And he used to be a millionaire at this time, and he would be driving into work in his Honda Accord because, his motivation was always to put all the money back into the company. So it really shows that he worked really hard, and it did pay off because Amazon has expanded beyond just an online e-commerce store into a lot of different things, such as cloud computing, which is Amazon Web Services, digital streaming, such as Amazon Prime Video, Prime Music. They bought Twitch.tv. They own the Whole Foods Market grocery store. They have all this artificial intelligence. They own low orbit satellites and a lot more stuff. It's hard to list it all. And so Jeff Bezos today is not the CEO. It's actually Andy Jassy is the current CEO of Amazon. He was previously the CEO of AWS. So Jeff Bezos can focus on space travel. So there you go. Hey, this is Andrew Brown from ExamPro, and we are taking a look at Amazon Web Services. And this is the name that Amazon calls their cloud provider service, and it's commonly referred to just as AWS. So here is the old logo where we see the full name, and here is the new logo. But I like showing the old logo because it has these cubes which best represent what AWS is. And it is a collection of cloud services that can be used together under a single unified API to build a lot of different kinds of workloads. So AWS was launched in 2006 and is the leading cloud service provider in the world. I put an asterisk there because technically AWS existed before 2006. And a cloud service provider, which is what AWS is often initialized as CSP. So if you hear me saying CSP, I'm just saying cloud service provider, okay? So just trying to look at the timeline of when services rolled out. The first one came out in 2004 and was Simple Queue Service, SQS. And this service still exists as of today. But at the time, it was the only service that was publicly available. So it wasn't exactly a cloud service provider at this time, and it was neither AWS, it was just SQS. But then a couple years later, we had Simple Storage Service, also known as S3, which was launched in March of 2006. And then a couple months later, we had Elastic Compute Cloud, also known as EC2. And EC2 is still like the most used service within AWS and is like the backbone for pretty much everything there. Then in 2010, it was reported that all of Amazon.com's retail sites had migrated to AWS. So even Amazon was using AWS full steam. And to support industry-wide training and skill standardization, AWS began offering a certification program for computer engineers on April 2013. And this is the type of certifications that we are doing as we speak. So I just want you to know that AWS was the one leading cloud certifications. If we just want to take a look here at the executive level, as of today, the CEO is Adam. He's the former CTO of Tableau, and he spent a decade with AWS as a VP of marketing, sales, and support. So he was there, he had left for a bit, and now he is back. Then we have Werner, and he's the CTO of AWS. He's been the CTO for pretty much the entire time AWS existed, with the exception of some time of the first year. He's famous for quoting, "Everything fails all the time." And then there's Jeff Barr, who's the chief evangelist. So if you're ever wondering who is writing all the blog posts and talking about AWS, it's always Jeff Barr, okay? All right, so what I want to do here is expand on what is a cloud service provider, also known as a CSP, just because there's a lot of things out in the market there that might look like a CSP, but they actually are not. So let's go through this list and see what makes a CSP. So this is a company which provides multiple cloud services, ranging from tens to hundreds of services. Those cloud services can be chained together to create cloud architectures. Those cloud services are accessible via a single unified API. So in AWS's cases, that is the AWS API. And from that, you can access the CLI, the SDK, the management console. Those cloud services utilize metered billing based on usage. So this could be per second, per hour, VPCUs, memory, storage, things like that. Those cloud services have rich monitoring built in. So, every API action is tracked and you have access to that. So in AWS's case, it's AWS CloudTrail. And the idea here is those cloud services have infrastructure as a service offering. So IaaS, that means they have networking, compute, storage, databases, things like that. Those cloud services offers automation via infrastructure as code. So you can write code to set everything up. And so here's just kind of an example of an architecture where we have a very simple web application running on EC2 behind a load balancer with the domain with Route 53. But the idea is just to show you that you're chaining these things together. If a company offers multiple cloud services under a single UI, but do not meet most of or all of these requirements, it would just be referred to as a cloud platform. So when you hear about Twilio or HashiCorp or Databricks, those are cloud platforms, and AWS, Azure, GCP are cloud service providers, okay? All right, let's take a look here at the landscape of cloud service providers. This is generally broken down into tier 1, tier 2, tier 3, but I've modified it to give each tier its own name, as I don't like to think of them as rankings, and more so that these cloud service providers are specialized for a particular thing. And I've also added a fourth tier because, the internet has always talked about 3 tiers, but there really is a fourth tier, and I wanted to make sure we had the full scope here included. So in the top tier, you're going to recognize some common names there: Amazon Web Service, Microsoft Azure, Google Cloud Platform, and Alibaba Cloud. In North America and Europe, AWS, Azure, and GCP are known as the big 3, but Alibaba Cloud is huge as well if you're in the Asia region, specifically China. So it's really just going to be dependent on where you live, which are considered the most commonly known or popular. But we'll talk about that here in a moment. But the reason I call tier 1 top tier is that these are very well-known providers. They're early to market. They have strong synergies between their services. They're just really good cloud service providers. You cannot go wrong with these providers. Then we have our tier 2, or I would call our mid-tier. These are backed by really well-known tech companies, but I would just say that their ability to become top tier did not work out the way they planned. So IBM at one point was looking to be a top tier provider, but they just did not keep up with AWS, and they just slipped into this mid-tier and kind of specialized, at least for a while, into ML AI services, and now they're just more like very expensive enterprise managed infrastructure for their existing clientele. Oracle, very, very inexpensive. That's their play. They try to be the cheapest, but their service overall is not fun to use. Interestingly enough, I believe Microsoft Azure was just signing a contract to use Oracle Cloud, so it's not unusual for some of these cloud service providers or these organizations to use other providers because they want to use their global infrastructure. But Oracle Cloud is not doing that great. There are other ones in the Asia region like Hual Cloud and Tencent Cloud. I honestly don't know a whole lot about them, but they do show up on the Magic Quadrant. So it's possible in the Asia region that these are the big 3, and AWS, Azure, and GCP do not play a larger role. But from our perspective, I put them into that mid-tier because they just don't have global awareness or global market dominance like the other 3 up there. Looking at the light tier, these were traditionally virtual private servers, so they just specialized in that, and they turned to offer more core infrastructure service offerings. So we have Vultr. I always thought it was pronounced Voltaire, but it's actually Vultr, DigitalOcean, and Akamai Connected Cloud, which was formerly known as Linode or Linode. So they merged their companies together, and they want to be like a cloud service providers, but they're very, very light in terms of their offerings. So, they'll have things like serverless and being able to run a Kubernetes cluster and some cloud storage and stuff, but they won't have things like the same level of event-driven metered billing or other kinds of functionality that you come to expect in the top tiers. But if you're working with a smaller organization, they are a lot simpler to utilize. So they are a great introduction to cloud for companies that find the top tier too complex. And then looking at the fourth tier, I call this the private tier. This is basically software that you can deploy onto your own machines in your data centers to get the same kind of functionality that you would if you were using, let's say, AWS or any of these other providers. And, previously I would put OpenStack into the mid-tier because in a sense that it was kind of like a cloud service provider that was using quite a bit, but I didn't feel like it had good fit there. So that's why we made this fourth tier. And we have a few different softwares. We have OpenStack, Apache CloudStack. Those are both open source. And there's VMware vSphere. I have an asterisk there because it's not really the same thing, but it is used a lot everywhere to manage a lot of virtual machines. And so I kind of feel like it should fit in there. But that gives you kind of an idea of the landscape of cloud. And we'll see you in the next one. So how do we determine who is the leader in cloud? Well, one way of indicating that is the Gartner Magic Quadrant for Cloud. So the Magic Quadrant is a series of market research reports published by the IT consulting firm Gartner that rely on proprietary qualitative data analysis methods to demonstrate market trends such as direction, maturity, and participants. So it says a series of reports, but the only thing I've ever seen are these graphics where they show the quadrant. It's a diagram that summarizes all the information. So I think you might have to pay to access the reports because it's definitely not just publicly accessible knowledge. And I don't think they would show all of how this stuff is calculated. But let's just take a look at this graphic here. So notice we have challengers in the top left corner, leaders in the top right corner. In the bottom left corner, we have niche players. And then in the bottom right corner, we have visionaries. So the idea here is that the closer you are to this top corner, the better you are doing. And the one that is closest to it is Amazon Web Services, followed with Microsoft pretty close in second, Google to the left, Alibaba Cloud next, Oracle, and then we have IBM, Tencent, and Hual. And there are other players, but they are so small that they are not showing up there. And we showed that in the landscape of CSPs, or maybe this is only for they consider what we call first tier or top tier cloud service providers. It's really useful to look at last year's MQ and to see how things have moved. So it looks like Microsoft has shifted a little bit forward here and gone a little bit closer to AWS. Google has significantly moved up, and Alibaba Cloud, it seems to be moving more to the right. And again, I'm just showing what their movements were from this year to that year. So they are over here now. Oracle is way over here now. And for whatever reason, Huawei Cloud is on the board. So it's interesting to see how they move. Another thing that's interesting here is that this one is 2022 of June, and this one is July of 2021. And right now, as the time I'm recording this video, it's 2023, near the end of the year. And I could not find a 2023 one. So even if it says June or July, they will release these out in October, November, etc., way later in the year. And so for whatever reason, they have yet to make the latest one available. So I'm still curious to see what that is here. So I'm just giving you the information that we have, but you can look at this stuff basically on the Gartner website if you want to see any of these magic quadrants for any of the industries there. And what I find is that if a company is doing really well, they'll always post it on their website. So it's very easy to find the Magic Quadrant for Cloud on the AWS website because they're the leader. So they definitely want to show that there. But yeah, there you go. So a cloud service provider can have hundreds of cloud services that are grouped into various types of services. But the four most common types of cloud services for infrastructure as a service, and I call these the four core, would be compute. So imagine having a virtual computer that can run applications, programs, and code. Networking, so imagine having virtual network defining internet connections or network isolation between services or outbound to the internet. Storage, so imagine having a virtual hard drive that can store files. Databases, so imagine a virtual database for storing, reporting data, or a database for general purpose web applications. And AWS in particular has 200 plus cloud services. And I want to clarify what cloud computing means, because notice that we have cloud computing, cloud networking, cloud storage, cloud databases, but the industry often just says cloud computing to refer to all categories, even though it has compute in the name. So just understand, when someone says cloud computing, they don't just generally mean the subcategory, they're talking about all of cloud, okay? So AWS has a lot of different cloud services, and I just want to kind of go quickly over the types of categories that we can encounter here and just mention the 4 core. So any CSP that has IaaS will always have these 4 core service offerings. We have compute, so in AWS this would be EC2 VMs. Storage, this could be something like EBS virtual hard drives. Database, so that could be RDS SQL databases. Networking and content delivery, but really it's networking. And this would be VPC, so private cloud network. Okay, so let's just look at all the categories that are outside the 4 core. So there could be analytics, application integration, AR, VR, AWS cost management, blockchain, business application, containers, customer engagement, developer tools, end user computing, game tech, IoT, machine learning, management and governance, media services, migration and transfer, mobile, quantum technologies, robotics, satellites, security, identity, and compliance. If there was more, I would not be surprised, but you can see there's a lot of stuff that's going on here. So let's take a look at all the AWS services that are available to us. So if you're on the marketing website, which is aws.amazon.com, what you'll see in the top left corner is products. And so these are all the categories, and for whatever we want, if it's like EC2, we can go into here and we can read all about it. So usually we'll have our overview, all right? And that's not very useful. And then we'll go over to features. And so this can be kind of useful to get some basic information, and pricing, which is something you'll do a lot in AWS, is you're always going to be going to a service, looking up its price. And so you'll make your way over here. Every single one is different. A very important page would be like getting started. So this will give you basic information. But what I do is I like to go all the way down to the bottom here and find my way over to the documentation. So I'll go here to documentation to get that deeper knowledge about that service. And as you can see, things get pretty deep with AWS in terms of the information they have. So hopefully that gives you an idea of the scope. Also, when you're logged into AWS, and this will be when we create our account, you can explore all the services this way as well. So these are all the AWS services, but you just notice that there's 2 ways to explore them, where this is actually you just actually utilizing the services, and then the marketing website is you reading about them and learning all about them, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at the evolution of computing. Your cloud service provider has all of these offerings, and the idea is that you need to choose the one that meets your use case. A lot of times, this all has to come around the utilization of space. That's what we're trying to illustrate here in this section here, and the trade-offs of why you might want to use some of these offerings, okay? For dedicated, we're talking about a physical server wholly utilized by a single customer. That's considered single tenant. And for Google Cloud, we're talking about single node clusters and bare metal machines where you have control of the virtualization, so you can install any kind of hypervisor or virtualization you want in the system. The trade-off here, though, is that you have to guess up front what your capacity is going to be, and you're never going to 100% utilize that machine because it's going to have to be a bit under in case the utilization goes up. That's you choosing the CPUs and the memories. You're going to end up overpaying because you'll have underutilized server. It's not going to be easy to vertically scale. It's not like you can just say resize it because the machine you have is what you have, right? You can't add more. I mean, I suppose they can insert more memory for you, but that's a manual migration, so it's very difficult. And replacing the server is also very difficult, okay? So you're limited by the host operating system. It's not virtualized, so whatever is on there is on there. And that's what your apps are going to have access to. If you decide to run more than one app, which is not a good practice for these kind of machines, you're going to end up with resource sharing where one machine might utilize more than the others. Technically, with a dedicated machine, you have a guarantee of security, privacy, and full utility of the underlying resources. I put an asterisk there because, yes, it's more secure, but it's up to you to make sure that it's more secure. So you have that's up to your skills of security, right? Whereas if you had a virtual machine or anything above that, there's more responsibility on the cloud service provider to just provide a secure machine, and they can do a better job than you. So why would you use a dedicated machine? Well, maybe you're doing high performance computing where you need these machines like very close together, and you have to choose what kind of virtualization you need to have, okay? So then we're looking at virtual machines. The idea here is you can run a machine within a machine. The way that works is we have a hypervisor. This is a software layer that lets you run the virtual machines. The idea here is now it's multi-tenant. You can share the cost with multiple customers. You're paying for a fraction of the server. You'll still end up overpaying for the underutilized virtual machine because a virtual machine is just like, you have to still say how many vCPUs, how much memory, and your app is, you don't want an app that uses 100%, right? You want to use exactly the amount you need, but you can see here, there's still going to be some underutilization. You are limited by the guest operating system, but now it's virtualized, so at least it's very easy to possibly migrate away. If you choose to run more than one app on a virtual machine, it can still run into resource sharing conflicts. It's easier to export or import images for migration. It's easier to vertically or horizontally scale, okay? And virtual machines are the most common and popular offering for compute because people are just very comfortable with those. Then you have containers, and the idea is you have a virtual machine running these things called containers. The way they do that is similar to a hypervisor, but instead you have, like here is a Docker daemon, so it's just a container software layer, okay, to run those containers. There's different kinds. Docker is the most popular. And the great thing is you can maximize the capacity because you can easily add new containers, resize those containers, use up the rest of the space. It's a lot more flexible, okay? Your containers will share the same underlying OS, but they are more efficient than multiple VMs. Multiple apps can run side by side without being limited by the same OS requirements and not cause conflicts during resource sharing. So containers are really good, but the trade-off is there are a lot more work to maintain. Then you have functions. Functions go an even step further. And the idea is that you, the containers where we talked about, that's a lot of work to maintain. Now the cloud service provider is taking care of those containers generally. Sometimes not. It depends if it's serverless or not. But the idea is that you don't even think about, and this is called serverless compute, but you don't even think about the OS or anything. You just know that what your runtime is. You run Ruby or Python or Node, and you just upload your code, and you just say, I want this to be able to run for this long and use this amount of memory, okay? You're only responsible for your code and data, nothing else. It's very cost effective. You only pay for the time the code is running. And VMs only run when there is code to be executed. But because of that, there is this concept of cold starts. And this is where the virtual machine has to spin up. And so sometimes requests can be a bit slow. So there's a bit of trade-off there, but functions or serverless compute is generally one of the best offerings as of today. But most people are still getting kind of comfortable with that paradigm, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at the types of cloud computing. And the best way to represent this is a stacked pyramid, and we'll start our way at the top with SaaS, also known as software as a service. So this is a product that is run and managed by the cloud service provider. You don't have to worry about how the service is maintained. It just works and remains available. So examples of this, and actually the first company to coin this was actually Salesforce. Then there's things like Gmail, Office 365, so think Microsoft Word, Excel, things like that. And they run the cloud, okay? And SaaS is generally designed for customers in mind. Then came along Platform as a Service, also known as PaaS. And these focus on the deployment and management of your apps, so you don't worry about provisioning, configuring, or understanding the hardware or operating system. And so here we'd have things like Elastic Beanstalk, Heroku, which is very popular among developers that just want to launch their code, or Google App Engine, and that is the old logo, but that's the logo I like to use because I think it looks cool. And so these are intended for developers. The idea is that you just deploy your code, and the platform does the rest. Then there is infrastructure as a service. There's no way to say that, like it's easy to say SaaS or PaaS, but there's no easy way to say IaaS. So this is the basic building blocks for cloud IT. It provides access to networking features, computers, and data storage space. And the idea here is you don't worry about the IT staff, data centers, and hardware. And so that would be like Microsoft Azure, AWS, Oracle Cloud, things like that. And these are for administrators, okay? So there you go. Hey, this is Andrew Brown from ExamPro, and we are taking a look at cloud computing deployment models, starting with public cloud. And the idea here is that everything, when I say everything, I'm talking about the workloads, the projects, the code, is built on the cloud service provider. So here is a diagram where we have a EC2 instance, a virtual machine running our application, and then we have our database in RDS, and we have the internet coming into our AWS account, and so everything is contained, all of our infrastructure is within AWS, all right? And so this is known as being cloud native or cloud first. And I put an asterisk beside cloud native because that was a term that was used prior to cloud service providers to refer to containers or open source models being deployed and being mobile other places. So just understand that it has two meanings, but in the context of this, cloud native just being like native to the cloud, like using cloud to begin with, okay? Then we have private cloud, so everything built on a company's data center, and being built on a data center is known as being on-premise because that is where the data center resides, near where you work. And so here you could be using cloud, but you'd be using OpenStack, which would be a private cloud. So here we have our on-premise data center, and the internet's coming into our data center, and we're running on OpenStack where we can launch virtual machines and a database, okay? Then there's the concept of a hybrid cloud, so using both on-premise and a cloud service provider together. And so the idea here is we have our on-premise data center, and then we have an established connection. Maybe it's a VPN connection, maybe it is a direct connection. But the idea is that we're bridging that connection and utilizing both our private and our public stuff to create a cloud workload. Then there is a fourth one called cross-cloud. Sometimes it's known as multi-cloud. And sometimes it's erroneously referred to as hybrid cloud, but it generally is not hybrid cloud, okay? And the idea here is when you're using multiple cloud providers. And so one example here could be using services like Azure Arc. So Azure Arc allows you to extend your control plane so that you can deploy containers for Kubernetes in Azure, within Amazon EKS, within GCP Kubernetes Engine. But being cross-cloud doesn't necessarily mean that you're running using a service that works across the cloud and manages it. It could just mean using multiple providers at the same time. Another service that is similar to Azure Arc, but is for Google Cloud Platform, is also known as Anthos. AWS has traditionally not been cross-cloud friendly, and so we haven't seen any kind of developments there where we see these other services that are or cloud service providers behind AWS trying to promote it to grab more of the market share, okay? So let's talk about the different deployment models and what kind of companies or organizations are still utilizing for these particular categories. So for cloud, again, this is where we're fully utilizing cloud computing. Hybrid is a combination of public cloud and on-prem or private cloud. And then on-prem is deploying resources on-premise using virtualization, resource management tools, sometimes called private cloud, or it could be utilizing something like OpenStack. So for companies that are starting out today or are small enough to make the leap from a virtual private server to a cloud service provider, this is where we're looking at cloud. So we're looking at startups, SaaS offerings, new projects and companies. So maybe this would be like Basecamp, Dropbox, Squarespace. Then for hybrid, these are organizations that started with their own data center but can't fully move to cloud due to the effort or migration or security compliance. So we're talking about banks, fintech, investment management, large professional service providers, legacy on-prem, so maybe CIBC, which is a bank, Deloitte, the CCP or CPP investment board. And then for on-premise, these are organizations that cannot run on cloud due to strict regulatory compliance or the sheer size of the organization, or they just have like an outdated idea of what cloud is. So they just have a lot of difficulties in terms of politics adopting cloud. So this would be public sector like government, super sensitive data like hospitals, large enterprise with heavy regulation, insurance companies. So again, hospitals, maybe AIG, the government of Canada. And so I shouldn't say that they aren't using cloud, but because AWS and all the cloud service providers have public sector offerings. So, I'm just trying to stage it as an example of things that could be still using on-premise. So, I know the government of Canada definitely uses cloud in a lot of ways. Same with AIG and hospitals, but generally these are the last holdouts of on-prem because there really isn't a good reason to be fully on-premise anymore. But again, there are some things that are still doing that, okay? Hey, this is Andrew Brown from ExamPro, and we are at the start of our journey creating ourselves an AWS account. So what you need to do is go to aws.amazon.com. If you don't have a lot of confidence how to get there, you just type in AWS into Google and then click here on the link where it says awasamazon.com. It'll take you to the same place. Now notice we have a big orange button in the top right corner. So this says sign into the AWS console. If it's the first time you've ever been to this website, so if I go to aws.amazon.com incognito, it will have the create an AWS account button. I don't know why they don't keep this consistent across the board, but I wish they did. But if you are on the screen, you can click here or there. But if you do see something that doesn't say, create an account or etc., you can just sign in. Okay, and then down below you can hit create a new AWS account. So that's the way you're going to get in there. And so you're going to put an email, a password, and create an AWS account name. I've created this so many times and it's so hard to set up new emails. I'm not going to do this again. It's not complicated, but one thing I need to tell you is that you do need to have a credit card. You cannot create an account without a credit card. And for those who are in places where maybe you don't have a traditional credit card, maybe you can get a prepaid one. So up here in Canada, we have a company called Koho. And so Koho is a Visa debit card. And so it's basically a virtual prepaid credit card. And so these do work on the platform as well. So if you have a traditional credit card or possibly could find one of these, you still have to load it with money, but it does give you a bit more flexibility to create that account. So what I want you to do is go through that process yourself. It's not complicated, and I'll see you on the other end, okay? So once you finish creating your account, you should be within the AWS Management Console, and this is the page you're always going to see when you log in. It's always going to show the most recent services here. And you'll notice in the top right corner that I have my account called ExamPro. If you're wondering how do you change that name, what you do is to go to My Accounts here, and once there, you'll have your account settings up here. And if you go to Edit, you can change that name here, okay? So, sometimes when you create your account, you don't like the account name that you gave it, and so that's your opportunity to fix it. But once we're in our account, what I want you to do is immediately log out because I want you to get familiar with the way you log into AWS because it is a bit different than other providers. And so I don't want you to get hung up later on with your account. So I've logged out. I'm going to go ahead and log back in. So you can click the orange button, or what I like to do is drop down My Account and go to AWS Management Console. It's a lot more clear. And you'll notice we're going to have two options, root user and IAM user. So this is what I'm talking about for the confusion. So when you log into your root user account, you are always using an email. And when you're logging as an IAM user, you're actually going to be entering the account ID or account alias. But what we'll do is go to the root user, and this is the email you use to sign up with the account. So for me, I called this one Andrew plus sandbox at exampro.co. I'm going to go to next. Sometimes you get this character box. It's very annoying, but it happens time to time. And so what I'm going to do is just go ahead and type that in. Okay. And hopefully it likes it. And then I'm just going to enter in my password. All right. And I'll be back into my account. And so notice it takes me back to the AWS Management Console. So the root account is not something we want to be generally using, except for very particular use cases. And we do cover that in the course. But what I want you to do is go set yourself up with a proper account. And so what we'll do is go to the top here and type in IAM. And this stands for Identity and Access Management. And we'll click on IAM here. And on the left-hand side, we're going to see a bunch of options here. And so notice right away we get to the IAM dashboard where it's going to start to make some recommendations for us. The first one is always to add MFA, multi-factor authentication. Another thing you can do is set an account alias. So you can see that I've set one here prior. So if I just go ahead and remove it, the way we'd have to log in is via the account alias, which is the same as the account ID. And so I don't really like that. So I'm going to just rename it to Deep Space 9. And these are unique, so you have to pick something that is unique to you. So it could be your company name or things like that. It's going to make it a lot easier to log in when we create our additional user here. So we'll come back to MFA at some point here. But what I want you to do is go over to users and go ahead and make yourself a new user. And so I'm going to call this one Andrew Brown. And I'm going to enable pragmatic access. I'm going to enable AWS Management Console. So this one's going to allow me to use the APIs to pragmatically work with AWS. And this one here is going to allow me to just log into the console, which is pretty fair here. So now that I have this, we can auto-generate it or give it a custom password. I'm just going to auto-generate it for the time being. And here it says you must create a new password at the next sign-in, which sounds fair to me. And we can go ahead and create ourselves a new group. So it's pretty common to create a group called admin. And notice here, this is where we're going to have a bunch of different policies. So the first one here, which is admin and access, provides full access to AWS services and resources. And this pretty much gives you nearly almost the same capabilities as the AWS root user account. And so that's going to be okay because we are an admin in our account. So I'll checkbox that on. But I just want to show you here, if you drop down filter policies and you went to AWS manage job functions, these are a bunch of pre-made AWS policies that you could apply to different users. So what's really popular after the administrator access is to usually give the power user access. And so this one allows a user to do basically anything they want with the exception of management of users and groups. So, it could be that that's something that you'd want to do for some of your users. I just don't want to have any trouble, so I'm going to give us admin access here. And we're going to go ahead and create this group. And so here is the group that we are creating. We're going to go next. We can apply our tags if we want. I'm not going to bother. We're going to hit next review and then hit create user. All right, and so now what it's doing is it's showing us the access ID and the access key secret that we can use to pragmatically access AWS. And then there's a password here. So I'm going to go ahead and show it. And what I'm going to do is just copy this into a clipboard anywhere. And so I'm just copying that off screen here because I'm going to need it to log in. And I'm just going to remember my username as well. All right. And so what we'll do is go ahead and hit close. So what I'll do is go back to my dashboard here. And remember, I set my account alias as deepspace9, but we could also use the account ID to log in. I'm just going to grab my account ID off screen here. And what I want to do now is go ahead and log out and now log into this IAM user. And this is the one that you should always be using within your AWS account. You shouldn't be using your root user account. So what I'll do is go over to IAM user here. And notice now that it says account ID, so 12 digits, or the account alias. So here I can enter in these numbers here, or I can enter in my alias, which is deepspace9. And again, you'll have to come up with your own creative one there for yourself. And we'll go ahead and hit next. And so notice what it's going to do is now ask me what my IAM username is. So I define mine as Andrew Brown. And then we had an auto-generated password there so that we had saw. And so I'm going to place that in there. We'll go ahead and hit sign in. And so now right away, it's going to ask me to reset the password. So I'm going to put the old password in there. And so now I need a new password. I strongly recommend that you generate out your passwords to be very strong. I like to go to password generator and I'll drop this down and I'll do something really long like 48 characters. And if you don't like weird characters, you can take those out there. Sometimes it loads here, so you got to try it twice. And I'm going to go down to, 48. There we go. And so that's pretty darn long. So I'm going to copy that off screen here so I do not forget. And you probably would want to put this in a password manager, something like Dashlane or some sort of thing like that. And we'll go ahead and we will paste that in and we'll see, I don't want Google to save it. And we'll see if it takes it. And so there we go. So what I'll do is now log out and I'll make sure my new password works because you really don't want to have problems later. So we'll type in deepspace9 Andrew Brown. Again, this is going to be based on what you have set. And we'll go ahead and log in. And there I am. And so now notice that it doesn't say ExamPro or whatever. It says Andrew Brown at deepspace9. So it's using the account alias and showing the name. And that's how I'm going to know whether I'm the root account user or whether I'm logged in as an IAM user. All right. So there we go. Okay, so now that we have the proper user account to log in, I just want to point out about regions. So in the top right corner, you'll notice it says North Virginia here. It possibly will say something completely else for you, but what you'll do is you'll click and drop that down and you'll see a big list of regions. And so sometimes when I log in AWS, it likes to default me to US East, Ohio, but I honestly like to launch all my stuff in US East, North Virginia. Even though I'm in Canada, I probably should be using the Canada Central region down here. But the default region is going to be based on your locality, okay? So just understand that it might be different. I strongly recommend for all of our follow-alongs you run in US East 1 because US East 1 is the original region, and it also has the most access to AWS services, and some AWS services such as like billing and costs and things like that are only going to show up in US East North Virginia. So just to make our lives a lot easier, we're going to set it there. But I want you to understand that some services are global services, meaning that it doesn't matter what region you're in, it's going to default to global. And one example could be CloudFront. So if I jump over to CloudFront here for a moment, and we do seem to have some CloudFront distributions here from a prior follow-along. But notice up here that it now says global. So CloudFront does not require a region selection. Let's make our way over to S3. All right. And this one's also global. So again, this one does not require a region selection. But if you go over to something like EC2, okay, this has a region dependency. So just be really careful about that because a lot of times you'll be doing a follow along and you'll be like, why aren't these resources here or whatever? And it's because this got switched on you and it can happen at any time. So just be cautious or aware of that, okay? So one of the major advantages of using AWS or any cloud service provider is that it utilizes metered billing. So that is different from a fixed cost where you'd say, okay, I want a server for X amount of dollars every month. But the way AWS works is that it's going to bill you on the hour, on the second, based on a bunch of factors. And so you're going to be able to get services at a lower cost. However, if you choose an expensive service and you forget about it, or if there's misconfiguration where you thought you were launching something that was cost effective but turned out to be very expensive, you could end up with a very large bill very, very quickly. And so that is a major concern for a lot of people utilizing cloud, but there's a lot of great toolings built into AWS to allow you to catch yourself if you happen to make that mistake. And before we go ahead and learn how to do that, I want to show you some place where you could end up having excessive spend without knowing it. So one example, and this has actually happened to me when I first started using AWS, before I even knew about all the billing tools, is I wanted to launch a Redis instance. And so you just have to watch, you don't have to do this, but Elasticache is a service that allows you to launch either a Memcache or Redis database. And I just wanted to store a single value. And so I went here and I scrolled down, it looked all good and I hit create, but I wasn't paying attention because apparently AWS likes to default the node type here to the cache R6G.large. All right. And you know, you might think that AWS has your best interest in play, and most services are pretty good. They make sure that they're either free or very low spend, but some of these, and Elasticache is an older service where they just have these weird defaults. So, you know, if we were to go look up this, the RG6 large, all right, and look at its spend, all right, and we would go over here. Whoops, I think I went to the China one. But if we were to go over here and look for that instance, I'm just trying to find it here for cost. This one down below, this doesn't say pricing. Does it say our pricing here? Here it is. So this one costs about 2 cents per hour. It doesn't sound like a lot, but if we go here and we do the math, we say 730. 730 is the amount of hours in a month. That is $150, okay? So if you don't know about that and forget about that, that's gonna be $150. And I'm gonna tell you that it used to be a lot higher. I'm pretty sure they used to have it defaulted to something like this or that, because I remember I did this and I had a bill that came in that was like 3,000 USD dollars. And I'm in Canada, so like 3,000 USD dollars is like $1 million up here. And so I remember it was a big concern and I freaked out, but that was okay because all I had to do was go to support. And what I had done is I went to the support center and I had opened a support case and I just said, hey, I had this really big bill. So you go here, right? And you look for billing and you look for something like charge inquiry or misspend. And you say, like, help, my bill's too high. And you just say, like, you explain the problem saying, hey, I was using Elastic Cache and it was set to a large default and I wasn't aware about it. Can you please give me back the money? And the great thing is that AWS is going to give you a free pass. If it's your first time where you've had a misspending, they generally will say, okay, don't do it again. And if it happens again, you will get billed, but go ahead and learn how to set up billing alerts or things like that, okay? So just so you know, don't freak out if you do have a really high bill. You're going to get a single free pass. But now that we know that, let's go learn how to set up a budget, okay? All right, so now that we've had a bit of a story about overspend for misconfiguration, let's learn how to protect ourselves against it. And we're going to go ahead and set up a budget. So go to the top here and type in budget. And what that will do is bring us over to the billing dashboard. Another way to get here is to go click at the top here and go to my billing dashboard. And then you'll see the left-hand menu here. And so the great thing about budgets is that the first two are free. It says there is no additional charge for AWS budgets. You pay for configured usage. But I'm pretty sure that that's not true because it used to be AWS budget reports. Okay, so that costs something. It used to be that AWS budgets, after successfully enabled, will incur 10 cents daily. So in addition to Budget Monitor, you can add actions to your budgets. The first two action-enabled budgets are free. Okay, so just be aware that just because AWS says there's no additional charge, read into it because sometimes the fine line will tell you it does cost something. But I know that the first two are free. What we'll do is go ahead and create a budget. I'm just going to close these other tabs here since we have no need for them. And we're going to be presented with a bunch of budget types. We're concerned about cost today, so we're going to go with a cost budget. And notice we can change the period from monthly to daily to quarterly to annually. If you change it to daily, you won't get forecasting, so I don't want that today. But a monthly is pretty good. You can have it recurring, which is strongly recommended, and then you can put a fixed cost. Notice that I already have some spend on this account, so it was like 25 bucks last month. I'm going to set my budget here to $100. And you can add filters here to filter that cost out. So if you want to say only for this region or things like that, you could do that. Notice that this is my spend over here. So this is my budget and that's the actual cost. Notice my cost has been going up the last few months because I've been doing things with this account. And so what I'll do is say simple budget here. We'll hit next. And so now it's asking us if we want to configure alerts. We probably do. So you'd hit add alert. And then you'd set a threshold like 80%, or you could say an absolute value. And then you'd put in your emails like andrew@exampro.co. And I want to point out that this is using AWS SNS, or it should be anyway. So Amazon SNS has no upfront cost based on your stuff here. So even though you're filling out an email, and maybe it doesn't show it, but I'm pretty sure that this would create an SNS topic. But what we'll do is hit next here. We have an alert, so we're just reviewing. Actually, this is for attaching any action. So maybe we want some kind of follow-up thing to happen here. So we say add action, and it requires specific IAM permissions on your behalf. Okay, sure. So I guess you could follow up actions. That's no different than on a building alarm, but we're not really worried about that right now. I'm not going to bother with an action. And we'll go ahead and create a budget. And so here it's going to say that our budget is $100. It's going to show us the amount used, forecast amount, current budget. Sometimes this takes time to show up. So I'm going to hit refresh and see if it shows up yet. There we go. So notice we have forecast amount $23, current budget, etc. Forecasted budget, forecasted versus budget. So it's pretty straightforward on how that works. I'm just curious if it actually created an SNS event. So I'm going to go over here, because a lot of services utilize SNS. So if I go over here default CloudWatch alarm. So I think this is something I had created before. So I'm going to go ahead and just delete it. It says default CloudWatch alarms. Actually, I'm going to just click into here and see what I have. Confirmed. So I think it might have used this when we created it. But the reason I'm bringing up SNS is that there's a lot of services that allow you to email yourself for alerts, and it always integrates with this service. And so I just kind of want to point that out so that you remember what SNS is for. But yeah, so setting up a budget is not too hard. So there you go. All right, so now that we've set a budget, what I want to talk to you about is the free tier. And the free tier is something that is available to you for the first 12 months of a new AWS account, and allows you to utilize AWS services without incurring any cost to you. And so it's in your advantage to utilize this free tier as you are experimenting and learning cloud. So if you want to learn about all the offerings, what you do is go to Google, type in AWS free tier, and you'll get this page that explains all the sorts of things here. So you can get 750 hours on EC2, RDS, things like that. There are stipulations in terms of what it would be. So here, this is a T2 or a T3 micro running Linux, Red Hat, or other type of OSs, okay? So there are details, and you have to read the fine print. Some services are only available for the first 2 months, things like that. So it's going to highly vary based on service, but it's worth giving this a read in areas that you are interested in. Now, the thing is how do you know that you are still in the free tier or you go outside of it? And that's what I want to talk to you about right now. So I am actually in another AWS account. So notice in the top right corner, it says brown.laptop@exampro.co. Sometimes I will switch into different AWS accounts during these follow alongs so I can best show you, these settings. So if you make your way over to billing, and actually I should show you up here, if we go to my billing dashboard, just trying to be consistent here, and you go to the left-hand side to billing preferences, what you can do is enable receive free tier usage alerts, and then put your email in there and save that. And so turn on this feature to receive email alerts when your AWS service usage is approaching or exceeded the AWS free tier usage limits, if you wish to receive these alerts, etc., 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 right? And while you're there, I want you to also checkbox receive billing alerts, so I can show you how to set a billing alert. And AWS says, budgets are a new thing, but billing alerts are still something that we use as of today. So if you checkbox that on, we'll be able to see your cost. If we go back here, it should show you, and it's because I'm out of the free tier on this account, but it would show you in the alerts, your usage there. So an example here is if we scroll down, this is in the documentation tracking your AWS free tier usage. You would see like a box like this, and it would say, hey, your free tier usage limit is here, and you're over it. Okay, so that generally would show up on this panel here, but again, I'm outside of the free tier, so I'm not seeing it here today, okay? So, hopefully that is clear. But yeah, there you go. All right, so we created ourselves a budget. We're monitoring our free tier, but there's another way that we can monitor our spend, and that is through billing alerts or alarms. And it is the old way before we had AWS budgets. This was the only way you could do it, but I still recommend it because there is a bit more flexibility here with this service. And so I wanted to teach you early on so that you know it's available to you, or if you want to play around with it in the future. So what you'll do is go to the top here and type in CloudWatch. And CloudWatch is one of those services where it's actually a collection of services. So there's CloudWatch Alarms, CloudWatch Logs, CloudWatch Metrics. Those are all individual services. And AWS loves to update their interface. So sometimes you'll be presented with this option to change the latest interface. I'm going to try out the new interface here. And that is one challenge with AWS is you always have to expect that they're going to change the UI on you, and you're going to have to work through it. So just understand that I try to keep my videos up to date as best I can, but part of the challenge is getting used to that. So this is what they have today. I don't know if they're going to stick with this, but this is what it looks like. But what I want you to do is make your way over to alarms on the left-hand side. And notice that we actually have a section just for billing, which is interesting. I don't remember them having that before, so it's new. So here it says AWS CloudWatch can help you monitor the charges of AWS bill. Remember that we had to turn that on. Get 10 free alarms with 1,000 free email notifications each month as part of the free tier. So understand that if you create billing alarms, they do cost money. as well if you go over that limit, but you sure get a lot. 10 free alarms is quite a bit. But what we'll do is go ahead here and create ourselves an alarm. We're going to go and choose a metric. And so here are the options we could choose from. And so we, I think, would like billing. And so we can do by service or total estimated charge. We're going to do a total estimated charge. We can only select USD. I've never seen any other currency ever there. And so here we kind of get this little graph where we can see stuff. But this is a lot more powerful than budgets because you can do anomaly detection. So like here it will actually check based between a range as opposed to just going through a particular value. But what I'll do is just set a value here like $50, right? So notice that it sets the line up here, and this is my current spend here, right? And so back to anomaly detection, this is a lot smarter. So the idea is that if something is outside this band of a certain amounts, then it would alert, okay? But I'm gonna go back here. I'm just gonna set this to $50. And that looks okay to me. You can change the period. 6 hours is fine. And there's additional configuration. That's fine as well. We're going to go ahead and hit next. And so the idea is that, if it passes that red line, it will go to an in alarm state. And then what it will do is we want to have it to trigger an SNS topic. So I would generally just create a new one here. We'll just say my billing alarm. Okay, and then here we'll just set the email, andrewexampro.co, and we'll go ahead and create that topic. And so that is now set. I don't know if it would confirm it. We might have to go to our email to confirm it. So notice it says pending confirmation. So what it has done is it sent me out an email, and it wants me to click that link to confirm that I want to subscribe to it. So I might just do that off screen to show you here, okay? So I'm just going to pull up my email here. Just give me a moment. Okay, and so if I come back here, this is the email that came in. So I'm just going to confirm that subscription. It says I'm confirmed, good. And if I refresh this page, we can now see that that is confirmed, all right? So we'll scroll down here. So we can trigger an auto scaling action. So maybe, if you have too many servers, you say, hey, the cost is too much. Shut down those servers. There's EC2 actions, things like that. So these are kind of similar to budgets, right? There's system manager actions. I imagine all these things are available in budgets as well, but budgets just makes it a little bit easier to look at. So I'm going to just say my simple billing alarm here. We'll hit next. All right. We'll hit create alarm. And there you go. So billing alarms don't have like forecasting and things like that. But they do have their own kind of special utility, and so I utilize both, okay? So there we go. We'll just go back to our management console and move on to the next one. So one of the strongest recommendations that AWS gives you is to set MFA on your AWS root user account. So that's something we're going to do right now. So make sure you're logged into the root user account. So I'm going to go log out as my IAM user. I'm going to go back and log in, and I'm going to log in as my root user here. So to do that, notice sometimes it will be expanded as the IAM user. Click and sign into root user here. We'll have root user. I'm going to go ahead and enter my email that I used. And if you do switch accounts frequently, they will ask you these silly CAPTCHAs, which drive me crazy, but it happens. You probably won't encounter it as much as I do. And so I'm going to go ahead and grab my password here and paste it on in. And so now that I'm in, what I want to do is make my way over to IAM. And I'm going to go and look for users. Actually, sorry, just right here. Add an MFA root user. We're going to go ahead and hit add MFA. All right, and so that's going to bring us to this screen. And so here we can activate our MFA. And so we have a few options here. So we have virtual MFA device, U2F security key, other hardware like a Gemalto token. So, I generally use this because I have a security key, and I want to show you what I'm talking about. So this is how I log into my machine or my AWS account. This is a security key, an UBI key that sits on my desk. I tape it so it doesn't fall off the cord. But the idea is that when I log in, I have to press this little button here to double confirm before I get into my account. But if you don't have a security key, you can just use a virtual MFA. And all that means is you're going to use something on your phone to log in. So we'll click continue here. And so it says install a compatible app on your mobile phone or device. And so if you click and open this, what it will do is tell you about some things that you can use. So if we scroll down to virtual, here they suggest if you have Android, iPhone, so Authy, Dual Mobile, LastPath, Microsoft Authenticator, Google Authenticator. So Google Authenticator, Microsoft Authenticator, and Authy, I have all those three installed. Honestly, Authy has the nicest, simplest UI, but I'm using Microsoft Authenticator quite a bit. So anyway, whichever you want to do, it's fine. But what we'll have to do is go back here, and then it says use your virtual MFA app on your device camera to scan your QR code. So once you have one of those apps installed, like Authy or whatever one you want, what you're going to do is open up the application, and I can't tell you exactly where it is, but you'll have to hit add account in your app. And then from there, it will ask you to scan your QR code. And so once you're ready, you hit show the QR code. You hit scan the QR code on your phone. I'm holding my phone up to my computer screen here, and it's going to find it. And I'm just going to take a moment here to rename the account so I can tell what it is. So I'm just naming it AWS Sandbox because that's what I call this account. And I'm going to go ahead and save that. And so now what I can do is enter 2 consecutive MFA codes. Now this always confused me what they wanted here, but the idea is that you're going to see one code, right? Whatever's on the screen right now. So I'm going to type in it says 734051, and I'm going to wait until the new code shows up. So there's like a timer in all these apps, and they go across the screen or they count down, and so you have to wait for that to happen. And so I'm just going to wait here a little bit. And once I get the new number here, this one is 071530. I'm going to hit assign MFA. And there we go. And I can't tell you how many times I messed that up because I didn't understand the consecutive numbers. But you're just waiting for the number that's on the screen to enter it in, and then enter the next one in to turn on MFA. And so now your account is protected, and every time you log in, you're going to have to enter in MFA. So let's log out and see what that looks like. So we'll go ahead and sign in. And again, we'll put in our root user account here. We'll type in 74M32T, submit. And I need to go grab my password. So that's in my password manager. So just give me a moment here. And now it wants the MFA code. So this is in my phone. And so I'm going to go enter it in. So this one says 475841. All right, we'll hit submit. Okay, and there we go. So that's going to happen every single time we want to log in. I'm going to tell you that if you get one of these, they're so much easier to use because you just press the button. Okay, so that's why I have this, because I cannot stand entering the code in time and time again. But you know, those are your options there. Okay. Hey, this is Andrew Brown from ExamPro, and we're looking at the concept of innovation waves. So when we're talking about innovation waves, we're talking about Kondratiev or K waves, which are hypothesized cycle-like phenomena in the global world economy. And the phenomenon is closely connected with technology life cycles. So here is an example where each wave is irreversibly changes the society on a global scale. And if you look across the top, we can kind of see what they're talking about. So we have steam engine cotton, railway and steel, electric engineering chemistry, petrochemicals, automobiles, information technology. And so the idea is that cloud technology is the latest wave. And I'm not sure if you'd fit Web3 in there as well, ML, AI, but maybe they're all part of the same wave or they're separate waves. But generally, they're broken up based on this PRDE here, where it says perspective, recession, depression, and improvement. And so this is the common pattern of wave where we see a change of supply and demand. And so if we're seeing this, we know that we are in a wave and where we are in a wave, okay? Hey, Hey, this is Andrew Brown from ExamPro, and we are looking at the concept of a burning platform. So a burning platform is a term used when a company abandons old technology for new technology with the uncertainty of success and can be motivated by fear that the organization's future survival hinges on digital transformation. And just to kind of give you a visualization, here is a literal burning platform. So imagine you have to jump from it to make a change. So, burning platform could be, stop using on-prem and start using cloud, or maybe it going from cloud to Web3. And that's generally the idea when we talk about a burning platform. So I just want to quickly show you that digital transformation checklist that I mentioned. And the way you can get to it is by typing in digital transformation, AWS. And so it should bring you to the public sector page. And here it is. So we click there, and all it is a PDF. So it's not new, it's from 2017, but that doesn't mean that it's not valid anymore. It's just that that's when it was made. So we scroll on down and we can see transforming vision. And so we have a checklist there. So if we click into this, we can see things like communicate a vision of what success looks like, define a clear governance strategy, including the framework of achieving goals, build a cross-functional team, identify technical partners, to talk about shifting the culture. And then down below, I assume that this one is related to that one. It's unusual because, they just have a checklist here, but then they have a sub-checklist, which must be clear to that. So reorganize staff into smaller teams, things like that. So it's not super complicated. You'll see each category go cloud native. They'll have a checklist, and if you are at the executive level or the sales level or trying to convince your VPs or stuff like that, give this a read. It might give you something useful in the end. To help better communicate that transformation for you, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at the evolution of computing power. So what is computing power? It's the throughput measured at which a computer can complete computational tasks. And so what we're pretty much used to as of these days is general computing. So a good example here would be a Xeon CPU processor. That's more of a high-end processor, not something you'd find in your home computer. But when we're talking about data centers, specifically, AWS data centers, Xeon CPU processors are what you're going to come across. Then came along a new type of compute, which is GPU computing. When we're talking about Google Cloud, they have tensor computing. And so this is where I get the 50 times faster based on that metric. And so I didn't have an exact metric here for AWS solution for this mid-tier of computing power. So I just borrowed that 50 times there. But the idea is that GPU computing or tensor computing is 50 times faster than traditional CPU. And generally that's going to be used for very specialized tasks when you're doing machine learning or AI. So it's not something you're going to be doing for your regular web workloads. But just understand that all of these fit. So we're not getting rid of general computing. We're just adding new levels of compute. Then there's the latest, which is quantum computing. And so here we have an example of the Rigetti 16Q Aspen 4. And so it literally looks like it's out of science fiction. And this thing is like 100 million times faster. It is super cutting edge, and we don't even know exactly how it works. And there's not even anything that's very applicable that we can use this for. But the idea is that we're not done with the evolution of computing power. Things are going to get a lot faster once we solve this last one here. And so AWS service offering here would be for general computing. You're looking at Elastic Compute Cloud, EC2. So we have a variety of different instance types, and they're all going to have different types of hardware with different types of general computing. For GPU computing, this is a specialized chip that AWS has produced called the AWS, and I don't know how to say it, but we'll just abbreviate it to Infer, so AWS Infer chip. And this was designed as a direct competitor to GCP's tensor computing unit, the TPU. And so this is intended for AI ML workloads, but it works with not just TensorFlow, but it works with any machine learning framework. So that is one advantage it has over TPUs. And then the last one here is AWS Brackets. So you can actually use quantum computing as a service on AWS as of even today. The way AWS is able to do this is they work with Caltech. So that's the California Technology University or Institute. I'm not sure the name of it there. So it's not exactly AWS producing this, but AWS is doing this as a partnership to give quantum computing accessible to you, okay? So I'm here in the AWS console because I just want to prove to you that you can use quantum computing on AWS. It's that accessible. So all you'd have to do is go to the top here, type in bracket, and then you make it over to Amazon bracket. And so here you can like set up quantum tasks. The first time you set it up, you got to go through this process here. I think I have to go through this onboarding to be able to show you the next step. So I'm going to go ahead and enable bracket in this AWS account. Okay. And I'm not going to launch anything. I'm just going to try to just kind of show you a little bit of what is accessible to you, because it's not super exciting, but the fact that you can do it is kind of interesting. So here I am on the inside here, and we have all these different types of quantum computing. So D-Wave, IONQ, Rigetti, things like that. And then down below, these are the quantum processing units, the QPUs. And then down below, you have the simulators, so you can kind of simulate these things here. So I think that's kind of interesting. But in terms of the cost, like if you scroll on down here, so AWS Bracket is part of the AWS free tier. It gives you 1 free hour of quantum circuit simulation time per month during the first 12 months. So it's free to do a circuit simulation. But if you actually want to run it on the actual hardware, you can see the cost. There's the per task price, the per shot price, things like that. What could you do with this? I don't know. There's things called like quad bits or something like that. And I can't imagine that you're going to be doing anything useful, but I think it's just more so like you are sending out quad bits or whatever they are and you're observing them. But what you could do with them, I have no idea, but it's just exciting that you can do that. I didn't have any spend just by activating that. I'm just kind of just showing you there, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at the benefits of cloud. And this is a summary of reasons why an organization would consider adopting or migrating to utilizing public cloud. And so we'll quickly go through the list here because in the follow-up slides, we actually go into them a bit more detailed. So we have agility, pay-as-you-go, economy of scale, global reach, security, reliability, high availability, scalability, and elasticity. So the thing is that AWS had this before. It was called the 6 advantages of cloud, but they have reworked it to include additional items. And so where you see these sub bullets here, those are the original 6, as you see, 1, 2, 3, 4, 5, 6. And so I kind of just put them where they kind of fall under the new categories there. And you'll notice that AWS has included high availability, elasticity, reliability, and security as new ones here, okay? And so the thing is that I have always, even in my original, I think in my original cloud practitioner, had cloud architecture as a separate section and included all these things in here. So it's a great thing to see that AWS has included it. But in terms of how I organize this course, we're not going to cover them in this section because I have the cloud architecture sections, so just understand that we will come to those eventually. And I would just say that AWS is still missing something on this list, which is fault tolerance. So, you know, my list looks like this, except I would add fault tolerance to it, so you have everything there, and disaster recovery, okay? So the benefits of cloud is a reworking expansion of the 6 advantages of the cloud, and we will look at the original 6 advantages and then look at another one that is more of a generalized one that I've used across my courses so that we fully understand the benefits, okay? All right, let's take a look here at the 6 advantages to cloud defined by AWS. And so these are still part of AWS's marketing pages, but you know, it's interesting because you can't find the benefits of the cloud in a single page on AWS, at least at the time of making this. So there's a bit of disconnect between the exam guide and the actual marketing material, but that's okay. I fill it all in for you. So, you know, I'm just again noting that the 6 advantages of cloud was the original description for cloud benefits, and we'll go through them, okay? So the first is trade capital expense for variable expense. So you can pay on demand, meaning that there is no upfront cost, and you pay for only what you consume, or you pay by the hour, minutes, or seconds. So instead of paying for upfront costs of data centers and servers. The next is benefit from massive economies of scale. So you are sharing the cost with other customers to get unbeatable savings, hundreds of thousands of customers utilizing a fraction of a server. Stop guessing capacity, so scale up or down to meet the current needs. launch and destroy services whenever. So instead of paying for idle or underutilized servers, we have increased speed and agility. So launch resources within a few clicks and minutes instead of waiting days or weeks of your IT to implement the solution on premise. We have stopped spending money on running and maintaining data centers. So focus on your customers developing and configuring applications. So instead of operations such as racking, stacking, and powering servers. The last is go global in minutes. So deploy your app in multiple regions around the world with a few clicks, provide low latency and a better experience for your customers at minimal cost. The 6 advantages of cloud still apply, and I like to include them here because they just have a different kind of lens or angle when you're looking at this stuff. And so we've looked at the 6 advantages of cloud, and now let's take a look at the next slide, my reworking of the 6 advantages of cloud to be more generalized, okay? All right, I just wanted to show you where that 6 advantages of cloud computing comes from. It's part of the AWS documentation, so I typed it in here, and you can see that it is still around. And so it's unusual because this used to be part of the marketing website. It had those nice little graphics, but for whatever reason, it's over here now in the overview of Amazon Web Services. And by the way, if you're starting out with AWS, this is a very light read, but it is a good read to get started with. We obviously cover all this stuff in the course, but maybe you'll get something different here. But the idea is that AWS has definitely expanded on this, but for whatever reason, this documentation hasn't changed. So just understand that I've polyfilled that for you in this course, okay? All right, so this is the 7 advantages to cloud. I said 6, but I meant to say 7. And so, since I've created fundamental courses for all the cloud service providers, I started to notice kind of a trend. And so what I did is I normalized it into my own 7 advantages. And this actually maps up really well to the new benefits of the cloud. So it looks like AWS was thinking the same as I was, with the exception of those cloud architect stuff, which I keep in a separate section. But let's go through it and see what is here. So the first is cost effective. You pay for what you consume, no upfront costs, on-demand pricing, so pay as you go, PAYG, with thousands of customers sharing the cost of resources. AWS used to refer to this always as on-demand pricing, and Azure always said pay as you go. And so it looks like AWS now uses both on-demand and pay as you go to describe them, which is great. But there you go. Then we have global. So launch workloads anywhere in the world, just choose a region. It's secure. So cloud provider takes care of physical security. Cloud services can be secure by default, or you have the ability to configure access down to a granular level. It's reliable. So data backup, disaster recovery, data replication, fault tolerance. It's scalable, increase or decrease resources and services based on demand. Elastic, so automate scaling during spikes and drop in demand. Current, so the underlying hardware and managed software is patched, upgraded, and replaced by the cloud provider without interruption to you. So I think this is one that isn't on the benefits of the cloud, which is a really good one. Yeah, that's the 7. Hey, this is Andrew Brown, and we're taking a look at AWS Global Infrastructure. So what is it? Well, the AWS Global Infrastructure is a globally distributed hardware and data centers that are physically networked together to act as one large resource for the end customers. So what does that mean? Well, if you look at the globe on the right-hand side, and that globe is really cool because AWS used to have a website where you could see a 3D globe and see where all their resources are. For whatever reason, they took it down, but I still have the screenshot of it. But the idea is that the global infrastructure represents all that hardware and the connectivity between that hardware around the world. So what kind of resources are we talking about? We're talking about regions. We're talking about availability zones, direct connections, POPs, also known as point of presence, local zones, wavelength zones. And we should point out that AWS has millions of active users or customers and tens of thousands of partners globally. So they really are kind of everywhere. And if you're wondering, well, what are all these resources? That's what we're going to get into next. We're going to break down what all these particular resources are, because you definitely need to know what they are. But hopefully that gives you at a high level that AWS has this thing called global infrastructure, okay? Hey, this is Andrew Brown, and we are on the marketing website for AWS under Global Infrastructure. And this is a great way if you want to explore more and make sense of that global infrastructure. So if we scroll on down here, we have a nice map, and it's kind of indicating as to where those regions are. Notice that there is ones in red, which are coming soon. The Canada West, they've been talking about that for, I think, a couple of years now. So still waiting for those, but just like every cloud service provider, they're always expanding. Looks like we can get a full list here. And it should indicate where, when they launched, and if they're launching more things. So, that is a nice little list that we can get access to. But if we go all the way to the top, across the top, we can go to regions and AZs. And this is where we should get better information. This is definitely different from before. And I don't think the top of Canada is supposed to look like that, but I guess it's the best that they can do. So what I want to point out on these pages is the terms of the number of resources. So I'm just going to bump up the font because it's a little bit small even for me. If we go on down below here, you can see that it's describing, let's say, a particular region. So here in Canada, we can see we have 3 availability zones and when it launched. Sometimes they have these asterisks on here. So it says located in the Montreal metropolitan area. So that's a good indicator because central Canada could mean Toronto, could mean Winnipeg. So that's why they put the asterisks on there. But just notice that what you'll usually see for availability zones, you'll never see anything beyond 6. I'm not sure why, but that seems to be the max. Usually when a region launches, it should have 3 availability zones. I think in the past, there might have been some that did not have at least 3. And the reason why it's important to have 3 in a zone is that is how we get high availability. The way you do that is you should have, let's say we're talking about compute. That compute should be running redundantly in 2 other data centers in your region to ensure that you have uptime in case the other 2 go out. So just make note of that. If you're coming from Azure, Azure will launch things without having all of their zones. GCP is really good where they'll always at least have 3. So each provider works a little bit differently there. But yeah, you can see here for North America, we just scroll through here, you can find your particular area and look at the map and wonder why it's so distorted. But yeah, hopefully that gives you kind of an idea there. And if you want to explore any of these other particular offerings, you absolutely can. Of course, we do cover in the course, so it's not really necessary to do that. But I thought it'd be nice to show you this page, okay? Ciao. Hey, this is Andrew Brown from ExamPro, and we are taking a look at AWS regions. And regions are geographically distinct locations consisting of 1 or more availability zone. And so here is a world map showing you all the regions that AWS has in the world. And the blue ones represent regions that are already available to you. And the orange ones represent ones that AWS is planning to open. So AWS is always expanding their infrastructure in the world. So always expect there to be more upcoming ones. Every region is physically isolated from and independent of every other region in terms of location, power, and water supply. And the most important region that you should give attention to is US East 1 in particular. So this is Northern Virginia. It was AWS's first region where we saw the launch of SQS and S3. And there are a lot of special use cases where things only work in US East 1. And we'll find that out here in a moment. What I do want to show you is what it looks like for an architectural diagram when you are seeing a region. So notice that we have this little flag here. It says US East 1, US West 1, and inside of it we have an EC2 instance. So that is going to represent a region in our architectural diagrams. But let's look at some of the facts here and understand why US East or US East 1 is so important. So each region generally has 3 availability zones, and that is by intention, and we will talk about that when we get to the availability zone section. Some new users are limited to 2 or to 2. But generally there's always 3, okay? New services almost always become available first in US East and specifically US East 1. Not all services are available in all regions. All your billing information appears in US East 1, so that's a US East 1 particular thing. The cost of AWS services vary per region. And so if you were on the marketing website or for AWS Global Infrastructure, you can see here in North America, they'll say like when it launched, how many availability zones, and there might be some conditions. So you'll notice there's like asterisks beside these things here. Or in this one in particular, there's an asterisk saying, hey, there are 3 zones, but generally you're limited to 2, okay? When you choose a region, there are 4 factors you need to consider. What are the regulatory compliance does this region meet? What is the cost of this AWS service in this region? What AWS services are available in this region? And what is the distance or latency to my end users? And those are those 4 factors that you should remember, okay? right, so we just talked about AWS regions. Now let's talk about how that affects our services versus regional and global services. So regional services are scoped based on what is set in the AWS Management Console on the selected region. So you have this drop down, and that's what you'll do. You'll say, okay, I want to have resources in Canada or in Europe. So this will determine where an AWS service will be launched and what will be seen within the AWS Services console. You generally don't explicitly set the region for a service at the time of creation. I explicitly mention this because when you use something like GCP or Azure, when you create the resource, that's when you select the region, but AWS it has this kind of global thing which is unique to their platform. Then there's the concept of global services. So some AWS services operate across multiple regions, and the region will be fixed to the word global. And for these, that's services like S3, CloudFront, Route 53, IAM. So the idea is if you were to go over to CloudFront and go into the CloudFront console, you'll notice that it will just say global, and you can't switch out of that. For these global services, at the time of creation, it's a bit different. So we were saying up here for regional ones that you don't select the region. But when you are creating global services, if you're using something like IAM, there is no concept of region because they're just globally available. So you don't have to determine a subset of regions. If you're using S3 bucket, that has to be in one region. So you actually do have to select a region at time of creation. And then there's something like CloudFront distributions where you are choosing a group of regions. So you either say all of the world or only North America, which is more like geographic distribution. So you don't say the region in particular, but hopefully that gives you a distinction between regional services and global services. Hey, this is Andrew Brown from ExamPro, and we are taking a look at availability zones. So availability zones, commonly abbreviated as AZ, and I'll frequently be using the term AZ, is physical locations made up of one or more data centers. So a data center is a secured building that contains hundreds or thousands of computers. And this is one of my favorite graphics I like to show. Of course, AWS would never have a dog in their data center, but I just thought that would be fun. A region will generally contain 3 availability zones. And I say generally because there are some cases where we will see less than 3, so there might be 2. Data centers within a region will be isolate from each other, so there will be in different buildings, but they will be close enough to provide low latency, and that is within the 10 milliseconds or less, so it's very, very low. It's common practice to run workloads in at least 3 AZs to ensure services remain available in case 1 or 2 data centers fail, and this is known as high availability, and this generally is driven based on regulatory compliance. So a lot of companies, they have to at least be running in 3 AZs, and that's why AWS tries to always have at least 3 AZs within a region. AZs are represented by a region code followed by a letter. So here, you'd have US East 1, which would be the region, and then the A would represent the particular availability zone in that region. So a subnet, which is related to availability zones, is associated with 2 availability zones. So you never choose an AZ when launching resources. You always choose a subnet, which is then associated to an AZ. A lot of services, don't even require you to choose a subnet because they're fully managed by AWS. But in the case of like virtual machines, you're always choosing a subnet, okay? So here is a graphical representation or a diagram that's representing 2 availability zones. So here we have the region US East 1 and US West 2, and then we have our 2 AZs. So here is 1A and 1B. And so these are effectively the subnets, okay? And so within those subnets, then you can see, or availability zones, you will see that we have 2 virtual machines, okay? So the US East 1 region has 6 AZs, and I thought that's just kind of like a fun fact because it is the most out of every single one. I don't think anyone comes close to US East 1, but of course it is the most popular. It is the first region, or so it's not a surprise that that one has that many, eh? Okay, so we just covered regions and availability zones, but I really want to make it clear what they look like, so I kind of have a visual representation. So let's say we have our AWS region, and in this particular one, we have Canada Central, which in particular is Montreal, so CA Central 1. And the idea here is that a region has multiple availability zones. So here you can see that we have 1A, 1B, and 1D. For some reason, AWS decided to not launch 1C. Maybe it's haunted. Who knows, And then within your availability zones, they are made up of one or more data centers. So just understand that an AZ is not a single data center, but could be a collection of buildings. And that these AZs are interconnected with high bandwidth, low latency networking. They're fully redundant, dedicated to metro fiber, providing high throughput, low latency networking between. So just very fast connections in between. And all traffic between AZs is encrypted. And these AZs are within 100 kilometers, so about 60 miles of each other, okay? So what I want to do here is just show you how regions and availability zones work with some different AWS services, so you have a general idea when you are selecting a region or AZ and when you're not. So within AWS, when you want to select a region, you're going to go up here and change it, and this is going to apply to regional services. A very famous example of a regional service would be EC2. So we go over to EC2, which is Elastic Cloud Computing or Compute, whatever. I always forget the name of it. And what we can do is go over to instances. I'm going to launch an instance. I'm not going to complete the process. I just want to show you what would happen when you go select some things here. So I'm going to go with Amazon Linux 2. We're going to just go to next here. And so here is where we're going to select our availability zone. So up here we have North Virginia, that's our region. And when I say we're selecting our availability zone, we're actually selecting the subnet. So here we are choosing a subnet, and a subnet is associated to a availability zone. And every single region has a default VPC, and that VPC has subnets set up, and the subnets are defaulted to each of the availability zones available. So US East 1 has 6 of them. So this server is going to launch in US East 1B. So this is a regional service, okay? Then we have global services like S3. So we go over to S3, and it says it's global, right? And so we're going to go ahead and create our bucket. And so here we choose the region. So we go down, we're going to say the region we want to be in, but we don't choose the availability zone because there's nothing to choose, because AWS is going to run these in multiple AZs, and it doesn't matter to you what it's doing there, okay? So there's that. And then there's something like CloudFront. So CloudFront's a little bit different here. So we go over to CloudFront, and we create ourselves a distribution. And so, yeah, if you don't have that option there, because sometimes AWS has like a splash screen, just click on the left-hand side, then go to distributions, okay? And so here, well, they changed it again on me. They're always changing this UI, but if we scroll on down, it should allow us to change where this is going to launch. It's like global and stuff like that. Literally, they just recently changed this, and that's why I'm confused. We'll scroll on down here. It used to be, maybe it's under legacy, additional, customized. Oh, it's here, sorry. Okay, so notice here the price class that says use the edge locations for best performance, North America and Europe, North America, Europe, Asia, Middle East, and Africa. So we're not choosing a particular region, we're picking a geographical area. And so those are pretty much the major examples of that. Then there's, of course, things like in IAM where you don't even say where it is. So you go into IAM, you know, and if I create something like a group over here, a user group, whoops, here, I say create group. You know, I'm not saying, oh, this is for this particular region or something like that, okay? So yeah, hopefully that makes sense. Hey, this is Andrew Brown from ExamPro, and let's take a look here at fault tolerance specifically for global infrastructure. And so before we jump into that, let's just define some fault terminology here. So let's describe what a fault domain is. So a fault domain is a section of a network that is vulnerable to damage if a critical device or system fails. And the purpose of a fault domain is that if a failure occurs, it will not cascade outside that domain, limiting the possible damage. And so there's this very popular meme called "This is fine," where there's obviously a serious problem, but the person's not freaking out. And I gave it some context to say, well, the reason they're not freaking out because they know that it is a fault domain and nothing outside of this room is going to be affected, okay? So you can have fault domains nested inside of other fault domains, but generally they're grouped in something called fault levels. So a fault level is a collection of fault domains. And the scoping of a fault domain could be something like a specific servers in a rack, an entire rack in a data center, an entire room in a data center, the entire data center building. And it's really up to the cloud service provider to define those boundaries of a domain. AWS abstracts it all away, so you don't have to think about it. But just to compare it against something else, when you're using Azure, you actually define your fault domains. So you might say like, okay, make sure that this workload is never running on the same VM on the same rack for these things. And you might like to have that level of control, but I really like the fact that AWS just abstracts it away. I'm not sure how they segment their fault domains, but they definitely are some broader ones, which we'll describe right now. So when we're looking at an AWS region, this would be considered a fault level, and then within that fault level, you would have your availability zones, and these would be considered fault domains. And of course, those data centers can have fault domains within them. Okay, like maybe they have everything in a particular room, and that room is secure. So like if there's a fire in that room, it's not going to affect the other room. Things like that. So each Amazon region is designed to be completely isolated from the other Amazon region. They achieve this with the greatest possible fault tolerance and stability. Each availability zone is also isolated, but the availability zone in a region are connected through low latency links. Each availability zone is designed as an independent failure zone. And so here we have some kind of different language that AWS is using. I've never experienced this terminology in any other cloud service providers, so I kind of feel like it's something that AWS made up. But basically a failure zone, they're just basically saying a fault domain. But let's kind of expand on their failure zone terminology. So availability zones are physically separated within a typical metropolitan region and are located in lower risk floodplains. Discrete uninterruptible power supply, so UPS, and an on-site backup generation facilities. Data centers located in different AZs are designed to be supplied by independent substations to reduce the risk of an event on the power grid impacting more than one availability zone. Availability zones are all redundantly connected to multiple tier 1 transit providers, and we'll talk about what those are in an upcoming slide. And just one thing I want to note here is that when you adopt multi-AZ, you get high availability. So if an application is partitioned across AZs, companies are better isolated and protected from issues such as power outages, lightning strikes, tornadoes, earthquakes, and more. So that's the idea behind, why we want to run in multi-AZ, okay? Because of these fault domains. Hey, this is Andrew Brown from ExamPro, and we're talking about the AWS Global Network. So the Global Network represents interconnections between AWS Global Infrastructure, and it's commonly referred to as the backbone of AWS. So is EC2, so just understand that that could be used in more than one way. But think of it as a private expressway where things can move fast between data centers. And one thing that is utilized a lot to get data in and out of AWS very quickly is edge locations. They can act as on and off ramps to the AWS Global Network. Of course, you can get to the network through POPs, which we'll talk about in the upcoming slides here. But let's just talk about edge locations and what services use them. So when we're talking about things that are getting on to the AWS network, we're looking at things like AWS Global Accelerator, AWS S3 Transfer Acceleration. And so these use edge locations as an on-ramp to quickly reach AWS resources in other regions by traversing the fast AWS Global Network. Notice that the names in it say accelerator, acceleration. So the idea is that they are moving really fast, okay? On the other side, when we talk about like an off-ramp, we're looking at Amazon CloudFront, which is a content distribution network. This uses edge locations as an off-ramp to provide at the edge storage and compute near the end user. And one other thing that is kind of always utilized in the global network are VPC endpoints. Now, these aren't using edge locations, but the idea here is that this ensures your resources stay within the AWS network and do not traverse over the public internet. So, if you have, a resource running in US East 1 and one in EU, they never have to go to the internet, it would make sense to always enforce it to stay within the AWS network because it's going to be a lot faster. So there you go. Hey, this is Andrew Brown from ExamPro, and we are taking a look at point of presence, also known as POP, and this is an intermediate location between an AWS region and the end user, and this location could be a data center or a collection of hardware. So for AWS, a point of presence is a data center owned by AWS or a trusted partner that is utilized by AWS services related for content delivery or expedited upload. So a POP resource could be something like an edge location or a regional edge cache. So as an example over here, we see an S3 bucket, and it has to go through a regional edge cache and then get to an edge location. Let's go define what those are. So an edge location are data centers that hold cached copies on the most popular files, so web pages, images, and videos, so that the delivery of the distance to the end users are reduced. Then you have regional edge locations, and these are data centers that hold much larger caches of less popular files to reduce a full round trip and also to reduce the cost of transfer fees. So to kind of help put POPs more in presence, just in the general sense, here is a diagram I got from Wikipedia that kind of just shows a bunch of different networks. And notice where the POP is. It's on the edge or the intersection of two networks. So here, we have, tier 3, and then there's tier 2, and there's this POP that is in between them, okay? So tier 1 networks is a network that can reach every other network on the internet without purchasing IP transit or paying for peering. And so the AWS availability zones, or AZs, are all redundantly connected to multiple tier 1 transit providers, okay? All right, so let's take a look at some AWS services that are utilizing POPs or edge locations for content delivery or expedited upload. So Amazon CloudFront is a content delivery network service, and the idea here is you point your website to CloudFront so that it will route requests to the nearest edge location cache. It's going to allow you to choose an origin, so that could be a web server or storage. That will be the source of the cache, and caches the content of what origin would return to various edge locations around the world. Then you have Amazon S3 Transfer Acceleration. This allows you to generate a special URL that can be used by the end users to upload files to a nearby edge location. Once a file is uploaded to an edge location, it can move much faster within the AWS network to reach S3. Then at the end here, you have AWS Global Accelerator. You can find the optimal path from the end user to your web servers. So global accelerators are deployed within edge locations, so you send user traffic to an edge location instead of directly to your web application. This service is really, really great for if, let's say, you're running a web server in US East 1, and you just don't have the time to set up infrastructure in other regions. You turn this on and you basically get a boost, okay? Hey, this is Andrew Brown from ExamPro, and let's take a look at AWS Direct Connect. So this is a private or dedicated connection between your data center, office, co-location, and AWS. And so the idea here is imagine if you had a fiber optic cable running from your data center all the way to your AWS, so that it feels like when you're using your stuff on your data center, like your local virtual machines, that there's like next to no latency, okay? So Direct Connect has two very fast network connection options. We have the lower bandwidth, which is at 50 to 500 megabytes per second. And then you have the higher bandwidth, which is 1 gigabytes to 10 gigabytes per second. So using Direct Connect helps reduce network costs, increase bandwidth throughput, so great for high traffic networks. It provides a more consistent network experience than a typical internet-based connection, so reliable and secure. I do want to point out the term co-location, if you've never heard of that before. A co-location or a carrier hotel is a data center where equipment, space, and bandwidth are available for rental to retail customers. And I do want to also point out that even though it says private up here, and this is the language that AWS used, I usually just say dedicated, but the connection is private, but that doesn't necessarily mean it's secure, okay? So we'll talk about that when we reach AWS VPNs and how we can use that with Direct Connect to make sure our connections are secure, okay? All right, so let's take a look at what a Direct Connect location is. So a Direct Connect location are trusted partner data centers that you can establish a dedicated high-speed, low-latency connection from your on-premise to AWS. So an example of a partner data center would be one like here in Toronto, the Allied Data Center. So you can tell that's right down in the Toronto Center. And so you would use this as part of Direct Connect service to order and establish a connection, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at local zones, which are data centers located very close to densely populated areas to provide single-digit millisecond low-latency performance, so things like 7 milliseconds for that area. So here is a map of local zones that exist and ones that are coming out. I believe the orange ones are probably ones that are on their way. And so to use a local zone, you do need to opt in, so you got to go talk to AWS, probably open a support ticket to get access to it. The first one to ever be launched was the LA one, and so when you want to see it, it looks just like an availability zone. It's going to show up under whatever region that is, because these are always tied to existing regions. So the LA one is tied to US West region, and the AZ would look like US West 2-LAX-1A, okay? So only specific AWS services have been made available. So there's particular EC2 types, EBS, Amazon FSx, Application Load Balancer, Amazon VPC. They probably have extended it to more services. Do you need to know that for the exam? No, but the point is that there's a limited subset of things that are available. The purpose of local zone is to support highly demanding applications sensitive to latency, so media and entertainment, electronic design and automation, ad tech, machine learning. So it kind of makes sense. Like when you look at LA, they're in the media entertainment, and so they're dealing with lots of media content, so it has to be really low for them, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at AWS wavelength zones, and these allow for edge computing on the 5G networks, and applications will have ultra low latency being as close as possible to the users. So AWS has partnered with various telecom companies to utilize their 5G networks. So we're looking at Verizon, Vodafone, KDDI, SK Telecom. And so the idea here is that you will create a subnet tied to a wavelength zone, and just think of it as like an availability zone, but it's a wavelength zone. And then you can launch your VMs to the edge of the targeted 5G network. So that's the network. You're using AWS to deploy an EC2 instance, and then when users connect to those radio towers, the cell towers, they're going to be routed to nearby hardware that is running those virtual machines. Okay, and that's all it is. It's just EC2 instances, but the advantage here is that it's like super low latency. Okay. Hey, this is Andrew Brown from ExamPro, and we are taking a look at data residency. So this is the physical or geographical location of where an organization or cloud resources reside. And then you have the concept of compliance boundaries, so a regulatory compliance, so legal requirement by government or organization that describes where data and cloud resources are allowed to reside. And then you have the idea of data sovereignty. So data sovereignty is the jurisdictional control or legal authority that can be asserted over data because its physical location is within a jurisdictional boundary. And so the reason we care about this stuff is that if we want to work with the Canadian government or the US government, and they're like, hey, you got to make sure that, if you want to work with us, all the data has to stay in Canada, and you need to give them that guarantee. So data residency is not a guarantee. It just says where your data is, right? And compliance boundaries are those controls that are in place to say, okay, this is going to make sure that data stays where we want it to be. And data sovereignty is just like the idea of the scope of the legal stuff that ties in with compliance boundaries. So how do we do that on AWS? Well, there's a few different ways, but let's just take a look at some ways that we can meet those compliance boundaries. One, which is very expensive, but also very cool, is AWS Outposts. So this is a physical rack of servers that you can put in your data center, and you'll know exactly where the data resides because, it's physical. If it's in your data center and you're in Canada, that's where it's going to be, okay? And I believe that, there is only a subset of AWS services that are available here, but, that is one option to you. Another is using services for governance. So one could be AWS Config. This is a policy as a code service. So you can create rules to continuously check AWS resource configuration. So if they deviate from your expectations, you are alerted, or AWS Config can, in some cases, auto-remediate. So if you were expecting, you had an AWS account, and you're saying this account is only to be used for Canada resources, and somebody launches, let's say, something in another region, then you could get an alert or tell AWS Config to go delete that resource, okay? Now, if you want to prevent people from doing it altogether, that's where IAM policies come into play. So these can be written explicitly to deny access to specific AWS regions. And this is great if you're applying it to users or roles, but if you wanted to have it organizational wide across all of your AWS accounts, you can use something called a service control policy. That is just an IAM policy that is used within AWS organizations that makes it organizational wide, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at AWS for government. So to answer that, we first have to understand what is public sector. So public sector includes public goods and government services such as military, law enforcement, infrastructure, public transit, public education, healthcare, and the government itself. So AWS can be utilized by the public sector or organizations developing cloud workloads for the public sector. And AWS achieves this by meeting regulatory compliance programs along with specific governance and security controls. So this could be meeting the requirements with HIPAA, FedRAMP, CJIS, and FIPS. Okay, so AWS has a special regions for US regulation called GovCloud, which we'll talk about next. Okay. Hey, this is Andrew Brown from ExamPro, and we are taking a look at GovCloud. And to understand what GovCloud is, we need to know what FedRAMP is. So FedRAMP stands for Federal Risk and Authorization Management Program. It's a U.S. government-wide program that provides a standardized approach to security, assessment, authorization, continuous monitoring for cloud products and services. So now that we know what FedRAMP is, what is GovCloud? Well, and again, it's not particular to AWS because Azure has GovCloud as well, but a cloud service provider like AWS or Azure generally will offer an isolated region to run FedRAMP workloads. And so in AWS, it's called GovCloud. And these are specialized regions that allow customers to host sensitive, controlled, unclassified information and other types of regulated workloads. So GovCloud regions are only operated by U.S. citizens on U.S. soil. They're only accessible to U.S. entries and root account holders who pass a screening process. Customers can architect secure cloud solutions that comply with FedRAMP, the DOJ's Criminal Justice Information Systems security policy, the U.S. International Traffic in Arms Regulation, Export Administration Regulations, the Department of Defense Cloud Computing Security Requirements and Guides. So if you want to work with the U.S. government, you want to engineer and use GovCloud, okay? Hey, this is Andrew Brown from ExamPro, and we're taking a look at running AWS in China. So AWS China is the AWS cloud offering in mainland China, and AWS China is completely isolate intentionally from AWS Global to meet regulatory compliance for mainland China. So that means that if you make a workload on the AWS Global, you can't interact with it within the AWS China one, okay? It's basically treated like a completely separate service, like AWS has its own Chinese version. And so AWS China is on its own domain at AWS.cn. And for everybody else, that's what's considered AWS Global. So when I'm using AWS from Canada, or use it from the US, or from India, or from Europe, or wherever, that is the AWS Global, okay? So in order to operate in AWS China regions, you need to have a Chinese business license, so ICP license. Not all services are available in China, so you will not have the use of Route 53. And you might say, well, why not just run in Singapore in AWS Global? And you could do that, but the advantage of running in mainland China means that you would not have to traverse the Great Firewall, okay? So all your traffic is already within China, so you don't have to deal with that. AWS has two regions in mainland China. So there's this one here, which is the Northwest region operated by NSWCF. And then you have the one in Beijing, North 1, operated by SynNet. So, you know, AWS just could not meet the compliance requirements, so they had to partner with local providers or data centers, and so that is how that works, okay? All right, so I want to show you how you get over to the Chinese AWS Management Console. So this one is aws.amazon.com. That is the global one for everyone outside of mainland China. But if you want to run resources on data centers within mainland China, this is at amazonaws.cn. And so it looks very similar. If you go to create a free account, you're going to fill in this stuff. But notice that you need to have your business registration certificate and additional information in order to run these data centers down below that AWS is partnered with. Also notice that the logo doesn't say AWS in it. And there's a good reason for that. If I type in AWS trademark China, AWS is actually banned from using the AWS logo in China for whatever reason. It's a weird reason if you ever want to read about it, but that's why you don't see AWS here, all right? So yeah, there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at sustainability for AWS Global Infrastructure. And before we talk about that, let's talk about the Climate Pledge. So Amazon co-founded the Climate Pledge to achieve net zero carbon emissions by 2040 across all of Amazon's businesses, which includes AWS. If y'all want to find out more information, go to sustainability.aboutamazon.com. There's a lot of great information there, and you'll learn exactly how AWS is achieving this, in particular, like their data centers. It's very interesting, okay? So AWS cloud sustainability goals are composed of three parts. The first is renewable energy. So AWS is working towards having their AWS global infrastructure powered by 100% renewable energy by 2025. And AWS purchases and retires environmental attributes to cover the non-renewable energy for AWS global infrastructure. So they would purchase things like renewable energy credits, also known as RECs, guarantees of origin, so GOs. The second point here is cloud efficiency. So AWS infrastructure is 3.6 times more energy efficient than the median of US enterprises data centers surveyed. So that's going to really rely on that survey. Surveys are not always that great, so, take that with a grain of salt, okay? Then we have water stewardship, so direct evaporative technology to cool our data centers, use of non-potable water for cooling purposes, so the recycling water, on-site water treatment allows us to remove, scale-forming minerals and reuse waters for more cycles, water efficiency metrics to determine and monitor optimal water use for each AWS region. And you'll find that water plays a large part on making these data centers very efficient, okay? So I just wanted to show you where you get to that sustainability information. So I just went to AWS Global Infrastructure, you click Sustainability, and that's going to bring us over to, oops, I have my Twitter open there, to the sustainability in the cloud. So if you want to read a bunch of stuff here about things that are going on that AWS is up to, see how they are progressing with renewable energy, there's cloud efficiency up here, so how are they being efficient? It's worth the read to really understand that there's a lot of water involved, like reducing water in data centers. I thought that was really interesting. They have the AWS podcast, but I don't think there's really much to it. A bi-weekly podcast of bite-sized stories about how tech makes the world better. That's not necessarily a sustainability podcast. It's just the AWS podcast in general. There's a download center. Amazon's 2020 sustainability report. So I guess you can download the reports to see what is going on there. So we could download the progress here and see what they've been up to. Okay, so there's a bunch of numbers, things like that. Okay, very short reports, but hey, at least you can download them. Okay, so just in case you're very interested in sustainability, all right? Hey, this is Andrew Brown from ExamPro, and we are taking a look at AWS Ground Station. So this is a fully managed service that lets you control satellite communications, process data, and scale your operations without having to worry about building or managing your own ground station infrastructure. And so when we're talking about Ground Station, a really good way to cement what the service is just think of a big antennae dish that's pointing into the sky, trying to communicate with satellites, because that's essentially what the service is doing. So the use cases here could be for weather forecasting, surface imaging, communications, video broadcasts. And to use Ground Station, the idea is that you would schedule a contact. So that's where you're selecting a satellite, a start and end time, and the ground location. And then you use an AWS Ground Station EC2 AMI and Amazon Machine Image to launch EC2 instances that will uplink and downlink data during the contact or receive downlink data in an Amazon S3 bucket. A use case could be something like you are a company, you've reached an agreement with a satellite image provider to use their satellites to take photos for a specific region or time or whatever. And so the idea is that you are using AWS Ground Station to communicate to that company's satellite and download that image data to your S3 bucket, okay? Hey, this is Andrew Brown, and we are looking at AWS Outposts, and this is a fully managed service that offers the same AWS infrastructure, services, APIs, tools to virtually any data center, co-location space, or on-premise facility for a truly consistent hybrid experience. And just to kind of summarize it, it's a rack of servers running AWS stuff on your physical location, okay? So before we jump into the service or technology itself, let's talk about what is a rack server or just a rack. So it's a frame designed to hold and organize IT equipment. So here's an example of a 4-2U rack. And there's the concept of rack heights. So the U stands for rack units or U spaces, with it equal to 1.75 inches. And the industry standard rack is a 4.8U. So that is a 7-foot rack. So a full size rack cage is commonly the 4-2 high. Okay, and in it you might have equipment that is of different sizes, so there could be 1U, 2U, 3U, or 4U high. So here's an example of, of an interior of a rack, and notice that like 1U, 2U, 4U, they're all a little bit shaped differently, but they give you kind of an idea of, what those are. So AWS Outpost comes in 3 form factors: the 4-2U, the 1U, and the 2U. So the first one here, the 4-2U, this is basically a full rack of servers provided by AWS. So you're not just getting the frame; it actually comes with, servers. And so AWS delivers it to your preferred physical site, fully assembled and ready to be rolled into the final position. It is installed by AWS, and the rack needs to be simply plugged in to the power and network. And there's a lot of details about the specs on this on the AWS website, so I'm not going to go through them all here. Then there are servers that you can just place into your existing racks. So we have the 1U. So this is suitable for 19-inch wide, 24-inch deep cabinets. It's using AWS Graviton 2 CPUs, and you can have up to 64 virtual CPUs. We have 128 gigabytes, 4 terabytes of local NVMe storage, and then you have the 2U. So suitable for 19-inch wide, 36-inch deep, Intel processors up to 128 virtual CPUs, 256 gigabytes of memory, 8 terabytes of local NVMe storage. So there you go. Let's take a look at cloud architecture terminologies. Before we do, let's talk about some of the roles that are around doing cloud architecture. So the first is solutions architect. This is a role in a technical organization that architects a technical solution using multiple systems via researching, documentation, and experimentation. And then you have the cloud architect. This is a solutions architect that is focused solely on architecting technical solutions using cloud services. Understand that in the actual marketplace, a lot of times solutions architect is used to describe both a cloud architect and a solutions architect. And, these are going to highly vary based on your locality and how companies want to use these terms, but this is just me broadly defining them here, so just don't take them as perfect word in terms of what they're representing. So a cloud architect needs to understand the following terms and factors and factor them into their design to architecture based on the business requirements. So we have the idea of availability, your ability to ensure a service remains available; scalability, your ability to grow rapidly or unimpeded; elasticity, your ability to shrink and grow to meet the demand; fault tolerance, your ability to prevent a failure; disaster recovery, your ability to recover from a failure. And there are a couple other things that that should be considered. They're not terminologies, but they're definitely important to a solutions architect or a cloud architect. And these are things you always need to consider as well. And this is just me talking to my solutions architect friends, where they'll always ask me these 2 questions after presentation. They'll say, how secure is the solution, and how much is this going to cost? All right. And so for the terminologies up here, we're going to define these right away, and we're going to figure these out throughout the course. We have 2 giant sections just on cost and security alone. So there we go. The first term we're looking at is high availability, and this is your ability for your service to remain available by ensuring there is no single point of failure and or you ensure a certain level of performance. So the way we're going to do that on AWS is you'd want to run your workload across multiple availability zones to ensure that if 1 or 2 availability zones became unavailable, your service or applications remain available because those other servers are going to be there. And the way we would accomplish that is via Elastic Load Balancer. So a load balancer allows you to evenly distribute traffic to multiple servers in one or more data center. If a data center or server becomes unavailable or unhealthy, the load balancer will route the traffic to only the available data centers within the server. And understand that just because you have additional servers doesn't mean that you're available. You might need to meet a particular threshold of availability. So you might need to have at least 2 servers always running to meet the demand. So it's based on the demand of traffic, okay? Let's take a look here at high scalability. So this is your ability to increase your capacity based on the increasing demand of traffic, memory, and computing power. And we have the terms vertical scaling, so scaling up, This is where you upgrade to a bigger server. And then there's horizontal scaling, scaling out. This is where you add more servers of the same size. And the great thing about scaling out or adding additional servers is that you're also going to get high availability. So if you do need 2 servers, it's always better to add an additional server as opposed to having a larger server. But it's going to be very dependent on a lot of factors, okay? So scalability and elasticity seem very similar, but there is a crucial difference, and this is your ability to automatically increase or decrease your capacity based on the current demand of traffic, memory, and computing power. Again, it's the fact that it happens automatically, and you can go both ways, increase or decrease. So for horizontal scaling, we have the concept of scaling out, so add more servers of the same size, and then scaling in, removing underutilized servers of the same size. And vertical scaling is generally hard for traditional architectures, so you'll usually only see horizontal scaling described with elasticity. And the way we would accomplish being highly elastic is using auto-scaling groups, ASGs, and this is an AWS feature that will automatically add or remove servers based on scaling rules you define based on those metrics, okay? Let's talk about being highly fault tolerant. So this is your ability for your service to ensure there is no single point of failure, preventing the chance of failure. And the way we could do that is with failovers. So this is when you have a plan to shift traffic to a redundant system in case the primary system fails. A very common example is having a copy or secondary of your database where all ongoing changes are synced. The secondary system is not in use until a failover occurs and it becomes the primary database. So when we're talking about databases on AWS, this is the concept of RDS multi-AZ. So this is when you run a duplicate standby database in another availability zone in the case your primary database fails. And last here is high durability. So this is your ability to recover from a disaster and to prevent the loss of data. So solutions that recover a disaster from a disaster is known as disaster recovery. So do you have a backup? How fast can you restore the backup? Does your backup still work? How do you ensure current live data is not corrupt? And so maybe a solution at AWS would be using Cloud Endure, which is a disaster recovery service, which continuously replicates your machines in a low-cost staging area in your target AWS account and preferred region, enabling fast and reliable recovery in the case of an IT data center fails. Okay? So to understand disaster recovery, we need to know more about things around it like business continuity plans, BCPs, and RTOs and RPOs. So a BCP is a document that outlines how a business will continue operating during an unplanned disruption in services. So it's basically the plan that you're going to execute if that happens. And so here we have a disaster, and you can see that there's a chance of data loss and downtime. And these two factors as RPO and RTO are going to define the length of these durations. So recovery point objective is the maximum acceptable amount of data loss after an unplanned data loss incident expressed as amount of time. So how much data are you willing to lose? And then recovery time objective, so the maximum amount of downtime your business can tolerate without incurring a significant financial loss. So how much time you're willing to go down, okay? So those are the two there. And now let's go take a look at the disaster recovery options that we can use to define in our BCP. So now let's take a look at our disaster recovery options. And based on what you choose, they're going to be a trade of cost versus time to recover based on the RPOs or RTOs, of course. And so sometimes this is represented vertically like a thermostat, or you can do it horizontally here. Both are valid ways of displaying this information, but I just have it horizontally here today. And so we have low or high, or you could say, even though I don't have it written here, this could be cold or this could be hot, okay? So on the left-hand side, we got backup and restore, pilot light, warm standby, multi-active site. Notice we're using the words like pilot light, warm, things that are relating to temperature. So again, cold and hot, all right? So let's just walk through what each of these things conceptually do in terms of architecture. So when you're doing a backup and restore, you basically back up your data, and at the time of disaster recovery, you're just going to restore it to new infrastructure. For a pilot light, the data is replicated to another region with the minimal services running to keep on replicating that data. And so you might have some core services running. A warm standby is a scaled down copy of your infrastructure. So you basically have everything that you would absolutely need to run an application, but the idea is it's not at scale. And so at any time when there's an incident, you're going to scale up to the capacity that you need. And then you have multi-site active, where you have a scaled up copy of your infrastructure in another region. So basically everything you have identically in another region. And so in terms of the RPOs and the RTOs, for backup restore, you're looking at hours. With the pilot light, you're looking at 10 minutes. With a warm standby, you're looking at minutes. And multi-site active, you're looking at real time. So, hopefully that gives you an idea of, the difference in terms of scale. But let's just look at more detail. So for a backup and restore, this is for low priority use cases, restore data after event, deploy resources after an event, and it's very cost effective. For Pilot Light, this is where you have less stringent RTOs and RPOs, so that you're going to be just running your core services. You're going to start and scale resources after the event, and this is a little bit more expensive. This is very good for warm standby. Is good for business critical services. So you scale resources after the event, and it's it's costly, but it's not as expensive as a multi-site active. So you get zero downtime, near zero loss. It's great for mission critical services, and it's just as expensive as your original infrastructure. So you're basically doubling the cost there. Okay. So we already defined RTO, but let's redefine it again based on what AWS describes in their white paper, and just look at how it maps against the disaster recovery option. So recovery time objective is the maximum acceptable delay between the interruption of service and restoration of service. This objective determines what is considered an acceptable time window when service is unavailable and is defined by the organization. And so this is the diagram found in the white paper. And so on the left-hand side, we have cost and complexity here, and then lengths of service interruption. And what you can see here is that the cost and complexity for a multi-site active is very high, but the length of service interruption is 0. And then as we go down, we have warm standby. So it's significantly, like at least half the complexity of that one. Then we have our pilot light down here and backup and restore. But notice backup and restore takes the longest amount of time. And notice here we have a recovery time objective. So in your BCP, you kind of define where that is based on the cost of business impact. So you might have to calculate that saying, okay, what is our cost over time based on the length of service interruption? Where do we want our RTO to be? What is the acceptable recovery cost? And this is where you're going to decide what you want to do. So here we have pilot light and backup and restore. And so this company, he has to decide whether they want to do a pilot light or they're going to do a backup and restore. But it sounds like this is where they're going to be, which is at the pilot light for what is acceptable in their business use case. Okay. Well, let's do the same for RPO. So recovery point objective is the maximum acceptable amount of time since the last data recovery point. The objective determines what is considered an acceptable loss of data between the last recovery point and the interruption of service, and is defined by the organization. Again, we pulled this from the AWS white paper for disaster recovery, and we have cost and complexity, but this time it's replaced with data loss before service interruption. So for multi-site, again, it's going to be very expensive and high up here. As you notice, it's not like a perfect curve. It's a bit different in terms of what it looks like. So here we have warm standby, pilot light. And so you'll see that the data loss is not a big deal, but for backup and restore, it really juts out there. So you can see that you can get pretty good results just with the pilot light, and the cost and complexity is very low. Again, we have to look at our cost and business impact. So we got to follow that line, and we need to see where our acceptable recovery cost is. And so you're going to notice that we have a bit of an intersection here. Okay, and so we need to determine, like, are we going to be doing a warm standby? It looks like we have the cost to do it, but, it just really depends, do we want to be down here or down there? Okay, so hopefully that helps them visualize that information for you. Hey, this is Andrew Brown from ExamPro, and what I want to show you here is a real-world architectural diagram. I created this a while ago. This is a previous version of the ExamPro, or technically Teacher Seat platform, that powers the learning experience for my cloud certifications. And so I'm hoping that by giving you some exposure, you'll absorb some information here, and that will carry through to really help you cement what these services do and how they work together. Now, you might be asking, how did I make this? Well, I'm in Adobe XD. It's by Adobe. It's free to download, but there's a lot of options out there. But the first thing you'll need is those AWS architectural icons. So these are free on AWS. You can download them in PowerPoint, download them as assets, as SVGs and PNGs, which is what I have done, and start using them in your whatever software you like. There's also third-party providers out there. So like there's Lucid Charts. I love Lucid Charts, but I don't use it to make architectural diagrams for AWS. But you can drag, drop and stuff, and they already have the library there. And there's a bunch of them that you can choose from. So, that's interesting. But let's take a look at one that we can download. Maybe everyone's familiar with PowerPoint. So here is the AWS architectural icons. And the reason I'm showing you this is not because it just contains icons, but it also suggests how you should build them. So if I go through here, they'll give you a definition of those system elements, how they would look like here. So we have our group icons, our layer group, our service icons, resource icons, where they should go. And then they have some interesting guidelines of like do's and don'ts. So here's like a simple example of a Git to an S3 bucket. Here's an example of using VPC, subnets, and things like that on the inside. And then you can see kind of like all the groups that we have. And it'll show all like the arrows. It's a big faux pas to make diagonal arrows. That's just something that AWS defined, but you'll see a lot of people do them anyway. And then you'll see all the icons. So do you have to make them like AWS suggests? No, but if you like the way they look, that is fine. Everyone just does whatever they want, honestly. So anyway, now that we've seen, how we can go get the resources to make our own, I have Adobe XD open up here. And so I just kind of want to walk you through what's going on here. So again, I said this is a traditional architecture, meaning that it's powered by virtual machines. And so what we need to look for is EC2, because that's where it's going to start. That's our virtual machine. And you'll notice we have one here. So there's a T2 that's running over here. And then over here, we have a T2. Okay, so we have a blue and a green environment. So this is our running environment. So I'm just going to zoom on in here. Okay, so the web app would be running on this. And then on the outside here, we have an auto-scaling group. And so auto-scaling groups allow us to manage a group of EC2 instances, and they will automatically scale if the demand increases or declines. So if this machine can't handle it, it will just automatically provision a new one. And so I've contained it in this environment here because I'm representing a blue-green deploy, meaning that when I deploy, this will be the environment that replaces things. And so you can see I have a lot of lines being drawn around here. So over here, we have parameter store. So parameter store is a place where we can store our environment variables or application configuration variables. And so I have this line going here, and it's just saying we're going to take these environment variables and put them into the application, okay? And then there's also the database credentials. So here we are using Postgres over here. And then we need the database credentials. So we're grabbing those database credentials. Those are stored in Secrets Manager, and we're giving it to the application. So the app knows how to connect to the database, and this one knows how to configure it, okay? Then we have a bunch of buckets here for different organizations. And so, S3 is for storage. So this is a way we're going to store a variety of things. So like user data, assets, artifacts, CloudFormation templates. So some of this is for the app. Some of them is for the infrastructure. So that's one thing there. Okay, then over here we have a CI/CD pipeline. So we have code pipeline. And so code pipeline is triggered by GitHub. So we put our code in GitHub. And when that happens, it's going to do a code build. So that's going to build out a server. And then from there, it's going to run another code build server. And then from there, it's going to then use code deploy. And so code deploy is going to trigger a deploy. What it will do is create a new environment. So it's going to create a copy of this. It's going to create a copy. This is actually the environment that's running. So we'll copy that, and that will be our new environment, right? Okay. And so when the deploy is done, it will swap it, and then that environment will become this new one. And so, again, this is actually really the running server. It's just kind of easy to get hung up on this one. But the idea here is that, that's how deployment works. But let's say, we want to get traffic to this actual instance. This is going to come through the internet. And the internet's going to probably go to Route 53. So Route 53 is used for domain names. So this would be like exampro.co, teacherseat.com. We pass that over to our Elastic Load Balancer, which in this case is an application load balancer. That's why it's called ALB. And that's going to distribute the traffic there. If we wanted to run the server in another availability zone so that we make it highly available, ALB, the Elastic Load Balancer, application load balancer, is going to have some traffic go here and some traffic go there. So this is just the blue environment, or whichever the current environment is over here. Now, when we want to deploy new versions, we're going to use launch templates, and launch templates are necessary when using auto-scaling groups. So, you do have to define launch template. It just says like, what is the shape of this instance type? Like, what's its family? What should it be? And then we need an Amazon machine image. So our Amazon machine image is custom built because we are installing all the stuff that we want on it. And so in order to automate that process, we are using SSM automation documents. So SSM stands for Systems Manager, and automation allows you to automate that step. So what it's going to do is launch an instance, install Ruby, install Postgres, download the code base. Then it's going to create that AMI, and then it will do a bunch of other stuff here as well. And this is going to run weekly, or actually at the time it was running nightly. So we're doing nightly builds so that we would always get the latest updates to our server. Because it's a virtual machine, there could always be new updates for that Linux version or Amazon machine Linux version we were using. And then there's a bunch of other stuff here. So, hopefully that kind of gives you an idea, like the complexity of it. And, this is how I like to make my architectural diagrams, very in detailed, so that we can look at them. But yeah, if that was too much, that's fine. But, that's just the complexity of it. If you build your own, you'll start to really grasp this stuff pretty well, okay? So what I want to do is just show you how high availability is built into some AWS services, where in other cases you have to explicitly choose that you want something to be highly available. So what I'm going to do is make my way over to S3. And so with S3, this is where you can create S3 buckets, and this allows you to store things. And so the great thing about S3 is that it's basically serverless storage. So the idea is that you're just going to choose your region, and by default, it's going to replicate your data across multiple data centers, or AZs. And so this one's already highly available by default with the standard tier. And so that is something that's really nice. But other services, like EC2, the idea is that you are going to launch yourself an EC2 instance. So we would launch that one. And the problem with this is that if you launch a single EC2, that is not highly available because it's a single server running in a single AZ. So here, we would choose our subnet. Our subnet is our availability zone, but you'd have to launch at least 2 additional servers, and then you'd have to route. You'd have to have something that would balance the traffic to the 3, which is a load balancer. And so in this case, you have to construct your high availability. Then you have services like Elastic Beanstalk. This is a platform as a service, and we'll go to environments here. I'm not sure it wasn't showing up there. And so the idea is that with Elastic Beanstalk, I'm just going to click on the main service here. You're going to go ahead and create your application or create your environment. You probably want to create an environment first here. Okay. And so I would choose a web server. And then the idea is I would just name it. So my application here, my environment. And then down below, you go configure more options. Whoops, it wants me to choose everything. That's totally fine. And we say configure more options. We're not going to create it because we don't want to create one. But the idea is that you could choose whether you want this to be highly available or not. So see, it's a single instance, so free tier. And then if you choose this, what it's going to do is set up a bunch of stuff for you. So it's going to set up an application load balancer for you. It's going to set up auto scaling groups for you to make it highly available. It's going to run at least between 1 to 4 instances. So this does everything that EC2 you'd have to do manually setting up. So that's really nice. Okay. So, some options have that. If we make our way over to RDS, and again, we're not creating anything. We're just looking at the options it gives us when we start these up here. We'll make our way over to RDS when it gives us a moment here. And if we go ahead and create ourselves a new database, and we look at something like a Postgres database, notice that we have a production option and a dev test option. And so I mean, usually it shows us the price down here. So even test dev is $118, which is not true. It can get cheaper than that. But the idea is that when you choose between these two options, it's going to set up multi-AZ. That means that it's going to run an additional database in another availability zone, replicate that data over so that it stays highly available. It's going to have auto-scaling part of it. And so some services, you just choose it abstractly. So you just have to understand what high availability is going to mean underneath. So hopefully that kind of gives you a picture of high availability on AWS. Hey, this is Andrew Brown from ExamPro, and we are looking at AWS Application Programming Interface, also known as AWS API. So before we talk about the API, let's describe what Application Programming Interface is. So an API is software that allows two applications or services to talk to each other, and the most common type of API is via HTTP requests. And so the AWS API is actually an HTTP API, and you can interact with it by sending HTTPS requests using an application interacting with APIs like Postman. And so here's kind of an example of what a request would be that would be sent out. And so the way it works is that each AWS service generally has a service endpoint. So see where it says monitoring, that's going to be CloudWatch. So sometimes they're named after the services, sometimes the name is a bit obscure. And of course, you can't just call an API request without authenticating or authorizing. And so you have to sign your request. And so that's a process of making a separate request with your AWS credentials to get back a temporary token in order to authorize that. And I don't have room to show it, but the thing is that what you'd be also going along with this request would be to provide an action. So when you look at the AWS API, it will show you a bunch of actions that you can call. They're basically the same ones you'll see in the IAM policies. So it could be like describe EC2 instances or list buckets. And they can also be accompanied with parameters, okay? So, we're probably not going to show you how to make an API request directly because that's not something that you would generally do. But what you would do is you'd probably use the AWS Management Console, which is powered by the API, use the AWS SDK, which is powered by the API, or using the AWS CLI. So we'll cover all those three, okay? All right, so what I want to do is just point you to where you'd find the resources to use the API programmatically. We're not going to actually use the API because there's a lot more to it than what I'm going to show you here, but at least you'll be familiar with how the API works. So I'm on the aws.amazon.com website. If you type in docs at the top there, it's going to bring you to the main documentation. And what we're looking for, if we scroll on down, there should be a general reference area where we have service endpoints. If we click into here, it's going to talk about how a service endpoint is structured. And if we go down to AWS API, we can see some additional information. Of course, to use the API, you're going to have to sign API requests first, which is not a super simple process, but you have to use an authorization header and send along some credentials and things like that. So if you want to know what service endpoints are available to you, if you search service endpoints list for AWS, this is the big list. And so if I was to go down here and look for EC2, might be a common example here, it's going to tell us what the endpoints are. And as you can see, they are regional based. But the idea here is that I could take something like this, okay, I could grab that, and using something like Postman, I could go and create a new request. And it's probably a post. I'm not sure what it's supposed to be. It's probably a post. And then you'd set your authorization header. There might even be one in here for AWS. See where it says AWS signature. So you can go here and put your access key and secret within here. So that's something nice about Postman. So it's going to do the signing request for you. So it makes your life a lot easier. And then from there, what you do is you go to your body and you'd want to enter in JSON. So to do JSON would probably be raw. You drop down the format JSON. And then you'd send your payload, whatever it is. So I haven't done this in a while because it's not a very common thing that I have to do, like describe EC2 instances. But there probably is like an action and some additional information that you'd send along. So, hopefully that gives you kind of an idea how the API works. But, you should never, in practice, ever have to really work with the API this way directly, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at the AWS Management Console. So the AWS Management Console is a web-based unified console to build, manage, and monitor everything from simple web apps to complex cloud deployments. So when you create your AWS account and you log in, that is what you're using, the AWS Management Console. And I would not be surprised if you're watching this video and they've already changed the default page here, since AWS loves to change the UI on us all the time. But the way you would access this is via console.aws.amazon.com. When you click sign in or go to the console, that's the link that it's going to. And so the idea here is that you can point and click to manually launch and configure AWS resources with limited programming knowledge. This is known as ClickOps, since you can perform all your system operations via clicks, okay? Let's talk about the AWS Management Console in brief here. So, of course, when you're on the home page, you go to AWS Management Console and you will end up logging in. And from there, we will make our way over to the AWS Management Console. When I say AWS Management Console, I'm referring to this home page, but I'm also referring to anything that I'm doing in this web UI, whether it's a subservice or not. So, a lot of times people will just call this the dashboard or the home page, but, it is technically the AWS Management Console, but everything is the AWS Management Console. You can drop down services here. If there's some that you like, you can favorite them on the left-hand side. I don't find that particularly useful. You can see the most recent ones here. They'll also show recently up here as well. We have the search at the top. Notice that there's a hotkey for Alt-S. I don't think I ever use it. But if I was to type in a service like EC2, it's going to get me the services. And then down below, it's the sub-features of it. So if I just click into that there, into this, this is the main, this is a service console. So I would call this the EC2 console or the EC2 service console. So if you ever hear me saying go to the EC2 console, that's what I'm saying. And you'll notice here, like there is stuff on the left-hand side. So I come back here, EC2 Image Builder, EC2 Global Views. These are considered services. But if you drop down, it says Top Features, or you go down here and it says Dashboard, Limits, AMIs. You go over here, the EC2 Dashboard, Limits, AMIs are here, and Limits are somewhere here, right there. So, okay, so those kind of map over pretty well. Polls and documentation, knowledge base articles, marketplace. I don't think I've ever touched those in my life. This here is the Cloud Shell. So if you click it, it will launch a Cloud Shell. We'll cover that when we get to that section. Here we have this little bell. It tells us about open issues. I think this is for the personal health dashboard. Yeah, it says PhD in the bottom left corner. So if I open that up, it'll bring up the PhD, the personal health dashboard. All right. Our region selector, our support. So nothing super exciting here, but just kind of giving you a bit of a tour so that you know there are some things you can do. Can you change the look of this? I don't think right now, as of yet, there is any way. I'm sure AWS is thinking about it because it's been a high request that's in demand, but this is what it looks like as of today, okay? All right, so I just want to describe what a service console is. So an AWS service each have their own customized console, and you can access these consoles by searching the service name. So you would go ahead and type in EC2, and then what we refer to this screen as the EC2 console. The reason I'm telling you this is that when you're going through a lot of labs or follow-alongs, you'll hear the instructor say, go to the EC2 console, go to the SageMaker console, go to the RDS console. And what they're telling you is to go type the name of the service and go to that particular service's console, okay? Some AWS service consoles will act as an umbrella console containing many AWS services. So, VPC console, EC2 console, Systems Manager console, SageMaker console, CloudWatch console, these all contain multiple services. So, for EC2, you might say, okay, well, I need a security group. There's no security group console. It's under the EC2 console, okay? So just be aware of that. So now I want to show you some of the service consoles to kind of distinguish how they might vary per service, okay? So if we were to look up EC2, and we just did look at this, but the interesting thing is that some consoles, the EC2 console, is the home for other AWS services, and you just have to learn this over time to know that. So for instance, Elastic Block Store is its own service, but it's tightly linked to EC2 instances, so that's why they always have it here. Same thing with AMIs, security groups, same thing with that. So these are interesting because these are basically part of virtual networking, and so you'd think they'd be under the VPC console, but they are actually under here with EC2. And so load balancing autoscaling groups tightly coupled to EC2. If we make our way over to VPC, here it's going to contain all the new stuff. Does it have a new experience? No, I guess this is the newest one. It looks a bit old and a little bit new here, but we have a lot of different things here like firewalls, VPNs, transit gateways, traffic mirroring. We make our way over to CloudWatch. Okay, and CloudWatch has very focused services. They're all actually named, and this is more like feels more like a single service where you have these very focused services where you have alarms, logs, metrics, events, insights, right? But you're going to notice that like the UI highly varies. So we had looked at CloudWatch, and then we had looked at VPC, and it looks like this. And then we looked at EC2, and it looked like that. And so there is inconsistencies because each service team, like that work on per service or whatever, they have full control over their UI. And so some of them are in different states of updating. So some people might have updated the left-hand column, but this part is old, or you might click around like under something else like EC2 dashboard, or maybe a better example might be AMIs. I remember we're in here and something looked old here. Yeah, see, these are the old buttons, and that's just how it is. So everything is very modular, and so they get updated over time. So that is the challenge that you're dealing with. You're always having like 3 different versions that are cobbled together in each UI. One thing that I found really interesting is that VPC has its own console, management console, but if you were to look up this in the SDK, so if I was to look up AWS SDK EC2, okay, I'm just looking up Ruby here as an example because that's what I know how to do. If you look under here, let's say you want to pragmatically work with VPCs, you'd think that it would have its own top-level VPC because it has in the console its own management console, but actually VPC is tightly coupled EC2, and so when you want to pragmatically use VPC, you're going to be using actually EC2 as how it was built. So the what I'm trying to get is the APIs don't one-to-one match with this kind of stuff, and so it's just kind of interesting that there's those kind of differences. But again, it's not that big of a deal. I'm just trying to say, like, keep your mind open when you're looking at this stuff, okay? So every AWS account has a unique account ID, and the account ID can be easily found by dropping down the current user in the global navigation. So what I'm going to do is pull up my pen tool here and just show you. It's right there. The AWS account ID is composed of 12 digits, and so it could look like this, or this, or this. The AWS account ID is used when logging in with a non-root user account, but generally a lot of people like to set their own alias because it's tiring to remember your account ID. You use it when you're creating cross-account roles, so you'd have the target account ID, the source account ID to gain access to resources in another AWS account. When you're dealing with the support cases, AWS will commonly ask you what your account ID is so they can identify the account that they want to look at. And it is generally good to keep your account ID private, as it is one of the many components used to identify an account for an attack by a malicious actor. So you don't have to be overly sensitive with it, but try to hide it when you can, when it's easy, okay? All right, so let's talk about the account ID, which appears up here in the top right corner where you can get the account ID. It also appears in IAM. So if we go over to IAM and you look on the right-hand side, it should show you the example here. It keeps on trying to take us to the old dashboard. That's fine. But you'll notice that it's over here, and I don't have MFA turned on because I'm in my IAM user account, but it should be turned on everything. That's a given. But I just want to show you where it is and also where you might be using it. So one example where you would need to know your account ID would be something like creating a cross-account policy. So I went here and went to policy and went create policy. And we went to, maybe it's a role. I think we want a cross-account role. It's not the policy, sorry. We go here and we say, I want to access something in another AWS account. What we have to do is specify the account ID, specify the accounts that can use this role. So you give, I think, the ID of the other account. Okay. And so that is one place where you'd use it. Another place would be when you're creating policies. So if I go back to policies here, I can create a policy here. And I can just choose something like S3. Okay. and I'll just choose list. And under the request conditions, I might specify, I think, the account ID. It should be in here. I know I can limit based on account ID. Principal account. So you could do principal account. So if I just looked up this here, AWS principal account. And you just got to get used to Googling things, because that's always what's happening here. And so we should be able to specify an account ID. Yeah, like that. So that would be the principal there. So if I just took that, and it doesn't matter what it is, we just put the value in here. String equals this, add. I should be able to go over here and now see the full statement. Nope, sometimes that happens because we don't have it fully filled out. But yeah, so that's pretty much how we use it. Like, it would normally show up as that. So if I just go ahead and go next, the policy contains an error. You are required to choose a resource. What do you mean? The resource is this, right? Oh, down here. Okay, sorry. So we'll just say all resources. Then we flip over. Now it's valid. And so here we can see our condition saying only from this account ID that it is allowed. Other places we're going to see account IDs are in ARNs, right? So if we had an EC2 instance, we don't have one launched right now. But if I was to go ahead and, oh, maybe we have some prior ones. Yeah, so if I was to checkbox this here, and you might not have any prior ones, so there might not be nothing for you to see. But if you look for the ARN, where's our ARN? Sometimes it doesn't show the ARN in the services. Sometimes it does. I wish that AWS always showed the ARN to make our lives a bit easier, but it could be because of other reasons why. But even though we don't have the ARN, I think it shows us the owner ID. And so that's the account ID number. You can tell because it's 12 digits. So hopefully that gives you kind of a tour of the account ID and what its purpose is in the account, okay? All right, let's take a look at AWS tools for PowerShell. So what is PowerShell? PowerShell is a task automation and configuration management framework. It is a command-like shell and a scripting language. So here it is over here. If you are a Windows user, you're used to seeing this because it has a big blue window. So unlike most shells, which accept and return text, PowerShell is built on top of the .NET Common Language Runtime, CLR, and accepts and returns the .NET objects. So AWS has a thing called the AWS tools for PowerShell, and this lets you interact with the AWS API via PowerShell commandlets. Commandlets is a special type of command in PowerShell in the form of the capitalized verb and noun. So in this case, it'd be new -S3 bucket. So, you know, we looked at the AWS CLI, and that is generally for bash, shells. And so PowerShell is just another type of shell that's very popular. And I just wanted to highlight it for those people that are, used to using Microsoft workloads or Azure workloads, that this actually exists, okay? All right, let's take a look at the PowerShell tools. I actually haven't used this one yet, so I'm kind of curious. I am on a Windows machine, so if I was to open CM or PowerShell, and you probably can't see this, but if I just bring this over here, if I type in PowerShell on my computer, you'll notice that I have it. So that's how you would launch it. It looks like a blue screen here, okay? If you're on a Mac, you're not going to have that, but that's totally fine. We don't need to have a Windows machine to use PowerShell because we can go ahead and use Cloud Shell. So make sure you're in a region that supports Cloud Shell. So I switch back to North Virginia. This is not important for the exam, but it's just kind of fun for me to go through this with you if you just want to watch here. And so I want to change this over to PowerShell. So I imagine that it must be over here. So how do we change to PowerShell? So we'll type in AWS AWS Cloud Shell PowerShell. Like, how do we do it? Okay, and so we're just going to scroll down here. So the following shells are pre-installed: the Bash, the PowerShell, the Z shell. You can identify them by that. Yeah, of course. To switch to new shell, enter the shell's program name in the command line prompt. Oh, wow, that's easy. So if we want PWSH, do we just type PWSH? Let's find out. Give it a moment to think. Oh, there we go. Okay, so now we're using PowerShell. And so I would think that AWS would give this pre-installed for us. So if we go over here to the instructions and we scroll on down, there's probably like, oh wait, like I don't use PowerShell a lot. It's very easy to install modules. I've done it before, but I never remember how to do it. But let's just see what we can find here. So I want the documentation for PowerShell here, and I'm going to go to maybe the reference here, because I just want to see some examples for the commandlets. And so we'll look for S3. Again, never done this before, but I'm always great at jumping into these things. And all I want to do is just list out the buckets. So I'm going to just search for the word list and just see if I can find something very simple here. And calls to get the list buckets API operation. So I think that is what we're going to be doing here. So I'm going to click into that. Okay. And then from there, what I'm going to do is just see if I can copy this command. So we will go ahead and copy this and paste it in here. And I like how we got this little shell here so we can tweak it. So we need the bucket name, but I don't want to return a list of all the buckets owned by the author. So we don't have a bucket name that we want to explicitly set here. So it's required false. So we can remove that. Okay, we'll look at the next one, select required false. Use the select command to control the commandlet output. The default is bucket. Specifying select will result in returning all the whole buckets. For that, specifying the name. But it says it's not required, so let's just take that out as well. I don't think we need any of these, actually. Let's just go and put that in there. And I think that there must be something we need to put in front of that, right? Well, let's just see what happens. The term is not recognized as the name of the commandlet function script is operable. So I think we're missing something in front of here. We'll go to the user guide here quickly. And we'll get to the getting started. I just want a super simple example here. New bucket, get bucket. Well, let's try this one here because they have it here. And so it should just work, right? I'm going to change this to US East 1. The term new bucket is not recognized as the name of the commandlet function. So I'm guessing that the commandlet's not installed. I would have thought that they would have installed it by default. So I guess what we'll do is look at how to install it. So installing on Linux, I suppose. So you can install the modularized version of the PowerShell on computers. To install AWS tools on Linux, PWSH to start PowerShell core session. So I guess that's how you must start it on Linux. And then install the module this way. So yeah, I said it's easy to install these things. We'll hit enter. Cross our fingers. Hope this works. Hope this is fast. I'm just going to take a look here, peek forward here. If you are notified the repository is untrusted, you're asked if you want to trust anyway. Just hit Y. So we're waiting for that here. You're installing this module from untrusted repository. It's funny that it's untrusted but it's by AWS. Maybe that's some kind of drama between Microsoft not letting AWS have an official module there. But it looks like it should be installed now. So if I type in get S3 buckets here, unless I typed it wrong, that still doesn't seem to be working. If I go up here and try to create a new bucket, still does not recognize the commandlet here. So there must be more going on here. If you're notified, you can now install the module for each service. Okay, well, what did we do? You're installing the modules from untrusted. If you trust it, change its installation policy value by running set policy command. Are you sure you want to install this module from the PS gallery? So I said yes, and I gave it a capital Y, and it didn't do anything else. So, oh, hold on here. So this is the installer. And then here is the actual tool that we want to install. So so we just installed this thing, and now we use this thing to install S3. Okay, great. Not hard, okay? And so we'll just say yes to all. And so that's going to install, I guess, everything. Oh, we said EC2 and S3. Well, we didn't need both, but that's fine. And so what I'm going to do is go get bucket. And so now it recognizes it. It lists out the items here. We can go and create ourselves a new bucket. So we'll do that. Okay, we'll make our way back over the AWS Management Console. We'll go to S3, just because I don't need all these buckets lying around here. And I'm going to go ahead and delete some of these buckets here. So we'll say delete my bucket. Great. And we'll go to this one here and say delete my bucket. Excellent. All right, and so we have an idea how to use PowerShell. And so PowerShell is just really popular because of its the way you do inputs is very standardized, and the outputs that come. So it's very popular and a very powerful scripting tool. That's our CLI tool as well. So hopefully that was interesting for you. But what we'll do is just close these off here and go back to our homepage. Always just clicking that logo there, and there we go. So Amazon resource names uniquely identify AWS resources, and ARNs are required to specify resource unambiguously across all of AWS. So the ARN has the following format variations. So there's a few different things here, but just notice here that sometimes it has a resource ID or it has a path, so with the resource type, or it could be separated by a colon. So the partition could either be AWS, China, or Gov Cloud, because this is basically the AWS portal or URL that are completely separated from each other, as we talked about those earlier in the course. Then there's the service identifier, so EC2, S3, IAM. Pretty much every service has their own service that name here that would be identified. Then the region would be pretty obvious, US East 1, CA Central 1. You'd have account ID, which would be 12 digits. The resource ID could be a name or a path. So like for IAM users, we have user Bob. This is an EC2 instance. And most of the ARNs are accessible via the AWS Management Console. And you can usually click the ARN to copy it to your clipboard. So here it is for an S3 bucket. And notice that it's a little bit different because it is a global service, AWS. There's no reason to specify the region or the account ID or anything else there, like the resource type. So straight away, we already know it's a bucket, so we can just say my bucket. So that one's really short, but in other cases, it's really long. So here it is for a load balancer, and it has all the information there. And notice that like this has a path, this is load balancer app, my server, MLB, and then it has the ID, okay? For paths and ARNs, they can also include a wildcard asterisk, and we'll see these like with IAM policies or paths. These are really useful when you are doing policies where you have to specify an ARN and you want to say a group of things and things like that. So there you go. All right, so now let's take a look at Amazon resource name, or also known as ARN. And so ARNs are used to reference objects. They're very commonly used when you're using the CLI or the SDK to reference to something. The easiest example is S3, right? So if we go over to S3 here and we create ourselves a new bucket. So I'll go ahead and create ourselves a new one here. We'll say my new bucket. I'm just going to put a bunch of numbers in here. It doesn't matter. We'll hit create bucket. And what we will see if we click into this is the ARN should be under properties. And there it is. Okay. So there are many cases where you might want to use the ARN, and a lot of times you'll just copy it. And a very common example would be, again, with IAM policies. So we go over to IAM policies, right? And I want to get to policies here to save myself some trouble. And we create a policy. You know, I might want to restrict someone to use only that bucket. So I say S3, okay? And then I'm going to say I want to be able to read and write from a particular bucket. We go drop down these resources here. And so here we have a lot of options. Maybe I'll just get rid of the read option. And I'm going to actually expand write because it's just creating too much work for me here. And I just want to have put object. That's what we use to put something into a bucket. So we expand the resource here. And notice this says add the ARN. So we go here and we could type the bucket name. So we do that, or we just paste it on in here at the top. So it's probably easier just to grab it sometimes. But if you don't know an ARN, a lot of times you can just expand this and then fill it in, and that's how you get an ARN. So I'll put that there. Let's list. Oh, you could also do it that way, which is easier too. And so now if I go to JSON, is it valid? There we go. So here it's saying this policy allows somebody to put an object into this particular bucket. And so that would be an example where we would use an ARN, okay? Or if you're doing, if you're using AWS support, you might have to use an ARN to get help from support saying, hey, look at this particular resource exactly here. And then the cloud support engineer can help you, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at the AWS command line interface. But before we do that, we've got to define some terms. So what is a CLI? So a command line interface processes commands to a computer program in the form of lines of text. Operating system implement a command line interface in a shell, okay? So we have a terminal. So a terminal is a text-only interface, so it has input-output environment. Then you have a console. This is the physical computer to physically input information into a terminal. Then you have the shell. A shell is the command line program that users interact with to input commands. Popular shell programs are Bash, ZSH, PowerShell, and you might remember this one, MS-DOS prompt. So this has been around for obviously a very long time. So maybe this kind of primes your mind for what is a shell. And just so you know, people commonly erroneously use terminal, shell, or console to generally describe interacting with a shell. So if we say shell or console or terminal, we're just talking about the same thing, but there is technically a difference between these three things, but most people do not care, and I wouldn't worry about it too much, okay? So now let's take a look at the AWS command line interface, which allows you to programmatically interact with the AWS API via entering single or multi-line commands into a shell, and then here I say or terminal, but really it's just the shell, okay? So here is an example of one. So we're trying to describe EC2 instances, and then we're getting the output because we asked to have it back in this table-like view. So the AWS CLI is a Python executable program. So Python is required to install the AWS CLI. The AWS CLI can be installed on Windows, Mac, Linux, Unix. The name of the CLI program is AWS. You'll notice that up here in the top left corner. There's a lot more to this, but this is all we need for now, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at the AWS CLI, and the easiest way to get started with this is actually via the Cloud Shell. So you'll notice this little icon here in the top right corner. That is Cloud Shell, and it's going to allow us to programmatically do things without having to set up our own environments. So if I just click that there, okay, and I say do not show again, close. And by the way, if you don't see Cloud Shell here, it could be your region. So like if I go to Canada Central, it doesn't have it there. And so if I was to search Cloud Shell here, okay, it's going to say it's only supported in those regions. So that's a bit annoying, but once Cloud Shell loads, it already has our credentials loaded within our account. And so this is going to save us a lot of time in terms of trying to get set up, with the exception that you have to wait for this environment to create. So it takes a little bit of time, but it's not that bad. And while that is waiting, what I'll do is show you actually how you'd install the CLI yourself. So if we typed in AWS CLI install, all right, and we went here, the way you would install, I believe it's a Python library, but if we went to version 2 and we just said Linux, you go down here, they'll have instructions. So you just curl it, unzip it, and do that. So, if it's this, and then once it's installed, you'll have the AWS CLI commands. This is still going. So, maybe I can show you what it would be like to install the CLI by hand. So if we wanted to do that, one easy way to do this is if we just go to GitHub. Doesn't matter what repository. I'm just looking for anything here. And if I open up Gitpod, so if we go on the top here and type in gitpod.com, I think maybe that. I just want to see, whoops, maybe it's Gitpods, like that. Oh, Gitpod, you're not giving me, oh, you know what, it's .io, that's why. Okay, so if we go back here, sorry, and we type in .io, what this will do is launch me a temporary environment. And so this is outside of AWS, so I'd actually have to install the CLI. So this would be a great opportunity to show you how to install the CLI. I'm just doing it this way because Gitpod is free to use, and it's going to set up an environment and let us simulate installing the CLI. So here is the CLI here. I'm going to see if I can bump up the font. Let's make the font as large as we can go. Light or dark? Dark sounds good to me. And so if we type in AWS, and give it a moment, we can see that we have the command here. So if I say AWS S3 ls, whoops, it should be able to list things out in a bucket. So this is what's currently in the bucket. If you're wondering how do I know what these commands are, I can just type in AWS CLI commands. Okay, and if we go here and we go to the CLI reference, then we have anything we want here, right? So we go down here and I just want to see what's running in S3, and I go here and I scroll on down. It's going to show me commands like copy, move, remove, sync, MB, RB, list, right? And if you're looking for a particular command, you go down and say, okay, I'll look at ls here, and it will explain to me all the little options that we can do with it. And then it will always give me examples, right? So I can see examples like that. So if I wanted to move something into an S3 bucket, so let's say I want to create a new S3 bucket, we'll type in AWS S3 and just hit enter, and it should tell us the subcommands. Maybe if I do like help, like this. And if we scroll on down, so I guess it just pulls up documentation. I was hoping it would give us like a tiny summary. Okay, so what we can do here, because I want to create a bucket, type in like buckets. If you don't know something, you just go AWS S3 CLI create bucket. We'll go here. And then what I do is I always just go to examples here. And so here we have AWS S3 API create bucket. And I know it's unusual. There's an S3 and there's an S3 API. I don't know why that is, but it's always been that way, and I just don't question it anymore. And so here I can go ahead and create a new bucket. So I'll just go ahead and paste that command in. I do want to change it up a bit here because this name that has to be unique. So just to make sure I get what I want, I'm putting random numbers in here. We're going to choose the region as US East 1. If I wanted to do other things here, I could scroll up and look at some flags here. So it looks all fine to me. So I think I'll go back here and just hit paste. Okay, and so it created that bucket for me. If I go over to S3, and we'll wait here a moment, we can see that bucket now exists. If I wanted to place something in that bucket, what I can do is just like touch a file. So I'll just say touch. Touch is a Linux command to make just an empty file. So we'll say hello.txt. And then it would be AWS S3. It would be SP to copy it. And I'm going to give it the local path, hello.txt. And then I need to give it the bucket address. So it'd be S3:// the bucket name. So we named it this. I'm not even going to try to type that in by hand because it's too hard. And then I want to say where I want to put this file. So I'm going to say hello.txt. And if I'm right, that should work as expected. And so it says I uploaded that file. I make my way back over to S3. I refresh. There is the file. If I want to copy this file back locally, all I have to do, I'm just going to I'm going to delete the original hello.txt file, ls, to show you that there's nothing there. And what I need to do, is just revert this. So instead of saying the address here, we can go and type in hello.txt. And if I do ls, there's the file. If you don't know what the address is of the bucket, a lot of times you can go here and find it. So it should be, because they're always changing this UI on me, but we'll go to properties here, and that's the ARN. Usually a good way to find it is if you go into an actual object. So if you go here, it'll give you the full URL. So I could have grabbed that, and I could have just pasted that in there. But you learn after time. It's not hard to remember this S3:// the unique name. I do want to show you how to install it by hand. So here I'm in Git pods. I'm not sure how I can change this to a dark theme because I really don't like this on my eyes. We'll go down below here to color theme, and we'll say Git pod dark. There we go. And so this is a temporary workspace. So when I close it, it'll be gone. So I'll be totally fine. And so I'm going to type in AWS to see that it's not installed. We're going to go over here. This runs Linux by default. So I already know that I'm going to use Linux. We want to use version 2 here. So for the latest version, use this command. For a specific version, no, we just want the generic one. So I'm going to go ahead and copy this. Whoops. Yes, allow. We'll paste that in. We'll hit enter. Okay, then we'll take the next command. Paste that in, hit enter. We'll go take the next command here. We'll hit enter. You can now run AWS. So we type AWS, and there's the command. So the only thing is that if we do AWS S3 ls, it's not going to work because we don't have any credentials set. So we'll give it a moment to think. So it says unable to locate credentials. You can configure credentials by running AWS configure. So we type in AWS configure. And by the way, if this font is too small, I believe I can bump it up like this. Not a great way to do it, but it works. And so it says AWS access key ID. So what we can do is go over to IAM, And what I'm looking for is my particular user over here. And if you remember, when we first created our account, it generated out access key. So I go to security credentials. And so we have a key here, but I need the secret. So this key is useless to me. So I'm going to go ahead and deactivate it, just because I don't even want this key. And I'm going to create myself a new key. So I'm going to have an access ID and secret. Whenever you generate these out, never, ever, 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 ever show anyone what these are. These are yours and yours alone, okay? So this is Cloud Shell. We're fine. We're just going to close that for now. And I'm going to go back over to get pods here and hit enter. So that's the ID. I'm going to go grab the secret, hit enter, paste. And I want it to go to US East 1 to save myself some trouble. You can change the output from JSON to tables. I'm going to leave it as the default here. And so now if I type AWS S3LS, I get a list. And so if I want to grab that file there, I'm going to grab that S3 URI, and we type in AWS S3 API, or sorry, it's just LS, CP. And we're going to paste that link in, and we're going to say hello.txt. And I must have done the command wrong. It's because we're missing S3 here. I just hit up on the keyboard to get that command back. And so I type in ls for list. And I mean, I have some other code here. So, you know, again, any repo you want on GitHub, it doesn't really matter. But you'll see there is that file. Probably shouldn't use this one because it makes a bit of a mess. But yeah, it's pretty straightforward. One thing to show you is where those credentials are stored. So by default, they're going to be stored in, it's going to be in a hidden directory in your root or your home directory called aws.credentials. So if I just do like ls here, you can see there's a config file and a credentials file. Cat lets me print out the contents of that file. So I go here, and it's saying the default region is US East 1. This is a TOML file, even though it doesn't have a .toml on the end of it. I just know by looking at it, that's what it is. Config lets you set defaults that are going to apply to all of your credentials. And then within the credential file here is the actual credentials. So if you wanted to just set them, you could go in here and just set them in here. You can also set multiple credentials. So if I go here and I'm going to open it up in Vi because I'm not sure how to open it up here in the main one. But if you wanted multiple accounts, you would do like ExamPro, and then you just repeat these with different keys, right? And then when you wanted to use a CLI command, actually, I'm going to go back here for a second. Okay. And if you want to, and by the way, I'm using Vi. If you never use Vim, it's a bit tricky to use. You might want to use Nano instead if you're kind of new to this. Because this will use like regular key cuts, and then down below it shows you what it is. So this is like Control X or Alt X? Alt X? Nope, Control X, there we go. But anyway, so if I go into this file and I delete the original one, right? And now I try to do this command here, even though we already have that file, it should either hang or complain. I could just kill that by doing Control C. If I do AWS S3LS, notice that it's hanging, so unable to locate credentials because there's no default one. But if I go and I put profile and I say ExamPro, right, it'll now use that profile. So that's the way we do it. But hopefully that gives you kind of a crash course into the CLI. So yeah, there you go. Okay, so I'm just going to go ahead and close these off. You can delete this bucket if you don't want it. It's probably a good idea to delete this here. And I'm just going to say permanently delete. Okay. Very, very good. Okay, close that off. And yeah, that's the introduction to the CLI. So yeah, there you go. Hey, this is Andrew Brown from ExamPro, and we are taking a look at software development kits. So a software development kit, or SDK, is a collection of software development tools in one installable package, so you can use the AWS SDK to programmatically create, modify, delete, or interact with AWS resources. So the AWS SDK is offered in a variety of programming languages. So we have Java, Python, Node.js, Ruby, Go, .NET, PHP, JavaScript, C++. And so here would be an example of some Ruby code where we are creating ourselves an S3 bucket. So we're just uploading a file there, okay? Okay, so now what I'm going to do is show you how to use the AWS SDK. And so to do that, we're going to need some kind of IDE, a basically code editor. And so we had looked at GitPods, which is a third-party service, and that's fine. But let's take a look at Cloud9, because that is built into AWS. So if I just type in Cloud9 here and go over to IDE, I'm going to launch myself a new environment. So I'll hit Create. I'm going to just say my SDK environment. env if you have a hard time typing environment like me. And we have some options. So create an EC2 instance for direct access, create it via Systems Manager, run a remote with SSH. I'm going to leave it as the default. Then we have the option to choose what size. I want to leave it on T2 Micro because that is the free tier. Then we're going to scroll on down. We have Amazon Linux 2, Linux AMI. I'm going to stick with Amazon Linux 2, and we can have it turn off after 30 minutes. A great option for us here. And we'll go ahead and hit Next. And we'll hit Create Environment. And so we're going to have to wait a little bit for this to launch. It'll take a few minutes. As that is going, let's go to Google, type in AWS SDK to get to the main page. And so the idea here is that there are a bunch of different languages you can use: C++, Go, Java, JavaScript.NET, Node.js, PHP, Python, and Ruby. And so I'm a really big fan of Ruby. I've been using Ruby since 2005, and so that's what we're going to do it in. It's also really easy to use, and it's a really great language. So, you know, down below, it's just showing you that there's all these different things. But if we go down to the SDK here, and we click on Ruby, we have examples where you have the developer guide, the API reference. And so this tells you how to get started. Even here, it's saying like, hey, go get started with Cloud9, which is great as well, I suppose. And so here it might show you how to install it. And when we open up the API references, this is what it looks like. So a lot of times when I want to do something, I know it's like, I want to do something with S3. So I scroll on down here and I look for S3, right? And then I just kind of like scroll around and look, you know what I mean? Sometimes I have to expand it, go into the client. Every API is slightly different. So you do have to kind of figure out how to navigate that. I'm actually under S3 right now, so I'm looking for the client. And I just know this from memory that this is where it is. So first you create yourself a client, and then you can do API operations. So if I wanted to like list buckets, I just search the word list and I just scroll on down, and there it is. I click into that and I have an example of how to list a bucket. So I'm going to go back to Cloud9, and it is ready, and it started in dark mode. If yours is not in dark mode, which really, honestly, why wouldn't you want dark mode? If we go up to, I think it's like File, where is it? Preferences here. Got to click the Cloud9 option, and I'm just seeing if it like remembers my settings. I really like two soft tabs here, but there should be something for themes down below, and so that doesn't seem like that's it. There used to be like oh, here it is. If you go here and just choose like whatever you want, I'm on Jet Dark here, and so if it's on Classic Light or something you don't like, you can fix that there. But I'm just going to go here and just fiddle with my settings because I really like to use Vim keys. I don't recommend this if you are to change this if you are not a programmer, but I'm just going to change it so that I can type here efficiently. So I'm just looking for the option here, and they moved it on me. Where did they move it? It'd probably be like key bindings. Vim mode. There we go. Again, don't do that. This is just for me, so I can move around in a different way. So what I want to do, and by the way, it looks like this default screen, we could have just changed it here. I just clicked through all that for nothing. It was here the entire time. But what we need is we need to make sure that we have our credentials. So if you type in AWS S3LS, that's like my sanity check that I always like to do to make sure I have credentials. Notice that we didn't have to set up any credentials. It was already on this machine, which was really nice. And so I'm going to create a new file here. And it's okay if you don't know anything about Ruby. We're just going to have fun here and just follow along. So I'm going to do example.rb. I'm going to make sure Ruby's installed by doing ruby-v. So it is installed, which is great. You need a gem file. So we'll say new gem file here. And if we go back to the installation guide, we need the gem SDK here. Actually, I'm going to look at how to generate a gem file. Gem file, because there's some stuff that goes to the top of those files, like this here. I think we just need this line here, so I'm just going to grab that. Whoops, paste that in. Allow. Good. And you can do gem AWS SDK. That will install everything, but we only want to work with S3. And so this is going to vary based on each language, but I know that if we type in S3, we'll just get S3, and that's all we really need. And so once we have that, what we'll need to do is use a bundle install. So we're going to make sure we're in the correct directory. I'm going to type in ls down below. Notice the gem file is there. And by the way, if the fonts are too small, I should probably bump those up. Let's see how we can do that. Editor, size, font, user settings. Good luck trying to find it, eh? Project, no. You'd think it'd have to be under user settings, right? Ah, here it is. Okay, so this is for probably the editor, so we'll go to 18 here. Code editor here. I'm trying to find the one for the terminal, probably over here. There we go. Much easier. Okay, so notice we have example.rb and gem file, so we're in the correct directory. Make sure I save that. I'm going to type in bundle install, and that's going to install the gems. Give it a moment there. It's going to fetch. Notice that it installed the AWS SDK S3 and everything that it was dependent on. And so now if we go over to our example.rb file, really when you're coding for the cloud, you can pretty much copy paste everything. So over here, we found this code here for S3 list buckets. And so I'm going to go ahead and paste that on in. Okay. And I know it looks really complicated, but we can quickly simplify this. So I know that this is just the output, so I don't need that. Okay. And in Ruby, you don't need parentheses or curlies if you don't have any things there. And so all I need to do is define a client. So if I click, if I go to the top here of this file, I think we're in the client right now. All the way to the top, all the way to the top here. That's what we need, okay? And so I'm going to paste that in. Now, we can set the region here. So I'm going to say US East 1, right? And then you'd have your credentials. Because the credentials are on the machine in the credentials file, they're going to auto load here, I believe. So I don't think I need to set them. So I'm just going to take that out here for a second. Okay. And I can do this if I want. This is just slightly different syntax. It might be easier to read if I do it this way for you. Okay. And I don't need double client there. So we have the client. I like to name this like S3 so I know what it is. And I put puts for the response. I'm going to do inspect. And so puts is like print. Okay. And so now if I type in bundle exec, let's just make sure that it's in the context of our bundler file, Ruby example.rb. We have a syntax error on this line here, unexpected thing here. Oh, it's because of this. It's because I commented out. So I'm just going to do curly, parentheses, comment out here. Okay. Actually, to make it a bit easier, I'm just going to bring this down like this. Okay, and we'll paste that there. Okay, and we'll try this again. Uninitialized constants AWS. Oh yeah, we have to require it. So we have to require AWS SDK S3, I think. We'll hit up. And we got a struct back. So it is working. We are getting an object back. If we want to play around with this a bit more, I'm just going to install another gem called pry. Pry allows us to inspect code. So we're going to do bundle install. And I'm going to go back to Ruby here. I'm going to put a binding pry in here. And then if I hit up and I do bundle exec Ruby example.rb, I installed it, right? Bundle install. Yes. Undefined method pry. Oh, because I have to require it again. Bad habit here. Okay, we'll hit up. And so now I have an interactive shell and I can kind of analyze that object. So we have a response. So if I type in RSP here, I have the structure object. I can type in buckets here. Okay, and it's showing me a bucket. I can get its name. Oh, I think it's an array. So I think I'd say like 0 here, or I could say first. This is just how the Ruby language works. We say name, I get the name, creation date. Okay, so you get the idea. Whatever you want to do, you search for it. You just say, I want to delete a bucket. I want to create a bucket, right? And you look for it. So I say create bucket here. I click on this, and I can see the options, and they are always really good about giving me an example. And then down below, they always tell you all the parameters that you have there. So that's how the SDK works. But yeah, the credentials were soft loaded here, but you could easily provide them yourself. I should just show you that before anything else, just because there's some variations there. And I'm just trying to look for it because it is separate code. So you could do this. This is one way of doing it. So you could do it separate from the code. So if you only wanted to configure it once, right? Because you could have a lot of clients. You wouldn't want to keep on, like for each client, you wouldn't want to put region in every time. So I could take this and put this right here, okay? And this is the file here where we have the credentials. So this would be our access key and our ID. And so you never want to put your code directly just in here. So if I open up, if we go cat, you would never want to do this, but I'm just going to show as an example here. Credentials. Oops, I got to get out of this exit. AWS credentials. Oh, did they not even show it on this machine? Which would be smart. We wouldn't really want to see our credentials here. I'm going to hit up, say ls. Oh, no, it's there. Okay. Cat. Whoops. Credentials. There it is. Okay, so if we look here, we can see that there are credentials set. It's a little bit different. We have this like session token. I guess it's to make sure that this expires over time. But if I was to take these, okay, and I was just to paste them in here, that's one way you would do it. You never ever want to do this, ever. Ever. You never want to do this because you'll end up committing that to your code. So this is really dirty to do, so I don't ever recommend to do it. If you wanted to have this apply to everything, you could put it up here. And so now when we call the client, we don't have to do it. Of course, if they're loaded on the machine, you don't have to do it. The other thing is, like, if you want, you could load them in via environment variables. That's usually what you want to do. So you say AWS access key, right? And then we say environment AWS access secret. And so you'd set those by doing, I think it's like an export, environment variables set in Linux. You'd think I'd know after like 15 years of doing this, but I never remember. So you type in export. So you go down into, here, you type in export, and you just say something like, I'm going to just show an example to see if it works. So I'm going to say hello world. Okay, and if I do hello like that, echo, see it prints it out. So that's how you would set it. You'd set those there, but there's actually very specific ones that AWS uses for the API, and it's these ones here. So you always want to use those. Okay, so you put that in there, and that in there. But of course, like if they're already set on your machine, you don't have to even specify those because it would auto load those environment variables. I don't think they're set right now. If we type in echo, just take a look here. Are they going to get auto loaded here? No. So, but anyway, so we could go here just as an example. And well, actually they just show them right here. So you see your access key, but we go and we type in export. And I'm going to paste the key in there, and I'm going to go to the front of it, and we're going to type AWS access key ID equals enter. And so now if I did echo on this, AWS access key ID, okay, it shows up. But I just want to show you how it can kind of vary and those conditions around it. So yeah, that is the AWS SDK. And yeah, a lot of times you're just copying, pasting code and just kind of tweaking it. You're not really writing real programming, okay? So hopefully that is less intimidating. So I'm just going to close these off. And I want to close down this Cloud9 environment. I might have to reopen this up in another tab and go to the management console here and then go over to Cloud9 and just close this tab. And then I'll go ahead and delete this environment. Oops, I'll just type delete here. Even if you didn't, it would turn off after 30 minutes and you have that free tier, so it's not that big of a deal. It's up to you whether you want to use Cloud9 or Git pods. Cloud9 is really good because it allows you to use, it runs on a virtual machine, right? So you have a container runtime there, and so it's very easy to run containers on it. Whereas in like, I've had some issues with Git pods, but Yeah, those are the two, okay? Well, let's take a look at AWS Cloud Shell, which is a browser-based shell built into the AWS Management Console. And so Cloud Shell is scoped per region. It has the same credentials as the logged in user, and it's a free service. So this is what it looks like. And the great thing about this is that, if you have a hard time setting up your own shell or terminal on your computer, or maybe you just don't have access or privilege to do so, it's just great that AWS makes this available to you. And so what you can do is click the shell icon up at the top, and that will expand this here. Some things to note about Cloud Shell is that it has some pre-installed tools. So it has the CLI, Python, Node.js, Git, make, pip, sudo, tar, tmux, vim, wget, vim, and more. It includes 1 gigabyte of storage free per AWS region. It will save your files in a home directory available for future sessions for the same AWS region. And it can support more than a single shell environment. So it has Bash, PowerShell, and ZSH. And so AWS Cloud Shell is available in select regions. So when I was in my Canada region, I was like, where's the little shell icon? But I realized it's limited for some areas. Okay. Hey, this is Andrew Brown from ExamPro, and we are taking a look at infrastructure as code, also known as IAC. And this allows you to write a configuration script to automate creating, updating, or destroying your cloud infrastructure. The way you can think of IAC, it's a blueprint of your infrastructure, and it allows you to easily share, version, or inventory your cloud infrastructure. So AWS has two different offerings for IAC. The first is CloudFormation, commonly abbreviated to CFN, and this is a declarative IAC tool. And then you have AWS Cloud Development Kit, commonly known as CDK, which is an imperative IAC tool. So let's just talk about the difference between declarative and imperative, and then we'll look at these tools a little bit closer each, okay? So declarative means what you see is what you get. It's explicit. It's more verbose, but there is zero chance of misconfiguration unless the file's so big that you're missing something. Commonly, declarative files are written in things like JSON, YAML, XML. So for CloudFormation, it's just JSON and YAML. And so that's that side there. So for imperative, you say what you want and the rest is filled in. So it's implicit. It's less verbose. You could end up with some misconfiguration. That's totally possible. But it does more than declarative. And you get to use your favorite programming language, maybe Python, JavaScript. Actually, CDK does not support Ruby right now, but I just have that in there just as a general description of what imperative is, okay? All right, so just a quick look at CloudFormation. So CloudFormation allows you to write infrastructure as code as either JSON or YAML. The reason why was AWS started with JSON, and then everybody got sick of writing JSON, and so they introduced YAML, which is a lot more concise, which you see on the right-hand side. So CloudFormation is simple, but it can lead to large files or is limited in some regards to creating dynamic or repeatable infrastructure compared to CDK. CloudFormation can be easier for DevOps engineers who do not have a background in web programming languages. A lot of times they just know scripting, and this basically is scripting. Since CDK generates out CloudFormation, it's still important to be able to read and understand CloudFormation in order to debug IAC stacks. Knowing CloudFormation is kind of a cloud essential when you go into the other tiers of AWS, like Solutions Architect, Associate, Professional, or any of the associates. You need to know CloudFormation inside and out, okay? Okay, so what I want to do now is introduce you to infrastructure as code. And so we're going to take a look at CloudFormation. And so we were just using Cloud9 for the SDK. So we're going to go back and create ourselves a new Cloud9 environment because we do have to write some code. So I'll go ahead and hit create here. And I'm going to just say CFN, that's short for CloudFormation example. And we'll hit next step. And we'll create ourselves a new environment, T2 micro. Amazon Linux 2 is totally fine. We'll hit next. It'll delete after 30 minutes. We'll be fine. We're within the free tier. We're going to give this a moment to load up. And remember, you can set your theme, your keyboard mode, whatever you want as that loads. And as that's going, we're going to look up CloudFormation. And so CloudFormation is very intimidating at first, but once you get through the motions of it, it's not too bad. So we'll go to the user guide here, as we always do. If you go to the getting started, it's going to just tell us some things. It's going to read about YAML files. I don't think I really need to read much about this here, so I think we'll just go start looking up some code. So something that might be interesting to launch is an EC2 instance, CloudFormation. So that's what I'll do is I'll type in what I want, so an EC2 instance, and I'll just start pasting in code. So if we scroll on down below here, I'm going to go to examples because I want a small example here. This is something that I might want to do. And we're going to give that a moment here. It's almost done. You can do it, AWS. Come on. As that is going, I'm going to open a new tab. I'm going to make my way over to CloudFormation. Okay. And you can see I have some older stacks here. Notice Cloud 9, when we create an environment, it actually creates a CloudFormation stack, which is kind of interesting. But if we go here, we can create a stack and we can create a file and upload it here. So, okay, so this is good. I'm going to go ahead and make a new file. We're going to call it template.yaml. Just so you know, YAML can be YML or YAML. There's a big debate as to which one you use. I think that AWS likes it when you use the full version, so I just stick with YAML. I'm going to double click into that. And so in this EC2 example, I'm just going to copy this, okay? And I'm going to paste this in here. And I'm going to type in resources. Oops, capital. Okay, so that's a resource I want to create. When you create CloudFormation, you always have a template version. So I just need a basic example here at the top. I guess that's a simple one, is like a hello world bucket. Maybe we should do a bucket because it'll be a lot easier. We don't have to make our lives super hard here. Okay. But what I'm looking for is the version, because that's the first thing that you specify. I'm just trying to find it within an example here. Oh, for frick's sakes. CloudFormation version. So if I don't have the format version, it's going to complain. There it is. Okay, so we'll copy that. We'll go back over here. We'll paste that in there. It might be fun to do like an output here. So I'm going to do like an outputs. And maybe instead of doing this, we'll type in AWS S3 CloudFormation. Because what I'm looking for is what we can set as output. So we'll say return values here. Maybe we just want returns the domain name. So we'll just say value ref, that's going to get the reference for it, and we have to say hello bucket. Type string. Say outputs CloudFormation example. And even though I've written tons of CloudFormation, it's just like if you're not doing it on day in, day out, you start to forget what it is. So here for outputs, we need a logical ID, description, value, and export. So that is what I want. So I'm going to go ahead and copy that back here. This is just so that when we run it, we're going to be able to observe an output from the CloudFormation file. Okay, so the logical ID is whatever we want. So hello bucket domain. It's funny because this is how you do kind of, that would be the format for Terraform. I was getting them mixed up. So the domain of the bucket, the value here is going to be ref hello bucket domain name. That's the output. Export. Value to export. Can I get an example here? House name. Oh, you know what? Export is for cross stacks. We don't need to do that. Okay, so that's fine. So what we'll do is set that, and we'll take out our old one. And so this should create us an S3 bucket. So with CloudFormation, you can provide a template here by providing a URL, or you can upload a file directly. So I'm just trying to decide here how I want to do this. You can also use a sample file or create a template in the designer. I'm going to go over to the designer because then we can just like paste in what we want. So if I go over to YAML here and we go back over here, I copy this. I'm just going to paste this in here. And we're going to hit the refresh button. Nobody ever uses the designer, but this is just kind of an easy example for me to place this in here. It's not really working. Maybe I gotta go to template, do it here. Refresh. There we go. So there's our bucket. It's nice to have a little visualization. And I believe this is going to work as expected. So now that we have our designer template, I think if we hit close, what's this button say? Validate template, probably a good idea, validating the template. Template contains errors, unresolved resource dependency in the output block of the template. Hello, domain, bucket. Seems like it should be fine. Let's go, whoops. Let's go back over here. That's what I did. I said reference that value. Oh, maybe it's get attrib. Okay. It's get ATT. Sorry. Get attrib CloudFormation. Can't remember if there's an R on the end of it. Oh, it's just ATT. This is if you're trying to get return intrinsic value. So a reference is like what the default one is, but every time we do like a logical name and attribute, that's how we get that there. So what I'm going to do here is just hit refresh, and I'm going to validate that one more time. Now it's valid. If I hover over this is going to upload it, create the stack. We could save this, save it. Oh, we can save it in an S3 bucket. So we'll say hello bucket. And so now we have this URL. So I'm going to copy it. Honestly, I never use this editor, so it's kind of interesting. I'm going to leave. And we probably could have hit create stack, but I just find it a bit easier if we just kind of do it through this here. So go back, create the stack. We're going to paste in the URL. We're going to say next. And we're going to say my new stack. And I didn't see what the name of the bucket was. Oh, there's no name, so it's going to randomize. That's perfect. So we'll go next. We have a bunch of options here. We'll hit next. We'll give it a moment here. I guess we have to review it, create the stack. And this is the part where we watch. So it says create in progress, and we wait, and we hit refresh. And we can see what's happening. It's trying to create a bucket. And if we go to resources, this is a lot easier to track because you can see all the resources that are being created. If you notice that when you use the when you're using the AWS management console to create an S3 bucket, it's instantaneous. But like with CloudFormation, there's a bit of a delay because there's some communication going on board. But here it is. And notice if we go to our outputs, this is the value of the bucket domain name if we were to make it with self-hosting, which is not what we're doing with it. We could also have an export name, which would be used for cross-referencing stacks, which is not something we care to do. But yeah, that's how you create a stack that way. But you know, we can also do it via the SDK here. So what I can do is look up what is the AWS CLI CloudFormation, because they have their own commands here. If I go here, there's a new one and there's an old one. So if we go create stack, yeah, there's things like this, like create stack, update. So if we wanted to do it this way, okay, and I copied this here. I'm just going to put this in my README here for a second. So here what you do is you say my new stack, and you can provide the template URL, or you could specify the local path here. So we have like a template body. So I'm going to go ahead and grab that. Okay, this would be like YAML. And I need to specify this file here. So template.yaml. And I'm just going to go pwd here to get the full path. Okay. And then I'm going to just paste that in there. Whoops. Okay, I'm going to do ls. Okay, so that gives us the full path to the file. We could also specify the template URL. And so this should work as well if I take this and paste that on as a command. Unable to locate parameter file. Oh, there's three triple slashes there. We'll just fix that there. Paste. Unable to load param file. No such file or directory. And there's a T missing. Okay. don't be like me and make sure you don't have spelling mistakes, okay? I can type clear down here so I can see what I'm doing. We'll hit enter, whoops. Unable to load the parameter file, no such file or directory. Home, well, you didn't want the /. So another thing we can try to do, I think it will take it relative. So if I do this, it should work. I don't ever remember having to specify the entire path. An error occurred while calling the create stack. My new stack name already exists. If I go back over here, give this a refresh. Oh, that's what we named our stack, the one that we did. So I'm going to say stack 2. Okay. Template format, unsupported structure when calling the create stack operation. Are you kidding me? I do this all the time. Template body, YAML file, CloudFormation. Unsupported structure. Take a look here. Oh, you know what? I think this one's out of date. That's why. So what we can do is go to our old stack here, and we can actually see the template. I can go ahead and copy this. Whoops. And we can go ahead and paste that in there. And then now what I can do, so, you know, that's the reason why it wasn't working. Okay, so we'll hit enter. Unsupported structure. It should be supported. Let's see if CloudFormation can help us out. Apparently there was very unhelpful error message formatting, so try the validate template option. I wonder if we could just do this. Maybe if that would help here. I'm just hitting up to try to run it again. Nope, I guess we can try to validate it here. It's like I'm not having much luck here today. So we'll just say this here. Maybe it's not even loading that file where it is, eh? So there's no errors. Just going to make this one line. Okay, created. So for whatever reason, I must have had a bug there. And so sometimes putting on one line helps that out because I must have had an obvious mistake there. And now we can see the stack is creating. It's doing the exact same thing. It's creating a different bucket though. If we go over to our S3 here. Again, you know, you don't need to be able to do this yourself to pass the exam. It's just so I'm just trying to show you like what it is so you kind of absorb any kind of knowledge about what's going on here. Notice down below it uses the stack name followed by the logical name of the resource there. Okay. And what we'll do is wait for that to create. Once that's created, we can go ahead and delete these stacks. We could also use the AWS CloudFormation to say like delete stack, but I don't want to bore you with that today. And so we'll hit refresh here, wait for those stacks to vanish. Okay, those are gone. What I'm going to do is kill this Cloud9 environment. If there's a way to do it from here, I have never known how to do it. Go back to your dashboard. Well, that's nice to know. And we'll go ahead and just delete this. Okay, we'll close that tab. And so now we are all in good shape. And so that was our introduction to CloudFormation, okay? Let's take a look here at CDK. So CDK allows you to use your favorite programming language to write infrastructure as code. And technically that's not true because they don't have Ruby, and that's my favorite. But anyway, some of the languages include Node.js, TypeScript, Python, Java, .NET. And so here's an example of TypeScript. TypeScript was the first language that was introduced for CDK. It's usually the most up-to-date. So not always does CDK reflect exactly what's in CloudFormation, but I think they're getting better at that, okay? So CDK is powered by CloudFormation. It generates out CloudFormation templates, so there is an intermediate step. It does sometimes feel a bit slow, so I don't really like that, but you know, it's up to you. CDK has a large library of reusable cloud components called CDK constructs at constructs.dev. This is kind of the concept of Terraform modules. It is really, really useful, and they're really well written, and they can just reduce a lot of your effort there. CDK comes with its own CLI. And I didn't mention this before, but CloudFormation also has its own CLI, okay? CDK pipelines allow you to quickly set up CI/CD pipelines for CDK projects. That is a big pain point for CloudFormation, where you have to write a lot of code to do this, whereas this CDK has that off the bat, makes it really easy for you. CDK also has a testing framework for unit and integration testing. I think this might be only limited to TypeScript because I didn't see any for the rest of the languages, but I wasn't 100% sure there. This one thing about CDK is that it can be easily confused with SDK because they both allow you to pragmatically work with AWS using your favorite language, but the key difference is that CDK ensures idempotence of your infrastructure. So what that means, that's such a hard word to say, but what that means is that if you use this CDK to say, give me a virtual machine, you'll always have a single virtual machine because it's trying to manage the state of the file. Whereas when you use SDK, if you run it every time, you'll end up with more and more servers, and it's not really managing state. So hopefully that is clear between the difference there. Okay, so we looked at CloudFormation, but now let's take a look at CDK, Cloud Development Kit. It's just like CloudFormation, but you use a programming language in order to implement your infrastructure as a code. I don't use it very often. I don't particularly like it, but if you are a developer and you don't like writing CloudFormation files and you want to have something that's more pragmatic, you might be used to that. This, I think, should be deleting because we were deleting the last one here, and notice how it's grayed out. I can't select it, so don't worry about that. Create a new one. We'll say CDK example. We'll hit next. T2 micro, EC2 instance, Amazon X2. You know the drill. It's all fine here. We're going to go ahead and create ourselves a new environment. We're going to let that spin up there. And as that's going, we're going to look up AWS CDK. So AWS CDK, and we probably want to go to GitHub for this. Okay, because it is open source. And so I want to go to getting started. And I have used this before, but I never can remember how to use it. Probably the easiest way to use this is by using TypeScript. So here's an example. Initialize a project, make directory, CDK. Oh, first we got to install it, right? So give that a moment. So this is Node. You know how we did like bundle install? This is like the same thing, but for TypeScript. Install or update the AWS CDK CLI from NPM. We recommend using this version, et cetera. So again, we're just waiting for that to launch. But as we wait for that, it's very simple. We're just going to install it, create a directory, go into that directory, initialize the example. Here it's setting up an SQSQ, which is that's quite a complex example. But you can see it's code, right? And then we run CDK deploy, and it will deploy it. And then hopefully we'll have that resource. So again, we're just waiting for Cloud 9. There we go. So Cloud 9 is more or less ready. Terminal seems like it's still thinking. And we have a JavaScript one, which I do not care about. There we go. There's our environment. We're going to make sure we have NPM. So we can type in NPM. Great. It says version 8.1.0. And so this is asking for 10. Okay, I don't know if this gives us like NVM installed. NVM? It does. So what we can do is do NVM list. That stands for Node Version Manager. Ruby has one as well. And so it's telling us what version we're on. I want to update. It looks like we have a pretty new version, but what I want is the latest version of, but that's Node version. That's not necessarily NPM. So we'll do Node version. Oh, 17. Okay, we're well in the range of the new stuff. So what I'm going to do is scroll on down. We're going to grab this link here, or this code here, hit enter. And that's going to install the AWS CDK. So it says file already exists. Oh, so maybe it's already installed on the machine. CDK, we'll just type in CDK. Because of course, AWS wants to make it very easy for us. This software has not been tested with, what was that warning? With Node 17.01, you may encounter runtime issues. Great, AWS. You're like the one that installed this stuff here. So we get a bunch of the commands, which is great. And so what we'll do is follow their simple instructions. We'll say, hello, CDK. We will CD into this. And now what we can do is run CDK init and this language here. And so that's going to do a bunch of stuff, creates tons of files. It's going to vary based on what you're using, like which language, because CDK comes available in a variety of languages. So if we type in AWS CDK documentation here, notice up here, Python, Java, .NET. So I think it has more than just those 3 languages, but you know, I wish it supported more. Like, yeah, see here is C#, Java, but I really wish there was a Ruby. So we'll give this a moment here to get installed, and I will see you back here when it is done, okay? Okay, it turns out I only had to wait like a second there, but it says there's a newer version of the CDK. You probably should install it, but I just want to get going here. So as long as I don't run into any issues, I do not care. But anyway, so looking at this, and again, I rarely ever look at this, but I'm a developer, so it's not too hard for me to figure out. But under the lib, this is our stack that we're creating. And here it is loading in SQS, it's loading in SNS, and then the core library, it's creating an SQS queue, and it's setting the visibility of that timeout. It's also creating an SNS topic. So those are 2 resources that we expect to be created. If we scroll on down to the getting started, it just says CDK deploy. So what we'll do is go ahead and hit enter and let that do whatever it wants to do. And it is thinking. There we go. So here we have IAM statement changes. So it's saying this deployment will potentially make potential sensitive changes according to your current security approval options. There may be security related changes not in this list. Do you want to deploy? Sure. We'll hit Y. Deploying, creating CloudFormation change set. So CDK is using CloudFormation underneath. It's not complicated. And as that is going, what we'll do is we'll make our way over to our AWS Amazon.com console. And if we go over to CloudFormation, we'll see if we see anything yet. So it's creating a stack here. We can click into it. We can go over to our events, see that things are being created. This is always a confusing, so I always go to resources to see what is individually being created, and they're all done. So we go over here, and they exist. So here it says that we have a queue called this, right? Sometimes they have links, you can link through it. So notice here I can click on the topic and get to that resource in SNS, which is nice. For SQS, I'm just going to type in SQS, enter, and there it is, okay? So we don't really understand what those are. We could delete the stack this way. There's probably a CDK way to delete the stack. So CDK destroy. I assume that's what it is. Destroy. Okay, so we'll type in CDK destroy. Give it a moment. We're going to say yes. Okay, it's deleting in progress. We can even go back here and double check. Still thinking. And again, you know, if we deleted these for real, it would take like a second. But, you know, sometimes they're just slow. Sometimes it's because a resource can get hung as well. But I don't think anything is a problem. So here we can see what the problem is. Not necessarily a problem, but it's just the SQS is taking a longer time to delete, where the SNS subscription is a lot faster. So I'll just see you back here in a moment, okay? Okay, so after a short little wait there, it finally finished. I just kept on hitting refresh until I saw it deleted, and so it's out of there. And so we'll get rid of our Cloud9 environment since we are done with it. So we'll type in Cloud9 up at the top. And we'll go ahead and delete. And we will go ahead and delete this here. Thank you. And we will go back to our AWS Amazon.console here, just so we can get our bearings straight here. And there we go. All right, let's take a look here at the AWS Toolkit for VS Code. So AWS Toolkit is an open source plugin for VS Code to create, debug, deploy AWS resources. Since VS Code is such a popular editor these days, I use Vim, but it's very popular. I figured I should make sure you're aware of this plugin. So it can do 4 things. You get the AWS Explorer. This allows you to explore a wide range of AWS resources linked to your AWS account. And sometimes you can view them, sometimes you can delete them. It's going to vary per service and what's available there. Then you have the AWS CDK Explorer. This allows you to explore your stacks defined by CDK. Then you have Amazon Elastic Container Service, ECS. This provides IntelliSense for ECS task definition files. IntelliSense means that when you type, and you'll get like auto completion, but you'll also get a description as to what it is that you're typing out. Then there is serverless applications, and this is pretty much the main reason to have the AWS Toolkit. It allows you to create, debug, deploy serverless applications via SAM and CFN. And so there you can see the command palette, and you can kind of access stuff there, okay? Let's take a look here at access keys. So an access key is a key and secret required to have pragmatic access to AWS resources when interacting with the AWS API outside of the AWS Management Console. So access key is commonly referred to as AWS credentials. So if someone says AWS credentials, they generally are talking about the access key, not necessarily your username and password to log in. So a user must be granted access to use access keys. So when you're creating a user, you can just checkbox access key. You can always do this after the fact, but it's good to do that as you're creating the user. And then you can generate an access key and secret. So you should never share your access keys with anyone. They are yours. If you give them to someone else, it's like giving them the keys to your house. It's dangerous. Never commit access keys to a code base because that is a good place for it to get leaked at some point. You can have 2 active keys at any given time. You can deactivate access keys, obviously delete them as well. Access keys have whatever access a user has to AWS resources. So, if you can do it in the AWS Management Console, so can the key. So access keys are to be stored in the AWS credentials file. So, and if you're not familiar with Linux, this tilde here, this actually represents your home folder. So whether you're on Windows or a Linux, that's going to be your home folder. And then you have this period AWS. That means that it's a hidden folder, but you can obviously access it. And so it's just a TOML-like file. I think it's TOML, but I never 100% verified that it's TOML. It looks just like TOML. And so what you'll have here is your default profile. And so this is what you would use, or this is what any of your tools you use, like the CLI or anything else, would automatically use if you did not specify a profile. You can, of course, store multiple access keys and then give it a profile name. So if you are doing this for the first time, you might just want to type in AWS config and it'll prompt you and you'll just enter them in there as well. I think that sets the default one. When you're using the SDK, you would rather probably use environment variables because this is the safest way to access them when you are writing code. All right. So there you go. All right, let's talk about access keys. Access keys are very important to your account. And so what we'll do is go to IAM. If you are the root user, you can go in and you can generate access keys for people. But generally, you're doing it yourself for your own account. So I go to users. I'm going to click into mine here, and we'll go over to security credentials. And here, you're going to notice access keys. And one thing that is interesting is that you can only ever have 2 access keys at a time. So if I hit create, I'm just going to close that. Notice that the button is grayed out. I can deactivate them if I feel that I haven't used them in a while, and I can make them active again so I can bring them back into access. Or what I can do is make them inactive, right? And then I can delete them. And so what I recommend, right, even if you do not want to pragmatically be using your account for anything, you always want to fill up both these. And the reason why, and this is for security reasons, is that if somebody wanted to come in and get into your account, what they would do is they would try to find a user where they have access to them, and then they would try to generate out a key. So if both these keys are taken up, so if you generate out both these keys, okay, and this is the one you want to use, you deactivate the other one, okay, we're not going to use that one. And so now there's no way for them to fill up that other slot, okay? And so that is my strong recommendation to you, but there's, again, only ever 2 here. I'm just going to delete both of these so that when we want to do whatever next in a tutorial, we'll go generate that out, okay? So I'm going to go ahead and clear that out. So hopefully that is enough for you to understand what to do with these access keys, okay? So I'm going to go back here. There you go. Let's take a look here at AWS documentation, which is a large collection of technical documentation on how to use AWS services, which we can find at doc.aws.amazon.com. And so this is kind of like the landing page where you can see all the guides and API references. If you expand them in there into EC2 and you click on the user guide, you can see HTML in PDF format, Kindle, and you'll notice there's a link to GitHub, and that's because all of these docs are open source and you can contribute to them if you choose to do so. I've done so multiple times in the past. It's quite fun. So AWS is very good about providing detailed information about every AWS service, and the basis of this course and any AWS certification will derive mostly from the AWS documentation. So I like to say that I'm not really coming up with new information. I'm just taking what's in the docs and trying to make it more digestible. And I think that's the thing is like, the docs are really good. You can read them end to end, but they are very dense. And so it can be a bit hard to figure out what you should read and what you should not. But they are a really great resource and you should spend some time in there, okay? So I just want to quickly show you the AWS documentation, like give you a bit of a tour of it. So if we go to aws.amazon.com and type in docs, and I'm sure you might have seen this through other tutorials, but the idea is that you have basically documentation for basically any possible service that you want. And a lot of times you'll click into it and what you'll get are these little boxes and they'll show you different guides and it's going to vary based on service, but a lot of times there's a user guide, there's an API reference. And those are the two that you'll see there. Maybe we go to something simpler like S3. That might be a simpler example. Yeah, user guide, API reference. And so all of these are on GitHub, right? If you open these up, the documentation is here. If you find something you don't like, you can submit issues and correct things. You can even submit your own examples. I have committed example code to the docs specifically for AI services. So you might be looking at examples that I implemented or even Ruby examples since I really like to promote Ruby on AWS. And you can download it as a PDF or you can take it as HTML. A lot of times you're going to the user guide, and the way I build the courses here is I actually go through and I read these end to end. So, you know, if you wanted to do that and you want to be like me, you can do that, or you can just watch my courses and save yourself the trouble and not worry about everything that is here. But generally the documentation is extremely, extremely good. There are some exceptions like Amazon Cognito where the content is good, but it's just not well organized. So I would say AWS out of every other provider, they have the most complete documentation. They generally don't keep their examples or like tutorials within here. It's usually pretty light. They'll have some examples, but like they like to have AWS Labs separately. So you type AWS Labs GitHub, right? You go here, and a lot of stuff is in here instead. So you have a lot of great tutorials and examples over there, okay? But yeah, pretty much that's all there is to it. Is there consistency between documentations? No, they kind of vary. You know, but it's all there is my point, and they're always keeping up to date. So yeah, that's all you need to know about the AWS documentation. Hey, this is Andrew Brown from ExamPro, and we are taking a look at the Shared Responsibility Model, which is a cloud security framework that defines the security obligations of the customer versus the cloud service provider. In this case, we're talking about AWS, and they have their own shared responsibility model. It's this big ugly blob here. And the thing is that every single CSP has their own variant on the model. So they're generally all the same, but some visualizations make it a little bit easier to understand, or they kind of include a little bit more information at different parts of it. And so just to make sure that you have well-rounded knowledge, I'm going to go beyond the AWS's shared responsibility model and just show you some variants. There's also variants not just per CSP, but also the type of cloud deployment model. And sometimes these are also scoped based on a cloud service category like compute or machine learning. And these can result in specialized shared responsibility models. So that's what we'll look at in this section, okay? All right, so let's take a look at the AWS Shared Responsibility Model. And so I've reworked the graphic because it is a bit hard to digest. And so I'm hoping that this way will be a little bit easier for you. I cannot include the in and of here just because we're limited for space, but don't worry, we'll follow that up with the next slide here. So there are two people that are responsible, or two organizations that are responsible, the customer and AWS. And on AWS's side, they're going to be responsible for anything that is physical. So we're talking about hardware, global infrastructure. So the regions, the availability zones, the edge locations, the physical security. So think of all that hardware that's there, those data centers, everything like that. Then there's also software, the services that they're offering. And so, this extends to all their services, but generally it breaks down to the four core. And so we're talking about compute, storage, database, and networking, okay? And when we say networking, we're talking about like physically setting up the wires and also, the software to set up the routing and all that kind of stuff there. Now, looking at the customer side of it, they're responsible for configuration of managed services or third-party software. So the platforms they use, so whether they choose to use a particular type of OS, the applications, so if they want to use like Ruby on Rails, IAM, so identity and access management. So if you create a user and you grant them permissions, if you give them things they're not supposed to have access to, that's on you, right? Then there's configuration of virtual infrastructure and systems. So that would be choosing your OS. That would be the networking. So there could be networking on the virtual machines themselves, or we could be talking about cloud networking in this case. Then there are firewalls. So we're talking about virtual firewalls. Again, they could be on the virtual machine, or it could be configuring like NACLs or security groups on AWS. Then there's security configuration of data. And so there is client-side data encryption. So if you're moving something from S3 from your local machine to S3, you might need to encrypt that first before you send it over. Then there's server-side encryption. So that might be turning on server-side encryption within S3 or turning encryption on your EBS volume. Then there's networking traffic protection. So, that's turning on VPC flow logs so you can monitor them, turning on AWS guard duty so that it can detect anomalies with your traffic or activities within your AWS account. And then there's customer data. So that's the data that you upload on the behalf of your customers or yourself, and what you decide to, like what levels of sensitivity that you want to lock it down. Do you want to use Amazon Macy to see if there's any public-facing personally identifiable information? That's up to you. So there's a lot here. And honestly, it's a lot easier than you think. Instead of thinking about this big diagram, what I do is I break it down into this. And so we have the in and the of, and that's what I said I could not fit on the previous slide there. But the idea is customers are responsible for the security in the cloud. So that's your data and configuration. So if it's data that's residing on there, or is there something you can configure, you are responsible for it. On the AWS side, they are responsible for the security of the cloud. So if it's anything physical or hardware, the operation of managed services or global infrastructure, that's going to be on them. And this in and of thing is very important for the exam, so you should absolutely know the difference between the two. This is kind of an AWS concept. I don't see any other cloud service provider talking about in and of, so you definitely need to know it, okay? So one variant we might see for the shared responsibility model would be on the types of cloud computing. This could also be applicable to the types of deployment models, but we're doing types of cloud computing here. And so we have the customer's responsibility and then the cloud service provider's responsibility. So we're seeing on-premise, infrastructure as a service, platform as a service, and software as a service. And so when you are on-prem, you're basically responsible for everything: apps, data, runtime, middleware, OS, virtualization, servers, storage, networking, basically everything. And just by adopting the cloud, you're almost cutting your responsibilities in half here. So now the cloud service provider is going to be responsible for the physical networking, the physical storage, those physical servers. And because they're offering virtual machines to you, they're setting up a hypervisor on your behalf. So virtualization is taken care of for you. And so, if you launch an EC2 instance, you're going to have to choose the OS. So that's why you're responsible, whatever middleware there, the runtime, so whatever kind of programs you install on it, the data that resides on it, and any kind of like major applications, okay? Then we have platform as a service. And so, the cloud service provider is going to take even more responsibility there. So when we're talking about this, we're thinking like AWS Elastic Beanstalk, right? So, you just choose what you want and it's all managed. So you might say, I want a Ruby on Rails server, but you're not saying what OS you need. You're not saying exactly, you might say what version of Ruby you want, but you don't have to manage it if it breaks or it might be managed updates and things like that. But the last thing here is like software as a service. And this is something where the CSP is responsible for everything. So if you're thinking of a software as a service, think of like Microsoft Word, where you're just writing, writing stuff in there, and you are responsible for where you might choose to store your data, but the data is like still handled by the cloud service provider because it's on the cloud, so on their servers, right? So yeah, hopefully that gives you kind of an idea across types of cloud computing responsibilities. All right, so what I want to do here is just shift the lens a bit and look at the shared responsibility model if we were just observing a subset of cloud services such as compute. And so we're going to see infrastructure as a service, platform as a service, software as a service, and now we have function as a service. And so that's what I mean when we shift the lens, we get new information. And so you can just see that you really don't want to look at this from one perspective, okay? So starting at the top here, we have bare metal. And so AWS's offering is called the EC2 bare metal instance. And this is where you basically get the whole machine. You can configure the entire machine with the exception of the physical machine itself. So as the customer, you can install the host OS, so the operating system that runs on the physical machine. And then you can install your own hypervisor. And then AWS is going to be responsible for the rest, the physical machine. Now, normally the next step up would be dedicated, but dedicated doesn't exactly give you more responsibility. It gives you more assurance because it's a single tenant virtual machine. And that's why I kind of left it out here. But we'll see it in the next slide that it is kind of on the model and shares the same spot as EC2. But EC2 is a virtual machine. And so here the customer is responsible for the guest OS. So that means that you can choose what OS you want, whether it is Ubuntu or Debian or Windows, but that's not the actual OS that is running on the physical machine. And so you're not going to have control of that. AWS is going to take care of that. Then there's the container runtime. So, you can install Docker on this or any kind of container layer that you want. So that's another thing that you can do. So AWS is going to be responsible for the hypervisor, the physical machine, and the host OS. All right. Then looking at containers, AWS has more than one offering for containers, but we'll just look at ECS here. And so this is where you are going to have you don't install the guest OS, right? The guest OS is already there for you. What you are going to do is choose your configuration of containers. You're going to deploy your containers. You're going to determine where you need to access storage for your containers or attach storage to your containers. And AWS is going to be responsible for the guest OS. There might not even be a guest OS, but the host OS, the guest OS, the hypervisor, the container runtime, and you're just responsible for your containers, okay? Then going to the next level here, we have platform as a service. And so this one also is a little bit odd where it fits because the thing is that this could be using anything underneath. It could be using containers. It could be using virtual machines. And so that's where it doesn't exactly fit well on a linear graph. But let's just take a look at some things here. So this is where you're just uploading your code. You have some configuration of the environment. You have options of deployment strategies, the configuration of the associated services, and then AWS is going to be responsible for the servers, the OS, the networking, the storage, the security. So it is taking on more responsibility than infrastructure as a service, whereas, AWS is just going to be responsible for that. So if it's a virtual machine that's being under the use, then AWS is going to be responsible for this customer stuff. Okay, you're not. If it's containers, then AWS is going to be responsible for this, but it just depends on how that platform as a service is set up. Actually, the way Elastic Beanstalk is set up is that you actually have access to all that infrastructure and you can fiddle with it. And so in that case, whereas like if you were to use Heroku, which is a third-party provider, they would take care of all this stuff up here. And so you would not have to worry about it. But on AWS, you actually are responsible for the underlying infrastructure because you can configure it, you can touch it. So that's where, again, these do not fit perfectly. And you can't look at platform as a service, meaning that you're not responsible for certain things. It really comes down to the service offering, okay? Then we're taking a look at software as a service. So on AWS, this is going to be something like Amazon WorkDocs, which is, I believe, a competitor. Not a very popular competitor, but a competitor to Microsoft SharePoint. This is for content collaboration. So as the customer, you're responsible for the contents of the document, management of the files, configuration of sharing access controls, and the database is responsible for the servers, the OS networking, the storage, the security, and everything else. So, if you use a Microsoft Word doc and you type stuff in it, you say where to save it, that's what you're responsible for, okay? The last one here on the list is our functions here. And so AWS's offer is AWS Lambda. And so as the customer, all you're doing is you're uploading your code, and AWS is going to take care of the rest. So deployment, container runtime, networking, storage, security, physical machine, basically everything. And so you're really just left to develop, okay? So, hopefully that gives you kind of an idea. And again, we could have thrown in a few other services. Like what we could not fit on this slide here was AWS Fargate, which is a serverless container as a function, or sorry, serverless container as a service, or container as a service. So, that has its own unique properties in the model as well, okay? So let's just have kind of a visualization on a linear graph here. So we have the customer's responsibility on the left-hand side and AWS's responsibility on the right. And we'll look at our broad categories. So we got bare metal, dedicated, virtual machines, containers, and functions. And so no matter which type of compute you're using, you're always responsible for your code. For containers, if the functions, when you're using functions, there are pre-built containers. So you'd say, I want to use Ruby, and there's a Ruby container, and you don't have to configure it. But obviously, when you are using container service, you are configuring that container. You are responsible for it. For virtual machines, you're responsible for the runtime, so you can install a container runtime on there or install a bunch of different packages like Ruby and stuff like that. The operating system you have control over in the virtual machines for the dedicated. And we saw with bare metal, you have both controls of the host OS and the guest OS. And then only bare metal allows you to have control of the virtualization where you can install that hypervisor. So hopefully that gives you an idea of compute and AWS's offering there, and also kind of how there's a lot of little caveats when we're looking at the shared responsibility model, okay? All right, so I have one more variant of the shared responsibility model, and this one is actually what is used by Google. So we're going to apply to AWS and see how it works. So let's just kind of redefine shared responsibility model, or just in a slightly different way so we fully understand it. So the shared responsibility model is a simple visualization that helps determine what the customer is responsible for and what the CSP is responsible for related to AWS. And so across the top, we have infrastructure as a service, platform as a service, software as a service. But remember, there's other ones out there like function as a service. It's just not going to fit on here. Okay, so and then along the side here, we have content, access policies, usage, deployment, web application security, identity, operations, access and authentication, network security. Remember, that's cloud networking security, the guest OS, data and content, audit logging. Now we have the actual traditional networking or physical networking, storage and encryption. And here we're probably talking about the physical storage, hardened kernel, IPC, the boot, the hardware. And so then here we have our bars. So we have the CSP's responsibility and the customer's responsibility. So when we're looking at a SaaS software as a service, the customer is going to be responsible for the content. Remember, like think of like a word processor, you're writing the content, the access policies, like say I want to share this document with someone, the usage, like how you utilize it, can you upgrade your plan, things like that. Then next on our list here is platform as a service. So generally, platform as a service is for developers to develop and deploy applications. And so they will generally have more than one deploy strategy. And, there might be some cost saving measures to choose, like you might have to pay additional for security, or it's up to you to configure it in a particular way, or you might have to integrate it with other services. We saw that PaaS is not a perfect definition or fit because, when we look at Elastic Beanstalk, if you have access to those resources and you can change them underneath, then you might have more responsibility there than you think that you would, okay? The next one here is infrastructure as a service. And so this is extending to identity. So who's allowed to, log into your AWS account, operations, the things that they're allowed to do in the account, access and authentication. Do they have to use MFA? Things like that. Network security. Obviously, you can configure the security of your cloud infrastructure or cloud network. Do you isolate everything as single VPC? How do you set up your security groups? Things like that. We know with virtual machines, you can set up the guest OS, there's data and content. But remember that bare metal is part of the infrastructure as a service offering. And so that's where we'd see hardware, or not hardware, but you'd have the host OS or virtualization. And so this, again, is not a perfect representation, but it generally works, okay? And then last on the list there, or just looking at what the AWS is responsible for audit logging. So, of course, AWS has CloudTrail, which is for logging API events. But audit logging could be things that are internally happening with those physical servers. Then the networking, the physical storage, hardening the kernel. AWS has, I think, what's called the Nitro system, where they have like a security chip that's installed on all their servers. Then it's the boot OS, and then the hardware itself, okay? So just remember, the customer is responsible for the data and configuration of access controls that reside in AWS. So if you can configure it or you can put data on it, you're responsible for it, okay? The customer is responsible for the configuration of cloud services and granting access to users via permissions, right? So if you give one of your employees access to do it, even if it's their fault, it's your fault. So remember that. And again, the CSP is generally responsible for the underlying infrastructure, we say generally, because, there's edge cases like bare metal. And coming back to AWS's in the cloud and of the cloud. So in the cloud, so if you configure it or store it, then you, the customer, are responsible for it. And of the cloud, if you cannot configure it, then the CSP is probably responsible for it, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at the shared responsibility model from the perspective of architecture. And if you're getting sick of shared responsibility model, don't worry. I think this will be the last slide in this section, but let's take a look here. So we have less responsibility, more responsibility at the bottom. So what we have down here is traditional or virtual machine architecture. So global workforce is most familiar with this kind of architecture, and there's lots of documentation frameworks and support. So maybe this would be using Elastic Beanstalk with Platform as a Service, or using EC2 instances alongside with auto-scaling groups, code deploy, load balancers, things like that. The next level here is microservices or containers. This is where you mix and match languages, better utilization of resources. So maybe you're using Fargate, which is serverless containers, or Elastic Container Service, or Elastic Kubernetes Service for containers. And at the top here, we have serverless, or commonly with functions as a service. So there are no more servers. You just worry about the data and the code, right? So literally just functions of code. And so you could be using the Amplify serverless framework, or maybe AWS Lambda for creating serverless architecture. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at computing services. And before we jump into the entire suite of computing services AWS have, let's just talk about EC2 for a moment, which allows you to launch virtual machines. So what is a virtual machine? Well, a virtual machine, or VM, is an emulation of a physical computer using software. Server virtualization allows you to easily create, copy, resize, or migrate your server. Multiple VMs can run on the same physical server, so you can share the cost with other customers. So imagine if your server or computer was an executable file on your computer, okay? So that's the kind of way you want to think about it. When we launch a VM, we call it an instance. And so EC2 is highly configurable server where you can choose the AMI, so the Amazon machine image, that affects options such as amount of CPUs or vCPUs, virtual CPUs, the amount of memory, so RAM, the amount of network bandwidth, the operating system, so whether it's Windows, Ubuntu, Amazon OS2, the ability to attach multiple virtual hard drives for storage, so Elastic Block Store. And so the Amazon machine image is a predefined configuration for a VM, so just remember that. And so EC2 is also considered the backbone of AWS because the majority of AWS services are using EC2 as the underlying servers, whether it's S3, RDS, DynamoDB, or Lambdas, that is what it's using. So when I say also, it's just because when we talk about the AWS network, that is the backbone for global infrastructure and the networking at large. And so EC2 is for the services, okay? Hey, this is Andrew Brown from ExamPro. So we just looked at what EC2 is. Well, let's look at more of the broader services for computing. And these are the more common ones that you'll come across. There's definitely more than just what we're going to see on this single slide here. So we'll break this down with virtual machines, containers, and then serverless. For virtual machines, remember, that's an emulation of a physical computer using software. And EC2 is the main one. But for our VM category, we have Amazon Lightsail. This is a managed virtual server service. It is the friendly version of EC2 virtual machines. So when you need to launch a Linux or Windows server, but you don't have much AWS knowledge, you could launch a WordPress here, and you could hook up your domain and stuff like that. So this is a very good option for beginners. We have containers, so virtualizing an operating system or OS to run multiple workloads on a single OS instance. So containers are generally used in microservice architecture when you divide your application into smaller applications that talk to each other. So here we would have ECS, Elastic Container Service. This is a container orchestration service that supports Docker containers, launches a cluster of servers on EC2 instances with Docker installed. So when you need Docker as a service, or you need to run containers. We have Elastic Container Registry, ECR. This is a repository of container images. So in order to launch a container, you need an image. An image just means a saved copy. A repository just means a storage that has version control. We have ECS Fargate, or just Fargate now. People are kind of forgetting that it runs on ECS these days. That's why I have it in there. It is a serverless orchestration container service. It is the same as ECS, except you pay on demand per running container. So with ECS, you have to keep a EC2 server running, even if you have no containers running. So it manages the underlying server, so you don't have to scale or upgrade the EC2 server. So there's the advantage over ECS, okay? Then we have Elastic Kubernetes Service, EKS. This is a fully managed Kubernetes service. Kubernetes, commonly abbreviated to K8, is an open source orchestration software that was created by Google and is generally the standard for managing microservices. So when you need to run Kubernetes as a service, then we have serverless category. So when the underlying servers are managed by AWS, you don't worry or configure servers. So AWS Lambda is a serverless function service. You can run code without provisioning or managing servers. You upload small pieces of code, choose how much memory, how long you want the function to run, is allowed to run before timing out, and you are charged based on the runtime of the serverless function rounded to the nearest 100 milliseconds. So there you go. Hey, this is Andrew Brown from ExamPro, and what I want to do is just show you a variety of different computing services on AWS. So I'm going to try to launch them, and we're not going to do anything with them. We're just going to simply launch them, okay? So the first I want to show you is EC2. And by the way, we will go more in depth in EC2 later on in this course here. But what I'm going to do is go ahead and launch the instance. Don't worry about all this stuff, but just choose the Amazon Linux 2, so it's in the free tier. All right, we're going to choose an instance type of a T2 micro, so that's part of the free tier. It's going to be set as 1. All these options are fine. I want you to go ahead and review and launch. We're going to launch, and I don't want to generate on a key pair. I'm going to proceed without a key pair. I'm going to acknowledge that because I don't want it. And that's all there is to launching an EC2 instance. And so I can go here and view my instances. And what you'll see is it's pending, okay? And usually it has like a little spinning icon. Maybe they've updated it since then. So I go here. It's hard to see because there's all these terminated ones, but I don't need to do anything with it. I just wanted to show you the actions that you'd have to do to launch it. Actually, we'll leave it alone. Maybe we'll see it when it's launched. The next one I want to show you is Elastic Container Service. And wow, this is old. Let's go. Let's get the new experience, please. It's so old. Okay, checkbox that on, and we'll hit get started, and we'll say create a cluster. And we have some options here: networking only, EC2 Linux plus networking, for use with either AWS Fargate or external Windows. This is if you're doing Fargate, which we're not doing right now. Fargate is part of Elastic Container Service. It used to be. It is called ECS Fargate, but AWS markets it as a separate service. We'll go to next and say my ECS cluster. We can create an empty cluster, but that would make it a Fargate cluster, which we don't want. There's an on-demand server. Look, it's M6I large. If you're very afraid of a lot of spend here, you don't have to do this. You can just watch me do it and just learn. Well, what I'm going to do is try to find something super cheap. So I want a T2 micro or a T3 micro. T2 micro is part of the free tier. I don't know if we get to choose T2 anymore in here. They might not let you. There it is. You know, T3 micro is great too. Whatever says it's free, that's what I'm going to go for. Number of instances, 1. The Amazon Linux version is fine. I don't care about a key pair. Use the existing VPC. I don't want to have to make a new one. Select the existing ones, okay? Let it create a new security group. That's totally fine. Allow those to be fine. Create a new role. That's fine. Create. Okay. And so that's going to create ourselves a cluster. I'm going to just make a new tab here. Let's just check on our EC2 instance. And so if we look at our EC2 instance, it is running. Okay, great. So it has a private IP address. It has a public IP address. All right. There's not much we can do with it. I can't even log into it because we didn't generate out a key pair. A lot of times you want to name these things. So I can just go here and name it my server. Okay. We go back to our ECS instance and the cluster is ready. So we'll go here and oh, nice. We got a new UI. And so if we wanted to deploy something as a service or a task, we would need to create a template, like a task definition file. They don't have a new UI for this. You're being redirected to the previous version console because this isn't available in the new experience yet. Of course it isn't. So we can create a new task definition file. That's what's used to run it. It's basically like a Docker file, compose file, whatever you want. We have Fargate or EC2. We are doing ECS, so we're going to have to do EC2. So we'll say my ECS task def file. Task role, optional IAM role. I don't need one. Network mode, I don't care. And then this is the idea is that because a container allows you to use up a particular amount of the thing, we don't have to use all of the memory. So we should look up what a T2 micro is because I don't even remember what size it is. Okay, T2 micro, AWS. So we go here, we look at the instance types, and we're going to flip over to T2, and it says that it's 1 vCPU, 1 gigabyte of memory. So what I'll do, 1. Yeah, 1. Okay, that's fine. So what we want, and this is in megabytes, so we'll say 500 megabytes. And I don't know if we can do less than 1, but I'm going to do 1 here. The task CPU must be an integer greater than or equal to 128. Okay, fine, 128. Oh, I guess it's 1024 would utilize the whole thing. So I could say 512, okay? And this is where we would add our container. So I don't do this every day, so I don't remember how to do this. We'll say my container, and I need a repository here. So I need like Docker Hub Hello World. Okay, I don't care what it is. I just need a image. That's simple. And I'm looking for the address here. I'm hoping that's just this. Docker Hub URL. So it'd be something like this, right? Docker IO probably. Docker IO, Docker image, Docker Hub URL in ECS. Okay, it goes to show how often I'm launching these things. So repository URL, Docker image. So I think that what we're going to do here, I would really just like the URL, please. Reviews, tags, where is it? Where is it? It's somewhere here, right? Well, let's just try it. We'll go and we'll type in, it says image and tag. So docker.io, hello world. I really need an image ID. Image URL, hello world, Docker Hub. They're not making my life easy here today. Anything. I just want to see like a single example. Docker.io. Docker.io URL examples. ECS. This is what it's like, you know? This is what you're going to be doing if you are, you know, a cloud engineer. You're going to be Googling a lot and just trying to find examples here. So here it says Docker.io, the name, the host name. Okay, so we'll just try it. Okay, so I think that the name here is underscore and then it's hello world, and that's what's throwing me off here, right? Docker.io. Just hold on here. Repository URL, and then there's the tag. I don't know if, like, is the tag going to be like latest, view available tags? Latest. Okay, so what I'll do here, and that's the thing, you have to have a lot of confidence too. So hard limit, soft limit, do I have to set it? Do I have to set any of these things? Can I just go to the bottom and hit add? Looks like I can. Okay, so we'll scroll on down, create. We create our task definition file, which is fine. We're going to go back to our cluster. It's going to bring us back to the new experience. We're going to click into this cluster. Holy smokes. We're going to hit deploy. And we are going to choose service. That means it's going to continuously run. Task means that when it's done running, it ends. We're going to choose our family, our version. That's the task definition file there. It's not compatible with the selected compute strategy. My task file. What if I just choose task? We'll take that. Okay, maybe some you have to like code it so that it continuously runs. I don't care. We don't need to run a service here. The selected task definition is not compatible with the selected compute strategy. Okay, let's see why. Can you double check if you're using Fargate strategy instead of the EC2 blog designed for the EC2 strategy? So probably what it's suggesting is that the strategy file I made is not for the right one here. Task definitions. Go back over here. Well, what's wrong with it? Task role, none. My container. So what I'm going to do, because I don't trust this, I'm just going to go ahead and delete this. Can I delete this? How do I delete this? Oh boy. Actions, deregister, deregister. We'll create a new one. And so AWS has tools like AWS Copilot CLI to make this a lot easier, because you can see this is very frustrating, but I chose this. So my task def requires compatibility of EC2. Default 512, 512, add container. We're going to, what was it, docker.io underscore, what's it called, hello world, latest. We'll just say hello world here. And we'll just say 512, which is fine. I don't care about any port mappings. I'm just reading it carefully here to see what it wants. We'll say 512. Maybe because I didn't specify them, it's complaining. This looks fine. We'll hit add. Okay. Constraints, type. This all looks fine. So we'll try this again. And so we now have our file. Let's see if we can just run this task from here. EC2. This is just another way to do it. So we just choose the cluster. This is actually a lot easier to do it. This is old, eh? This is ugly. And so now it launches. So, you know, if you have trouble one way, then just do it another way. And sometimes it'll work here. So I don't expect this task to really work in any particular way. If it's pending, that's fine. If it fails, that's fine. If it's successful, that's fine. I don't care. I just want to go through the motion. So it was successful. It ran and then it stopped. I don't know if we could see like the output anywhere. Probably what it would do is it would log out something like into somewhere. And so I don't know if like there's logs turned on for this. If I go over to like CloudWatch logs, maybe I could see something. A lot of these services will automatically create CloudWatch logs. So sometimes you can just go look at them there. So we'll drop down. We'll go to log groups here. There is some stuff here. There's a couple that I created from before. Just go ahead and delete those. And so what I'm looking for is like ECS. So no, there's no logging happening here, which is totally fine. So that is ECS. For Fargate, it's pretty much the same. The difference is that Fargate is like it has to start up and run, so it's a lot slower to watch. Okay. And now let's go take a look at Lambda. Okay. So this is our serverless compute. So we'll go ahead and create ourselves a function. We can start from a blueprint. That doesn't sound too bad. And I personally like Ruby, so well, I'm not getting much here. But what we can do is look for something like hello. Do we have like a hello world? There we go, hello world. And we'll click that, and we'll say my hello world. It's going to create those permissions. That's fine. It's showing us the code. It's very simple. Okay. It's going to console log out these values. Not a very good hello world function. Doesn't even say hello world. How can you call it a hello world function if it doesn't say hello world? I don't understand. So we're going to go ahead and create this function. Usually doesn't take this long. Okay. So here is our function. Here is our code. Notice that this is Cloud9. Okay. And you can even move that over to Cloud9. They didn't have this button here before. That's kind of cool. I hit test. They used to have it up here, but I guess they wanted to make it more obvious. So they moved it down here, which is nice. So what I can do is hit this, oops, my test. And it's going to send a payload here to the actual function. And it's going to tell us if it worked. Okay, so can I run my test? We go over here to test. They changed it a bit. So I guess I created it there. It succeeded. So I have my logs. Okay, so it's going to output those values there. So there are the 3 values, which basically is nothing. Maybe you were supposed to set those as an environment variable, but you can see you're just uploading some code, right? It's just a bit of code. It's not like a full app or anything. So we launched an EC2 container. We did an EC2 instance, a container. We did a serverless function. There's other things like EKS, but that is really, really hard to set up. Okay, because you'd have to use like Kubernetes commands and stuff like that. And my Kubernetes knowledge is always very poor. I'm just taking a peek here to see if they've updated it. So yeah, you create the cluster, but like deploying it is, forget it. I'm just trying to think if there's anything else I kind of want to show you. No, those are the main 3, I would say. So I'm pretty happy with that. What I'm going to do is go and kill all these things. So we're going to go over to Lambda. Okay. And I'm going to go ahead and delete this. And as you saw, ECS was the hardest. And no matter how many times I've built things on ECS and I've deployed full things on ECS, I can't remember. And I always have so much trouble with task definition files. It's unbelievable. We'll go over to our cluster here. And ECS cluster up here. Make sure you're not in the Fargate cluster. I know I'm clicking really fast, but there's just so many things to click. And I'm going to click into this cluster. We're going to go hit edit, because this is running an EC2 instance, right? I need to destroy it. It just took me back to the old one here. I want to delete the cluster. Click back here. Where do I delete it? Up here? Here? I can't checkbox anything. How do I delete this? Do I have to delete the task first maybe? So we'll go here. I mean, it's already stopped. There's nothing to do. Edit. Account settings? Wow, this is confusing. Okay. How to delete ECS cluster. You gotta be kidding me. I have to actually look this up. So open the ECS console from navigation. In the navigation, choose clusters. In the new, turn off new ECS experience and choose the old console. The delete cluster workflow is not supported in the ECS console. Are you serious? Then why do you have it? Like, why even let people use the new experience if you don't have all the functionality there? Oh, I was going to give it feedback, but it didn't let me. Here it says, I need to delete an ECS cluster. No. Okay, so I'm here. There's my big ugly cluster. Delete cluster. Okay? So yeah, it's a struggle, okay? Like, things are always changing on me. But you just have to have confidence, and if you've done it a few times, you know that you can do it, right? And that's one of the biggest hangups to cloud, I would say. So it's going to take a few minutes, apparently, to delete the cluster. As that is going, let's go over to EC2. I didn't close it. I kept this tab open. And there's our EC2 instance. We can go ahead and terminate that instance. Terminate. Okay. And if this says it's terminating, then we're in good shape. Terminating or shutting down, that's fine. And notice here, that's the ECS instance. Just make sure you shut down the my server, not the ECS instance, because that's going to stop. And so this is already terminated. But if we go back here, notice that it says that it's not done, but it clearly has shut down. Okay. So I'm going to wait here for a bit, even though I know it's been deleted. Maybe it's deleting things like the auto scaling group. So we go down below here, right? So that's probably what it's doing. It's probably trying to destroy the auto scaling group. But it doesn't show any here, so it must have already destroyed it. Yeah, so the task service is delete. So I'll be back here in a bit, but I know it's safe. It's already deleted, but I'll see you back here in a bit, okay? So I waited literally a second, and it's now deleted. So we deleted our Lambda. We deleted our... Oh, did we delete our Lambda? Good question. Now, I'm not really worried about the Lambda because... I guess we did, but I'm not really worried about it because... you know, when it rests at idle, it's not costing us anything, where the ECS and the EC2 are backed by EC2 instances, so we do have to shut those down, okay? And again, remember, make sure you're in the correct region. Sometimes that gets flipped over, and then you think those resources are gone, but they're actually not. They're just running in another region. So there you go. Hey, this is Andrew Brown from ExamPro, and we're taking a look at higher performance computing services on AWS. So before we do, we got to talk about the Nitro system. So this is a combination of dedicated hardware and lightweight hypervisor, enabling faster innovation and enhanced security. All new EC2 instance types use the Nitro system, and the Nitro system is designed by AWS, okay? So this is made up of a few things. We have Nitro cards. These are specialized cards for VPCs, EBS, instance storage, and controller cards. You have Nitro security chips. These are integrated into the motherboard, protects hardware resources. And we have the Nitro hypervisor. This is the lightweight hypervisor memory and CPU allocation, bare metal-like performance. There's also Nitro enclaves, but you know, that's a bit out of scope here. But that has to do with like EC2 isolation, okay? Then we have bare metal instances. So you can launch EC2 instances that have no hypervisor, so you can run workloads directly on the hardware for maximum performance and control. We have the M5, the R5 EC2 instances that can run bare metal. There's other ones I believe I've seen as well, but you know, if you are running bare metal, you can just go investigate at the time of, okay? We have BottleRocket. This is a Linux-based open source operating system that is purpose-built by AWS for running containers on VMs or bare metal hosts. Then let's just define what HPC is. So it's a cluster of 100 of thousands of servers with fast connections between each of them with the purpose of boosting computing capacity. So when you need a supercomputer to perform computational problems too large to run on a standard computer or computers, or would take too long, this is where, you know, HPC comes into play. One solution here is AWS Parallel Cluster, which is an AWS-supported open-source cluster management tool that makes it easy for you to deploy and manage high-performance computing HPC clusters on AWS. So hopefully that gives you an idea of this stuff, okay? All right, so let's take a look at HPC, or high performance computing on AWS. So HPC is for running large complex simulations and deep learning workloads in the cloud with a complete suite of high performance computing product services. Gains insight faster and quickly, move from idea to market, blah, 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 blah. It's for ML, or very complex scientific computing stuff. These run at least on C5Ns, okay? And the way it works is that you use this CLI called pcluster for AWS Parallel Compute, or AWS Parallel Cluster stuff. And so let's see if we can get this installed very easily. So what I'm going to do is see how hard it is to install. Now, I don't recommend you running this because I don't know what it's going to cost me. And if I make a misconfiguration, I don't want you to have that spent here. But I don't think it's that dangerous. So I'm going to go back over to US East 1 here. I'm going to open up Cloud Shell. And I'm going to give it a moment to load. And so as that is loading, let's take a look at how we would go ahead and install this. So install the current parallel, AWS Parallel. I think we can just copy that line, okay? And so we have to wait for our environment to spin up, all right? So once it has spun up, we will install it. And then we will jump over to this tutorial here. Okay, so we'll give this a moment. And after waiting a little while here, it looks like our shell is ready. It looks like it's in bash. I'm just going to type in AWS S3LS as a sanity check. Okay. And it works. That's great. So we'll go back over here, and I'm going to go back up to install for Linux. And what I need is that single command. Where is it? So I'm certain that we already have Linux or Python installed, but I just want the command to install it. We saw it a moment ago here. I'm just going to back out till I can find it. One more. There it is. So it's under, oh, it's this link here. And that's what I talk about, the documentations being tricky. Sometimes you have to click these headings here to find stuff. So this is the first time installing it, so we'll grab that. Usually you're supposed to create in virtual environments with Python. I don't care. This is my cloud shell. It doesn't matter to me. So we're going to go ahead and download that, and hopefully it is fast. And it was super fast, which was really nice. And so what we'll do is go check out the pcluster version. Okay, and that looks fine to me. I'm going to go down below here to run our first job. The returns, it gives outputs. I don't think we need to configure it because we already have our CLI. So what I'm going to do is go ahead and create ourselves a new cluster. Beginning cluster creation, configuration file, config not found. So I guess we do have to configure this. Configure. And it's asking what region do we want to be in. If I have US East 1, I would choose it. For some reason, it's all the way for number 13. That is not a lucky number, but I'm going to choose it anyway. No key pair found in US East 1 region. Please create one of the following. So create an EC2 key pairs. No options found for EC2 key pairs. That's fine. So what I'll do is go over here. And we'll go over to EC2. And we will go over to key pairs, key pairs, key pairs, key pairs. We'll create ourselves a new one here. So we'll say HPC key pair, or just my HPC. So we know what it's for. We have PuTTY or PEM. We're going to do PEM because we're on Linux. We'll create that. And notice that it downloaded the PEM down here, and we're going to need that for later. And so what I'll do is I'll type in pcluster here again, configure. We'll choose 13. We'll choose number 1 here. Allowed values for the scheduler. I have no idea what these are. Let's choose the number 1. Allowed values for the operating system. Amazon Linux 2. I know what that is. Minimum cluster size 1. Maximum cluster size 2. Head notice instance. Oh, T2 micro. You can do that? Yeah, let's do it. I didn't know we could do that. Enter. Compute type T2 micro. Sure. So I thought that we'd have to use a C5N, but I guess apparently not. Automate VPC creation. Yes, of course. Network configuration. So allowed values for the network configuration. Head node in a public subnet and compute fleet in a private subnet. Head node and compute. We'll do it in the both just to make our lives easier. I don't care. First one sounds more secure, of course. And so, oh, it's creating a CloudFormation stack. Wow, this is easy. I thought this was going to be super painful. Okay, so we'll go over here. We'll go take a look at what CloudFormation's doing. All right. Now, I don't care if we actually run a task on here, but it was just interesting to go through the process to see how hard it was. And we will go look at what resources are being created. So it's creating an internet gateway. So it's literally creating a isolate VPC for it, which is totally fine, I guess. It's creating a subnet. It's creating a route table. Refresh here. I'm not sure how much it wants to create here. It just looks like VPC. That's all it's creating. I thought maybe the EC2 instances would show up here, but maybe it's going to launch that on a need-be basis. Okay, so that's all created. Oh, now it's doing a VPC gateway. I think VPC gateways cost money. Let's go take a look here. VPC pricing. Yeah, there's a transfer fee, so just be careful about that. You know, again, you can just watch along here. You don't have to do it. Default route depends on public. So now it's creating EC2 route. I don't know what an AWS EC2 route is. I've never seen that before. Sometimes what we can do is go into EC2 and then take a look on the left-hand side. You see anything in here? If we don't know what it is, we just type in EC2 route, CloudFormation. Sometimes CloudFormation is great for figuring out what a component is. Not all components are represented in the AWS management console. So specify route in the route table. Oh, it's just a route. Okay. And we'll go back here. We'll refresh. So that is done. Is the stack done? Created complete. Good. We'll go back to our Cloud Shell. It says you can edit your configuration file or simply do etc. So now let's see if we can create the cluster. I assume this would create EC2 instances. So the job scheduler you are using is SGE. This is deprecated in future. Use parallel cluster. Well, should have told me. Okay. There is a new version of 3.0.1 parallel available. I don't understand because I just installed it, right? We'll go back to CloudFormation. We're just going to probably create nested stacks, which that's what I thought it would do. Nested stacks means that it's reliant. So there's one main one, and then there's children stack. So go here, see what resources it's creating. Oh, whole bunch of stuff. Wow. So many things. An SQSQ, SNS, network interface, a DynamoDB table. Yeah, you probably don't want to run this. You just want to watch me do it. And then we go into here. It's creating an EC2 volume, so that's going to be EBS. And then here we have a log group. I don't know why they separated those out. Didn't seem very necessary. We are waiting on the Elastic IP. That always takes forever, creating Elastic IP. Root instance profile, that is the IAM role for it. Oh, that didn't take too long. These take a long time. I never know why. Create a role, it's really easy, but attaching an IAM policy, you're always waiting for those. So I'm going to just stop it here. I'll be back in a second because I don't want to have to make you watch me stare at the screen here, okay? All right, so after a really, really long wait, and it always takes some time there, it finally created, I'm not sure what it's made. I mean, we generally saw over here in the outputs, but usually the cost that I'm worried about is whatever it's launching under EC2. It might not even have launched any servers here. We're going to take a look here and see if there's anything. So we have a master and a compute, and they're T2 micros. So seems pretty safe here. This compute is not running yet. So I'm assuming that this is like the machine that does the computing. And maybe if you had multiple machines here, like that would be the cluster, like it would manage multiple computes. I'm not particularly sure, but let's just keep going through the tutorial and see what we can do. The next step is we need to get this PEM key in our Cloud Shell here. So this, I don't know where this is, but what I'm going to do is I'm going to move it to my desktop. I'm doing this off screen, by the way. So I'm moving it to my desktop, and then I'm just going to go and upload the file. Okay. And there it is. So we'll say open, and we'll say upload. And it's going to upload it here onto this machine. And I believe this is on like, I think this uses an EFS instance. Like if you're wondering where the storage for Cloud Shell is, if we go over here, I think it's EFS. Is it? I don't know where it is. Okay, maybe it's just maybe it's somewhere else. Okay, I can't remember where it is. But anyway, so now it's created the cluster. Can I hit enter here? Okay. Can I create a tab? Like if I quit this, is it going to kill it? It exited it, which is, I think it's fine. I don't think it stopped running. And so now if I do an ls, there's my key. And so we can go back to our instructions. We just have too many tabs open here. Drag this all the way to the left here. And so we can try to use our key here to log in. So what I'm going to do is go here and we'll say my HPC PEM and see if that works. We'll say yes. And permission denied. It is required your private key is not accessible. That's because we have to chmod it. I never remember the command anymore because I rarely SSH into machines. But if we go to connect and we go to SSH client, it'll tell us what we need to run. Chmod 400. Okay, so that's what we need to do is we need to do a chmod 400. Just wanted to grab that code there. Okay. And now if we hit up, we should SSH into the machine. There we are. We are in the instance. We'll type in exit. And so now we want to run our job on this machine. And if we go back over to here, I guess we can go create our first job. So I'm just doing this in Vi. And I'm going to paste that in. Yep. And I don't want the first line. Oh, okay, that's perfect. Oh, great. Right quit. Oh, there's no file name. Hold on here. So I need to name this file something. So I'm going to say job.sh. And we're going to paste that again here. We'll say paste. And I don't know if that's cut off. Yeah, it is. Okay, great. Is that one okay? I don't trust that the first line is there. So what I'm going to do is go back to our tutorial here. It's shebang /bin/bash. This, then that, /bin/bash. Just double check it. Looks good to me. We're going to quit that. I'm just going to make sure that it is what we said it is. So job.sh. Looks correct to me. Good. And so we'll try to run our job here. So I'm going to say q job.sh ls. And I guess it really depends on what we decided to use when we set up that thing. I can't remember what we choose as our queue. We do qstat. Oh, okay. So I think the thing is, like, you see how we have SGE? I think that's what we use to queue up jobs, and so we have to have that installed probably. So install. Configure SunGrid engine. SGE install Linux. Oh boy, that looks like a lot of work. So I don't think we need to do anything further here, but as far as I understand, the idea is that you're choosing some kind of way to manage these. And so I'm not sure what qsub is. Let's just go look up what that is. What is qsub? Oh, that is the SunGrid engine. Okay, so how do we install that? I'm just going to see if we can install it. So I'm going to do, I think this is using yum. So if I do clear here, clear, yum install qsub. Let's see if I can do it. Sudo yum install qsub. No package available. Amazon Linux 2 qsub, because that's probably what we're running in Cloud Shell. Qsub doesn't tell us how to install it. That's great. So that's probably what it is. And so in order to use this, we would have to install that sun whatever, and then we go through, we do qsub, it would queue it up. You could do qstat, cat hello, destroy it. That's pretty much all we really need to know to understand this. It would have been nice to queue up a job and see it work, but you know, we're getting kind of into a hairy territory here, and I think that we fundamentally understand how this does work. So what I'm going to do is I'm going to go here, I'm going to remove the job.sh here, and I want to destroy this cluster. So I'm going to do p cluster commands to figure out what all the commands are. And there's probably a delete command. So we'll go back up here. P cluster. Where is our crate? So we'll say delete. Okay, and so what that's going to do is just tear down all this stuff now. So if we go over to CloudFormation. Okay, and it looks like it's destroying, so yeah, I'll see you here back in a bit when it's all destroyed, okay? All right, so after a short little wait there, it has destroyed. It has been so long that my connection vanished, but just make sure if you did follow along for whatever reason, make sure that the stuff is deleted, and it looks like it did not destroy this, so I'm gonna go ahead and delete that. That's just VPC stuff, so I'm not too worried about it. I know that's gonna roll back no problem, and so I'm gonna consider this done. So I'm gonna make my way back to the management console, close this stuff up, and we are good to go for our next thing. Hey, this is Andrew Brown from ExamPro, and we're taking a look at edge and hybrid computing services. So what is edge computing? When you push your computing workloads outside of your network to run close to the destination location. So an example would be pushing computing to run on phones, IoT devices, external servers, not within your cloud network. What is hybrid computing? When you're able to run workloads on both your on-premise data center and the AWS VPC, okay? So we have a few services here, starting with AWS Outposts. This is a physical rack of servers that you can put into your data center. AWS Outposts allows you to use AWS API and services such as EC2 right in your data center. Then we have AWS Wavelength. This allows you to build and launch your applications in a telecom data center. By doing this, your applications will have ultra low latency since they will be pushed over the 5G network and be closest as possible to the end user. So they've partnered with things like Verizon, Vodafone Business, and a few others, but those are the two noticeable ones, okay? We have VMware Cloud on AWS. So this allows you to manage on-premise virtual machines using VMware within EC2 instances. The data center must be using VMware for virtualization for this to work, okay? Then we have AWS Local Zones, which are edge data centers located outside of the AWS region, so you can use AWS closer to the edge destination. When you need faster computing, storage databases in populated areas that are outside of AWS region, you could do this. There's some other edge offerings on AWS that aren't listed here, like SageMaker has what's called like Neo SageMaker. That lets you do edge computing with ML, but I mean, this is good enough, okay? All right, so I wanted just to show an example of edge computing because we didn't cover it in our generic compute. And so there's a variety of services that allow you to do edge computing like Wavelength. And so I've never actually launched Wavelength before. And I think that you have to request it. So if I go over to support here, again, I've never done this before, but I'm sure we can figure it out pretty easily. I feel that if we create a case, maybe it's like service limit. We type in wavelength here. Oh, nope, not there. So how do we get wavelength? Wavelength AWS request. So that's what I'm looking for here. Okay. How do I use wavelength? AWS. Whoops. And sometimes what I'll do is go to the docs here, opt into wavelength zones. Before you specify wavelength zone for a resource or service, you must opt into it. To opt in, go to the AWS console. Okay, so we'll go to EC2. And then it's going to say, use the region selector in the navigation bar to select the region which supports your wavelength. So I know that there's stuff in US West because of Las Vegas, right? Or not Las Vegas, but Los Angeles, right? So if we go over here, there's definitely that over there. On the navigation pane of the EC2 dashboard, under account attributes, select zones. Okay, do we see zones here? Zones. Oh, EC2 dashboard. Zones. Let's go check here again. On the navigation pane, choose EC2 dashboard. We are there, right? And under account attributes settings, account attributes. Oh, over here. Okay. Oh, it's here. Zones. And so there we have two zones, and we see switch regions to make zones a different region. Okay, so under zone groups, turn on wavelengths. Zone groups. Okay, nothing there. So I'm just going to switch over to another one here. Maybe Oregon. Maybe it's US West 2. Oh, look at all the stuff we have here. I've never seen these before. Okay, so here is the wavelength one. So that is the Los Angeles one. We can go ahead and enable this. Before disabling the zone group, I'm not sure what zone groups cost. So wavelength zone pricing. Again, you might just want to watch me do this because it might cost money. And so you might not want to have to spend for that. Pricing. Provides mobile networks. Wavelengths are available across whatever. Learn about the data transfers in a price about EC2 instances. Okay, so what's the price? If we go into here. All right, so what I'm going to suggest to you is don't do this, but I'm going to do it, and we're just going to see what the experience is like, okay? So I'm going to update my zone. So now I have this one, so we'll say enable. I'm going to assume that it has to do with like data transfer costs. Okay. And we're going to go over to EC2. And we're going to go over to instances here. We're going to launch an instance, and we're going to see if we have that available. Now, I don't know if we're restricted to particular instances. I'm going to assume we can launch a Linux machine. It'd be really weird if we couldn't, you know. We'll go over to configuration, and what we want to do is choose the zone. So how do we do it? So once it's turned on, confirmation and confirm it, configure your network. So create a VPC, create a carrier gateway so you can connect your resources into the VPC to the telecommunication network. Holy smokes, this is complicated. But it's just kind of interesting to see like the process, right? You know, it's not for our use case, but carrier gateway, right? And as I do this, I always check up all the costs here. So I say carrier gateway pricing AWS, because maybe that's where the price is. Okay, if you don't get a pricing page, then usually that's hard to say. Logically isolated virtual networks. Again, it's not telling me what. To use carrier, you need to opt into at least one wavelength zone, but I did, right? And sometimes what happens is that it just takes time for the opt-in to go. So go here, manage the zone settings. That was a lot easier way. So we have one. We're opted in right here. Okay. And okay, we'll go here again. If that one didn't work, we can try. So I guess these are all the regions, Denver, things like that. Can I opt into this one? Opt in. It's not super exciting. Like all we're going to do is launch an EC2 instance, but you know, we'll go through the process here a bit. And I don't know why I can't create one. So we'll go back over to the instructions here. So you can connect. So create a route table using the VPC to the route table. So I think that's as far as we're going to get here because I'm not seeing any options here, but the idea was that we would have to create a carrier gateway, we'd update our route tables, and all we would be doing is launching an EC2 instance. So, you know, it's no different than launching it. You just choose a different subnet. So I think you'd have to create a subnet for that zone and launch it in there. And that would be edge computing. Another example of edge computing would be something like via CloudFront, which we have these edge functions, or not edge functions, yeah, functions here. And so these are functions that are deployed to CloudFront. So my CloudFront function, and these would be deployed to edge locations, right? And all you can use here is JavaScript. So here's an example of one, and I'm fine with this. Development, live, this function's not published. We'll go to test the function, it's good. Publish that function. And so the advantage of this is that, you know, if you have functions that are in AWS Lambda, there's a chance of cold start. Whereas if they're deployed on the edge here, there's still probably a cold start, but it's going to be a lot faster because it's a lot closer to the edge location. So, you know, it's just a different cases. But yeah, there was one where we're launching EC2 workload into wavelengths, which we couldn't complete, which is totally fine. And then we have these functions on the edge. There's other edge computing services, like within SageMaker, you can deploy, I think it's called like Neo SageMaker. And then for IoT devices, those are obviously on the edge, so you can deploy those as well. But generally, that gives you an idea of edge computing, okay? Hey, it's Andrew Brown from ExamPro, and we're looking at cost and capacity management computing services. So before we talk about them, let's define what is cost management. So this is how do we save money And we have capacity management. How do we meet the demand of traffic and usages through adding or upgrading servers? So let's get to it. The first are the different types of EC2 pricing models. So you got spot instances, reserved instances, saving plans. These are ways to save on computing by paying up in full or partially, or by committing to a yearly contract or multi-year contract, or by being flexible about the availability and interruption to computing services. We have AWS Batch, so this plans, schedules, and executes your batch compute workloads across the full range of AWS computing services, which can utilize spot instances to save money. We have AWS Compute Optimizer, so suggest how to reduce costs and improve performance by using machine learning to analyze your previous usage history. We have EC2 Auto-Scaling Groups, so ASGs. These automatically add or remove EC2 servers to meet the current demand of traffic. They will save you money and meet capacity since you only run the amount of servers you need. Then we have ELB, so Elastic Load Balancer. So this distributes traffic to multiple instances. We can reroute traffic from unhealthy instances to healthy instances and can route traffic to EC2 instances running in different availability zones. And then we have Elastic Beanstalk here, which is easy for deploying web applications without developers having to worry about setting up and understanding the underlying AWS services, similar to Heroku. It's a platform as a service. So not all of these are about cost. Some of them are about capacity management, like ELB. But yeah, there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at the types of storage services. And no matter what cloud service provider you're using, they're usually broken down into these three, where we have blocks, file, and object. Okay, so let's take a look at the first. So this is going to be for block storage. So for AWS, this is called Elastic Block Store. Data is split into evenly split blocks directly accessed by the operating system and supports only a single write volume. So imagine you have an application over here, and that application is using a virtual machine that has a specific operating system, and then it has a drive mounted to it. It could be using FC or SCSI here. But the idea here is when you need a virtual drive attached to your VM is when you're going to be using block, okay? The next one here is for file, or it's just basically a file system. So this is AWS Elastic File Storage. So the file is stored with data and metadata, multiple connections via a network share, supports multiple reads, writes, locks the file. So over here, we could have an application, but it doesn't necessarily have to be an application. And so it's using NAS exports as the means to communicate. And so the protocols here can be NFS or SMB, which are very common file system protocols. And so the idea here is when you need a file share where multiple users or VMs need to access the same drive. So this is pretty common where you might have multiple virtual machines and you just want to act as like one drive. One example that could be like, let's say you're running a Minecraft server. You're only allowed to have one world on a particular single drive, but you want to be able to have multiple virtual machines to maximize that compute. That'd be a case for that. So there you go. Then the last one here is like object storage. And so for AWS, this is called Amazon Simple Storage Service, or also known as S3. So object is stored with data, metadata, and a unique ID. Scales with limited no file limit or storage limit. So there's very little limit to this. It just basically scales up. Supports multiple reads and writes, so there are no locks. And so the protocol here, we're going to be using HTTPS and API. So when you just want to upload files and not have to worry about the underlying infrastructure, not intended for high IOPS, so input and outputs per seconds. Okay, so depending on how fast you have to do your read and writes, are going to determine whether you're going this direction or the other way, or how many need to actually connect at the same time, and whether it has to be connected as a mount drive to the virtual machine, okay? Hey, it's Andrew Brown from ExamPro, and we're going to do a short introduction into S3 because on the Certified Cloud Practitioner, they ask you a little bit more than they used to, and so we need to be a bit familiar with S3 because it is, at least I think that AWS considers its flagship storage service, and it really is one of the earliest services. It was the second one ever launched. Okay, so what is object storage or object-based storage? So data storage architecture that manages data as objects as opposed to other storage architectures. So file systems where these are others, right? So which manages data as files, and a hierarchy, and block storage, which manages data as blocks within sectors and tracks that get stored on an actual drive. And so the idea here is we have S3, which provides basically unlimited storage. You don't need to think about the underlying infrastructure. The S3 console provides an interface for you to upload and access your data, okay? So we have the concept of an S3 object. So objects contain your data. They are like files, but objects may consist of a key. This is the name of the object, a value, the data itself made up of a sequence of bytes, the version ID, when versioning enabled the version of the object, metadata, additional information attached to the object. And then you have your S3 buckets. So buckets hold objects. Buckets can also have folders, which in turn hold objects. S3 is a universal namespace, so bucket names must be unique. It's like having a domain name, okay? And one other interesting thing is an individual object can be between 0 bytes and up to 5 terabytes. So you have unlimited storage, but you can't have files of incredible size. I mean, 5 terabytes is a lot, but nothing beyond that for a single file. But just understand that you can actually have a 0-byte file. And for like associate certifications, that can be an actual question. So that's why it's there. All right, let's take a look at S3 storage classes. And so for the Certified Cloud Practitioner, we need to know generally what these are. For associate levels, we need more detail than we have here, but let's get through it. So AWS offers a range of S3 storage classes that trade retrieval time, accessibility, durability for cheaper storage. And so the farther down we go here, the more cost-effective it should get, pending certain conditions, okay? So when you put something to S3, it's going to go into the standard tier, the default tier here. And this is incredibly fast. It has 99.99% availability, 11 nines durability, and it's replicated across 3 AZs. And so, we have this cheaper meter here on the left-hand side, and that would imply this is very expensive. And it's not actually expensive, but it is expensive at scale when you can better optimize it with these other tiers. So just understand that. Then you have the S3 intelligent tiering. So this uses ML to analyze objects and usage and determine the appropriate storage class. Data is moved to the most cost-effective access tier without any performance impact or added overhead. Then you have S3 standard IA, which stands for infrequent access. This is just as fast as S3 standard, but it's cheaper if you access the files less than once a month. There's going to be an additional retrieval fee applied. So if you do try to retrieve data as frequently as S3 standard, it's going to actually end up costing you more. So you don't want to do that, okay? Then you have S3 one zone IA. So as it says, it's running in a single zone. So it's as fast as S3 standard, but it's going to have lowered availability, but you're going to save money, okay? There is one caveat though. Your data could get destroyed because it's remaining in a single AZ. So if that AZ or data centers suffer a catastrophe, you're not going to have a duplicate of your data to retrieve it, okay? And then you have S3 Glacier. So for long-term cloud storage, retrieval of data can take minutes to hours, but it's very, very, very cheap. And then you have S3 Glacier Deep Archive, which is the lowest cost storage class, but the data retrieval is 12 hours. And so, all of these here to here, these are all going to be in the same AWS S3 console or Amazon S3 console. S3 Glacier is basically like its own service, but it's part of S3, so it kind of lives in this weird state. There's one here that we didn't have on the list here, which is S3 Outputs, because it has its own storage class and doesn't exactly fit well into this kind of linear, cheaper thing here, okay? Hey, it's Andrew Brown from ExamPro, and we are taking a look at the AWS Snow family. So this is storage and compute devices used to physically move data in or out of the cloud when moving data over the internet or private connection that is too slow, difficult, or costly. So we have Snow Cone, Snowball Edge, and Snowmobile. And so there originally was just Snowball, and then they came out with Snowball Edge. And Edge introduced edge computing. That's why there's edge in the name. But pretty much all of these devices have edge computing, and they do individually come with some variants. So with the Snow Cone, it comes in 2 sizes, where it has 8 terabytes of usable storage, and then there's one with 14 terabytes of usable storage. For Snowball Edge, it technically has like 4 versions, but I'm going to break it down to 2 for you. We have Storage Optimized, where we have 80 terabytes of usable storage there, and then Compute Optimized 30.9.5 terabytes. And even though it's not here, you get a lot of vCPUs and increased memory, which could be very important if you need to do edge computing before you send that over to AWS. And then last here we have Snowmobile, which can store up to 100 petabytes of storage. in the associates, I cover these in a lot more detail because there's so much more about these, like the security of them, how they're tamper-proof, something like how they have networking built in, the connection to them. But for this exam, that's just too much information. You just need to know that there are three ones in the family, and generally what the sizes are, and that they're going to be all placed into Amazon S3. What's interesting is that the snowmobile only does 100 petabytes, but AWS markets it as you can move exabytes of content because you can order more than one of these devices. So they'll market it saying like Snowball Edge is when you want to move petabytes of data, and Snowmobile is when you want to move exabytes. But you can see that a single thing isn't in the exabyte, it's just in the petabyte, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at all the AWS storage services in brief here, so let's get to it. So the first is Simple Storage Service, S3. This is a serverless object storage service. You can upload very large files and an unlimited amount of files. You pay for what you store. You don't worry about the underlying file system or upgrading the disk size. You have S3 Glacier. This is a cold storage service. It's designed as a low-cost storage solution for archiving and long-term backup. It uses previous generation HDD drives to get that low cost. It's highly secure and durable. We have Elastic Block Store, EBS. This is a persistent block storage service. It is a virtual hard drive in the cloud, and you attach to EC2 instances. You can choose different kinds of hard drives, so SSD, IOPS, SSD, throughput HDD, and cold HHD, okay? We have Elastic File Storage, so EFS. It is a cloud-native NFS file system service. So file storage, you can mount to multiple EC2 instances at the same time when you need to share files between multiple servers. We have Storage Gateway. This is a hybrid cloud storage service that extends your on-premise storage to the cloud. We got three offerings here. File Gateway, so extend your local storage to Amazon S3. Volume Gateway caches your local drive to S3, so you have a continuous backup of the local files in the cloud. Tape Gateway, so stores files onto virtual tapes for backing up your files on very cost-effective long-term storage. And we got one more page here because there's a lot of services here. We have AWS Snow family, so these are storage devices used to physically migrate large amounts of data to the cloud. And so we have Snowball and Snowball Edge. These are briefcase-sized data storage devices between 50 to 80 terabytes. I don't believe Snowball is available anymore. It's just Snowball Edge, but it's good to have all of them in here so we can see what's going on. We have Snowmobile. This is a cargo container filled with racks of storage and compute that is transported via a semi-trailer tractor truck to transfer up to 100 petabytes of data per trailer. I don't think we're going to be ordering that anytime soon because that's pretty darn expensive, but that's cool. We have Snowcone. This is a very small version of Snowball that can transfer 8 terabytes of data. We have AWS Backup, a fully managed backup service that makes it easy to centralize and automate the backup of data across multiple AWS services. So EC2, EBS, RDS, DynamoDB, EFS, Storage Gateway. You create the backup plans. We have Cloud Endure Disaster Recovery, so continuously replicates your machine in a low-cost staging area in your target AWS account and preferred region, enabling fast and reliable recovery in case of IT data center failures. We have Amazon FSx. This is a feature-rich and highly performant file system that can be used for Windows, so that would be using SMB, or Linux, which uses Lustre. And so there we have the Amazon FSx for Windows file server. So use SMB protocol and allow you to mount FSx to Windows servers. And then the Lustre one, which uses Linux Lustre file system and allows you to mount FSx Linux servers. Are there any storage services missing here? Not really. I mean, you could count Elastic Container Repository as one, but that's kind of something else. Or you could also count maybe code commit, but I kind of put those in a separate category where those are in our developer tools or our containers, okay? All right, so what I want to do is show you around S3. So we'll make our way up here and type in S3. And we'll let it load here. And what we're going to do is create a new bucket. If you do not see the screen, just click on the side here, go to buckets, and we'll create ourselves a new bucket. So bucket names are unique. So let's say my bucket, and we'll just pound in a bunch of numbers. I'm sure you're getting used to making buckets in this course so far. So if we scroll on down, notice that it says block public access settings for this bucket. And this is turned on, like the blocking is turned on by default because S3 buckets are the #1 thing that are a point of entry for malicious actors where people leave their buckets open. So if we want to grant access to this bucket for people to see this publicly, we'd have to turn this off, okay? But for now, we're going to leave that on. You can version things in buckets, which is pretty cool. You can turn on encryption, which you should turn on by default, and use the Amazon S3 key. On the Certified Cloud Practitioner, it's going to ask you about client-side encryption and server-side encryption, so you definitely want to know what these are. I'm going to turn it off for the time being, so we can kind of explore here by ourselves here. Then there's object lock, so we can lock files so that people aren't writing to them multiple times. So we'll go ahead and create a bucket, and it's very quick. So here's the new bucket we made, and you'll notice we have nothing here, which is totally fine. If I go to properties, we can see that we can turn on bucket versioning, turn on encryption. But what I'm going to do is I'm going to go grab some files. I remember I saved some files recently here. I'm just going to make a new folder called Star Trek. I just have some graphics. You can pull anything off the internet you want to do this yourself. But I'm just going to prepare a folder here. It'll take me a moment. Okay. Just a moment. Okay, great. So now I have my folder prepared. And so what I want to do is upload my first file. So I can go here and upload. And actually, I can upload multiple files. You can even add a folder, which is nice. And so in here, if I want to upload these files here, whoops, I'll just select multiples. I'll hit open. It'll queue them up, which is really nice. We can see the destination details here. If we want to turn it versioning on, we could there. We could apply permissions for outside access, but we have things turned on. But what's really important is the properties, where we have these different tiers. And so based on the tier that you use, the lower you go, at least it should be, the cheaper it's going to get. But it's going to have some trade-offs, and we cover that through the course. Then there's that server-side encryption, and I'm going to hit upload. We'll just individually turn it on. So you're going to see this progress go across the top. These have all been uploaded. I'm going to click on my destination bucket. And so what we can do is we can open these. If they're images, they'll show us right here in the browser. We can download them, so if we need to get them again. All right, we can create a folder here and just say Star Trek or Enterprise D. Enterprise D here. Okay, but it's not really easy. It's not like I can drag this into there. I might be able, there's no move option. So you'd actually have to copy it into the destination and then delete the old one. It's not like using a file system, there's a lot more work involved, but it's a great storage solution. So let's look at encryption. So I have this selected here. If I click into it, I can go to permissions. I can go to versions, see that. I'm looking for encryption. Here we go. So if I turn it on, I can enable encryption, and I can choose whether I want to use an Amazon S3 key, so SSE S3. So an encryption key that Amazon S3 creates, manages, and uses for you. Then you have AWS SSE KMS. And I believe this uses AES up here, which is totally fine. Then you have KMS down here, and it's interesting because they're like, AWS will manage the key for you, and then this one, AWS will manage the key for you. It's just slightly different. This one, of course, is a lot simpler. There's not many reasons not to turn on encryption, but I'm going to go turn this one so that it is encrypted here. And just because it's encrypted doesn't mean we can't access the file. I can still download it. I can still view it because AWS is going to decrypt it, right? So if I go, I click on this one, and I say open, okay? Even though it's encrypted, I can still view it, right? It just means that it's encrypted on the storage, right? So if somebody were to steal that hard drive, whatever hard drive it's sitting on AWS, if they can even figure it out, it's encrypted. They're not going to be able to open up the file, right? So that is the logic there. But through here, I can get it. Something that's really interesting with S3 is the ability to have lifecycle events. So I'm just kind of looking where that is. It's usually in the bucket. So if I go to management up here, I can set up a lifecycle rule. And what I can do is say like, move this to deep storage. Okay. And then I can say what it is that I want to filter. So maybe it's like data.jpg. Or I can say apply to all objects in the bucket. I acknowledge that. And we say move current versions of objects between storage classes. And I checkbox that on. And I can say move them to Glacier after 30 days. I think if I go lower, it'll complain. Probably when I save there. And so the idea is that we can move things into storage. So maybe you have files coming in down below. It's showing you here, right? So a file is uploaded. And then after 30 days, then move them into Glacier so we save money. Okay, that's a big advantage of S3. There's a lot of things going on in S3 here. Like you can turn on, wherever it is, you can turn on web hosting, so you can turn this into like a website down below here. There's a whole bunch of things that you can do, okay? So we're not going to get into that because that's just too much work. But, we learned the basics of S3. So what I want to do to delete this, I have to empty it first. Watch, it'll be like, you cannot delete it. You need to empty the bucket first. So go ahead and empty it. And I'll say my bucket empty. Or, sorry, I guess I have to type in permanently delete. Permanently delete. No. They used to, oh yeah, I can copy it. Okay, great. And so once the bucket is emptied, I can go back to the bucket. And I'll go back one layer, and then I'll go ahead and delete my bucket. And you can only have so many buckets. I think it's like 100. You have like 100 buckets. How many buckets can you have in AWS? 100 buckets. Yeah, I was right. And I think if you wanted to know how many, there's probably like a service limits page. Service limits, service quotas. So you go here, you say AWS services, S3. How many buckets? 100 right there. Okay. So, that gives you kind of an idea what's going on there. But there you go. That's S3. All right, so let's go take a look at Elastic Block Store, which is virtual hard drives for EC2. So what I'm going to do is make my way over to the EC2 console because that is where it's at. And on the left-hand side, if we scroll on down, you'll see Elastic Block Volumes or Elastic Block Store Volumes. And so we can go here, and the idea is we can go ahead and create ourselves a volume. And what you'll notice is that we have a few different options here. We have general purpose, provisioned IOPS, cold HDD, throughput optimized, magnetic. Magnetic being basically like physical tape that you can use to back up, like the old school stuff. And so you have all these options here, and you can choose the size. So when you change these options, you're going to notice that some things are going to change, like the throughput or IOPS. So notice that general purpose is fixed at between 300 to 3000. And notice that it goes from 1 gigabyte to how many ever that is. That's a lot there. And so it's not too complicated, but in practicality, I don't really create volumes this way. What I do is I'll just go launch an EC2 instance. So I'll say launch EC2 instance, and we'll choose Amazon Linux 2. And again, if we haven't done the EC2 follow along, we'll cover all this stuff in more detail. Don't worry about it. We go to configure instance, then we go to add storage. And this is what you're going to be doing when adding EBS volumes to your EC2 instances. And you'll notice we always have a root volume that's attached to the EC2 instance that we cannot remove. We can change the size up here. I believe it shows us right here that we have up to 30 gigabytes. So sometimes you might want to max that out to take advantage of the free tier. You notice we can also change this. There might be some limitations in terms of the root volume. So notice that we have a few more options here. We can't have a cold HDD or HDD as our root volume. Notice we have a delete on termination. So EBS volume persists independently from the running life. So you can choose to automatically delete EBS volume when the associated instance is terminated. So if you take this off, if the EC2 instance is deleted, the volume will still remain, which could be something that's important to you. For encryption here, you might want to turn it on. And so generally AWS always has a KMS managed key, which is free. So you checkbox that on, it will be encrypted. You can turn it on later, but you can never turn encryption off, but you should always turn encryption on. And so just be aware to turn that on. You can also add file systems down below here, but maybe we'll talk about that later because I think that gets into EFS, okay? So that is a different type of file storage there, but that's pretty much all there is to it. You just go ahead and create your volume there, and then it would show up under EBS. We could take snapshots of them to back them up. That goes to S3, but that's all we really need to know here, okay? All right, let's take a look at Elastic File System, or EFS, storage, managed file storage. What does EFS stand for? EFS system, Elastic File System. Okay, sorry. And so what we can do is go ahead and create a file system here. So I'm going to say my EFS. And the great thing is that it basically is serverless, so it's only going to be what you consume, right? So what you store and what you consume. And I think that's what's going to be based on. We have to choose a VPC. I want to launch it in my default VPC. And we have the choice of regional or one zone. I guess this is going to be based on what gets backed up to S3 possibly. So one zone probably is more cost effective, but I'm going to choose regional. And that's a new option I never noticed before. I just opened it up to see a few more things here. We have general, max IO, bursting, provision, things like that. We'll hit next. We'll choose our AZs. And then you might have to set up a policy. So I'm going to hit next here. You'll go ahead and hit create. So, this is really interesting, but the trick to it is really mounting it to an EC2 instance. And that's kind of the pain, okay? So if we go into this, you have to mount it, and there are commands for it. So like EFS mounting Linux commands, okay? I've done this in my Solutions Architect Associate, but, again, I'm not doing it on a regular basis, so I don't remember. And so if we go here, I'm just trying to see if we can see some code that tells us how to mount it. So mounting on an EC2 Linux instance with the EFS mount helper. So I don't know if they had that before, but that sounds interesting. So sudo mount -t, the file system, the EFS mounting point. Yeah, this looks a lot easier than what we had before. Okay, so before I had to enter a bunch of weird commands, but now it looks like they've boiled it down to a single command. But once you have your EFS instance, I'm going to assume that there is an entry point here. Just clicking around here, seeing what we can see. I would imagine we have to create an access point. So my access point. Sure. I don't know if it's going to let me just do that. It did. And so I would imagine that you'd probably use an access point. Let's go back here. EFS mount point. I think that's the same thing. I think the mount point and the access point, you create access points, and that's what you use. We can go here and we can attach it. So, oh yeah, here's the command. So, mount via DNS or mount via IP address. So, it doesn't look too hard. We can try to give it a go. I haven't done it in a while. It looks like they've made it easier. So, maybe we'll try it out. Okay. So, we'll go to EC2 here. And I'm going to launch an instance. I'm going to choose Amazon Linux 2. Okay, we're going to go and choose that. And then we want to choose a file system. And so it's going to mount to here. Okay. And storage is fine. All this is fine. And I'm going to go ahead and launch this. And I need a new key pair. So create a new key pair. This will be for EFS example. Okay. We're going to download that key pair there. We're going to launch this instance. Okay, and then we're going to go view this. And as that is launching, what I'm going to do is open up my Cloud Shell. And I'm going to want to upload this pen. So again, like before, I'm going to drag it to my desktop off screen. And then what I'm going to do is upload this file. So I have it. EFS example. Okay, we're going to upload it. Because I just want to see if we can access that EFS volume. And so if I do ls, that's our old one, which I can delete, by the way. I'm never going to use that anytime soon. Yes. ls. And I'm going to just delete the hello text there, so it's a bit cleaner for what we're doing. And so we need to chmod that 400 EFS example. And we saw that's how, like if you want to try to connect to a server remotely, that's what you do, right? So I believe that the drive is mounted. If I go to storage, does it show up here? Doesn't show up under here. But what we're waiting for are these two status checks to pass, and then we can SSH into this machine. And I'm just going to go back here and take a look here. So using the EFS mount helper, so sudo mount -t EFS TLS, this volume to EFS. And so I imagine it's going to mount it to EFS here using the NFS client. So I guess it just depends on what we're going to have available to us. Even if the status checks haven't passed, I'm going to try to get into this anyway. So what we can do is click on this, grab the public IP address. We'll type in SSH, EC2-user, @ paste this in, -I, EFS, example PEM. I usually don't log in via SSH, but just for this example I will. And so I want to see if this drive exists. Usually it'd be under mount, right? There it is. Okay, so it already mounted for us. So I can do touch hello world.txt. Say sudo here. I can say sudo vi. I'm going to open up the file and say hello from another computer. Okay. And so I've saved that file. And what I want to do now, whoops. Oh, okay, sorry. I'm in the Cloud Shell here. But what I want to do now is I want to kill this machine. Okay, and what I'm going to do is spin up another EC2 instance. I'm going to see if when I mount that, if that file is there, if it actually worked. But wow, that is so much easier than before. I can't tell you how hard it was to attach an EFS volume the last time I did it. So we'll go ahead, we'll add that, and the storage is fine. We're going to go to review here. We're going to say launch, and I'm just going to stick with the same key pair there. We're going to give that moment to launch, and we're going to go to view instances. And so now this one is launching. As that's launching, let's just go peek around and see what we can see. So, you know, I imagined if we didn't add that file system during the boot, and we're adding it after the fact, we probably could just ran that line and added it really easily. I'm not going to bother testing that because I just don't want to go through that trouble to do that. I still can't remember what these access points are for, but it's okay. It's kind of out of the scope for the Certified Cloud Practitioner. And so I'm just curious. So we get some nice monitoring here, right? So that's kind of nice. I guess they're trying to suggest here like AWS backup, data sync, transfer. So that would just be backing up. Simplify, automates, accelerates moving data. Okay, that's pretty straightforward. Transfer family, fully managed SFTP. Okay, so nothing exciting there. And we're going to refresh that there. And this is initializing. So let's go see if we can connect to this one. So I'm going to go ahead, grab that public IP address. I'm going to hit up. Okay. I'm going to swap out that IP address, and we're going to see if we can connect to that machine yet. So we'll say yes. And we got into it, so that's great. And so what I'm going to do is go again into the mount directory, EFS, FS1, LS, and there it is. I'm going to do cat hello world. And so it works. And so that's the cool thing about EFS is that you have a file system that you can share among other EC2 instances. I'm sure users could connect to it using the NFS protocol. I'm not the best at like networking or storage networking, so I'm not going to show that here to you today, but that gives you a general idea how EFS works. Again, you only pay for what you store. It is serverless. So we'll go here and type delete because I'm done with this. I'll probably destroy the instance first so it doesn't get mixed up. And just so we clean up a little bit better here, I'm going to delete these keys here. Delete. Okay, and we'll go ahead and delete this one as well. Delete. So I'm done with that. We'll make sure that that is tearing down. That is good. And we'll make our way back over here. And it says enter probably the ID's name in. So we'll enter that in and we'll hit confirm. And we'll see, is it deleting? I'm not confident with it. I'm going to do it one more time. Confirm that by entering the file system's ID. So we'll put it in again. Is it destroying? I cannot tell. There we go. So it's destroying. We are in good shape. It is gone. Our data is gone. But yeah, that is EFS. All right, let's take a look at the Snow family in AWS. So if we type in Snow up here and we click into AWS Snow family, this is where we can probably order ourselves a device. I might not be able to order them. At least when I originally looked at this, like way back in the day, it wasn't available in Canada, so I'm kind of curious to see what there is. But the idea is that you're going to go here and order, and you have some options. So you can import into S3 or export from S3. And then down below we have local compute storage. So perform local compute and storage workloads without transferring data. You can order multiple devices and clusters for increased durability and storage capacity. So it sounds like you're not transferring data. You're just using it locally on it's like basically renting temporary computers, which is kind of interesting. I never saw that option before, but we're going to choose import into AWS S3, and we're just going to read through this stuff. And it's not my expectation that we're going to even be able to submit a job here. And you probably don't want to because it's going to cost money, but I just want to show you the process so we can see what there is here. So Snow Job Assistance. If you're new to Snow Family, run a pilot of 1 to 2 devices, so batch files smaller than 1 megabyte, benchmark and optimize, deploy staging workstations, discover and remediate environmental issues early. Files and folders name must conform to Amazon S3. Prepare your AMI. Once the pilot is completed, confirm the number of Snow Family devices that you can copy devices to simultaneously. Follow the best practices. Use the following resources to manage your Snow devices. So we have AWS Open Hub, and then there's the Edge Client, CLI. So Open Hub is a graphical user interface you can use to manage Snow devices, so that's kind of cool. And then we have the CLI, which I imagine is something that's very useful to use. So just close those off here, and then we have other things. So I'm going to say I acknowledge, I know what I'm doing, which I don't really, but that's okay. And then here we are going to enter in our address. So we say Andrew Brown, and I'm not gonna enter this in for real, just whatever. So it'll be Toronto, ExamPro, Canada. Oh, see, so there's the thing. You can only ship it to the US, and so that's as far as I can get. Okay. And that's the thing is, like, if you really want to know AWS inside and out, you got to be in the US. But let's pretend that we do have an address in the States. What's a very famous address? So what is the address of the White House? Okay. There it is. So I'm just going to copy that in. Because, again, we're not going to submit this for real. I just want to see what's farther down the line here, okay? What's NW? Is that the state? It's in Washington, right? Is this part of it? NW, Northwest? Is that a thing? I'm from Canada, so I couldn't tell you. So we'll go down here, and we have Washington. Do we have a second address line? It doesn't look like it. We have a zip code. I believe this is the zip code. And do we need a phone number? Looks like we do. 416 111 11111. Okay. We have 1 day or 2 day shipping. Why not just have one, right? And so then we can choose our type of device. So we have snow cone SSD, snow cone optimized. I'm surprised I never took a screenshot of this earlier. Compute optimized, things like that. So you can choose which one you want. It looks like we're going to see some different options, but we'll go with snow cone. My snow cone. And snow cones do not ship with a power supply or Ethernet cable. Snow cone devices are powered by 45-watt USB-C power supply. I'll provide my own power supply and cable. Do not ship with a power supply or Ethernet cable. That's fine. Snow cone wireless. Snow cone connect to your wireless connection. Connect the buckets you want. There's a bucket we created earlier. Compute using EC2 instances. Use a device as a mobile data center by loading an EC2 AMI. So here's an AMI that I might want to use. AWS IoT Greengrass validated AMI. Not interested in remote device management. You can use Ops Hub or etc. to monitor, reboot your device. That's fine. And so then we need to choose our security key. I don't know if we'll have to set the service role. We'll see what happens here. And we'll let it update. That's fine. And so then I guess we just hit create job. And so I don't really want to order one. So I'm not going to hit that button. And also it's going to go to the White House and they're going to be like, Andrew Brown, why did you do that? So that's not something I feel like doing today, but at least that gives you an idea of that process there. And I imagine that if you go the other way, it's going to be pretty similar. Yeah, it's just like same stuff, I think. So it saved that address. It's not a real address. And the options are a little bit limited here. And it's like NFS based, S3 based. So it's slightly different, but it's basically the same process. Just curious, we'll take a look at the last one there. Since there are 3 options, just curious. Okay, similar thing. Okay, so yeah, that's pretty much all I want you to know about the Snow family, and that's about it. Okay. Hey, this is Andrew Brown from ExamPro, and we are taking a look at what is a database. So a database is a data store that stores semi-structured and structured data. And just to emphasize a bit more, a database stores more complex data stores because it requires using formal design and modeling techniques. So databases can generally be categorized as either being relational, so structured data that strongly represents tabular data, So we're talking about tables, rows, and columns. So there's a concept of row-oriented or columnar-oriented, and then we have non-relational databases. So these are semi-structured that may or may not distinctly resemble tabular data. So here is a very simple example. The idea is that you might use some kind of language like SQL, put in your database, and you'll get back out tables for relational databases. But let's just talk about some of the functionality that these databases have. So they can be using a specialized language to query, so retrieve data, so in this case SQL, specialized modeling strategies to optimize retrieval for different use cases, more fine-tuned control over the transformation of the data into useful data structures or reports. And normally a database infers someone is usually using a relational row-oriented data store. So, just understand that when people say database, that's usually what they're talking about, like Postgres, MySQL, relational row store is usually the default, but obviously there's a lot more broader terms there, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at what is a data warehouse. So it's a relational data store designed for analytical workloads, which is generally column-oriented data store, okay? So companies will have terabytes and millions of rows of data, and they'll need a fast way to be able to produce analytics reports. So data warehouses generally perform aggregation. So aggregation is the idea of grouping data together, so find a total or an average. And data warehouses are optimized around columns since they need to quickly aggregate column data. And so here's kind of a diagram of a data warehouse. And so the idea is that it could be ingesting data from a regular database. Here I'm just getting out my pen tool, so it could be a regular database, or it could be coming from a different data source that isn't compatible in terms of the schema, and you use like ETL or ELT or ETL to get that data into that data warehouse. So data warehouses are generally designed to be hot. So hot means that they can return queries very fast, even though they have vast amounts of data. Data warehouses are infrequently accessed, meaning they aren't intended for real-time reporting, but maybe once or twice a day or once a week to generate business and user reports. Of course, it's going to vary based on the service that is offering the data warehouse. A data warehouse needs to consume data from a relational database on a regular basis. And again, it can consume it from other places, but you'll have to transform it to get it in there, okay? Hey, this is Andrew Brown from ExamPro, and we're taking a look at a key value store. So a key value store or database is a type of non-relational database or NoSQL that uses a simple key value method to store data. And so key value stores are dumb and fast, but they generally lack features like relationships, indexes, aggregation. Of course, there are going to be providers out there that have managed solutions that might polyfill some of those issues there, but I want to show you the underlying way that key value stores work to kind of distinguish them between document stores. So a key value stores literally a unique key alongside a value. And the reason I'm representing that as zeros and ones is because I want you to understand that that's what it is. It's basically just some kind of data there. And how the key value store interprets it is going to determine what it is. So when you look at a document database, that is just a key value store that interprets the value as being documents, right? And so key value stores can and do commonly store multiple, like an associative array. That's pretty common. So even for DynamoDB, that's how it does it. And so that's why when you look at a key value store, it looks like a table, but it's not actually a table. It's schemaless because underneath it's really just that associative array. And so that's why you can have rows that have different amounts of columns, okay? So due to the design, they're able to scale very well beyond a relational database, and they can kind of work like a relational database without all the bells and whistles. So hopefully, that makes sense, okay? All right, let's take a look at document stores. So a document store is a NoSQL database that stores documents as its primary data structure. And a document could be an XML type of structure, but it also could be something like JSON or JSON-like. Document stores are subclasses of key value stores, and the components of a document store are very comparable to relational databases. So just kind of an example here where in a relational database they'd be called tables. Now you have collections. They were called rows. Now they're called documents. You had columns. They had fields. They may have indexes. And then joins might be called embedding and linking. So you can translate that knowledge over. they're not as they don't have the same kind of feature set as a relational database, but you have better scalability. And honestly, document stores are just key value stores with some additional features built on top of it. Okay. Hey, it's Andy Brown from ExamPro, and we're going to take a look at the NoSQL database services that are available on AWS. So we have DynamoDB, which is a serverless NoSQL key value and document database. It is designed to scale to billions of records with guaranteed consistent data returned in at least a second. You do not have to worry about managing shards. And DynamoDB is AWS's flagship database service, meaning whenever we think of a database service that just scales, is cost effective, and very fast, we should think of DynamoDB. And in 2019, Amazon, the online shopping retail, shut down their last Oracle database and completed their migration to DynamoDB. So they had 7,500 Oracle databases with 75 petabytes of data. And with DynamoDB, they reduced that cost by 60% and reduced the latency by 40%. So that's kind of to be like a testimonial between relational and a NoSQL database. So when we want a massively scalable database, that is what we want DynamoDB for. And I really just want to put that there because if you remember that, you're going to always be able to pass or get those questions right on the exam, okay? Then we have DocumentDB. So this is a NoSQL document database that is MongoDB compatible. So MongoDB is very popular NoSQL among developers. There were open source licensing issues around using open source MongoDB, so AWS got around it by just building their own MongoDB database, basically. So when you want a MongoDB-like database, you're going to be using DocumentDB. We have Amazon Keyspaces. This is a fully managed Apache Cassandra database. So Cassandra is an open source NoSQL key value database similar to DynamoDB that is column or store database, but has some additional functionality. So when you want to use Apache Cassandra, you're using Amazon Keyspaces. Hey, this is Andrew Brown from ExamPro, and we are taking a look at relational database services, starting with Relational Database Service, RDS. And this is a relational database service that supports multiple SQL engines. So relational is synonymous with SQL and online transactional processing, OLTP. And relational databases are the most commonly used type of database among tech companies and startups just because they're so easy to use. I use them. I love them. RDS supports the following SQL engines. We first have MySQL. So this is the most popular open source SQL database, and it was purchased and is now owned by Oracle. And there's an interesting story there because when Oracle purchased it, they weren't supposed to have it. MySQL was sold to Oracle Sun Systems, and then within the year, Oracle purchased it from them, and the original creators never wanted it to go to Oracle, just because of their the way they do licensing and things like that. And so the original creators came back and they decided to fork MySQL and then maintain it as MariaDB, just so that Oracle never kind of pushed away the most popular database so that everyone had to go to a paid solution. Then you have Postgres, so PSQL, as it's commonly known, is the most popular open source SQL database among developers. This is the one I like to use because it has so many rich features over MySQL, but it does come with added complexity. Then Oracle has its own SQL proprietary database, which is well used by enterprise companies, but you have to buy a license to use it. Then you have Microsoft SQL, so Microsoft's proprietary SQL database. And with this one, you have to buy a license to use it. Then you have Aurora. So this is a fully managed database. And there's a lot more going on here with Aurora. So we'll talk about it. It almost acts as a separate service, but it is powered by RDS. So Aurora is a fully managed database of either MySQL, so 5 times faster, or Postgres SQL, 3 times faster database. So when you want a highly available, durable, and scalable and secure relational database for Postgres and MySQL, you want to use Aurora. Then you have Aurora Serverless. So this is a serverless on-demand version of Aurora. So when you want the most of the benefits of Aurora, but you can trade off to have cold starts, or you don't have lots of traffic or demand, this is a way you can use Aurora in a serverless way. Then you have RDS on VMware. So this allows you to deploy RDS-supported engines to on-premise data centers. The data center must be using VMware for server virtualization. So when you want databases managed by RDS on your own database center, I realize that this is a small spelling mistake, should say just on here, but yeah, there you go. Hey, this is Andrew Brown from ExamPro, and we're looking at the other database services that AWS has because there's just a few loose ones here. So let's talk about Redshift. So it is a petabyte-sized data warehouse, and data warehouses are for online analytical processing, OLAP. And data warehouses can be expensive because they are keeping data hot, meaning that they can run a very complex query and a large amount of data and get that data back very fast. So when you need to quickly generate analytics or reports from a large amount of data, you're going to be using Redshift. Then you have ElastiCache. So this is a managed database of an in-memory and caching open source databases such as Redis or Memcache. So when you need to improve the performance of an application by adding a caching layer in front of your web servers or database, you're going to be using ElastiCache. Then you have Neptune. This is a managed graph database. The data is represented as interconnected nodes. I believe that it uses Gremlin as the way to interface with it, which is no surprise because that's what it looks like most cloud service providers are using. So when you need to understand the connections between data, so mapping fraud rings or social media relationships, very relational database heavy information, you're going to want to use Neptune. We have Amazon Time Streams. It's a fully managed time series database. So think of devices that send lots of data that are time sensitive, such as IoT devices. So when you need to measure how things change over time. We have Amazon Quantum Ledger Database. This is a fully managed ledger database that provides transparent, immutable, cryptographically variable transaction logs. So when you need to record a history of financial activities that can be trusted. And the last one here is Database Migration Service, DMS. It's not a database per se, but it's a migration service. So you can migrate from on-premise database to AWS, from two databases in different or same AWS accounts using different SQL engines, and from an SQL to a NoSQL database. And I'm pretty sure we cover this in a bit greater detail in this course, okay? All right, let's go take a look at DynamoDB. Which is AWS's NoSQL database. So we'll go over to DynamoDB. And what we'll do is create ourselves a new table. And we'll just say my DynamoDB table. And you always have to choose a partition key. You don't necessarily have to have a sort key, but it could be something like you want it to be really unique. So it could be like email, and this one could be created at, right? And so we have string, binary. Notice that the types are very simple. Then for settings, we have default settings or customized settings. So the default is use provision capacity mode, read, write, 5 rules, etc. Custom. No secondary indexes, use KMS. So I'm going to just expand that to see what I'm looking at. We have two options here, on demand. So simplify billing by paying the actual reads and writes that you use, or provisioned, this is where you get a guarantee of performance. So if you want to be able to do, you know, whatever it is, 1,000, I don't know what it goes up to, but like 1,000 read writes per second, then that's what you're paying for, okay? You're paying for having a guarantee of that capacity, okay? I'm not going to create any secondary indexes, but that's just like another way to look at data. Notice down below that we have a cost of $2.91. Then we have encryption at rest, so you can do owned by Amazon DynamoDB. That's pretty much the same as like AWS has, or S3 has SSC S3 there. You could use CMK. Actually, I guess most of these are probably KMS, I would imagine. We'll go ahead and create the table here. And that's going to create the table. This is usually really, really fast. We'll go here. And what we can do is insert some data. So as it's just starting up here, we can go over to our tables. They recently changed this UI, so that's why I look a bit confused. View items up here. Okay, and then from here, we can create an item. So I can add something, say, so Andrew at exampro.co and 2021. Well, we'll just do the future. So let's say 2025, 0505. I don't want to have to think too hard here. But we can add additional information. So I can say like, today, true. We could say, make it like a list. Food. And then I could go here and then add a string. It is not working. Oh, there we go. There we are. So we could say like banana. And then we could say pizza, right? We can go ahead and create that item. So now that item is in our database. we can do a scan that will return all items. We can query where we can actually have some limitations of what we're choosing. There's the party queue editor, so we can use SQL to select it. I have not used this before. Party queue, AWS, or party queue, DynamoDB. Examples. I'm hoping I can just find like an example of some of the language getting started here. I don't need an explanation. Just show me an example query here, and I'll get to it here. Okay, so here's some examples, right? So maybe we can give this a go. So we have our table here. So my DynamoDB table, and I just want the email back. We don't need a where. We'll run this, see if it works. There we go. I'm not sure if we could select additional data there. So I know that we had some other things like food. There it is. Okay. So that's really nice addition to it. DynamoDB can stream things into a DynamoDB stream to go to Kinesis and do a lot of fun things. So there's all sorts of things you can do with DynamoDB. But I'm pretty much done with this, so I'm going to go ahead and delete this table. And notice that it also created some CloudWatch alarms, so we want to delete this as well. Create a backup. No, we do not care. Go ahead and delete that. And that is DynamoDB. Okay, so now I want to show you RDS, or Relational Database Service. So go to the top here, type in RDS, and we'll make our way over there. And so RDS is great because it allows us to launch relational databases. Sometimes the UI is slow. I'm not sure why it's taking so long to load today, but every day is a bit different. And so what we're going to do is go ahead and create a new database. You're going to notice that we're going to have the option between creating a standard or easy. I stick with standard just because I don't like how easy hides a lot of stuff from us. Even here, like it says 2 cents per hour, but it's not giving us the full cost. So I really don't trust it, because if you go down here and you chose their dev test here, look, it's like $100. It's not showing the cost preview right now, maybe because we didn't choose the database type. Sorry, I wanted to choose Postgres. But before we do that, let's look at the engine types we have. Amazon Aurora, so we have between MySQL and Postgres, MySQL, MariaDB, Postgres, Oracle, Microsoft SQL. Notice for Microsoft SQL, it comes with a license. You don't have to do anything with that. It might change based on the edition here. Nope, comes with a license for all of them, which is great. If you want to bring your own license, that's where you need a dedicated host, right? Running Microsoft SQL. For Oracle, you have to bring your own license. That's going to be based on importing with the AWS License Manager. But if we go over to Postgres, which is what I like to use, we're going to set it to dev test to try to get the cheapest cost. Scroll down, look, $118. We can get it cheaper. We get it super cheap. So here are the passwords going to be testing 123. A capital on the T, so and an exclamation mark on the end, okay, because it has a bunch of requirements of what it wants. Here I want a T2 micro, so I'm just going to scroll down here. What is going on here? Standard. Oh, look, M classes. I don't want an M class. I want a burstable class. That's the cheap ones. And so we go here. Can we still do a T2 micro, or is it now T3? So I don't see T2. So I imagine a T3 micro must be the new AWS free tier. So we go AWS free tier here, right? And if I go to databases, RDS, on the T2 micro, 750 hours, but I can't select it. So I'm going to assume that the T3 micro must be the new tier if it's not there, right? Unless it's saying include previous generations. And then maybe I can see it then. Okay, so I don't see it there. I really don't like how they've changed this on me. Okay, so the oldest I can choose is a T3 micro, which is fine. I just know T2 being the free tier, that's all. This is fine. We don't want auto scaling turned on for our example here. We do not want a multi-AZ, so do not create a standby. That's going to really jump up our cost. We don't need public access. It will create a VPC. That is fine. Password authentication is fine. We have to go in here, which I don't know why they just don't keep that expanded, because you always have to come in here, name your database. So my database. We choose our Postgres version here. I'm going to turn backups off because if we don't, it's going to take forever to launch this thing. Encryption is turned on. You can turn it off, but generally it's not recommended. We can have performance insights turned on. I'm going to turn the retention. We'll leave it to 7 days because we can't turn that off. We don't need enhanced monitoring, so I'm just going to turn that off. And that's fine. We're not going to enable delete protection here. And so we are good. We can now go ahead and create our database. And what we'll do here is wait for that database to be created. So the thing is like, if we're doing the solutions architect or the developer associated stuff, I'd actually show you how to connect to the database. It's not that hard to do. Like you just have to connect, grab all the database information. So it's going to have an endpoint, a port, stuff like that. And you'd use something like Table Plus or something to connect to the database. But that's out of scope of the Certified Cloud Practitioner. I'm just going through the motions to show you that you can create an RDS database very easily, but not how to connect to it and actually utilize it, okay? And so that would spin up and we would have a server, and after that we can just go ahead and delete the server here. So I can just say delete me, okay? And that's all there really is to it. There is the special type of database, like Aurora doesn't have its own like console page, it's part of RDS. So if you want to spin up Aurora, you just choose the compatibility you want. You can choose between provisioned or serverless. And serverless is supposed to be really good for scaling to zero cost, so that's something there. So you'd fill that all out, but the initial cost is a lot more expensive. You can't choose a T2 micro here, unless it lets you now. It is for provisioned. It's oh, T3 medium is the smallest you can go. Okay, so if you reach to the point where you're using a medium-sized database, then you might consider moving over to Aurora just because it's going to be highly scalable, etc., like that. So that's a consideration there. There's also something called Babelfish that AWS announced last year when I shot this, or when I'm shooting this as of now. And the idea was to make it compatible with MySQL SQL Server to migrate over to Aurora PostSQL, which is kind of interesting. But that's about it. So if our database is destroying, I think it is. I'm just going to go back over here to RDS. It's taking a long time to load today. And I think it's already deleted. Maybe we go to databases here. It's deleting. So I'm confident it's going to delete. So there we go. All right, let's take a look at Redshift. So Redshift is a data warehouse, and it's generally really expensive. So it's not something that you're going to want to launch day to day here. But let's see how far we can get with it just by running through it. So what we'll do is go ahead and create a cluster. And again, you can just watch me do this. You don't have to create. You don't have to create one yourself. So free trial configure for learning, that sounds good to me, is free for a limited time if your organization has never created a cluster. Well, I rarely ever create these. So when the trial ends, delete your cluster to avoid the charges of on-demand. Okay, that sounds fair. So here we're going to have 2 VPCUs. It's going to launch a DC2 large. So let's look that up for pricing. Show me prices, please, please, please. I think it's loading right here. Okay. So I don't know how much it is, but I know it is not cheap. And down below we have sample data is loaded into your Redshift cluster. That sounds good to me. Ticket is the sample data. Okay. Ticket sample data. Redshift. I just imagine they probably have like a tutorial for it here. They do, right here. And so, because I want to know what we need to do to query it, right? If we can even query it via the interface here. So the admin user is AWS user, and the password is going to be capital T, testing 1, 2, 3, 4, 5, 6, exclamation. And we'll hit create cluster. Oh, cool, we can query the data right in here. So that's what I wasn't sure about, whether we would be able to just query it in line, because before you'd have to use Java with JDBC or an ODBC driver and download the jar, and it's not as fun as it sounds, of course. but it looks like we can query data once the data is loaded. So that looks really good. I guess we can pull data in from the marketplace, so that looks pretty nice too. And I guess we could probably integrate it into other things like QuickSight, because you probably want to adjust your data over there. Again, I usually don't spend a lot of time in Redshift, but it looks like it's a lot easier to use. I'm very impressed with this. So I don't know how long it takes to launch a Redshift cluster. I mean, it is 160 gigabytes of storage there. It's even at the smallest, it's pretty large. So what I'm going to do is to stop the video, and I'll be back when this is done, okay? Okay, so after a short little wait here, it was a lot faster than I was expecting, but it's available. And so it looks like here it says to query the sample data, use Redshift version 2. So I'm going to click that, and I'm sure there's tons of buttons to get here, and it'd be great if it just populated the query for me. It doesn't, but this looks really nice UI. I wonder if it has like some existing queries. No, that's okay. So what I'm going to do here is I'm going to go ahead and pull out this query and see if we can get this to work here. Never found out what those prices were though. Okay. And what we'll do is hit run. I like how there's like a limit of 100, but here it has that. So we'll go ahead and hit run and see what data we get. So relation sales does not exist. Okay. So what's going on here? We'll go up here. So most of the examples in the Redshift documentation uses a sample database called ticket. This small database consists of 7 tables. You can load the ticket dataset by following this here. Okay, so to load the sample data from Amazon S3. Okay, so I would have thought it already had the data in there. I could have swore it would have. Dev, public, tables, 0 tables. Okay, so I don't think there's any data in here, and so we're going to have to load it ourselves. I really thought it would have added it for us. But let's go ahead and create these tables and see if this is as easy as we think. So run that, create that table. Cool, okay. We got it down here. We'll run that. We'll just run each at a time. I think there's 7 of them, so. Data already exists. Okay, that's fine. Event already exists. It's saying all these tables exist. Maybe I just wasn't patient. Okay. Interesting. All right, so maybe we'll go back and run that query. Maybe we just had to wait a little while for that data to load. Run. Okay, so you know what? I think it was doing this for us. If it did not create it for us, we would have to go through all these steps, which is fine because we're learning a little bit about Redshift, but it looks like we just had to wait there. So it looks like you would run those, you download that, you use the copy command to bring it over there. It looks like you can do all of this via the this interface here, and we've done a query, so that's kind of cool. I imagine you probably could like save it or export it. What if we chart it? What happens? Okay, you can chart it. That's kind of fun. Can we export it out to, we can save it. I thought maybe it could export out to QuickSight, but I suppose you'd rebuild it in QuickSight, eh? But yeah, I guess that's it right there. So that's pretty darn simple. So what I'm going to do is make my way back over to Redshift because we are done for this example. And we will go over to clusters here. And I'm going to go ahead and delete my cluster. Delete. Create file snapshot. Nope. Delete. Delete the cluster. And there we go. So I'm pretty sure that will succeed, no problem there. And we are done with Redshift. And Redshift is super expensive, so just make sure that thing deletes, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look here at cloud native networking services. And so I have this architectural diagram I created, which has a lot of networking components. When people create networking diagrams for AWS, they don't always include all these things there, even though they're there. So we're just being a little bit verbose so you can see, okay? The first thing is our VPC, our virtual private cloud. This is a logically isolated section of the AWS cloud where you can launch AWS resources. That's where your resources are going to reside. Not all services require you to select a VPC because they're managed by AWS, but I wouldn't be surprised if under the hood they are in their own VPC, okay? Then if you want the internet to reach your services, you're going to need an internet gateway. Then you need to figure out a way to route things to your various subnets, and that's where route tables come in. Then we need to define a region that it's going to be, which is a geographical location on your network. Then you have your availability zones, which are basically your data centers where your AWS resources are going to reside. Then you have subnets, which is a logical partition of an IP network into multiple smaller network segments. And these pretty much map to your availability zones if you're making one per AZ. And then we have NACLs. These act as a firewall at the subnet level. Then we have security groups that act as a firewall at the instance level. So hopefully that gives you a good overview, okay? All right, so now let's take a look at enterprise or hybrid networking. So we have our on-premise environment or your private cloud, and then we have our AWS account or our public cloud. So there's a couple services here that we can bridge them together. The first is AWS Virtual Private Network, VPN. It's a secure connection between on-premise remote offices and mobile employees. Then you have Direct Connect. This is a dedicated gigabit connection from on-premise data center to AWS. So it's a very fast connection. A lot of times with Direct Connect, we say it's a private connection, but that doesn't necessarily mean secure. It's not encrypting the data in transit. So very commonly, these services are used together, not just singular, okay? And then we have private links. And so this is where you already are using AWS, but you want to keep it all within AWS, never going out to the internet, okay? So these are generally called VPC interface endpoints. And then the marketing pages call them private links, which is a bit confusing. But, you know, it just keeps traffic within the AWS network so it does not transverse out to the internet, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at VPCs and subnets. So a VPC is a logically isolated section of the AWS network where you launch your AWS resources and you choose a range of IPs using a CIDR range. So a CIDR range is an IP address followed by this net mask or submask, and that's going to determine how many IP addresses there are. And there's a bunch of math behind that, which we're not going to get into. But anyway, so here is an architectural diagram just showing a VPC with a couple subnets. So subnets is a logical partition of an IP network into multiple smaller network segments. And so you're essentially breaking up your IP ranges for VPCs into smaller networks. So just thinking about cutting up a pie, okay? So subnets need to have a smaller CIDR range to the VPCs represent for their portion. So /24 is actually smaller, which is interesting. The higher the number gets, the smaller it gets. And so this would allocate 256 IP addresses. And so that's well smaller than 16, okay? We have the concept of a public subnet. So this is one that can reach the internet, and a private subnet, the one that cannot reach the internet. And these are not strictly enforced by AWS. So the idea is that when you have a subnet, you can just say, don't by default assign publicly assignable IP addresses, but it's totally possible to launch an EC2 instance into your private subnet and then turn on the IP address. So you got to do other things to ensure that they stay private or public, okay? Hey, it's Andrew Brown from ExamPro, and we are comparing security groups versus NACLs. So I have this nice architectural diagram that has both NACLs and security groups in them, and we'll just kind of talk about these two. So NACLs stand for Network Access Control Lists, and they act as a virtual firewall at the subnet level. And so here you can create and allow and deny rules. And this is really useful if you want to block a specific IP address known for abuse. And I'm going to just kind of compare that against security groups, because that's going to be a very important difference, okay? So security groups act as a firewall at the instance level, and they implicitly deny all traffic. So you create only allow rules. So you can allow an EC2 instance to access port on port 22 for SSH, but you cannot block a single IP address. And the reason I say that is because in order for you to block a single IP address in secure group, you would literally have to block, or you'd literally have to allow everything but that IP address, and that's just not feasible, okay? And so if you can remember that one particular example, you'll always be able to remember the difference between these two. One other thing that AWS likes to do is ask which ones are stateless, which ones are stateful, but at the Cloud Practitioner level, they're not going to be asking you that, okay? All right, let's learn a bit about networking with AWS. So what I want you to do is go to the top and type in VPC, which stands for Virtual Private Cloud. And what we'll do is set up our own VPC. It's not so important that you remember all the little bit of details, but you get through this so that you can remember the major components. So what I'll do is create a new VPC. I'm going to call this my VPC tutorial. And here I'm going to say 10.0.0.0/16. The reason you're wondering why I'm doing that, if we go to XYZ here, this tells you the size of it. So I go here and I put 16. So you can see we have a lot of room. If we do 24, it takes up, it's smaller. See? So this is basically the size of it, right? The empty blocks over here. So we're going to have a lot of room. So we do 10.0.0.0/16. We don't need IPv6. We're going to go ahead and create that. And once we have that, we can go ahead and create a subnet, which we will need. So we're going to choose our VPC. We'll go down here and say my subnet tutorial. And we'll choose the first AZ. You can leave it blank, it'll choose at random. And then we need to choose a block that is smaller than the current one. So 16 would be definitely, well, 16 is the size that we have now, so we can match that size. But 10.0.0.0/24 would be absolutely smaller, okay? So go ahead and create that subnet. And so that is all set up now. Let's see if our route table is hooked up. So our route table says where it links to, and it says to local. So it's not going anywhere, and that's because we need to attach a internet gateway that allows us to reach the internet. So if we go over here and create a new internet gateway, we'll say my IGW, and we'll go ahead and create that. And what we'll do is associate that with our VPC we created here, okay? And so now that we have the internet gateway attached, we want that subnet to make its way out to the internet. So if we go to the route table, we can edit the route table association here. I like how it keeps on showing me this as if I don't know what I'm doing, but I do. And so this would change that particular association, but I want to add to that route table. So I thought when I clicked that, it would allow me to add more, but apparently I got to go to route tables over here. And I'm looking for the one that is ours. We can see that it's over here. We could even name it if we wanted to, like my route table. Notice when we apply names, it's actually just applying a tag. See over here? It's always what that is. So we'll go over to routes, and we want to edit the routes, and we want to add a route, and we want this to go to 000, and we're going to choose the internet gateway. Okay? We're going to say save changes. And what that's going to allow us to do is to reach the internet. And so what I want to do is go back to subnet. I was just curious about this. I've never used this before. So it looks like we could just choose some options here. I'm not too concerned about that, but I assume like that's used for debugging. Azure's had those kind of services for a long time, and so AWS has been starting to add those so you can easily debug your network, which is nice. So we have a subnet. The subnet can reach the internet because there's an internet gateway, and it's hooked up via the route table. One thing that matters is, will it assign a public IP address? So that is something that we might want to look into. It's not the default subnet, which is totally fine. So it says auto assign is no. So that might be something that you might want to change. So here we would go to edit the route table association. No, it's not there. They changed it on me. It used to be part of the setup instructions. You used to just checkbox it now, and they moved it. Modify the auto assign. So we'll say enable. So that means it's always going to give it a public IP address on launch. And while we're here, I'm just going to double check if I have any elastic IPs that I did not release. Okay, just double checking here. And so this is all set up, and we should be able to launch a EC2 now within our new VPC. So I'll go over here to EC2. Okay. and I'm going to launch a new instance. I'm going to say Amazon Linux 2. We're going to choose this tier here. And now what we should be able to do is select that. And that is our subnet there, okay? Go ahead and launch that. I don't care if we use a key whatsoever, so I'm going to go ahead and launch that there. Okay, we'll go back. And so there you go, it is launching. So we created our VPC and we launched in it, no problem whatsoever. So hopefully that is pretty darn clear. So yeah, what I'm going to do is I'm going to let that launch because I want to show you security groups. So within AWS, you can set security groups and NACLs, and that's going to allow or deny access based on stuff. And when we launched this EC2 instance, it has a default security group that was assigned. We could have created a new one, but what I might want to do is create myself a new security group here. Okay, and you can end up with a lot really fast. Like here's a bunch, and I can't even tell what's what. So like there's a bunch for load balancers and things like that. And so I might just go ahead and delete a bunch of these because I cannot tell what is going on here. And we'll delete these security groups. And sometimes they won't let you delete them because they're associated with something like a network interface or something. All right, but we need to find out which one we're using right now. So the one that we are using is the Launch Wizard 4. So we'll go into here. And I don't know if you can rename them after they've been created. I don't think so, which is kind of frustrating because if you want to rename it, it's like, I don't want that to be the name. So what's interesting is you can go here and you can edit the routes, the rules, the inbound rules and the outbound rules. And so here it's open on port 22. So that allows us to SSH in. We could drop this down and choose different things. So if we want people to access a website, we go port 80 and we say from anywhere, IPv4 6. So now anyone can access it. You might want to do something like give it access to Postgres that runs on port 5432, things like that. Could be something else, like maybe you need to connect to Redshift, that's on that port. You can go ahead and save those rules. We're just going to say from anywhere. You can even say my IP, so maybe only I'm allowed to connect to it, right? And so you added inbound rules. You don't really ever have to touch outbound rules. It's set for all traffic, so it's stuff that's leaving that there. One interesting thing to note about security groups is that you don't have a deny option, right? So let's say you only wanted a particular IP address. You only wanted, let's say, what's my IP? My IP address. So that is my IP address. And let's say I wanted to block it, right? So I go here and I say, okay, I want to block on all TCP, I want to block this number, right? But I can't do that. All I can say is I allow this number. So in order to do it, I would have to enter everything but this number in here. And you can enter ranges in with like these forward slashes and stuff like that. But you would imagine that'd be really hard because you have to start and go like, you'd have to start and go through every single IP address in the world to get it out of here. And that's almost impossible. And that's the key thing I want you to remember about security groups. So that's security groups. And there's also NACLs. NACLs, they're associated with subnets, so they probably show up under VPC. I rarely touch NACLs. Rarely ever have to. I mean, they're great tools, but you know, for me, I just don't ever need them. So NACLs are associated with subnets. So we can go here and try to see my subnet tutorial. So when we created our subnet, we got a NACL for free, and we can set inbound and outbound rules. And so here's where we could say, okay, I want to add a new rule. And I want to make the rule number 150. You always do these in hundreds, okay, or the power of 10s so that you can move them around easily. And I can say all traffic that comes from this IP address. I'm going to put the /0. That just means a single IP address. And I say deny, right? And so now this, at my address, I can't access that EC2 instance, okay? If I try to go, there's nothing running on the server, but if I was to try to use it, I wouldn't be able to do it. And this applies to anything for that subnet. It's not for a particular instance, it's for anything in that subnet. So hopefully that is pretty clear there. But that's pretty much all you really need to know. I mean, there's lots of other stuff like network firewalls, all these other things. It gets pretty complicated. It's well beyond what we need to learn here, but what we'll do is tear down that EC2 instance. Okay, we'll terminate that. And once that instance is destroyed, we can get rid of our security group and a bunch of other stuff. And there's always a bunch of these darn things. So we'll say delete. One security group associated. So we go here. This is the one we are using, but I want to get rid of all these other ones. Okay, if I go here, it could be because like of inbound rules. So see this one, because you can reference another security group within a security group. So I'm just going to go save that there. Just say my IP there. Whoops. It's set to NFS. So that might have been set up for our access point. Or I could just delete it. That would probably be easier. Okay. So that's one that's kind of a pain. So I'm just looking for rules that might be referencing other security groups to get rid of them. Okay, let's try this again. We'll go ahead and delete. I'm leaving the defaults alone because those come with your VPCs and you don't want to get rid of those. So it won't let me delete this one, so I'm going to go edit that rule. Delete it, save it. You might not have this kind of cleanup to do. It just might be me here, you know. Outbound, inbound. Let's try this again here. Delete. And I'll open this one up. Must be this one that is referencing the other one. I'm just going to delete the rule. And this is something that's just kind of frustrating with AWS, but it's just how it is, where sometimes it's hard to get rid of resources because you have to click through stuff. So it's not always a clean, you might have like lingering resources. And this isn't going to cost us anything, but it's just the fact that that it just makes things harder to see what you're doing, you know? This last one really doesn't want to go away. So I'm just trying to delete all the rules out of here, get rid of it. Can I delete this one now? One group associated. And it will not show me what it's talking about. Okay, here it is. Okay, this is referencing it. I think it was the one, it was an old one. I don't know what this is. We'll go down here. And we'll go here and delete that. And while I've been cleaning all these up, now we can go over to our instance, make sure that it's terminated. It is good, because if our instance is not terminated, we cannot destroy the VPC. Prior, the VPC could not be destroyed unless you detach the internet gateway. I wonder if it's going to still complain about that. We'll say yes. It actually looks like it includes it in the cleanup. Type delete here. There we go. So we're all good. We're all cleaned up. There you are. Hey, this is Andrew Brown from ExamPro, and in this video I just want to show you CloudFront. So let's make our way over to CloudFront. And CloudFront is a content delivery network, and it's used to cache your data all over the place. As you can see, I have some older ones here. If you have a splash screen, what you can do is just look for the left-hand side. There might be a hamburger menu. Open that up, and then click on distributions. And what we're going to do is create a new distribution. If you don't want to create one, because these do take forever to create, you can just kind of watch along. I don't even feel like I'm going to hit the create distribution button because I just hate waiting for so long. But the idea is that you have to choose an origin. And so the origin could be something like an S3 bucket, a load balancer, media store. This is where the content distribution network is going to source its content, right? So if I say this bucket here, and it would probably default to the root path. The idea is that it's going to be able to pull content from there and then cache it everywhere. And then down below, you can say, okay, set the type of protocol, redirect to here. You can set up caching rules, or like how often do you want it to cache, like cache a lot, don't cache a lot. But the great thing is like you have these Lambda edge functions, so you can read and modify the request and response to the CDN, which is very powerful. But what I'm going to do is I'm just going to go look at what we already have, because again, I said they take forever to spin up, and we're not going to see too much if we do. So once it's spun up, this is what it looks like. So you'll have an origin. It says where it's pointing to. You can create multiple origins, group them. You can modify your behavior. So that was basically what we were looking at before. As you can see, we have our behavior there. Nothing super exciting. We can set up error pages. You can restrict based on geographical location. So if you're, for whatever reason, if you're not allowed to serve content in UK, you could say exclude this geographical region, right? So you have an allow list or a block list saying like, okay, we can't do UK, because like, let's say you just don't want to do, we say England. You don't want to do GDPR for whatever reason. You could block out, I don't know, I'm having a hard time here. Britain? England? It's England, right? United Kingdom? There we go. So you just say, okay, forget United Kingdom. I don't have to do GDPR now. For invalidations, the idea is that, it is a cache. So things can get stale or just persist. And so here you can just type in, say, I want to get rid of image.jpg, and then you create that invalidation, and then it will go delete it out of the cache. And so the next time someone requests, they'll get the fresh content. This usually doesn't take that long. But that's pretty much CloudFront in a nutshell, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at EC2, also known as Elastic Compute Cloud. And so this is a highly configurable virtual server, or it's also known as a virtual machine, and that's what we're going to generally refer to it. EC2 is resizable compute capacity. It takes minutes to launch new instances, and anything and everything on AWS uses EC2 instances underneath. That's why we generally call it the backbone to all the AWS services. And you're going to just have to choose a few options here. So the first thing you'll need to do is choose your OS via your Amazon machine image. So that's where you get Red Hat, Ubuntu, Windows, Amazon Linux, SUSE. It might also come with pre-installed libraries and things like that. Then you can choose your instance type. That's going to determine things like your vCPUs, your memory. So here you can see how many there are, and you'll have like a monthly cost. And that's the name of the instance type. Then you have to add storage. So very commonly, you're attaching Elastic Block Storage or Elastic Files system or service. And so, if you do choose your EBS, you are going to have to determine what type it is. So whether it's a solid state drive, a hard disk drive, a virtual magnetic tape, or even attaching multiple volumes, not just a single one. And the last thing is configuring your instance. So this is configuring the security groups, the key pairs, user data, IAM roles, placement groups, all sorts of things. So we will experience in that because we will show you how to launch an EC2 instance, and it'll make a lot of sense if it does not make sense right now, okay? All right, let's take a look here at EC2 instance families. So what are instance families? Well, instance families are different combinations of CPU, memory, storage, and networking capacity. And instance families allow you to choose the appropriate combination of capacity to meet your application's unique requirements. Different instance families are different because of the varying hardware used to give them their unique properties. And we do talk about this thing about capacity reservation, where AWS can actually run out of a particular type of instance family because they just don't have enough hardware in that data center, and so you have to reserve it. But let's go through the different types of instance families. The first is general purpose, and these are the names of the different families. Very popular ones is the T2, and one that's really interesting is the Mac, which actually allows you to run a Mac server. So these are a great balance of compute, memory, and network resources. So you're going to be using these most of the time. The use cases here would be web servers, code repositories, things like that. Then you have compute optimized. So they all start with C. No surprise there. They're ideal for compute-bound applications that benefit from high-performance processor. Their edge cases here are scientific modeling, dedicated gaming servers, ad server engines, things like that. Then you have memory optimized. And so there's a variety here. These are fast performance for workloads that process large data sets in memory. They're great for in-memory caches, in-memory databases, real-time big data analytics. Then you have accelerated optimized. So this is your P2, P3, P4, things like that. These are hardware accelerators or coprocessors. These are great for machine learning, computational finance, seismic analysis, speech recognition. If you're doing ML on AWS, you'll start coming across these types. AWS technically has a separate page on SageMaker ML machines, but they're all pulling from these instance families, okay? Then you have storage optimized, so I3, I3EN, things like that. These are high sequential read and write access to very large data sets on local storage. The use cases here would be NoSQL, in-memory or transactional databases, data warehousing. For the Certified Cloud Practitioner, you just need to generally know these 5 categories, not the names of the instance families. If you're doing associates or above, you definitely want to know these things in a bit more detail. And I want to say that commonly instance families are called instance types, but an instance type is a combination of size and family. But even AWS's documentation doesn't make this family distinction clear. But I know this because, in Azure, they make that very clear, and GCP. And so I'm bringing that language over here to just kind of normalize it for you, okay? Well, let's take a look at what EC2 instance types are. So an instance type is a particular instance size and instance family. And a common pattern for instance sizes you'll see is things like nano, micro, small, medium, large, X large, 2X large, 4X large, 8X large. And, generally they're to the power of 2s, but sometimes it'll be like 12, 14, 16, or it's even. And so when you go to launch your EC2 instance, you're going to have to choose that instance type. And so here you can see, here's our T2 micro, and then we have the small, the medium, the large, the X large. Okay, but there are exceptions to this pattern for sizes. So, there is one particular one called .metal, and so that's going to indicate that this is a bare metal machine. And then sometimes you get these oddball ones like 9x large. So, the rule of power of 2 or even numbers is not always the case. But generally, it'll be pretty even for, the start here, okay? Just talking about instance sizes. So the EC2 instance sizes generally double in price and attribute. So just bringing up these numbers a little bit closer, starting at the small here, you're going to notice 1, 2, it doesn't maybe double there, but 4, and here we see 12, 24, almost doubles there, almost doubles there. But I want to show you that the price is generally almost double. So 16, 33, 67, 135. And so a lot of times, you always have the option to say, okay, do I want to go to the next instance size up or have an additional instance of the same size? And sometimes it's a better approach to get an additional instance because then you can distribute it across another AZ, but then you also meet additional capacity. So there you go. So we talked about dedicated instances and hosts a little bit, but let's just make that distinction very clear. So dedicated hosts are single-tenant EC2 instances designed to let you bring your own license, so BYOL, based on machine characteristics. And so we'll compare the dedicated instance to the dedicated host across isolation, billing, physical characteristics visibility, affinity between a host and instance, targeted instance placement, automatic instance placement, and add capacity using allocation request. So for isolation, for dedicated instance, you're going to get instance isolation. So you can have the same customer on the same physical machine, but there is virtualization there for them, and there's a guarantee of that. For a dedicated host, you have physical server isolation, so you get the whole server. For billing, on a dedicated instance, it's per instance billing, and it's going to have an additional fee of $2 per region. And for dedicated hosts, it's per host billing, so it's a lot more expensive, but you get the whole machine. For visibility of physical characteristics, you're not going to get any of that information for a dedicated instance. For a dedicated host, you are, such as sockets core host ID. And this is really important when you have a bring your own license and they're saying this license is for X amount of cores or X amount of sockets. Then we have affinity, so there's no affinity for dedicated instance. For dedicated hosts, you'll have consistency with deploys to the same instance to the same physical server. There's no control of target instance placement for dedicated instance. You do have control on a dedicated host. For automatic instance placements, you have it for both. And to add capacity using allocation requests, it's a no for dedicated instance, and it's a yes for dedicated host. So I want to come back to The main point that's what's highlighted here is that on a dedicated host, you have visibility of sockets core host ID. And this is really, really important when you're bringing your own licensed BYOL, such as, Microsoft SQL servers, where you have to specify the amount of cores and things like that, okay? So we've been talking about tenancy, and I just wanted to make it very clear the difference between the different levels of tenancy on AWS. So we have 3, okay? So we got dedicated hosts. So your server lives here, and you have control of the physical attributes. So basically, the whole server, okay? Then we have dedicated instances. So your server is on the same physical machine as other customers, but the actual slot that you have, the dedicated instance, will always be the same. And then we have the default, so your instance will live somewhere on the server, and when you reboot it, it's going to be somewhere else. So there's no guarantee that it's going to be in the same place every single time, okay? Hey, this is Andrew Brown from ExamPro, and in this follow along, we're going to be looking at EC2 and also services that are adjacent to it, so like auto-scaling groups, load balancers, elastic IPs, things like that. So we fully understand EC2. You don't have to know tons for the exam, but you should be able to go through the motions of this with me so that you can cement that knowledge for some of those deeper concepts like working with key pairs and things like that. So let's make our way over to the EC2 console and learn what we can learn. And generally when you go to the EC2 console, it'll bring you to the dashboard. For whatever reason, it didn't bring me there. And then the idea here is that on the left-hand side, we can make our way over to instances. Okay, and this is where we can launch our first instance. So if we go here and launch our instance, the first thing we're going to be presented with is to choose our AMI, or Amazon Machine Image. And so that is a template that contains the software configuration, so the operating system, applications, and other binaries that would be installed on that OS by default. All right, and so we have a variety that we can choose from in the quick starts. And generally the ones that you're going to see first are the ones that AWS support. So there are AMIs or operating systems that AWS will support when you contact them, and then there's ones that are outside that where they'll still help you with, but they might not have the knowledge on. So just understand that if you pick from these core ones, you're going to be in good shape. The most popular is the Amazon Linux 2 because it's part of the free tier, and it is very minimal and well hardened by AWS, so it's a very good choice there. But you can see you can install a bunch of things. So like if you want to launch a Mac OS server, you can absolutely do that. A Red Hat, SUSE, Ubuntu, a Windows server, you name it, they have it. If you wanted something more farther out there, you can go to the marketplace and subscribe to one that is managed by a company. Basically everything exists under the sun here. Or you could get a community AMI, so these are ones that are contributed by the community for free. But we're going to go back to Quick Start here. And what I want you to notice is that there is this AMI ID. That's how we can uniquely identify what we're using. If we were to change region, even with the same Amazon Linux 2 instance, this thing will change. So just understand that it is regional based, and it comes in a 64-bit variant and a ARM variant. And so we're going to be using the x86 here. You can notice here you can change it on the right-hand side. We're going to stick with x86. I'm going to go ahead and hit next. So now we're going to choose our instance type, and so this is going to decide greatly how much we're going to be spending, because the larger it is, the more we're going to spend. So see this T2 Micro, if we wanted to know the pricing for that, we go to EC2 Pricing AWS. And once we get to EC2 Pricing, we want to go to On Demand. And from here, this will load. And so down below, we can kind of go find our price. So it should show us the list. Ah, here it is. Okay. So I can say a T2 Micro. And we can see the on-demand is this. So it seems really cheap. What you got to do is do the math. So if you do times 730, that's how many hours there are in a month. If we launch a T2 Micro, and let's say we didn't have the free tier. You do, if you first made your account, you're going to have 750 hours for free with the free tier. But if you didn't, it would only cost you $8.46 USD, okay? So just be aware of that. And if you ever need to figure something out, go there, copy it, do the math, 730. It's pretty easy. So here we have a T2 Micro in the T2 family. It's going to have one vCPU. Notice it has a V for virtual, so there could be more than a single CPU on the underlying hardware, but we're only going to have access to one virtual CPU. We have 1 gigabyte of memory. It's for low to moderate network performance, so that's a factor that can change if you need like gigabit stuff, like really fast connections for on-prem hybrid connections, and you have specialized servers for that. But for this is fine. The T2 Micro is great. If you want, you can also search this way to see all the instance families and things like that. You can filter for current generations, all generations. So this is fine, okay? So from there, we're going to go to configure our instance type. You can say, let's launch multiples of these instances. Let's turn on spot to save money and try to bid for a particular price. We can change our VPC. It's going to default to the default VPC. If you have no subnets, it's going to pick one at random here, which is fine. Whether to auto-assign a public IP address. If you do not have an IP address, you cannot reach the internet. So generally, you want this to be enabled. This is dependent on the subnet, whether it will default to enabled, but it doesn't matter if you have an EC2 instance in a private or public subnet. You can always override this and give it a public IP address. You have placement groups, which allows you to place servers together closely, not something for the certified cloud practitioner. There's capacity reservations, so if you're worried about AWS running out of this, you can reserve capacity, so that's kind of interesting. Domain join directory, this isn't something that I've done much with, but I imagine that has something to do with Active Directory or something like that to join information. Then you need to have an IAM role, and we absolutely do need an IAM role here. So what I want you to do is create a new role. I'm just going to close off these other tabs here, and we will go, wait a moment, create a new role here. And we want to do this for EC2. So we say EC2 is what we're creating the rule for. We'll hit next. And I don't know if I have a policy, but I'm going to go ahead and, well, I don't need to make a new policy, but I just want SSM. And the reason I want SSM is so that I can use Sessions Manager to log in, so we don't have to use key pairs. We will use key pairs, but if we didn't want to use it, that's what we could do. And this used to be the old role, and it'll tell you, hey, go use this new one here. So I just want to make sure I know which one it is. And so we'll just checkbox that on. We'll hit next. We can add tags. Right here it'd be, well, actually, we don't need to add any tags here, so that's fine. We'll just hit next. And then I'll just say my SSM EC2 role. Okay. And we'll create that role. And now that we have created that role, we can go back to our first tab here and give this a refresh and then drop down, and it should show up here. If we go down here a little bit, we could turn on extra monitoring. There is monitoring built in, but if you wanted to monitor to a lower, more frequently, you could do that as well. We want shared tenancy, right? This is where you change to dedicated instance or dedicated host. Obviously, these cost more, but we're going to stick with shared. Elastic inference, so this is for attaching a fractional GPU, great for ML, not something that we want. There's credit specification. I don't remember seeing this before. Selecting unlimited for credit specification allows for to burst beyond the baseline. So it's for bursting. Here you can attach an EFS. So if you need a file system that you want to mount or attach. Then there's the enclave option. So Nitro Enclave enables you to create isolated compute environments to further protect your and securely process highly sensitive data. So it might be something you might want to checkbox on based on your use case. And then down below we have our ability to enter our user data. And this is something we want to do because we want to install Apache so that we have something to work with here. So what I'm going to do is make a shebang. So that is a pound and an exclamation mark. I know that's really small, so I'll try to bump up my font here so you can see what I'm doing. And we're going to do a /bin and a /bash. On the next line here, we're going to do yum install -y httpd. That's going to install Apache. And why it's not called Apache, I don't know why, but they call it HTTPD. There's no Apache in the name there. And so we'll say systemctl start HTTPD, systemctl enable HTTPD. So we're saying start up Apache and then make sure that it stays running if we restart our machine. Very simple. So from there, we will go to our storage. We'll say add our storage. And this is at 8 gigabytes by default. We could turn that up to 30 if we like. So you can go all the way up to 30 if you like, and you might want to do that, but I'm going to leave it at 8. We could change our volume type. I'm fine with GP2 because that's very cost effective. And if we want to turn on encryption, and you should always turn on encryption, there's no reason not to. And so we'll turn that on. It's not like it's going to cost you more. It's going to be the same cost. It's just your choice there. If we want to add a tag, yes, we're going to add a name, and we're going to say my EC2 instance. Okay. And so that's going to give us a name, which is something we would really like to have. Then we have our security group. I'm going to just create a new security group called my EC2 SG here. and just say my EC2 SG. Something you cannot do is rename a security group once you've made it, so make sure you don't make a spelling mistake up here. And we want to be accessing that HTTP, or it's going to launch a website. So in order to do that, we need to make sure we have HTTP as the type with the port 80 open. And we want it from anywhere, so we'll say anywhere, and that will be 0.0.0.0/0, and that's for the IPv4. This is for the IPv6. Okay, so we'll just say internet, and this is for SSH, right? And for this, I would probably suggest to say my IP, but since we might be using a Cloud Shell to do that, we're going to leave it as anywhere so that we don't have any issues connecting. So from here, we'll review and launch, and you can review what it is that's going on here. It's going to say here, hey, you have an open port. That's okay. We want the internet to see our website because that's the whole point there. And we'll go ahead and launch it. It's going to ask for a key pair. We can go down and say proceed without key pair, but what I'm going to do is I'm going to create a new key pair because I want to show you how those work. And I'm sure we've already done in this course once, but we'll do it again. And so I'm going to just name this as my EC2 instance here. And then we're going to go download that key pair. It's going to download a PEM file there. And so now we can go ahead and launch that instance. And while that is launching, so I'm going to just close this other tab here. We're going to click on the view instances. And so here is that instance. That's why we put the tag so we could have a name there. We're going to wait for that to start. But as that's going, I'm going to make a new tab by just right-clicking here on the logo. Click anywhere pretty much to do that. And once we do that, we'll click on Cloud Shell. And as that is going, what I want to do is take this PEM down below. I'm going to move it to my desktop to make it easier for me to upload. I'm doing this off screen. Okay. And once this environment's running, I'm going to go ahead and upload that. Okay. So we'll just give it a moment to do that. We're also waiting for the server to spin up. As you'll notice, there is a public IP address here. It says it's running. So if we want, we can copy it. We're looking for those two checks to pass. So the server could be available, but generally you want to wait for those two system checks because one says, hey, the hardware's fine, the network's fine, things like that, okay? But if I take that IP address, paste it on up here, we have the web page, so that is working. No problem there, so that's great. And we'll go over to Cloud Shell, and that is still starting. It's not the fastest, but that's just how it is. And, you know, we'll get going here in a second, as soon as this decides to load. There we go. So it's loaded. I can type clear here just to clear that screen out. And so what I want to do is upload that PEM file. So I'm going to go and upload that file. We're going to go ahead and select it. I'm going to go to my desktop here. Whoops, my desktop. And we are going to choose my EC2 instance PEM. All right. And from there, we'll hit upload. And that's going to upload that PEM file. Once that is uploaded, we're going to do ls. Okay, and so this is from a previous tutorial, so I'm going to go ahead and just delete that other one there. We'll say remove EFS example PEM. Yes. Okay, we'll type clear. And then what we can do here is type in chmod, and I believe it's 400. And what did we call this? My EC2 instance PEM. If you hit tab, it will autocomplete, which is nice. And if you do ls-la, we can take a look at that file and see it should look like this. It should have only one R here. So the idea is you're locking it down so it's not writable or executable. It's just readable because that's what you have to have it if you want to SSH. And so if we want to SSH, what we'll do is hit the connect button here. And we have 4 options. They just give you too many options. There's going to be a 5th one for sure soon. But right now we're talking about SSH. So for SSH, we had to chmod our file, which we did. And then we need to use this DNS to connect to it. And so this is the full line here. If you click on this, copy that over and paste it in. That should be everything. And notice we're doing EC2 user, followed by this. You could put the IP address in here instead if you preferred. So if you were over here, you could go and take that IP address, which is, I think, shorter, nicer. But, you know, if you just click that one button, it works, that's fine. You always have to accept the fingerprint. Then you'll be inside the instance. You can type who am I to see which user you are. You're the EC2 user. And that's the user that AWS creates for their Amazon Linux instances. It's going to vary per AMI. So not all AMIs have an EC2 user. It might be something else, but that's generally the ones that AWS uses for their supported ones. And so if we do an ls, Again, we're in the server right now. We can tell because it says right here. Or if we do a PWD, we can kind of look around. So I think it's going to be at var ww. That's where HTTPD or Apache always puts their files here. So if I go in here, whoops, I'm just looking for the index file. So I thought the index file was in cd var ww HTML. Well, where the heck is it? So I'm going to just touch a file here and see if it overrides it. Oh, I don't care. I'll just type sudo. And what we can do is just try to restart this system ctl. There's a very similar command that's like service, and so I always forget the order of it. So I think it'd be, I'm just checking, probably restart HTTPD. And so failed to restart, the policy was not provided as the name service. Service. Maybe sudo. There we go. And so if we go back here, I'm going to see if it changed. Because it will take whatever is in the index.html file. So if there's no file there, it's going to show that there. And so what I can do is I can edit this file. So I'm going to type vi index.html. And I'm going to hit I for insert mode. Oh, it says it's read only. So what we have to do, Q quit. Oops, clear, ls. And so what we need to do is do sudo vi index.html. And so Vim, every single key is a hotkey, okay? And I'm not teaching Vim here, but I'm going to teach you the basics. But the idea is that when you're here, notice that the cursor is blinking. When I hit I, it enters insert mode, and now I can type normally. So I'd say, hello, hello cloud, okay? And then I'm gonna hit escape to go back to navigation mode, whatever you wanna call it. I'm gonna hit colon, so it brings up the command. I'm gonna type in write and quit, okay? And hit enter, and so I'll type clear, and so, whoops, clear. And so we'll hit up till we get that command. Sudo systemctl restart HTTPD. We'll hit that, hit enter. Okay, and it should restart pretty fast. There it is. So it says hello cloud. I probably didn't even have to restart it to do that. But anyway, so now that instance, you can see how we're updating that. So what I want to do is just do a sanity check and make sure that if we restart this instance, that we're going to be able to have Apache running. That's something you should always do. If you have an app and or anything and you install it, restart your server, make sure that everything works. So what I'm going to do is just hit exit here. So we go back to the top level Cloud Shell, type clear. I'm going to go back over to my EC2 instance. I might have to click around to find it here. And what I want to do is reboot it. Okay. And if I reboot the machine, the IP address is going to stay the same. Okay. So if I reboot it, the IP address is going to stay the same. And the reboot's going to happen really fast. If we want to observe that reboot, we could go over to here on the right-hand side, go to the system log, and it would show us that it had rebooted. I think so, yeah, it does a cloud init there. I think it rebooted. Not sure. But anyway, if it's rebooted, then we can go ahead and connect and make sure everything's fine. So let's just go here and hit enter. And let's see if what the web page is here. Notice that it's hanging, right? So it's probably because it's still restarting, even though it doesn't look like it is. And that's something that you have to understand about the cloud, is that you have to think about what you're doing and have confidence that it is happening, and also just double check it. But that's something that can be kind of frustrating because these are globally available services. They're massively scalable. And so one of the trade-offs is that you don't always have the most responsive UIs. AWS has one of the most responsive UIs out of all the major providers, but even still, like, sometimes I have to second guess myself. But the page right now is not working. Now it is, so it's fine. So it just took time for that to reboot. And so what I want to do is connect a different way. So we're going to go here and we're going to hit, we're going to checkbox that on. We're going to hit connect. And instead of using SSH client, we're just going to go to Sessions Manager and hit connect. And this is the preferred way of connecting because you don't have to have this SSH key. And that's a lot more secure because if someone has that key and you hand it to someone, they could hand it to somebody else, and then you have a big problem on your hands. So here, this looks very similar, but if you type who am I, it actually logs in as the SSM user, which is kind of annoying. So I type in sudo su I have to do this hyphen here, and then I'm going to say the user I want to be, which is EC2 user. And then if I type who am I, we are the correct user. You can't do anything in that SSM hyphen user or SSM user, so you got to switch that over. And I can bump this up to make it a bit larger. So this is obviously not as nice as working over here or even in your own terminal, but it's a lot more secure and it's tracked and all these other things. So we really should be using it, okay? And I really don't like having to bump this up with my HTML. I'm going to just go back to 0 there. There's probably like a way to configure that. But anyway, let's just go and take a look at our file. I'm going to type vi again, and we're going to do var www html index html. I'm going to put sudo in front of there. And again, remember, you have to hit I to go into insert mode. And what I'm going to do is just capitalize that, hello cloud, give that exclamation mark, colon WQ to quit, right quit. I'm going to go back here, refresh. Okay, so we don't have to restart our server, which is nice. All right, so that's that. That's pretty clear. So I'll hit terminate here. And I don't think we need Cloud Shell for anything, so I'm just going to close that. And so that's pretty much it when it comes to working with an EC2 instance. And so the next thing I want to show you is Elastic IP, okay? Okay, so now I want to show you Elastic IP, commonly abbreviated to EIP. And so all that is, it's just a static IP, an IP that does not change, because this EC2 instance here, notice that it's 54.163.4.104. And what would happen if we were to stop this instance, not reboot it, but stop it because for whatever reason we had to, or for whatever reason. And if we were to stop this instance and we were to restart it, okay, and we have to wait for it to stop, but that IP address is going to change, okay? So 54.163.4.104, hopefully we can observe that. I'm just going to write that down so we do not forget, so I can prove to you that it does change. And now that it's still stopping here. So as that's stopping, we're just going to go ahead and get our Elastic IP, and I will prove that as we go here. So I'm going to go over to here. And so what I want to do is reserve or allocate an Elastic IP address. And so I'm going to say US East 1. And it's going to say from the Amazon pool of IPv4 addresses. So AWS has a bunch of IP addresses they're holding on to. And so you can just allocate one. And once you've allocated, that's your IP address. So coming back to here. Okay, this is stopped. Notice there is no public IP address. We're going to start it again. Okay, and then we'll just checkbox it on, and we just have to wait a little while to see what the IP address is going to be. I'm going to tell you, it's going to be something else. So if I go back here, this is 54.235.12.110, and our original one was 54.163.4.104. So the reason why it's important to have the same address is that if you have a load balancer, well, not a load balancer, but if you have a domain pointing to your server, and you reboot, then you have a dangling a path or route where Rev 3 is going to be pointing to nothing. And so AWS does have things to mitigate that, like aliases and things like that. But in general, you know, there's cases where you just have to have a static IP address. And so we had allocated one over here, and if we want to assign it, we're going to associate that Elastic IP address. We're going to drop it down, choose the EC2 instance. I suppose the private IP as well. And then we're going to go ahead and hit allocate or associate. And once it's associated, it should now have 34.199.121.116. So we go over here. And we're going to take a look here. And that's its IP address. We can pull it up. Okay. And that's that. So yeah, that's Elastic IP. Okay, so now that we have our Elastic IP, we have our EC2 instance running. Let's say, you know, we lose the server, we terminate it. So we would lose all of our configuration. So if we wanted to bake this AMI to save it for later, what we'd have to do is go and create an image. So to do that, we go to the top here, and we go to images and templates, and we can create an image, or we can create a template, which is a lot better. But for the time being, we're going to go ahead and create an image. And when you create an image, you're basically creating an AMI. And so here, I'm just going to say my EC2. And I'm going to go 000 to just kind of like number it. So that's a very common numbering. Just do 3 zeros and then increment by 1. And so here I can just say my Apache server. And so it's going to save some settings like the fact that there is a volume. You could save some tags there. And so I might go ahead and add a tag and just say name, and we'll just say my EC2 server, or so that it remembers that. Okay. And then what we'll do is go ahead and create our image. And so this can take a little bit of time. If we go over to images here, it's going to be spinning for a while, and we'll just wait until it's done, okay? All right, so after waiting a little while here, our AMI is ready, so we're just waiting for it to go available. If you do not see it, just make sure you hit the refresh, because sometimes AWS will just spin forever, and so that's just something you'll have to do. So, hopefully that makes sense. What we'll do is go make our way back over to instances here, and we can launch one this way. Well, actually, we can do it over from the AMI page. So what I'm going to do is just terminate this instance. We're all done with it. Okay, and we'll hit terminate. It's totally fine. And it had a message about elastic IPs, about releasing them. So when it does that, the elastic IP is still over here. So it did not release it. So what we're going to do is go ahead and disassociate the elastic IP. Okay, and then we're also going to release the IP address, because if we don't, we're going to have this IP address that's sticking around that we're not using. AWS is going to charge us $1 month over month. So just be aware of those, because that's just kind of like a hidden cost there. But what we're going to do is go over to AMI, and we're going to select it here. We're going to go to Actions, and we're going to go ahead and launch. And what it's going to do is make us fill out all this other stuff again. So if you had made a launch template, we wouldn't have to fill out all this stuff. It'd be part of it. But that's what I'm trying to show you with this AMI stuff. So instead of filling out all this, what I'm going to do is now go create a launch template, just to kind of show you that that would be a much easier way to work. So we go over to EC2 instances, and then on the left-hand side, we're looking for a launch template. Launch configurations is the old thing. Launch templates, here we go. So what we'll do is create ourselves a launch template. We'll just say my Apache server. And then down below, we need to choose our AMI. So we're going to go here, and we need to type it in. So what did we call it? My EC2. I really don't like this search here. It's very slow and frustrating, but once we find it, whoops, that's why I don't like it, because a lot of times it'll be loading and you'll end up clicking the wrong thing. Okay, so, I don't like this. Okay, we'll type in my. Give it a second. There it is. And just wait, because it will keep loading. And then once it's loaded, hit enter. And so it has that instance selected. And then from there, don't include it in the launch template. So here we could be explicit. I would say I want this to be T2 micro, but we could exclude it if we wanted to. We could specify the key pair here. Not that we really want to use key pairs. We'll say my EC2 instance. Then down here for the networking, we can specify that security group we created. So we created one here called my EC2 SG. Storage is fine. It's going to be encrypted. Network interface is fine. Advanced details. What I want to do is set the IAM instance profile. That's really important, because we don't want to have to figure out that role every single time. So we'll put that there. And that should be everything. And we could put user data in there, but it's already baked into our AMI, so we don't have to worry about anything. So what I'm going to do here is go ahead and create this launch template. And then we're going to view this launch template. And so now what we can do is then use it to launch an instance. Okay? And so we're going to look here, and it's very similar to the EC2, but except it's vertical. So we're going to have one instance. It's going to use that AMI, that instance type, so you can see how you can override them, which is nice. We're going to check the advanced details and make sure that IAM profile is set, and we'll go ahead and launch this from a template. So from there, we can go ahead and click the instance value there. And just be aware that when you do click through links like that, you'll end up with a search. So I was just checkbox that off so I can see what I'm doing. And so we're just waiting for this instance to show up. And the only thing I noticed is it didn't set our darn tags. So I wanted the name in there. And I think it's because we set it in the AMI, but it didn't carry over to the launch template. So I'd have to go back to the launch template and update it probably. So if I go into here, into the launch template, we can probably modify, create a new version, and then add tags there. So we'd say name, my Apache server. I realize I'm changing it between them. And so that should allow us to have a version 2. So we'll create that. But anyway, that will be for the next time we launch it, okay? And so this instance is running. I'm going to go grab the IP address. The server may or may not be ready. We'll take a look here. And so it's just spinning. If it's spinning, it's either the server is not ready or our port's not open. So it was just getting ready to work there. So it is working now. So that is our launch template. So now, we don't have to worry about losing our stuff. And if we need to make new versions, we can just bake new AMIs and increment them and attach them as new versions of that launch template, okay? All right, so what I want to show you in this follow along is to set up an auto-scaling group for our EC2 instance. And the idea behind this is that we'll be able to always ensure that a single server is running or increase the capacity if the demand requires it. So in order to create an auto-scaling group, we can go all the way down below to here. And so, I really don't like the auto-scaling group form, but it's okay. We'll work our way through it. So the first thing is we'll have to create name our auto-scaling group. So let's just say my ASG, and then we'll have to select a launch template, which is great because we already have one. And then we'll have to select the version. I'm going to select version 2 so that it applies that tag name, and we'll go to next. And so here, it's going to need to select a VPC, and then we need some subnets. So we're going to choose 3 just because to have high availability, you have to be running in at least 3 different availability zones. So that's why we have 3 different subnets. And then down below, we have the instance type requirements. So T2 micro, launch template, looks good to me. So we'll go ahead and hit next. And then from here, we can choose to do a load balancer. And so I want to do the load balancer separate, so we won't do it as of yet, but very often if you're going to have an auto-scaling group, you're going to usually have a load balancer, but we'll talk about that when we get to that point there. So we'll just go to the bottom here and hit next. And so this is what's important. So how many do you want to be always running? And so we always want to have 1, and maybe the maximum capacity is 2, and you want the desired capacity to be around a particular number. So if you had 3 and you said the desired is 2, there are things that could try to work to always make sure there's 2, but we just want to have 1 for this example. We can set up a scaling policy. So I do target tracking scaling policy. And so here we could do it based on a bunch of different things. So if the CPU utilization went over 50%, it would launch another server. So that might be something we might want to set. So we're not going to try to trigger the scaling policy, but we might as well just apply it because it's not too hard. And then you can also do a scale in protection policy. So if you want to make sure it does not reduce the amount of servers, that's something you could do. We could add a notification to say, hey, there's a scaling policy happening here, which is fine. We don't have to worry about that. And there's tags. So add tags to help you search, filter, etc. So I'm going to put a tag here. I'm going to just say name. I'm just wondering if this is going to attach to the EC2 instance or this is for the auto-scaling group. You can optionally choose to add tags to instances by specifying tags in your launch template. So we already did that, so I don't need to put a tag here. And so we can review our auto-scaling group and go ahead and create that auto-scaling group. Okay, and so that auto-scaling group expects there to be a single instance. So what's going to do is it's going to start launching an instance. And so what I'm going to do is just get rid of this old server because we don't need it anymore, this old one here. Okay, and you can already see, okay, that the load balancer is launching this new one here. And remember, we updated our version 2 to have that name, so that's how we know that it is. So if we go back over to our auto-scaling group, okay, it's now saying there's an instance. We don't have a status as of yet. And so there are ways of doing status checks to determine whether or not the server is working. Because if the server is unhealthy, what it would do is it would actually kill it and then start up a new one, right? So if I go down below, it's right now doing an EC2 health check. And the EC2 health check just means that, is the server working, right? Is it running? It doesn't necessarily mean like, hey, can I load this web app? But, it's very simple. So we'll give it a moment here to start up and just make sure that it's working. Okay, and I think it's ready. So if I take that public IP address here and paste it in, there it is, okay? So if we were to tell it to increase the capacity to 3, then what it would do is it would launch 3, and then it should probably launch it all evenly to those other, it should evenly launch it to all those other availability zones, and then we'll have something that is highly available, okay? So that's pretty much it for this, and then we'll move on to auto-scaling groups. All right, so we have our EC2 instance now managed by an auto-scaling group. And the great thing is that if we terminate this instance, this auto-scaling group will launch another instance to meet our particular capacity. The only thing, though, is that if we were to have multiple EC2 instances running, like 3 of them, how would you distribute traffic to them all, right? So, you have an IP address coming in from the internet, but let's say you want to evenly distribute it, and that's where a load balancer comes into play. And even if you have a single server, you should always have a load balancer because it just makes it a lot easier for you to scale when you need to. And it acts as an intermediate layer where you can attach a web application firewall. You can attach an SSL certificate for free. So there's a lot of reasons to have a load balancer. So what we'll do is go down below on the left-hand side, and we're going to make our way over to load balancers, and we're going to create ourselves a new load balancer. So I'm going to hit create load balancer here. And you're going to see we have a lot of options: application load balancer, network load balancer, gateway load balancer, and then the classic load balancer. And so we are running an application, so I'm going to create an application load balancer. And here I'm going to say my ALB for an application load balancer. This is going to be internet facing. It's going to be IPv4. We're going to let it launch in the default subnet, and we're going to choose the same AZs, right? So that we get the same subnets as that are in our auto-scaling group, and that's really important, okay? And then here, we need to have a security group, and I just feel like selecting the same one here because that should work, no problem there. And we want to make sure that we can listen on port 80, and then it's going to forward it to a target group. And it looks like I might have a target group there from before. So just to reduce that confusion, you won't have this problem. I'm just going to double check if that's true. So do I have a target group from there from before? Yes, I do. That came from, I'm not sure. It might have been created by Elastic Beanstalk and wasn't deleted. Okay, so I'll go back over to here just so there's less confusion. And we were selecting our target group. So we're going to have to create a new target group. So we'll go over here. And here you can choose whether it's instance, IP, Lambda, application load balancer. So you could point it specifically to an IP address. And so if it was a static IP address, that would make sense. Apparently, you can point it directly to instances. I don't remember seeing that option before. I guess that makes sense. Yeah, no, sorry, that makes sense because I would go to VPCs, okay? Or sorry, ASGs, auto-scaling groups. It's just that you are pointing them to auto-scaling groups. You're not pointing them to instances. So that's why that's confusing. So I'm going to say my target group. It'll be for port 80 here. Protocol HTTP 1 is fine. We want it to be in the same VPC, so that's fine as well. And down below we have our health check. And so the / means that it's going to hit the index HTML page. And so if it gets back something healthy, and that something healthy is going to be port 80, then it's going to be considered good. And then we can say the threshold of the check. So I'm just going to reduce this so it's not so crazy. So we'll say 3, 2, and then 10. Okay. And then it expects back a 200, which I think that's what we'll get back. So we'll go ahead and hit next. And so now we have our target group, and it should register instances. So it's saying, hey, we detected this, and this fits the requirements for this. So this is now, this EC2 instance is now in this target group. Okay. So we can go back over here. And we can now drop down and choose, hit the refresh button and choose our target group. So I'm not seeing it here. So I'm going to go back over here. Oh, we didn't create it. Okay. And now we can go back, hit refresh. And there it is. And yeah, that looks all good. So we'll go ahead and hit create load balancer. We can view the load balancers, and these create really fast. If we scroll on up, what we can do is now access our server through this DNS name. Okay, so we copy that, paste that on in there. Does it work? Not as of yet. So if it's not working there, because we did say look at these instances, another way is to directly associate your auto-scaling group with the load balancer. So if I go into here and we hit edit, there is a way, load balancer. So we want to associate it this way, and we want to say this target group here. And also while we're here, we might as well set it to ELB. So it's going to use the ELB check. So that makes it so the auto-scaling group, if it wants to restart a server, it's going to use the ELB's check, which is a lot more sophisticated. And then what we'll do is go hit update. Okay. And now if we go back over to our load balancer, I'm just going to close some of these tabs so it's a little less confusing. Load balancer here. I think we should be able to see through here whether it is seeing it. Let's go down below, listeners, monitoring, integrated services. No, it's going to be through the target group. Okay. I mean, it already had it there. So maybe it's just that it hasn't finished the check. So over here it has a health status check. Oh, now it's healthy, okay? So if it's healthy in the target group and the load balancer is pointing to it, then it should technically work. So we're going to go ahead and copy the DNS again here. Make a new tab, paste it in. And there it is, okay? So that's how you're going to access all your instances that are within your auto-scaling groups. You're going to always go through the DNS. And so if you had a Route 53 domain, like you had your domain managed by AWS, you just point to the load balancer, and that's how you hook it up. So that's pretty much it. So yeah, there you go. All right, so there you go. We learned everything we wanted to know about EC2. So the last thing to do is to tear everything down. So we have a load balancer, we have an auto-scaling group, and those are the two things we'll have to pull on down. So the first thing would be to take down the auto-scaling group. And when you delete an auto-scaling group, it's going to delete all the EC2 instances. So we'll do it that way. If you tried to delete the EC2, it would just keep on spinning up. So you have to delete that first. And so as that's deleting, then we'll be able to delete our load balancer. I'm going to try anyway to see if I can delete it at the same time. And so I'll go up here. I'm going to go ahead and delete that load balancer. Actually, it did work, no problem. I'm going to make sure I don't have any elastic IPs. I'm going to also make sure I don't have any key pairs. You can keep your key pairs around, but like I just want to kind of clean this up. So, okay. Okay, and that instance should be terminating. Gotta go back to the auto-scaling group here. If we click into it, we can check its activity here. So it's just saying successful. So it is waiting on ELB connection draining, which is kind of annoying because we deleted our ELB, so there's nothing to drain. Draining is just to make sure that you know, there's no interruptions when terminating services, so it's just trying to be smart about it. And all I want to see is that it's just saying terminating over here, and then I think we're done. Okay, so we'll just have to wait a little while here, okay? And I'll see you back in a moment, okay? All right, so after waiting a very long time, it did destroy. So if I go down over to my load balancer here, we're going to see that it does not exist. So there was that connection draining thing, which was kind of annoying. It's probably because I deleted the load balancer first, and then the auto-scaling group second, and probably connection draining was turned on, but it's not a big deal. We just waited, and it did eventually delete. So we're pretty much all done here. So there you go. Hey, this is Andrew Brown from ExamPro, and we are taking a look at EC2 pricing models, and there are 5 different ways to pay with EC2. Remember, EC2 are virtual machines, so we have on-demand, spot, reserved, dedicated, and AWS savings plans. So what we'll do is look at these in summary here, and then we'll dive deep onto each of these different pricing models. So for on-demand, you are paying a low cost, and also you have a lot of flexibility with this plan. You are paying per hour, so this is a pay-as-you-go model. Or you could be paying down to the second, which we'll talk about the caveats there when we get to the on-demand section. This is suitable for workloads that are going to be short-term, spiky, unpredictable workloads. that cannot be interrupted, and it's great for first-time applications. And the on-demand pricing model is great when you need the least amount of commitment. For spot pricing, you can see we can save up to 90%, which is the greatest savings out of all these models here. The idea here is you're requesting spare computing capacity that AWS is not using, and that's where you're going to get that savings. You have flexible start and end times, but your workloads have to be able to handle interruptions because these servers can be stopped at any time to be giving to more priority customers. And this is great for non-critical background jobs, very common for like scientific computing, where jobs can be started and stopped at any given time. This has the greatest amount of savings. Then you have reserve or reserved instances. This allows you to save up to 75%. This is great for steady state or predictable usage. You're committing with AWS for EC2 usage over a period of 1 or 3 year terms. You can resell unused reserved instances, so you're not totally stuck with this if you buy them. This is great for the best long-term savings. Then you have dedicated, so these are just dedicated servers, and technically not a pricing model, but more so that the fact that it can be utilized with pricing models. But the idea here is it can be used with on-demand, reserved, or even spot. This is great when you need to have a guarantee of isolate hardware for enterprise requirements, and this is going to be the most expensive. So yeah, there you go, and we'll dive deep here, okay? So the on-demand pricing model is a pay-as-you-go model where you consume compute and then you pay later. So when you launch an EC2 instance, by default, you are using that on-demand pricing, and on-demand has no upfront payment and no long-term commitment. You are charged by the second up to a minimum of 60 seconds, so technically a minute, or the hour. So let's just talk about the difference between those per second billing and those per hour billing. So per second are for Linux, Windows with SQL Enterprise, Windows with SQL Standard, Windows with SQL Web Instances that do not have a separate hourly charge. And then everything else is going to be per hour. And so, you know, when I'm launching EC2 instance, I can't even tell when something's per second or per hour. You just have to know that it has a separate hourly charge. But generally, you know, if you're just launching things, it's going to probably be the per second billing. When you look up the hourly or the pricing, it's always shown in the hourly rate. So even if it is using per second billing, when you look up that pricing, it's always going to show it to you like that. But on your bill, you'll see it down to the second, okay? Up to the first 60 seconds. And on-demand is great for workloads that are short-term, spiky, or unpredictable. But when you have a new app development, this is where you want to experiment. And then when you're ready to start saving because you know exactly what that workload is going to be over the span of a year or 3, that's where we're going to get into reserved instances, which we'll cover next. Hey, this is Andrew Brown from ExamPro, and we are taking a look at reserved instances, also known as RI. And this is a bit of a complex topic. But, you know, if we do get through it, it's going to serve you well through multiple AWS certifications. So let's give it a bit of attention here. So RI is designed for applications that have a steady state, predictable usage, or required reserve capacity. So the idea is that you are saying to AWS, I'm going to make a guaranteed commitment saying this is what I'm going to use, and I'm going to get savings because AWS knows that you're going to be spending that money, okay? So the idea here is that the reduced pricing is based on this kind of formula where we have term, class offering, the RA attributes, and payment options. Technically, the RA attributes don't exactly factor into it, other than the fact that an RA attribute could be like the instance type size. But I'm going to put that in the formula there just because it is an important component. So let's take a look at each of these components of the formula to understand how we're going to save. So the first is the term. So the term, the idea here is the longer the term, the greater the savings. So you're committing to a 1-year or 3-year contract with AWS. And one thing you need to know is that these do not renew. So at the end of the year, the idea is that you have to purchase again. And when they do expire, your instances are just going to flip back over to on-demand with no interruptions to service. Then you have class offerings. And so the idea here is the less flexible the offering, the greater the savings. So the first is standard. And this is up to a 75 reduction in the price compared to on-demand. And the idea here is you can modify some RA attributes, which we'll talk about when we get to the RA attribute section there. Then you have convertible, so you save up to 54% reduced pricing compared to on-demand, and you can exchange RIs based on the RI attributes if the value is greater or equal in value. And there used to be a third class called schedule, but this no longer exists. So if you do come across it, just know that AWS is not planning on offering this again for whatever reason. I'm not sure why. Then there are the payment options. So the greater upfront, the greater the savings. So here we have all upfront. So full payment is made at the start of the term. Partial upfront, so a portion of the cost must be paid upfront, and the remaining hours in the terms are billed at a discounted rate. And then there's no upfront, so you are billed at a discounted hourly rate for every hour within the term, regardless of whether the reserved instance is being used. And this is really great, this last option here, because basically you're saying to AWS, you're saying like, I'm just going to pay my bill as usual, but I'm going to just tell you what it's going to be, and I'm going to save money. So if you know that you're going to be using a T2 medium for the next year, you can do that, and you're just going to save money, okay? So RIs can be shared between multiple accounts within an organization, and unused RIs can be sold in the reserved instance marketplace, but we'll talk about the limitations around that when we get a bit deeper in here. Just to kind of show you what it would look like in AWS console, and they updated it. I love this new UI here. The idea here is you're going to filter based on your requirements, and that's going to show you RIs that are available, and then you'll just choose the desired quantity. You can see the pricing stuff there. You're going to add it to cart. You're going to check out, and that's how you're going to purchase it, okay? So another factor to that formula were RI attributes, and sometimes the documentation calls them RI attributes, sometimes they call them instance attributes, but these are limited based on class offering and can affect the final price of the RI instance, and there are 4 RI attributes. So the first is the instance type. So this could be like an M4 large, and this is composed of an instance family, so the M4, and then the instance size, so large, okay? Then you have the region, so this is where the reserved instance is purchased. Then you have the tenancy, whether your instance runs on shared, so the default, which would be multi-tenant, or a single tenant, which would be dedicated hardware. And then you have the platform, whether you're using Windows or Linux. Even if you're using on-demand, of course, this would just affect your pricing, but there are some limitations around here, which we'll get into as we dive a bit deeper here with RI, okay? All right, let's compare regional and zonal RI. So when you purchase an RI, you have to determine the scope for it, okay? So this is not going to affect your price, but it's going to affect the flexibility of the instance. So this is something you have to decide. So we're going to talk about regional RI, which is when you purchase it for a regional, and zonal RI, when you purchase it for an availability zone. So when you purchase it for a regional RI, it does not reserve capacity, meaning that there's no guarantee that those servers will be available. So if AWS runs out of those servers, you're just not going to have them. But when it's zonal, you are reserving capacity, so there's a guarantee that those will be there when you need them. In terms of AZ flexibility, you can use the regional RI for any AZ within that region, but for the zonal RI, you can only use it for that particular region. When we're talking about instance flexibility, you can apply the discount to any instance in the family, regardless of the size. But then when we're looking at AZ, there is no instance flexibility, okay? So you're just going to use it for exactly what you defined. You can queue purchases for regional RI. You cannot queue purchases for zonal RI. So there you go. Let's talk about some RI limits here. So there's a limit to the number of reserved instances that you can purchase per month. And so the idea here is that you can purchase 20 regional reserved instances per region, and then 20 zonal reserved instances per AZ. So if you have a region that has 3 AZs, you can have 60 zonal reserved instances in that region, okay? There are some other limitations here. So for regional limits, you cannot exceed the running on-demand instance limit by purchasing regional reserved instances. The default for on-demand limit is 20. So before purchasing your RI, ensure on-demand limit is equal to or greater than your RI you intend to purchase. You might even want to open up a service limit increase just to make sure you don't hit that wall. For zonal limits, you can exceed your running on-demand instance limit by purchasing zonal reserved instances. If you already have 20 on-demand instances and you purchase 20 zonal reserved instances, you can launch a further 20 on-demand instances that match the specification of your zonal reserved instances. So there you go. let's talk about capacity reservation. So EC2 instances are backed by different kinds of hardware, and so there is a finite amount of servers available within an availability zone per instance type of family. Remember, an availability zone is just a data center or a collection of data centers, and they only have so many servers in there, so if they run out because the demand is too great, you just cannot spin anything up. And so that's what's happening. You go to launch a specific EC2 instance type, but AWS is like, sorry, we don't have any right now. And so the solution to that is capacity reservation. So it is a service of EC2 that allows you to request a reserve of EC2 instance type for a specific region and AZ. So here you would see that you just select the instance type, platform, AZ, tenancy, the quantity, and then here you might manually do it, specify time, or you might say, okay, I can't get exactly what I want, but can you give me something generally around that kind of stuff or that type that I want. So the reserve capacity is charged at the selected instance type on-demand rate, whether an instance is running in it or not. And you can also use regional reserved instances with your capacity reservations to benefit from billing discounts. So there you go. So there are some key differences between standard and convertible RI, so let's take a look at it here. So the first is that with standard RI, you can modify your attributes. So you can change the AZ within the same region, you can change the scope from a zonal RI to a regional RI or vice versa, you can change the instance size as long as it's a Linux and it has the default tenancy, you can change the network from EC2 Classic to VPC and vice versa. But when you're looking at convertible, you don't modify RI attributes, you perform an exchange, okay? And so standard RIs cannot do exchanges, where convertible RI, you can exchange during the term for another convertible RI with new RI attributes. And this includes the instance family, instance type, platform, scope, and tenancy. In terms of the marketplace, they can be bought in standard RI in the marketplace, or you can sell your RI if you don't need them anymore. But for convertible RI, they cannot be sold or bought in the marketplace. You're just dealing with AWS directly, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at the reserved instance marketplace. We had mentioned it prior, so let's give it a little bit more attention here. So it allows you to sell your unused standard RI to recoup your spend for RI you do not intend or cannot use. So reserved instances can be sold after they have been active for at least 30 days, and once AWS has received the upfront payment, you must have a US bank account to sell RI on the RI marketplace. There must be at least 1 month remaining in the term for the RI you are listing. You will retain the pricing and capacity benefit of your reservation until it's sold and the transaction is complete. Your company name and address upon request will be shared with the buyer for tax purposes. A seller can set only the upfront price of an RI. The usage price and other configurations such as instance type, availability zone, platform will remain the same as when the RI was initially purchased. The term length will be rounded down to the nearest month. For example, a reservation with 9 months and 15 days remaining will appear as 9 months on the RI market. You can sell up to 20,000 USD in reserved instances per year if you need to sell more RI. Reserved instances in the GovCloud region cannot be sold on the RI marketplace. So there you go. Hey, it's Andrew Brown from ExamPro, and we are taking a look at spot instances. So AWS has unused compute capacity that they want to maximize the utility of their idle servers. All right, so the idea is just like when a hotel offers booking discounts to fill vacant suites, or planes offer discounts to fill vacant seats. All right, so spot instances provide a discount of 90% compared to on-demand pricing. Spot instances can be terminated if the computing capacity is needed by other on-demand customers, but from what I hear, rarely does spot instances ever get terminated. It's designed for applications that have flexible start and end times, or applications that are only feasible at very low compute costs. So you see some options here like load balancing workloads, flexible workloads, big data workloads, things like that. There is another service called AWS Batch, which is for doing batch processing, and this is very common what you use Spot with. And so, you know, if you find the Spot interface too complicated and you're doing batch processing, you want to use this service instead. There are some termination conditions. So instances can be terminated by AWS at any time. If your instance is terminated by AWS, you don't get charged for a partial hour of usage. If you terminate an instance, you will be still charged for an hour that it ran. So there you go. Hey, this is Andrew Brown from ExamPro, and we are taking a look here at dedicated instances. So dedicated instances is designed to help meet regulatory requirements. AWS also has this concept called dedicated hosts, and this is more for when you have strict server-bound licensing that won't support multi-tenancy or cloud deployments, and we'll definitely distinguish that in this course, but just not in this slide in particular. And so to understand dedicated instances or hosts, we need to understand the difference between multi-tenancy and single tenancy. So multi-tenancy, you can think of it like everyone living in the same apartment. And single tenancy, you can think of it everyone having their own house. So the idea here is that you have a server. I'm just going to get my cursor or my pen out here to say server. And you have multiple customers running workloads on the same hardware. And the idea is that they are separated via virtual isolation. So they're using the same server, but it's just software that might be separating them, okay? And then we have the idea of single tenancy. So we have a single customer that has dedicated hardware. So the physical location is what separates customers. And the idea here is that dedicated can be offered via on-demand, reserved, and spot. So that's why we're talking about dedicated here in the pricing model, just so you know that, even though these are a lot more expensive than on-demand, you can still save by using reserved and also spot, which I was very surprised about. And when you want to choose dedicated, you're just going to launch your EC2 and you'll have a drop down where you have that shared. So that's the default. Dedicated, so you have dedicated instance and dedicated host. And again, we'll talk about dedicated host later when we need to here. And so again, the reason why enterprises or large organizations may want to use dedicated instances is because they have a security concern or obligation about against sharing the same hardware with other AWS customers. Okay. Hey, this is Andrew Brown from ExamPro, and we are taking a look at AWS savings plans. And this is similar to reserved instances, but simplifies the purchasing process. So it's going to look a lot like RI at the start here, but I'll tell you how it's a bit different, okay? So there are three types of saving plans. You have Compute Savings Plan, EC2 Instance Saving Plans, and SageMaker Saving Plans. And so you just go ahead and choose that. You can choose two different terms, so 1 year, 3 year, so it'd be simple as that. And then you choose the following payment options. So you have all upfront, partial payment, and no upfront. And then you're going to choose that hourly commitment. You're not having to think about standard versus convertible, regional versus zonal, RI attributes. It's a lot simpler. And let's just talk about the three different saving plans or types in a bit more detail. So you have compute. So compute savings plans provides the most flexibility and helps to reduce your cost by 66%. These plans automatically apply to EC2 instances usage, AWS Fargate, AWS Lambda service usage, regardless of the instance family, size, AZ, region, OS, or tenancy. Then you have EC2 instances. So this provides the lowest prices, offering saving up to 72% in exchange for commitment to usage of individual instance families in a region. So automatically reduce your costs on the selected instance family in the region, regardless of AZ size, OS, tenancy. Gives you the flexibility to change your usage between instances within a family in that region. And the last is SageMaker. So it helps you reduce SageMaker costs by up to 64%. Automatically apply to SageMaker usage regardless of instance family, size, component, AWS region. If you don't know what SageMaker is, that's AWS's ML service, and it uses EC2 instances, or specifically ML EC2 instances. So everything's basically using EC2 here, but there you go. All right, let's take a look at the Zero Trust model. And the Zero Trust model is a security model which operates on the principle of trust no one and verify everything. So what I mean by that is malicious actors being able to bypass conventional access controls demonstrates traditional security measures are no longer sufficient, and that's where the Zero Trust model comes into play. So with the Zero Trust model, identity becomes the primary security perimeter. And so you might be asking, well, what do we mean by primary security perimeter? The primary or new security perimeter defines the first line of defense, and it's security controls that protect a company's cloud resources and assets. If it still doesn't make sense, we do cover a part of the defense in depth where you see the layers of defense from data all the way to physical. And so you can kind of see, what we're talking about in that model there. But the old way that we used to do things is network-centric. So we had traditional security focused on firewalls and VPNs since there were few employees or workstations outside the office, or they were in a specific remote office. So we treated the network as kind of like the boundary. So if you're in office, there's nothing to worry about. But we don't think like that anymore because everything is identity-centric. So this is where we have bring your own device, remote workstations, which are becoming more common. We can't always trust that the employee is in a secure location. We have identity-based security controls like MFA, providing provisional access based on the level of risk from where, when, and what a user wants to access. And identity-centric does not replace, but it augments network-centric security. So it's just an additional layer of consideration for security when we're thinking about our AWS cloud workloads, okay? All right, so we just loosely defined what the zero trust model is. So let's talk about how we would do zero trust on AWS. And so zero trust has to do a lot with identity security controls. So let's talk about what is at our disposal on AWS. So on AWS, we have Identity and Access Management, IAM. This is where we create our users, our groups, our policies. So an IAM policy is a set of permissions that allow you to say, okay, this user is allowed to use these services with these particular actions. Then you have the concept of permission boundaries. And so these are saying, okay, these aren't the permissions the user has currently, but these are the boundaries to which we want them to have. So they should never have access to ML services. And if someone's to apply them permissions, it'll always be within these boundaries. Then you have service control policies, and these are organization-wide policies. So if you have a policy where you don't want anyone to run anything in the Canada region, you can apply that policy at the organizational level and it will be enforced. Then within an IAM policy, there are the concept of conditions. And so these are all the kind of like little knobs you can tweak to say, how do I control based on a bunch of different factors? So there is source IP, so restrict where the IP address is coming from. A requested region, so restrict based on the region, as we were just mentioned as an example. Multi-factor auth present, so restrict if MFA is turned off. Current time, so restrict access based on time of day. Maybe your employee should never be really using things at night, and so that could be an indicator that someone is doing something malicious. So only give them access during a certain time of day. And so that's where we're going to figure out, based on all these type of controls, security controls to our AWS resources, we can kind of enforce the zero trust model on AWS. AWS does not have a ready-to-use identity controls that are intelligent, which is why AWS is considered not to have a zero trust offering for customers, and third-party services need to be used. So what I'm saying is that technically, this checkbox is this thing saying, okay, we can kind of do zero trust on AWS, but there's a lot of manual work. And, if I was to say, okay, I don't want anyone using this at nighttime, that doesn't really detect, you know what I'm saying? It's not going to say, oh, I think this time is suspicious or malicious, so then restrict access only to these core services and anything outside of those services can't be used. It just can't exactly do that without a lot of work yourself, and that's what I'm talking about here, where we have a collection of AWS services that can be set up in an intelligent-ish detection way for identity concerns, but requires expert knowledge. So the way you might do that on AWS is that all the API calls go through AWS CloudTrail. And so what you could do is feed those into Amazon GuardDuty, and GuardDuty is an intrusion detection and protection system. So it could detect suspicious or malicious activity on those CloudTrail logs, and you could follow that up with remediation, or you could pass that on to Amazon Detective that could analyze, investigate, and quickly identify security issues that it could ingest from GuardDuty. But I'm telling you that this stuff here is not as easy for the consumer. And so, of course, you can do zero trust model, but it's going to take a lot of work here. And there are some limitations, which we'll talk about next here. So now let's see how we would do zero trust on AWS with third parties. So AWS does technically implement a zero trust model, but does not allow for intelligent identity security controls, which, you can do it, but it's a lot of work. So let's kind of compare it against kind of a third party where we would get the controls that we would not necessarily get with AWS. So for example, Azure Active Directory has a real-time and calculated risk detection based on data points than AWS. And this is based on device and application, time of day, location, whether MFA is turned on, what is being accessed, and the security controls verification or logic restriction is much more robust. So, just as one particular example, like device and application is not something that AWS factors in with the existing controls, or at least not in a way that is consumer friendly. And, I can't say on AWS, okay, when you think that this is the type of threat, only allow them access to these things. Or if you think they're in a risky area or risky location, only give them access to, these things where there's not sensitive data. You can't exactly do that in AWS very easily. And so this is where third-party solutions are going to come into play. So you have Azure Active Directory, Google Beyond Corp, Jump Cloud, and all these have more intelligent security controls for real-time detection. And so the way you would use these is these would be your primary directories. For Google Beyond Corp is just a zero trust framework. So I guess you'd use Google's cloud directory. But the idea anyway here is that you'd use single sign-on to connect those directories to your AWS account. And that's how you'd access those AWS resources, and you get this more robust functionality, okay? Hey, it's Andrew Brown from ExamPro, and we're looking at identity. Now, we need to know a bunch of concepts before we talk about identity on AWS, so let's jump into it. The first is a directory service. So what is directory service? Well, it's a service that maps the names of network resources to network addresses. And a directory service is shared infrastructure or information infrastructure for locating, managing, administrating, and organizing resources such as volumes, folders, files, printers, users, groups, devices, telephone numbers, and other objects. A directory service is a critical component of a network operating system, and a directory server or a name server is a server which provides a directory service. So each resource on the network is considered an object by the directory server. Information about a particular resource is stored as a collection of attributes associated with that resource or object. Well-known directory services would be a domain name service. So the directory service for the internet, Microsoft Active Directory, and they have a cloud-hosted one called Azure Active Directory. We have Apache Directory Service, Oracle Internet Directory, so OID, Open LDAP, Cloud Identity, and Jump Cloud, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at Active Directory. Now, you might say, well, we're doing AWS. Why are we looking at this? Well, no matter what cloud service provider you're using, you should know what Active Directory is, especially when it comes to identity, because you can use it with AWS. So let's talk about it. So Microsoft introduced Active Directory domain services in Windows 2000 to give organizations the ability to manage multiple on-premise infrastructure components and systems using a single identity per user. And since then, it's evolved. Obviously, it's running beyond Windows 2000 as of today. And they even have a managed one called Azure AD, which is on Microsoft Azure. But just to kind of give you an architectural diagram here, the idea is that you would have your domain servers here. And they might have child domains, and the idea is that you have these running on multiple machines so that you have redundant ability to log in from various places. When you have a bunch of domains, it's called a forest. And then within a domain, you actually have organizational units. And within organizational units, you have all your objects like your users, your printers, your computers, your servers, all things like that, okay? Hey, it's Andrew Brown from ExamPro, and we're talking about identity providers, or IPDs. So hey, this is Andrew Brown from ExamPro, and we are talking about identity providers, also known as IDPs. So an identity provider is a system entity that creates, maintains, and manages identity information for principals and also provides authentication services to applications with a federation or distributor network, a trusted provider of your user identity that lets you authenticate to access other service identity providers. So this could be like Facebook, Amazon, Google, Twitter, GitHub, LinkedIn. Federated identity is a method of linking a user's identity across multiple separate identity management systems. And so some things that we can use for that is like OpenID. So this is an open standard and decentralized authentication protocol. It allows you to be able to log in to different social media platforms using Google or Facebook account. OpenID is about providing who you are. Then we have OAuth 2.0. This is an industry standard protocol for authorization. OAuth doesn't share password data, but instead uses authorization tokens to prove an identity between consumers and service providers. OAuth is about granting access to functionality. And then we have SAML, so Security Assertion Markup Language, which is an open standard for exchanging authentication and authorization between an identity provider and a service provider. And this is important use for SAML, which we use for single sign-on via the web browser. Okay. Hey, this is Andrew Brown from ExamPro, and we're looking at the concept of single sign-on. So SSO is an authentication scheme that allows a user to log in with a single ID and password to different systems and software. SSO allows IT departments to administer a single identity that can access many machines and cloud services. So the idea is you have Azure Active Directory. This is just an example of a very popular one. You'd use SAML to do SSO, and you can connect to all things: Slack, AWS, Google Workspaces, Salesforce, or your computer. The idea here is once you log in, you don't have to log in multiple times. So you log into your primary directory, and then after that, you're not going to be presented with a login screen. Some services might show an intermediate screen, but the idea is you're not entering your credentials in multiple times. So it's seamless. All right, let's talk about LDAP. So Lightweight Directory Access Protocol is an open, vendor-neutral, industry-standard application protocol for accessing and maintaining distributed directory information services over IP networks. So a common use of LDAP is to provide a central place to store usernames and passwords. LDAP enables for same sign-on. So same sign-on allows users to use a single ID and password, but they have to enter it every single time they want to log in. So maybe you have your on-premise Active Directory, and then it's going to store it in that LDAP directory. And so the idea is that, all these services like Google, Kubernetes, Jenkins is going to deal with that LDAP server. So why would you use LDAP over SSO, which is more convenient or seamless? So most SSO systems are using LDAP under the hood, but LDAP was not designed natively to work with web applications. So some systems only support integration with LDAP and not SSO. So you got to take what you can get, okay? Let's take a look here at multi-factor authentication, also known as MFA, and this is a security control where after you fill in your user's name and email password, you have to use a second device such as a phone to confirm that it's you that is logging in. So MFA protects against people who have stolen your password. MFA is an option in most cloud providers and even social media websites such as Facebook. So the idea is I have my username or email and password. I'm going to try to log in. This is the first factor. And the second factor, or multi-factor, is I'm going to use a secondary device, so maybe my phone, where I'm going to enter in different codes, or maybe it's passwordless, so I just have to press a button to confirm that it's me, and then I'll get access. So in the context of AWS, it's strongly recommended that you turn on MFA for all your accounts, especially the AWS root account. We'll see that when we do the follow-alongs. Let's take a look at security keys. So a security key is a second device used as a second step in authentication process to gain access to a device, workstation, or application. A security key can resemble a memory stick, and when your finger makes contact with a button of exposed metal on the device, it will generate and autofill a security token. A popular brand of security keys is the YubiKey, and this is the one I use and looks exactly like the one that's right beside my desk. It works out of the box with Gmail, Facebook, and hundreds more. Supports FIDO2, WebAuthn, U2F. It's waterproof and crush resistance. It has variations like USB-A, NFC dual connectors on a single key. Can do a variety of things. So when you turn on MFA on your AWS account, you'll have virtual MFA device. So that's when you're using something like a phone or using software on your phone to do that. Then there's the U2F security key. So this is what we're talking about right now. And there's even other kinds of hardware MFA devices, which we're not really going to talk about, but just security keys tie into MFA. And this is a lot better way than using a phone because, you can have it on your desk and press it, and, you don't have to worry about your phone being not charged, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at AWS Identity and Access Management, also known as IAM. And you can use this service to create and manage AWS users, groups, use permissions to allow and deny their access to AWS resources. So there's quite a few components here. Let's get to it. So the first is IAM policies. So these are JSON documents which grant permissions for specific users, groups, or a role to access services. And policies are attached to IAM identities. Then you have IAM permissions or permission. And this is an API action that can or cannot be performed, and they're represented in the IAM policy document. Then there's the IAM identities. So we have IAM users. These are end users who log into the console or interact with AWS resources pragmatically or via clicking UI interfaces. You have IAM groups. So these group up your users so they all share the same permission levels. So that maybe it's admins, developers, or auditors. Then you have IAM roles. So these roles grant AWS resources permissions to specific AWS API actions and associate policies to a role and then assign it to an AWS resource. So just understand that roles are when you're attaching these to resources. So like if you have an EC2 instance and you say it has to access S3, you're going to be attaching a role, not a policy directly, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at IAM policies a little bit closer here, and they are written in JSON and contain the permissions which determine the API actions that are allowed or denied. And rarely do I write these out by hand because they have a little wizard that you can use to write out the code for you. But if you want to, you absolutely can write it out by hand, but we should know the contents of it and how these JSON files work. So the first thing is the version, which is the policy language version, and it's been 2012 for a very long time. I don't see that changing anytime soon. If they happen to change what the structure of the JSON is, then you have the statements, and these are for policy elements, and you're allowed to have multiples of them. So the idea is that this is the policies or permissions, we should say, that you plan on applying. Then you have the SID. This is a way of labeling your statements. This is useful for like visualization or for referencing it for later on, but a lot of times you don't have to have a SID. Then there's the effect. It's either allow or deny. Then you have the action. So here we're saying give access to S3 for all actions under it. There's another action down below where it's saying give access. I'm gonna get my pen tool out here just to create a service link role. So that's a cross account role there. Then there's the principal. So this is the account, user, role, or federated user to which you would like to allow access or deny. So we're specifically saying this IAM user named Barkley in our AWS account there. Then there are the resources. So the resources to which the action applies. So in this one up here, we are specifying a specific AWS bucket. Here we're saying all possible resources in an AWS account. And then the condition. So there's all sorts of different kinds of conditions. So this is a string-like one, and it's saying, look at the service name, and if it starts with this or that, then they'll have access to that. So this person, even though it says all resources, they're really only going to have access to RDS, okay? So in this follow along, we're going to take a closer look at IAM policies. So go to the top and type in IAM. And what we'll do is make our way over here, all the way over to policies. And what I want to do is create a new policy that only has access to limited resources. So let's say we want to create an Amazon EC2 instance, and that EC2 instance has access to a very particular S3 bucket. So what I want you to do is make your way over to S3, and we're going to create ourselves a new bucket. And I'm going to go ahead and create a bucket here. We're going to call this policy tutorial. And I'm going to just put a bunch of numbers here. You'll have to randomize it for your use case. And so now that we have our bucket, what we're going to do is go ahead and create a policy. And the policy is going to choose a service. We're going to say S3. And what I want to do is only be able to list out actions. I'm going to expand this so I don't want everything. So we're just going to say list buckets. Okay. And then what we'll do is expand this here. And I want to say for a particular bucket. So we'll go back over here, click into our bucket. And we're going to go ahead and set those permissions by finding that ARN. We're going to paste that. We're going to paste that ARN up there. Sometimes it's a bit tricky. It vanishes on you. And we could set other conditions if we wanted to, but this is pretty simple as it is. And so that's our rule here, right? So we're saying this policy allows us to list this bucket for that, okay? So what we'll do is go ahead and hit next. We'll hit review, and we'll just say my bucket policy, and we'll create that policy. Okay, so there's a few other things I think that I'd like to do with this policy. I'm going to pull it back up here. So if we want to find it, you used to be able to filter these based on the ones that you created. But yeah, these are like the little icons. So these are ones that I've created up here. And so there's my bucket policy. And I feel like I want to update this policy to have a bit of extra information here. So I'm going to go edit this policy. No, you know what? I think this is fine. So what I want to do is now create a role. And we're going to create a new role, and I'm going to call this, well, before I do, I need to choose what it's for. So it's going to be for EC2. So we're going to go ahead and hit next. We're going to choose our policy. So my bucket policy, there it is. And I want to add another one here because I want to be able to use Sessions Manager because I really don't want to use an SSH key to check that this works. And so for this, I need to use SSM. So I'm going to type in SSM here. And I'm going to just make sure this is the new one. So this policy will soon be deprecated. Use Amazon SSM Managed Core Instance. You should always open these up and read them and see what they do. And so that's the one that's going to allow us to access Systems Manager so we can use Sessions Manager, okay? And so I'm going to say my EC2 role for S3. And we're going to go ahead and create ourselves a role. And so now that we have our role, I'm going to go over to EC2. And I'm going to go ahead and launch myself a new instance. We're going to choose Amazon Linux 2. We're going to stick with T2 Micro. I'm going to go over to configuration here. Everything is fine here. I'm fine with all that. Storage is fine. We'll go to security group. And I don't want any ports open because I'm not going to be using SSH. We're going to launch this instance. I don't even want a key pair. Okay. And then we're going to go over here. And so what we're waiting for is this instance to launch. As that is going, what I want to do is go over to my S3 bucket, and I want to place something in this bucket. So I do have some files here. So what I'm going to do is create a new folder here. Whoops. I'm going to go back, and I'm just going to create a folder first. Create a folder. Enterprise D. And I'm going to click into this, and then I'm going to upload all of my images here. So you'll have to find your own images off the internet. This is just the ones I have. And we'll go ahead and upload those. Give that a moment. Okay, and so we don't have access to read those files. We'll adjust our policy as we go so that we can do that, okay? So this instance should be running. It doesn't have the 2 status checks passed, but we should be able to connect to it. So click on connect here. And so we have options like EC2 Instance Connect, Sessions Manager, SSH Client. I want you to go to Sessions Manager. It says we weren't able to connect to your instance. Common reasons, SSM agent wasn't installed. We absolutely have that installed. The required IAM profile. Oh, right. So we were supposed to attach, I forgot to do it. We were supposed to attach an IAM profile, right? So an IAM profile is the role. It holds the role that's going to give the permissions to that instance. And since we didn't add it, we have to go retroactively add it after the fact. And so I'm going to have to modify the IAM role, and we're going to choose my EC2 role for S3, and we're going to save that. And actually when that happens, you have to reboot the machine. You only have to do that if you have no role attached, like prior, no profile attached, and you're attaching it for the first time. But after that, you never have to reboot the machine. This is the only case where you'd have to do that. That's why when I launch an EC2 instance, I always at least have the SSM role attached, the managed one that gets Sessions Manager, so that I don't ever have to do a reboot in case I have to update the policy. And so we will give that a moment there. It says initializing, so I'm going to try again to connect to it, okay? And we still don't have that option there. So I'm going to go back to my instances. I'm going to check to see if the role or policy is attached, or profile, I should say. So I'm just looking for it here. There it is. And so if I click into this, into the role, we can see that we have the Amazon SSM managed instance core there. So that's set up. And the my bucket policy. So this has everything that it should be able to do it, no problem. Okay, so I'm going to try that again. Okay, so now the connect shows up. AWS is finicky like that. You just have to have confidence in knowing what you're doing is correct, okay? We'll go ahead and hit connect. And I didn't have to use SSH keys or anything, and this is a lot more secure way to connect to your instances. When it logs us in, it's going to set us as the SSM user, but we want to be the EC2 user, okay? That's AWS always makes their their Linux versions as the EC2 user, and that's what you're supposed to use. But it's just that's how you have to get to that. You just have to type that sudo su-ec2 user, okay? Just once. And if you type who am I, that's who you are. If you type exit, you'll go back to that user. So if I type exit, and I type who am I, I'm now this person. So I'm going to go back, hit up, go back in there, type clear. So now I want to see if I have access to S3. So I have to do AWS S3 LS. I want to see if I can list buckets. It says access denied. So, I mean, that kind of makes sense because if you have list buckets and we're just saying only that bucket, that might not make a whole lot of sense. So I'm going to go back to my policy. I might have just written a crummy policy, but we'll say IAM here. If we have that one open, we should just go here and click on this policy here. I'm going to edit that policy. So what I'm going to do is I'm just going to change it and we're going to say all resources, review the policy, save changes, and we'll see how fast that propagates. Okay. Because I'm pretty sure I don't have to do anything here. It should just now give me full access to S3. Just going to keep on hitting up here. So what I'm going to do is I'm just going to take like a 3-4 minute break. Going to get a drink. I'm going to come back here and see if this propagates. I'm pretty sure I don't have to do anything for that to propagate. And I think that I've attached everything correctly here, okay? Okay, so I haven't had much luck here. It's still having the same issue. So if that is happening, what I'm going to do is I'm just going to reboot it because maybe I didn't give it a good opportunity to reboot there. Again, I don't think we should have to reboot it every time when we're changing things there, but we will give it another go here and see if that fixes that problem there. So no sessions manager is going to time out here, which is totally fine. It's going to kill that session there. And so what we'll have to do is close this out because there's not much we can do with that. And we're going to go ahead and go back to connect. And so we're waiting for this button to appear because it is rebooting. So if we want to monitor that stuff, usually there is an option here to monitor where it'll show us the system logs of what it's doing. So here it's just like restarting the machine. I'm not sure if we expect to see something after this. So I can click that there. And yeah, it's easy to get turned around in this. So I can connect to it again now. We'll type in sudo su-ec2 user, AWS S3 LS. And we still have access denied for list buckets. So if that's the case, it could be that sometimes you need other permissions when doing list policy, like list buckets. So if that's the case, we're going to do a sanity check. I'm just going to say all permissions here, okay? And this way, there's no way that I've set this incorrectly. It just has to work now. So type this in. There we go. Okay, so there has to be something more to it. So just because you say list buckets, you know, like means there must be more to it, right? So if I go here to this, right, and I say, whoops, and I say list buckets here, we'll say copy, paste, okay. here it's saying maybe I need get object as well. So I just know from using AWS a long time that that's the case, that it could be more than one thing. So, you know, that was in the back of my mind that that could be happening. And I guess that is. But notice I didn't have to restart my my server, boot my server to get those to work. But anyway, let's go lock that down and see if we can just kind of make this more focused. So let's say all resources, I'm going to specify the condition. So I might want to just say for particular buckets. So we'll say specific. When you checkbox everything, then you have to do this. So for storage accounts, these are fine. Any for objects, that could be something. We'll say multi-region access, bucket, any bucket. But what I'm going to say is I want to only allow them to access things in a particular bucket. And so if I go to ARN here, what is our bucket name? Our bucket name is policy tutorial 3414 whatever, right? And so we can actually give it a wildcard, or we can say enterprise D. And we learned this in the course that you can provide ARNs with randomized things there. I don't know if I spelt it wrong over here, so I should really double check. I should probably just copy it. Oops. I just don't want to type it wrong. And so this, okay, means that we should only be able to get stuff from there. I'm going to review the policy. Let's see if it takes. Save the changes. And if I just view the JSON here, notice it says anything from here, right? So allow S3 anything as long as it's within here. And then it also broke it up into sub ones for here, okay? So anyway, what I want to see is what happens if I upload something into the loose area here. So I'm going to say upload, and I'm going to just say add a file. And we're just going to grab data here and upload it. Go back to our bucket. There's our file. We have that stuff in there. And so if I go back over to my EC2 instance, which I'm still connected to, who am I? Okay, great. Clear. So I'm going to say AWS S3LS, see if that works still. It does. Good. And so what I want to do is see if I can copy a file locally. So I'm going to do AWS S3 copy. I think it was S3. No, it's just S3. Copy policy S3 / policy tutorial 34141. Whoops, 34 tutorial hyphen 34141 / enterprise D data.jpg. I think it's a JPG. Let's go double check. Yeah, it is. Okay. And then I just want to say data.jpg. And it downloaded it, right? So I'm going to remove that one. And so now what I'm going to do is I'm just going to see if my policy is working, or maybe my permissions aren't exactly what I think they are. And I was able to download it. So these policies can get kind of tricky because like this one says allow all actions for these, but then these say all actions. And so that makes it hard because I want get object. So another thing we can do, and if that one doesn't work really well, I'm just going to write one by hand. It's not that scary to write these by hand. You just get used to it. So I'm going to say effect. Is it disallow? Or maybe it's deny. Deny. Action. S3 get object. I believe that's what it is. Resource. And then I'm going to specify exactly the resource I don't want it to allow. So we're going to say ARN AWS S3 3 colons policy tutorial 34141. I'm going to say data.jpg. Now, if this is not valid, it's going to complain and say, hey, you didn't write this right. And it's fine. Okay, so we'll save those changes. And so that should deny access to that, right? Hopefully I got the policy right. Okay, so that one doesn't work, which is fine. And that one's fine. So that worked. We were able to deny that. But you can see there's a little bit of an art to creating these policies. As you make more of them, it becomes a lot easier. So hopefully it's not too scary, but that's all there really is to it that I want to show you today. So what we're going to do is clear out this bucket. We're done with this bucket here. So we'll say delete. Whoops, we got to empty it first. And we'll just say permanently delete here. Okay. And we will exit that out. We're going to go ahead and delete that bucket. Grab its name here. And we'll go back over here. I think I forgot to delete this bucket from earlier. I'm just going to delete that because I don't need that bucket. If that's okay with you. Just going to go ahead and delete that. And we have that EC2 instance running, so we want to stop that. So we go ahead and we're going to terminate that. Yes, please. And then we'll go to IAM and do some cleanup. I have some custom roles I've been creating, from prior things, a lot of those. Usually there's a way to, we've redesigned it. Okay, where's the redesign? This is the redesign? That can't be it. Because there'll be like roles that AWS makes. I think these are all roles that I've made. I don't want to delete service roles. But I want to get rid of some of these because I just have too many, It's getting out of hand for me. And I'm going to just see if it will let me delete all of these. Let's delete those. There we go. Just clean up a bit. I still have a lot here, but there's like service roles that AWS creates once, and you really don't want to delete those because you don't. And then I have a bunch of these, like I'm never going to use these, so I might as well detach them, delete, detach. You really don't want to keep like roles that you're never going to use around. Things like that, like gauze. We're going to be using that again. Delete. There's that bucket we just created. But anyway, you get the idea. So yeah, that's IAM. Okay. Principle of least privilege, POLP, is the computer security concept of providing a user, role, or application the least amount of permissions to perform an operation or an action. And the way we can look at it is that we have just enough access, so JEA, permitting only the exact actions for the identity to perform a task. And then we have just in time, JIT, permitting the smallest length of duration an identity can use permission. So usually when we're talking about POLP, it's usually a focus on here, but now these days there's a larger focus on JIT as well. And so JIT is the difference between having long-lived permissions or access keys versus short-lived ones. And the most progressive thing in POLP is now risk-based adaptive policies. So each attempt to access a resource generates a risk score of how likely the request is to be from a compromised source. So the risk score could be based on many factors such as device, user location, IP address, what service is being accessed and when, did they use MFA, did they use biometrics, things like that. And right now, as of this time, AWS does not have a risk-based adaptive policies built into IAM. You can roll your own. What's interesting is Cognito has risk-based adaptive policies. They call it like adaptive authentication, but that's for user pools and not identity pools. User pools is for getting access to an app that you have built through an IPD, where identity pools in Cognito is about getting access to AWS resources. So, I'm sure AWS will get it eventually, but they just don't have it right now, and you have to rely on third-party identity solutions to get risk-based adaptive policies. Now, talking about just enough access and just in time is like, you think, how would you do that with AWS? You just add and remove permissions manually. Well, one thing you could do is use something like Console.me. So this is an open source Netflix project to self-serve, short-lived IAM policies so an end user can access AWS resources while enforcing JEA and JIT. And so there's a repo there as well. But the idea is they have like this self-serve wizard. So you say, I want these things, and then the machine decides, okay, you can have them, or you don't need them. And it just frees you up asking people and worrying about the length and stuff like that. Okay. Hey, this is Andrew Brown from ExamPro, and we are taking a look at the AWS root user. And this gets confusing because there's an AWS account, root user, and regular user. So let's distinguish what those three things are. So here we have an AWS account, and the account which holds all the AWS resources, including the different types of users. Then you have the root user. This is a special account with full access that cannot be deleted. And then you have just a user, and this is a user for common tasks that is assigned permissions. So just understand that sometimes people say AWS account, they're actually referring to the user, and sometimes when they're saying AWS account, they're actually referring to the AWS account that holds the users. I know it's confusing, it's based on what people decide the context is when they're speaking. So the AWS account root user is a special user who's created at the time of the AWS account creation, and they can do they have a lot of conditions around them. So the root user account uses an email and password to log in, as opposed to the regular user, who's going to provide their account ID, alias, username, and password. The root user account cannot be deleted. The root user account has full permissions to the account and its permissions and cannot be limited. And when we say it cannot be limited, we're saying that if you take an IAM policy to explicitly deny the root user access to resources, it's not something you can do. However, you can do it in the case of AWS organizations with service control policies, because a service control policy applies to a bunch of accounts, so it's one level above, and so that is a way of limiting root users. But generally, you can't limit them within their own account. There can only be one root user per AWS account. The root user is instead for very specific and specialized tasks that are infrequently or rarely performed, and there's a big list, and we'll get into that here in a moment. And the AWS root account should not be used for daily or common tasks. It's strongly recommended to never use the root user's access keys, because you can generate those and use them. It's strongly recommended to turn on MFA for the root user, and AWS will bug you to no ends to tell you to turn it on. So let's talk about the tasks that you should be performing with the root user, and only the root user can perform. So changing your account settings. So this includes account name, email address, root user password, root user access keys. Other account settings such as contact information, payment currency preference, regions do not require the root user credentials. So not everything. Restore IAM user permissions. So if there's an IAM admin, so it's just a user that has admin access who actually revokes their own permissions, you can sign into the root user to edit policies and restore those permissions. So you can also activate IAM access to the billing and cost management console. You can view certain tax invoices. You can close your AWS account. You can change or cancel your AWS support plan, register as a seller in the reserved instance marketplace, enable MFA delete on S3 buckets, edit or delete an Amazon S3 bucket policy that includes an invalid VPC ID or VPC endpoint ID, sign up for GovCloud, and something that's not in here, I took this from the documentation, but you can use the AWS account user to create the organization. You can't create that with any other user. So the ones I highlighted in red are very likely to show up in your exam, and that's why I highlighted them there for you, but there you go. Hey, this is Andrew Brown from ExamPro, and we are taking a look at AWS Single Sign-On, also known as AWS SSO. And so this is where you create or connect your workforce identities in AWS once and manage access centrally across your AWS organization. So the idea here is you're going to choose your identity source, whether it's AWS SSO itself, Active Directory, SAML 2.0 IDP. You're going to manage user permissions centrally to AWS accounts, applications, SAML applications. And it uses, you get single click access to all these things. So, just to kind of zoom in on this graphic here, you have your on-premise Active Directory. It's establishing a AD trust connection over to AWS Single Sign-On. You're going to be able to apply permissions to access resources within your AWS account. So via AWS organizations in your organizational units down to your resources. You can also use AWS SSO to access custom SAML-based applications. So, if I built a web app and I like the ExamPro platform and I wanted to use SAML-based connections for single sign-on there, I could do that as well. And you can connect out SSO access to your business cloud application. So Office 365, Dropbox, Slack, things like that. So there you go. Well, let's take a look here at application integration. So this is the process of letting two independent applications to communicate and work with each other, commonly facilitated by an intermediate system. So cloud workloads strongly encourage systems and services to be loosely coupled. And so AWS has many services for the specific purpose of application integration. And these are based around common systems or design patterns that utilize application integration. And this would be things like queuing, streaming, pub/sub, API gateways, state machines, event buses, and I'm sure there are more, but that's what I could think about that are the most common ones, okay? So to understand queuing, we need to know what is a messaging system. So this is used to provide asynchronous communication and decouple processes via messages and events from a sender, a receiver, or a producer and a consumer. So a queuing system is a messaging system that generally will delete messages once they are consumed. It's for simple communication. It's not real time. You have to pull the data. It's not reactive. And a good analogy would be imagining people that are queuing in a line to go do something. So for AWS, it's called Simple Queuing Service, SQS. It's a fully managed queuing service that enables you to decouple and scale microservices, distributed systems, and serverless applications. So a very common use case in a web application would be to queue up transactional emails to be sent, like sign up, reset password. And the reason why we have queuing to decouple those kind of actions is that if you had a long running task and you had too many of them, it could hang your application. So by decoupling them and letting a separate compute service take care of that, that would be something that would be very useful, okay? Let's take a look here at streaming. And so this is a different kind of messaging system, but the idea here is you have multiple consumers that can react to events. And so in streaming, we call messages events, and then in a queuing system, we just call them messages. But events live in the stream for long periods of time, so complex operations can be applied. And generally, streaming is used for real-time stuff, whereas queuing is not necessarily real-time. And so AWS's solution here is Amazon Kinesis. You could also use Kafka, but we'll focus on Kinesis here. So Amazon Kinesis is the AWS fully managed solution for collecting, processing, and analyzing streaming data in the cloud. So the idea is that you have these producers that are producing events, could be EC2 instances, mobile devices, could be a computer or traditional server. They're going to go into the data stream. There's a bunch of shards that scale, and there's consumers on the other side. So maybe Redshift wants that data, DynamoDB, S3, or EMR, okay? But the thing you have to remember is that streaming is for real-time data. And as you can imagine, because it's real-time and it's doing a lot more work than a queuing system, it's going to cost more, okay? So we have another type of messaging system known as pub/sub. So this stands for publish subscribe pattern, commonly implemented in messaging systems. And a pub/sub system, the sender of messages, the publishers do not send their messages directly to receivers. They instead send their messages to an event bus. The event bus categorizes their messages into groups. Then receivers of messages, subscribers, subscribe to these groups. Whenever new messages appear within their subscriptions, the messages are immediately delivered to them. So the idea is you have publishers, event bus subscribers, and event buses appear more than once. So it actually appears in streaming, appears in this pub/sub model, and then it can appear in other variations. So you're going to hear it more than once, the word event bus. So the idea here is the publisher has no knowledge of who the subscribers are. The subscribers do not pull for messages. Messages are instead automatically immediately pushed to the subscribers, and messages and events are interchangeable terms in pub/sub, all right? And so, you know, the idea here with publisher subscribers, just imagine getting like a magazine subscription, right? If you think of that, you kind of think of the mechanisms that are going here. In terms of practicality, it's very common to use these as a real-time chat system or a webhook system. So, you know, hopefully that gives you an idea there. In terms of AWS's solution, we're using Simple Notification Service, SNS. This is a highly available, durable, secure, fully managed pub/sub messaging service that enables you to decouple microservices, distributed systems, and serverless applications. So here we have a variety of publishers like the SDK, the CLI, CloudWatch, AWS Services. You'll have your SNS topic. You can filter things, fan them out, and then you have your subscribers. So Lambda, SQS, emails, HTTPS looks very similar to streaming, but again, there's not a lot of communication going back between it. It's just publishers and subscribers, and it's limited to these things here. So it's a very managed service, right? Whereas Kinesis, you can do a lot more with it. Okay. So what is API Gateway? Well, it is a program that sits between a single entry point and multiple backends. API Gateway allows for throttling, logging, routing logic, or formatting of the request and response. When we say request and response, we're talking about HTTPS requests and responses. And so the service for AWS is called Amazon API Gateway. So API Gateway is just a type of pattern. And this is the few cases where AWS has named the thing after what it is. And so we have Amazon API Gateway, which is a solution for creating secure APIs in your cloud environment at any scale. Create APIs that act as a front door for applications to access data, business logic, or functionality from backend services. So the idea is that you have data coming in from mobile apps, web apps, IoT devices, and you actually define the API calls, and then you say where do you want them to go. So maybe tasks are going to go to your Lambdas, and then other routes are going to go to RDS, Kinesis, EC2, or your web application. And so these are really great for having being able to define your API routes and change them on the fly, and always route them to the same place. Okay. So what is a state machine? It is an abstract model which decides how one state moves to another based on a series of conditions. Think of a state machine like a flow chart. And for AWS, the solution here is AWS step functions. So coordinate multiple AWS services into a serverless workflow, a graphical console to visualize the components of your application as a series of steps, automatically trigger and track each step and retries when there are errors so your application executes in order as expected every time, logs the state of each step so when things go wrong, you can diagnose and debug problems quickly. And so here's an example of using a bunch of steps together on the AWS Step Functions service. And so, this is generally applied for serverless workflows, but it is something that is very useful in application integration, okay? So what is an event bus? An event bus receives events from a source and routes events to a target based on rules. So I'll get my pen tool out here. So we have an event, it enters the event bus, we have a rules, tell it to go to the target. It's that simple. And we have been seeing event buses in other things like streaming and PubSub, but AWS has this kind of event bus offering that is kind of high level. It's called EventBridge, and it's a serverless event bus service that is used for application integration by streaming real-time data to your applications. The service was formerly known as Amazon CloudWatch Events. They gave it a renaming to give it a better opportunity for users to know that it's there to use, and they also extended its capabilities. And so the thing is that a lot of AWS services are always emitting events, and they're already going into this bus. And so if you utilize this service, it's a lot easier than having to roll your own thing with other services. So Amazon EventBridge will just define an event bus. So there is an event bus, holds event data, defines the rules on an event bus to react to events. You always get a default event for every single AWS account. You can create custom event buses scoped to multiple accounts or other AWS accounts. You have a SaaS event bus scoped to third-party SaaS providers. You have producers. These are AWS services that emit events. You have events. These are data emitted by services. They're JSON objects that travel the stream within the event bus. You have partnered sources. These are third-party apps that can emit events to event buses. You have rules. These determine what events to capture and pass to targets. And then targets, which are AWS services that consume events. So yeah, it's all just this great built-in stuff that's going on here. And so, there might be a case where you can use EventBridge and save your time, a lot of time and effort doing application integration, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at the application integration services at a glance here, so let's get through them. So the first is Simple Notification Service, SNS. This is a PubSub messaging system, sends notifications via various formats such as plain text, email, HTTPS webhooks, SMS text messages, SQS, and Lambda pushes messages which are then sent to subscribers. You have SQS. This is a queuing messaging system or service that sends events to a queue. Other applications pull the queue for messages commonly used for background jobs. We have step functions. This is a state machine service. It coordinates multiple AWS services into a serverless workflow, easily share data among lambdas, have a group of lambdas wait for each other, create logical steps, also works with Fargate tasks. We have Event Bridge, formerly known as CloudWatch Events. It is a serverless event bus that makes it easy to connect applications together from your own application, third-party services, and AWS services. Then there's Kinesis, a real-time streaming data service, creates producers which send data to a stream. Multiple consumers can consume data within a stream, used for real-time analytics clickstreams, ingesting data from a fleet of IoT devices. You have Amazon MQ. This is a managed message broker service that uses Apache ActiveMQ. So if you want to use Apache ActiveMQ, there it is. Managed Kafka service. And this gets me every time because it says MSK, and that is the proper initialization, but you'd think it'd be MKS. It is a fully managed Apache Kafka service. Kafka is an open source platform for building real-time streaming data pipelines and applications similar to Kinesis, but more robust, very popular, by the way. We have API Gateway, a fully managed service for developers to create, publish, maintain, monitor, and secure APIs. You can create API endpoints and route them to AWS services. We have AppSync. This is a fully managed GraphQL service. GraphQL is an open source agnostic query adapter that allows you to query data from many different data sources. So there you go. Hey, this is Andrew Brown from ExamPro, and we are comparing virtual machines to containers. So I know we covered this prior, but I just want to do it one more time just to make sure that we fundamentally understand the difference before we jump into containers. So the idea is that if you were to request an EC2 instance, it has a host operating system that we don't really know much about, but we don't really need to know. And then the idea is you have a hypervisor which allows you to deploy virtual machines. And so when you launch an EC2 instance, you're actually launching a VM on top of a hypervisor on a server within the AWS data center's servers there. And you're going to choose an operating system, so like Ubuntu, and it might come with some pre-installed packages, or you're going to install your own libraries, packages, and binaries. And then you're going to decide what kind of workloads you want to run on there. So it could be Django, MongoDB, so your database, and some kind of queuing system like RabbitMQ. But the difficulties with virtual machines, you're always going to end up with some unused space because you're going to want to have some headroom to make sure that if Django needs more memory or MongoDB needs more storage, that you have that room that you can grow into. But the idea is that you're always paying for that even when you're not utilizing it. And so, that can be not as cost effective as you'd like it to be. So when we're looking at doing this again and we are using containers, instead of the hypervisor, we have container virtualization. A very common one would be called Docker daemon for Docker, of course. And so now you're launching containers. And so maybe you have Alpine, and this is for your web app. And then you install exactly the libraries, packages, and binaries you need for that. And then for MongoDB, you want to have a different OS, different packages. And same thing with RabbitMQ. Maybe you want to run it on FreeBSD. And the idea is that you're not going to have this waste because it's kind of changed in the sense that these containers are flexible, so they can expand or decrease based on the use case of what they need. And if you use particular services like AWS Fargate, you're paying for running the containers, not necessarily for over provisioning. Okay, so VMs do not make best use of space. Apps are not isolated, which could cause config conflicts, security problems, or resource hogging. Containers allow you to run multiple apps which are virtually isolated from each other. Launch new containers, configure OS dependencies per container. Okay. Hey, this is Andrew Brown from ExamPro, and we are taking a look at the concept of microservices. And to understand microservices, we first need to understand monoliths or monolithic architecture. And the idea here is that we have one app which is responsible for everything, and the functionality is tightly coupled. So I'm going to get my pen tool out here, and just to highlight, notice that there is a server, and everything is running on a single server, whether it's load balancing, caching, the database, maybe the marketing website, the front-end JavaScript framework, the back-end with its API, the ORM connected to background tasks, things like that. And that's the idea of a monolith. And that's what a lot of people are used to doing. But the idea with microservice architecture is that you have multiple apps which are responsible for one thing, and the functionality is isolate and stateless. And so just by leveraging various cloud services or bolting it onto your service, you are technically using microservice architecture. So maybe your web app is all hosted in containers. So you have your APIs, your ORM, your reports. Maybe you've abstracted out some particular functions into Lambda functions. You have your marketing website hosted on S3. You have your front-end JavaScript hosted on S3. You're now using Elastic Load Balancer, Elasticache, RDS, SQS, and that's the idea between monoliths and microservices, okay? Well, let's take a look here at Kubernetes, which is an open source container orchestration system for automating deployment, scaling, and management of containers. It was originally created by Google and now maintained by the Cloud Native Computing Foundation, so the CNCF. Kubernetes is commonly called K8. The 8 represents the remaining letters for Kubernetes, which is odd because everyone calls it Kubernetes with the S on there, but that's just what it is. The advantage of Kubernetes over Docker is the ability to run containers distributed across multiple VMs. A unique component of Kubernetes are pods. A pod is a group of one or more containers with shared storage, network resources, and other shared settings. So here is kind of an example where you have your Kubernetes master. It has a scheduler, controller, etcd you might be using. It uses an API server to run nodes. Within the nodes, we have pods, and within the pods, we have containers. Kubernetes is ideally for microservice architectures where a company has tens to hundreds of services they need to manage. I need to really emphasize that. Tens to hundreds of services, all right? So, Kubernetes is great, but just understand that it is really designed to be used for massive amounts of microservices. If you don't have that need, you might want to look at something just easier to use, okay? All right, let's take a look here at Docker, which is a set of platform as a service products that use OS level virtualization to deliver software in packages called containers. So Docker was the earliest popularized open source container platform, meaning there's lots of tutorials, there's a lot of services that integrate with Docker or make it really easy to use. And so when people think of containers, they generally think of Docker. There's, of course, a lot more options out there than Docker to run containers, but this is what people think of. And so we said it's a suite of tools. So the idea is you have this Docker CLI. So these are CLI commands to download, upload, build, run, and debug containers. A Docker file, a configuration file on how to provision a container. Docker Compose, which is a tool and configuration file when working with multiple containers. Docker Swarm, an orchestration tool for managing deployed multi-container architectures. Docker Hub, a public online repository for containers published by the community for download. And one really interesting thing that came out of Docker was the Open Container Initiative, OCI, which is an open governance structure for creating open industry standards around container formats and runtimes. So Docker established the OCI, and it is now maintained by the Linux Foundation. And so the idea is that you can write a Docker file or do things very similarly and use different types of technologies that can use containers. As long as they're OCI compatible, you can use them. So Docker has been losing favor with developers due to their handling of introducing a paid open source model, and alternatives like Podman are growing, and that's why we're going to talk about Podman next, okay? So let's take a quick look here at Podman, which is a container engine that is OCI compliant and is a drop-in replacement for Docker. I just want to get you exposure here because I want you to know about this and that you can use it as opposed to using Docker. There are a few differences or advantages that Podman has. So Podman is daemonless, where Docker uses a container daemon. Podman allows you to create pods like Kubernetes, where Docker does not have pods. Podman only replaces one part of Docker. Podman is to be used alongside BuildA and Scopio. So, Docker is an all-in-one kind of tool. Everything is done via a single CLI and everything is there. But, they just wanted to make it more modular. And so these other tools, anytime you say Podman, it usually means we're talking about Podman, BuildA, and Scopio. So BuildA is a tool used to build the OCI images, and Scopio is a tool for moving container images between different types of container storages. Podman's not going to show up in your exam, but you should practically know it just for your own benefit, okay? Let's take a look here at the container services offered on AWS. So we have primary services that actually run containers, provisioning and deployment on, tooling around provisioning and deployment, and supporting services. So the first here is Elastic Container Service, ECS. And the advantage of this service is that it has no cold starts, but it is a self-managed EC2. So that means that you're going to be always paying for the resource as it is running, all right? Then you have AWS Fargate. So this is more robust than using AWS Lambda. It can scale to 0 costs. And it's being managed by AWS Managed EC2. However, it does have cold starts, so if you need containers launching really fast, you might be wanting to use ECS. Then you have Elastic Kubernetes Service, EKS. This is open source. It runs Kubernetes, and this is really useful if you want to avoid vendor lock-in, which is not really a problem, but that or it's just you want to run Kubernetes. Then you have AWS Lambda, so you only think about the code. It's designed for short-running tasks. If you need something that runs longer, you'd want to use that is serverless. You'd use AWS Fargate, which is serverless containers. You can deploy custom containers. So prior, AWS Lambda just had pre-built runtimes, which were containers. But now you can create any kind of container and use that on AWS Lambda. For provisioning and deployment, you can use Elastic Beanstalk. So it can deploy Elastic Container Service for you, which is very useful. Now there's App Runner, which kind of overlaps on what Elastic Beanstalk does, but it specializes for containers. And I believe that it can, actually I don't know what it uses underneath because it is a managed service. So Elastic Beanstalk is open. You can see what is running underneath. And App Runner, I don't believe you can see what is running underneath. It's just taken care of by AWS. Then there's AWS Copilot CLI. So this allows you to build, release, operate production-ready containerized applications on App Runner, ECS, and AWS Fargate. For supporting services, you have Elastic Container Registry. This is a repo for your containers, not necessarily just Docker containers, but containers in general, probably OCI-compliant containers. X-ray, so analyze and debug between microservices. So, it's distributed tracing. Then you have step functions, so stitch together Lambdas and ECS tasks to create a state machine. And the only thing I don't have on here would be, being able to launch an EC2 instance from the marketplace that has a container runtime installed like Docker. I just don't feel that that's very relevant for the exam, but it is another option for containers, not something that people do very often, but there you go. Hey, this is Andrew Brown from ExamPro, and we're taking a look here at organizations and accounts. So AWS organizations allow the creation of new AWS accounts and allows you to centrally manage billing, control access compliance, security, and share resources across your AWS accounts. So here's kind of a bit of a structure of the architecture of AWS organizations, and we'll just kind of walk through the components. So the first thing you have is a root account user. This is a single sign-in identity that has complete access to all AWS services and resources in an account, and each account has a root account user. So generally you will have a master or root account, and even within that you'll have a root account user. And for every additional account that you have, you'll notice over here we have a root account user. Then there's the concept of organizational units. These are commonly abbreviated to OUs. So they are a group of AWS accounts within an organization which can contain other organizational units, creating a hierarchy. So here is one where we have called Starfleet, and here's one called Federation Planets. And underneath we have multiple accounts, AWS accounts within that organizational unit. And even though it does not show it here, you can create an organizational unit within an organizational unit. Then we have service control policies, SCPs, and these give central control over the allowed permissions for all AWS accounts in your organization, helping to ensure your accounts stay within your organization's guidelines. What they're trying to say here is that there's this concept of AWS IAM policies, and all you're doing is you're creating a policy that's going to be organizational unit-wide or organizational-wide or for select accounts. So it's just a way of applying IAM policies across multiple accounts. AWS organizations must be turned on, and once it's turned on, it cannot be turned off. It's generally recommended that you do turn it on because basically if you're going to run any kind of serious workload, you're going to be using AWS organizations to isolate your AWS accounts based on workloads. You can create as many AWS accounts as you like. One account will be the master or root account. And I say root account here because this is the new language here, and some of the documentation still calls it master account. So just understand this is the root account, not to be confused with the root account user. So Another clarification I want to make is an AWS account is not the same as a user account, which is another thing that is confusing. So when you sign up for AWS, you get an AWS account, and then it creates you a user account, which happens to be a root user account. So hopefully that is clear. So AWS Control Tower helps enterprises quickly set up a secure AWS multi-account. It provides you with a baseline environment to get started with a multi-account architecture. So it does this a few different ways. The first thing is it provides you a landing zone. This is a baseline environment following well-architected and best practices to start launching production-ready workloads. So imagine you wanted to go have the perfect environment that you know is secure, is correctly configured, and has good logging in place. That's what a landing zone is. And so AWS's landing zone for Control Tower is going to have SSO enabled by default, so it's very easy to move between AWS accounts. It will have centralized logging for AWS CloudTrail so that, they're going to be tamper evident or tamper proof away from your workloads where they can't be affected. It'll have cross-account security auditing. So yeah, landing zones are really great to have. Then there's the account factory. They used to call this a vending machine, but they changed it to account factory. The idea is that it automates provisioning of new accounts in your organization. It standardizes the provisioning of new accounts with pre-approved account configuration. You can configure account factory with pre-approved network configuration and region selections. Enables self-service for your builders to configure and provision new accounts using AWS Service Catalog. AWS Service Catalog is just pre-approved workloads via CloudFormation templates that you created to say, okay, you're allowed to launch this server or these resources. And the third and most important thing that AWS Control Tower comes with is guardrails. So these are pre-packaged governance rules for security, operations, compliance. The customers can select and apply enterprise-wide or to specific groups of accounts. So AWS Control Tower is the replacement of the retired AWS Landing Zone. So if you remember AWS Landing Zones, which was never a self-serve, easy thing to sign up for, it required a lot of money and stuff to go in there. They just don't really have it anymore, and AWS Control Tower is the new offering there, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at AWS Config. And to understand AWS Config, we need to know what compliance as code is. And to understand compliance as code, we need to understand what change management is. So change management in the context of cloud infrastructure is when we have a formal process to monitor changes, enforce changes, and remediate changes. And compliance as code, also known as CAC, is when we utilize programming to automate the monitoring, enforcing, and remediating changes to stay compliant with the compliance program or expected configuration. So what is AWS Config? Well, it's a compliance as code framework that allows us to manage change in your AWS accounts on a per region basis, meaning that you have to turn this on for every region that you need it for. And so here is a very simple example where let's say we create a config rule and we have an EC2 instance and we expect it to be in a particular state. And then in the other case, we have an RDS instance and it's in a state that we do not like. So the idea is that we try to remediate it to put it in a state that we want it to be. And those config rules are just powered by lambdas, as you can see based on the lambda icon there. So when should you use AWS Config? Well, this is when I want this resource to stay configured a specific way for compliance. I want to keep track of configuration changes to resources. I want a list of all resources within a region, and I want to use analyze potential security weaknesses, and you need detailed historical information. So there you go. Hey, this is Andrew Brown from ExamPro, and in this follow along, we're going to take a look at AWS Config. So AWS Config is a tool that allows you to ensure that your services are configured as expected. So I've already activated it in my North Virginia region. So what I'm going to do is just go over to Ohio here because it is per region activated, and I'll go over to config. And then what we'll have to do is set it up. So there is this one-click setup, and it did skip me to the review step because it's kind of piggybacking on the configuration of my original one here. But the idea is that you'll just say record all resources in this region or things like that. You'll have to create a service role link if you have not done so. So this will look a little bit different, but here it's using an existing one. You'll have to choose a bucket, or create a bucket. It's not super complicated. So you get through there, you hit confirm, and basically you're going to end up with this. So the inventory lets you see all the resources that, or not all of them, but most resources that are in your AWS account in this particular region. This will not populate right away, so you will have to wait a little bit of time for that to appear. One really nice thing are conformance packs. I really love these things. When AWS first brought these out, there was only like a couple, but now they have tons and tons and tons of conformance packs. So you can go deploy a conformance pack, and you can open up the templates. I just want to show you, look at how many they have. So there's some you might recognize like NIST, CIS, things like that, well-architected stuff. And all these are, and I'm not sure if it's easy to open these up, but all these are, if we open them up, they're on GitHub, is these are just CloudFormation templates to set up configuration rules. And so there's a variety of suggested rules, like around IAM best practices and things like that that we can load in. But the idea is that you're just going to create rules. So you go here and you add a rule, and they have a bunch of managed rules here that we can look at. But I think it might be fun to actually run a conformance pack. I'll just show you what it looks like to add a rule first. So let's say we wanted to do something for S3, and it was making sure that we are blocking public access. So we go next here. Generally, you'll have a trigger type you can choose, whether it's configured when it happens or it's periodic. This is disabled in this case here, and you just scroll on down. And then once you've added the rule, what you can do is also manage remediation. So if this rule said, hey, this thing is non-compliant, we want you to take a particular action, and you have all these AWS actions that you can perform, and you can notify the right people to correct it or have it auto-correct if you choose to do so. For rules, you can also make your own custom ones. So that's just you providing your own Lambda function. So you're providing that Lambda ARN. And so basically you can have it do anything that you want. Whatever you want to put in a Lambda, you can make AWS config check for. Okay, so it's not super complicated here, but this one here is just going to go ahead and check. And so if we go and reevaluate, we might just take some time to show up. So they're going to say that it's compliant or non-compliant, okay? And it should be compliant. But while we're waiting for that to happen, let's just see how hard it is to deploy a conformance pack, because I feel like that's something that's really important. Oh, you can just drop them down and choose them. That's great. So we might want to go to IAM here. Oops, Identity and Access Management. And hit Next. And say my IAM best practices. And you might not want to do this because it does have spend. And when I say spend, it's not going to happen instantly, but the idea is that if you turn this on and forget to remove it, you will see some kind of charges over time, because it does check based on the rules. It's not super expensive, but it is something to consider about. But anyway, so it looks like we created that conformance pack. So if I refresh, it looks like it's in progress. I wonder if that's going to set up a CloudFormation template. I'm kind of curious about that. So we'll make our way over to CloudFormation. And it is. So that's really nice, because once that is done, what we can do is just tear it down by deleting the stack. So I'm going to go back over to our conformance pack here. Let's take a look here. And so it still says it's in progress, but it is completed, and we can click into it. And we can see all the things that it's doing. So it says IAM groups have user check conformance pack. And so it looks like there's a bunch of cool rules here. So what we'll do is we'll just wait a little while, and we'll come back here and then just see if this updates and see how compliant we are from a basic account, okay? All right, so after waiting a little while there, it looks like some of them are being set. So I just gave it a hard refresh here. And here you can see that it's saying is root account. Whoops, we'll give it a moment here to refresh. But is the root account MFA applied? Yes. Have we done a password policy? No. And actually, I never did a password policy, which is something I forgot to do. But here they're just talking about the minimums and maximums of things that you can do. Okay, so that's a conformance pack. But if we go to rules, actually, I guess it's all the rules here. I can't really tell the difference between the conformance pack rules and our plain rules. It's kind of all mixed together here, I think. Yeah, so it's a bit hard to see what's going on there. If we go to the conformance pack and click in again, it might show the rules. Yeah, there we go. So here's the rules there. We're seeing a little bit more information. So use a hardware MFA. So you know how they're talking about using a security key, like what I showed you that I had earlier in the course, things like that. IAM password policy, things like that. So, you know, not too complicated, but I think I'm all done here. So what I'm going to do is I'm going to go over to CloudFormation and tear that on down, but you get the idea. Well, I might want to show you Drift. So there used to be a way, it's because I keep changing things on me here, but there's a way to see history over time. And so that was something that they used to show. And I'm just trying to like find where they put it because it is like somewhere else. Resources maybe? Resource timeline. Okay, so they moved it over into the resource inventory. And so if we were to take a look at something, anything, maybe this here, resource timeline, and there might not be much here, but the idea is it will show you over time how things have changed. So the idea is that not only can you say with AWS config, is something compliant, but when was it compliant? And that is something that is really important to know, okay? So very simple example, maybe not the best, but the idea is that we can see when it was and was not compliant based on changes to our stuff. But anyway, that looks all good to me here. So I'm going to make my way over to CloudFormation. Actually, I already have it open over here. We're going to go ahead and delete that stack. Termination protection is enabled. You must first disable it. So we'll edit it, disable it, whatever. Okay, we'll hit delete there. And as that's deleting, I'm going to go look for and config my original rule there. Again, I'm not really worried about it. I don't think it's going to really cost me anything, but I'm also just kind of clear the house here just so you're okay as well. And so if we go over to our rules, the one that I spun up that was custom, I think was this one here, because these are all grayed out, right? So I can go ahead there, delete that rule, type in delete, and we are good. So there you go. That is it. All right. AWS Quick Starts are pre-built templates by AWS and AWS partners to help deploy a wide range of stacks. It reduces hundreds of manual procedures into just a few steps. So the Quick Start is composed of 3 parts. It has a reference architecture for the deployment, an AWS CloudFormation templates that automate and configure the deployment, a deployment guide explaining the architecture, implementation in detail. So here's an example of one that you might want to launch, like the AWS Q&A bot. And then you'll get an architectural diagram and a lot of information about it. And from there, you can just go press a button and launch this infrastructure. Most quick start reference deployments enable you to spin up a fully functional architecture in less than an hour. And there is a lot, as we will see here when we take a look for ourselves. All right, so here is AWS Quick Starts, where we have a bunch of CloudFormation templates built by AWS or Amazon or AWS partner networks, APM partners. And there's a variety of different things here. So I'm just going to try to find something like Q&A bot. Q&A bot, just type in bot here. And I don't know why. It was here the other day. Now it's not showing up, which is totally fine. But, I just want anything to deploy just to kind of show you what we can do with it. So you scroll on down, we have this graphic here that's representing what will get deployed. So we have CloudFront, S3, DynamoDB, Systems Manager, Lex, Poly, all these kind of fun stuff. And there's some information about how it's architected. And the idea is you can go ahead and launch in the console or view the implementation guide. Let's go take a look here. And there's a bunch of stuff. So we have solutions and things like that, conversational things like that. But what I'm going to do is go ahead and see how far I can get to launching with this. It doesn't really matter if we do launch it, but it's just the fact that I want to just show you what you can do with it. So if we go to the designer, it's always fun to look at it in there because then we can kind of visualize all the resources that are available. And I thought that that would populate over there, but maybe we did the wrong thing. So I'm just going to go back and click. I'm just going to click out of this. Oops, cancel. Let's close that. Leave, yes. And we will launch that again. And so this, view in the designer, I hit the wrong button. Okay. And so now this should show us the template. It might just be loading. There we go. So this is what it's going to launch. And you can see there's a lot going on here. Just going to shrink that there. And I don't know if you can make any sense of it, but clearly it's doing a lot. And so if we were happy with this and we wanted to launch it, I know I keep backing out of this, but we're going to go back into it one more time. We can go here and we can go next. And then we would just fill in what we want. So you name it, put the language in. And this is stuff that they set up. So maybe you want a male voice, set the admin and stuff like that. And it's that simple, really. And every stack is going to be different, so they're all going to have different configuration options, but hopefully that gives you kind of an idea of what you can do with quick starts, okay? Let's take a look at the concept of tagging within AWS. So a tag is a key and value pair that you can assign to an AWS resource. So as you are creating a resource, it's going to prompt you to say, hey, what tags do you want to add? You're going to give a key, you're going to give a value. And so some examples could be something like based on department, the status, the team, the environment, the project, as we have the example here, the location. And so tags allow you to organize your resources in the following way. For resource management, so specific workloads, so you can say, developer environments, cost management and optimization, so cost tracking, budgets and alerts, operations management, so business commitments, SLA operations, mission critical services, security, so classification of data, security impact, governance and regulatory compliance, automation, workload automation. And so it's important to understand that tagging can be used in junction with IAM policies so that you can restrict access or things like that based on those tags, okay? All right, I just want to show you one interesting thing about tags, and it's just the fact that it's used as the name for some services. So when you go to EC2 and you launch an instance, the way you set the name is by giving it a tag called name. And I just want to prove that to you. Just like one of those little exceptions here. So we choose an instance here. We go to configure, storage, and then what we do is we add a tag and we say name and my server name, okay? And then we go ahead and review and launch. We're going to launch this. I don't need a key pair, so we'll just say proceed without key pair. I acknowledge, okay? And we will go view the instances and you'll see that is the name. So that's just like one of those exceptions or things that you can do with tags. If there's other things with tags, I have no idea. That's just like a basic one that everybody should know. And that's why I'm showing to you with the tags. But there you go. So we just looked at tags. Now let's see what we can do with resource groups, which are a collection of resources that share one or more tags. Or another way to look at it, it's a way for you to take multiple tags and organize them into resource groups. So it helps you organize and consolidate information based on your project and the resources that you use. Resource groups can display details about a group of resources based on metrics, alarms, configuration settings, and at any time you can modify the settings of your resource groups to change what resources appear. Resource groups appear in the global console header, which is over here, and under the Systems Manager. So technically it's part of AWS Simple Systems Manager or Systems Manager interface, but it's also part of the global interface. So sometimes that's a bit confusing, but that's where you can find it, okay? All right, so what I want to do is explore resource groups and also tagging. So what I want you to do is type in resource groups at the top here. And it used to be accessible, not sure where they put it, but it used to be accessible here at the top, but they might have moved it over to Systems Manager. So I'm going to go to SSM here. Not sure why I can't seem to find it today. And on the left-hand side, we're going to look for resource groups. All right, so what I want to do is take a look at resource groups, and I'm really surprised because it used to be somewhere in the global now, but I think they might have changed it. And what's also frustrating is if I go over to Systems Manager, it was over here as well. And so on the left-hand side, I'm looking for resource groups. It's not showing up. So I don't know, AWS, you keep moving things around on me, and I can only update things so quickly in my courses. But if you type in resource groups and tag editor, it's actually over here. I guess it's its own standalone service now. Why they keep changing things, I don't know. But the idea is we want to create a resource group, so you can create unlimited single region groups in your AWS account. Use the group to view related insights, things like that. So I'm going to go ahead and create a resource group. You can see it can be tag-based or CloudFormation based, but I don't have any tags, so I don't really have anything tagged. So what I'm going to do is make my way over to S3. We're just going to create some resources, or a couple of resources here, with some tags so that we can do some filtration. So I can go ahead and create a bucket. I'm going to say my bucket, this, like that, whoops. And then down below, I'm going to go down to tags, and we're going to say project, and we're going to say RG for resource group. Okay, and then I can go back over to here, and then I'm going to just say, I can say exactly what type I want. I'm going to support all resource types. And I'm going to say project, RG, see how it auto-completes? And we'll go down below, we'll just say my RG, a test RG. We'll create that. And so now we have a resource group and we can see them all in one place. Resource groups are probably useful for using in policies. So I can say like resource group IAM policies. That's probably what they're used for. Okay, so before you use IAM managed to access resource groups, you should understand IAM features, things like that. And so administrators can use JSON policies to specify who has access to what. And so a policy action or resource group is used following the prefix resource groups. So my thought process there is that if you want to say, okay, you have access to a resource, you can just specify a resource group and it will include all the resources within there. And so that might be a better way to apply permissions at a per project basis. And that could save you a lot of time writing out IAM policies. So that's basically all there really is to it. Also, you kind of get an overview of the resources that are there. So that can be kind of useful as well. There's the tag editor here. I can't remember what you use this for. You can set up tag policies. Tag policies help you standardize tags on resource groups in your accounts. Used to define tag policies in AWS org to attach them to the entire organization. We're not in the org account, so I'm not going to show you this, and it's not that important. But just understand that resource groups can be created and they are used within IAM policies in order to grant or deny access to stuff. You can go ahead and delete that resource group. And really, AWS, stop moving that on me. If you move it one more time, I'm just never going to talk about resource groups again, okay? Hey, this is Andrew Brown from ExamPro, and we're taking a look at business-centric services. And you might say, well, why? Because in the exam guide, it explicitly says that these are not covered. But the thing is that when you're taking the exam, some of the choices might be some of these services as distractors. And if you know what they are, it's going to help make sure that you guess correctly. And the thing is that some of these services are useful and you should know about them. So that's another reason why I'm talking about them here. So the first one is Amazon Connect. This is a virtual call center. You can create workflows to route callers. You can record phone calls, manage a queue of callers based on the same proven system used by Amazon customer service teams. We have Workspaces. This is a virtual remote desktop service, secure managed service for provisioning either Windows or Linux desktops in just a few minutes, which quickly scales up to thousands of desktops. We have WorkDocs, which is a shared collaboration service, a centralized storage to share content and files. It is similar to Microsoft SharePoint. Think of it as a shared folder where the company has ownership. We have Chime, which is a video conference service. It is similar to Zoom or Skype. You can screen share, have multiple people on the same call. It is secure by default and can show you a calendar of upcoming calls. We have Workmail. This is a managed business email, contacts, calendar service with support of existing desktop and mobile email client applications that can handle things like IMAP, similar to Gmail or Exchange. We have Pinpoint. This is a marketing campaign management service. Pinpoint is for sending targeted emails via SMS, push notifications, voice messages, so you can perform A to B testing or create journeys, so complex email response workflows. We have SES. This is a transactional email service. You can integrate SES into your application to send emails. You can create common templates, track open rates, keep track of your reputation. We have QuickSight. This is a business intelligence service. Connect multiple data sources and quickly visualize data in the form of graphs with little to no knowledge. Definitely you want to remember QuickSight, SES, Pinpoint, because those definitely will show up in the exam. The rest probably not, but they could show up as distractors, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at provisioning services. So let's first define what is provisioning. So provisioning is the allocation or creation of resources and services to a customer, and AWS provisioning services are responsible for setting up and managing those AWS services. We have a lot of services that do provisioning. Most of them are just using CloudFormation underneath, which we'll mention here, but let's get to it. The first is Elastic Beanstalk. This is a platform as a service to easily deploy web apps. EB will provision various AWS services like EC2, S3, SNS, CloudWatch, EC2 autoscaling groups, load balancers, and you can think of it as the Heroku equivalent to AWS. Then you have OpsWorks. This is a configuration management service that also provides managed instances of open source configuration managed software such as Chef and Puppet. So you'll say, I want to have a load balancer or I want to have servers, and it will provision those for you indirectly. Then you have CloudFormation itself. This is an infrastructure modeling and provisioning service. It automates the provisioning of AWS services by writing CloudFormation templates in either JSON or YAML, and this is known as IAC, or infrastructure as a code. You have quick starts. These are pre-made packages that can be launched and configure your AWS compute, network, storage, and other services required to deploy a workload on AWS. We do cover this in this course, but quick starts is basically just CloudFormation templates that are authored by the community or by Amazon Partner Network, okay? Then we have AWS Marketplace. This is a digital catalog for thousands of software listings of independent software vendors that you can use to find, buy, and test and deploy software. So the idea is that you can go there and provision whatever kind of resource you want. We have AWS Amplify. This is a mobile web app framework that will provision multiple AWS services as your backend. It's specifically for serverless services. I don't know why I didn't write that in there, but like DynamoDB, things like whatever the GraphQL service is called, API Gateway, things like that. Then we have AWS App Runner. This is a fully managed service that makes it easy for developers to quickly deploy containerized web apps and APIs at scale with no prior information experience required. It's basically a platform as a service, but for containers. We have AWS Copilot. This is a command line interface that enables customers to quickly launch and manage containerized applications on AWS. It basically is a CLI tool that sets up a bunch of scripts to set up pipelines for you. It makes things super easy. We have AWS CodeStar. This provides a unified user interface, enabling you to manage your software development activities in one place, easily launch common types of stacks like LAMP. Then we have CDK. And so this is infrastructure as a code tool, allows you to use your favorite programming language, generates out CloudFormation templates as a means of IAC. So there you go. Hey, this is Andrew Brown from ExamPro, and we are taking a look at AWS Elastic Beanstalk. Before we do, let's just define what PaaS is. So Platform as a Service allows customers to develop, run, and manage applications without the complexity of building and maintaining the infrastructure typically associated with developing and launching an app. And so Elastic Beanstalk is a PaaS for deploying web apps with little to no knowledge of the underlying infrastructure, so you can focus on writing application code instead of setting up an automated deployment pipeline or DevOps tasks. The idea here is you choose a platform, upload your code, and it runs with little knowledge of the infrastructure. And AWS will say that it's generally not recommended for production apps, but just understand that they are saying this for enterprises and large companies. If you're a small to medium company, you can run on Elastic Beanstalk for quite a long time. It'll work out great. Elastic Beanstalk is powered by CloudFormation templates, and it sets up for you Elastic Load Balancer, ASGs, RDS, EC2 instances pre-configured for particular platforms, monitoring integration with CloudWatch SNS, deployment strategies like in-place, blue-green deployment, has security built in, so it could rotate out your passwords for your databases, and it can run Dockerized environments. And so when we talk about platforms, you can see we have Docker, multi-container Docker, Go, .NET, Java, Node.js, Ruby, PHP, Python, Tomcat, Go, a bunch of stuff. And just to kind of give you that architectural diagram to show you that it can launch multiple things, okay? Hey, it's Andy Brown from ExamPro, and in this follow along, we're going to learn all about Elastic Beanstalk. Maybe not everything, but we're going to definitely know how to at least use the service. So Elastic Beanstalk is a platform as a service, and what it does is it allows you to deploy web applications very easily. So here, I've made my way over to Elastic Beanstalk. We need an environment and an app, and then we set up our application. We have two tiers: a web server environment, a worker environment. Worker environment is great for long-running workloads, performing background jobs and things like that. And then you have your web server, which is your web server, and you can have both, and it's generally recommended to do so. But anyway, what we'll do is create a new application. So let's say my app here, and there's some tags we can do, and then it will name based on the environment. Then we need to choose an environment name. So let's say my environment, and just put a bunch of numbers in there. Hit the check availability, scroll on down, and we have two options: managed platform, custom platform. And I'm not sure why custom is blanked out, but it would allow you to, I think, use your own containers. So I'm a big fan of Ruby, so I'm going to drop down to Ruby. And here we have a bunch of different versions. And so 2.7 is pretty new, which is pretty good. And then there's the platform version, which is fine. And the great thing is it comes with a sample application. Now you could hit create environment, but you'd be missing out on a lot if you don't hit this configure more options. I don't know why they put it there. It's not a very good UI, but if you click here, you actually get to see everything possible. And so up here, we can have some presets where we can have a single instance. So this is where it's literally running a single EC2 instance. So it's very cost effective. You can have it with spot pricing, so you save money. There's high availability. So, you know, if you want it set up with a load balancer, an auto scaling group, it will scale very well, or you can do custom configuration. We scroll on down here. You can enable Amazon X-Ray, you can rotate out logs, you can do log streaming. There's a lot of stuff here. And basically it's just like, it sets up most for you, but you can pretty much configure what you want as well. If we had the load balancer set, if I go here, go to high availability, now we'll be able to change our load balancer options. You have different ways of deploying. So you can go here and then change it from all at once, rolling, immutable, traffic splitting, depends on what your use case is. We can set up a key pair to be able to log into the machine. There's a whole variety of things. You can connect your database as well, so it can create the database alongside with it, and then it can actually rotate out the key so you don't have to worry about it, which is really nice. What I'm going to do is go to the top here and just choose a single instance because I want this to be very cost effective. We're going to go ahead and hit create environment. And so we are just going to wait for that to start up, and I'll see you back when it's done, okay? Okay, so it's been quite a while here, and it says a few minutes. So if it does do this, what you can do is just give it a hard refresh. I have a feeling that it's already done. Is it done? Yeah, it's already done. So and here it says on September 2020, Elastic Beanstalk introduced, etc. Default. I don't care. But anyway, so this application, I guess it's in a pending state. I'm not sure why. Let's go take a look here. Causes, instance has not sent any data since launch. None of the instances are sending data. So that's kind of interesting because I shouldn't have any problems, you know what I mean? So what I'm going to do is just reboot this machine and see if that fixes the issue there. But usually it's not that difficult because it's the sample application. It's not up to me as to how to fix this. You know what I mean? So I'm not sure, but what we'll do is we will let the machine reboot and see if that makes any difference, okay? All right, so after rebooting that machine, now it looks like the server is healthy. So it's not all that bad, right? If you do run into issues, that is something that you can do. And so let's go see if this is actually working. So at the top here, we have a link. And so I can just right click here. It says, congratulations, your first AWS Elastic Beanstalk Ruby application is now running. So it's all in good shape. There's a lot of stuff that's going on here in Elastic Beanstalk that we can do. We can go back to our configuration and change any of our options here. So there's a lot of stuff, as you can see. We get logging. So click the request log. So if we click on this and say last 100 lines, we should be able to get logging data. We have to actually download it. I wish it was kind of in line. But here you can kind of see what's going on. So we have SD out, access logs, error logs, Puma logs, Elastic Beanstalk engine, so you could use that to debug. Very common to take that over to support if you do have issues. For health, it monitors the health of the instances, which is great. Then we have some monitoring data here. So it gives you like a built dashboard. So that's kind of nice. You can set up alarms. You have not defined any alarms. You can add them via the monitoring dashboard. So I guess you'd have to, you'd have to somehow add them. I don't think I've ever added alarms for Elastic Beanstalk, but it's nice to know that they have them. You can set up schedules for managed events. Then this is event data. So it's just kind of telling you, it's kind of like logs. It just tells you of things that have changed. So there's stuff like that. What I'm looking for is to see how I can download the existing application, because there's a version uploaded here. Oh, the source is over here. Okay. So I think it's probably over here, the one that's running. So that's it. If it was easy to find, what I probably would do is just modify it and, oh, yeah, it's over here. So if we go here and download the zip, I wonder if it'd be even worth playing with this. So I'm just going to see if we can go over to Cloud9 and give this a go quickly. So if we go over and launch a Cloud9 environment, maybe we can tweak it and upload a revised version. So we'll go say create new, we'll say EB environment for Elastic Beanstalk. We'll set it all the defaults. That's all fine. It's all within the free tier. We'll create that environment. What I'm going to do is just take this Ruby zip file and move it to my desktop. And as that is loading, we'll give it a moment here. I'm just going to go back. And I was just curious, does it let you download it directly from here? No. So the only thing is that, if you download that application, Elastic Beanstalk usually has a configuration file with it. And so I don't know if they would have given that to us. But if they did, that would be really great. But we just have to wait for that to launch there as well. I guess you can save configurations and roll back on those as well. But we will just wait a moment here. While it's going, I might just peek inside of this file to see what it is this zip contains. Just going to go to my desktop here, open up that zip. So it looks pretty simple. It doesn't even look like a Rails app. It looks like maybe it's a Sinatra app. I thought before that it would have deployed a Ruby on Rails application, but maybe they keep it really simple. I don't see, usually it's like YAML files they use for configuration. I don't see that there. So it might be that the default settings will work fine. There's a config.ru and stuff like that, but once Cloud9 is up here, we will upload this and see what we can do with it, okay? So there we go. Cloud9 is ready to go. And so if we right-click here, right-click here, we should be able to upload a file. If not, we can go up here to the top. Or it's here or there. Where is the upload? I've uploaded things in here, so I absolutely know we can. I just got to find it. Is that the upload? Upload files, Cloud9. Oh boy, that's not helpful. That's not helpful at all. So let me just click around a little bit here. I mean, worst case, I can always just bring it in via a curl. Oh, upload local files. There it is. I was just not being patient. Okay, so we'll drag that on in there. And we will... Did it upload? Yep, it's right there. Okay, great. And so we need to unzip it. So what I'll do is just drag this on up here. I'll do an ls, and we'll say unzip ruby.zip. And so that unzipped the contents there. I think the README was part of Cloud9, so I'm going to go ahead and delete that out. Not that it's going to hurt anything. And so now what we can do, and we'll delete the original zip there. And let's see if we can make a change here. So I'm just going to open it up, see what it is. So it's running Sinatra, so that's pretty clear there. We have a proc file to say how it runs. We have a worker sample, so that just tells how the requests go. You don't need to know any of this. I'm just kind of clicking through it because I know Ruby very well. We have a cron YAML file, so that could be something that gets loaded in here. So I think basically a Sinatra app probably just works off the bat here, but if we want to make a change, we probably just make a change over to here. So I'll go down here, and this is your second AWS Elastic Beanstalk application. So the next thing we need to do is actually zip the contents here. I don't know if it would let us zip it within here, but I'll have to look like zip the contents of a directory, Linux. Just goes to show Google is everything. So the easiest way to zip a folder, zip everything in the current directory, Linux. Okay, that's easy. So we'll go back over here and we will type in zip, and it wants -r for recursive, which makes sense. And then the name of the zip. So ruby2.zip, and we'll do period. Zip warning found is who is zip? Oh, yum install zip. Maybe we have to install zip, but maybe it's not installed. Sudo yum install zip. Since it's Amazon Linux 2, it uses yum. And so package already installed. So I'm going to type zip again. So zip is there now. Great. Oops. Don't need to install it twice. Zip warning, ruby2 zip not found or empty. Okay, so install zip and use zip-r. You can use the flag to best compensate. So if that's not working, what I'm going to do is just go up a directory. Why is it saying not found or empty? Maybe I need to use... Okay, so I think the problem was I was using the wrong flag, so I put F instead of R. I don't know why I did that. So I probably should have done this. Okay, and so that should have copied all the contents of that file. So what I'm going to do is go ahead, make sure I have that selected and download that file. And once I have downloaded that file, I'm going to just open the contents to make sure it is what I expect it to be. So we're going to open that up and get out of here, WinRAR. And it looks like everything I want. So what I'm going to do is go back over to here. I'm going to make sure I have my Ruby 2 on my desktop. And we're going to see if we can upload another version here. So upload and deploy, choose the file. We're going to go all the way to my desktop here, and we're going to choose Ruby 2. And like Ruby 2 will be the version name, or we'll just say 2. And we'll deploy, and we'll see if that works. Okay, but there are like Elastic Beanstalk configuration files, like YAML files that can sit in the root directory. And so generally you're used to seeing them there, but you know, I would imagine that AWS probably engineered these examples so that it uses all the default settings. But once this is deployed, I'll see you back here in a moment, okay? After a short little wait, it looks like it has deployed. So what I'm going to do is just close my other tabs here and open this up and see if it's worked. It says your second AWS Elastic Beanstalk Ruby application. So we were successful deploying that out, which is really great. So what we can do now is just close that tab there. And since we have that cloud environment, it will shut down on its own. But, you know, just for your benefit, I think that we should shut it off right now. So go ahead and delete that. I'm going to go back over to Elastic Beanstalk here. And I just want to destroy all of it. So we'll see if we can just do that from here. Terminate the application. Enter the name. So I think we probably have to enter that in there. And so I think that, oh, a problem occurred, rate exceeded. What? That's AWS for you. So it's not a big deal. I would just go and check it again. And maybe what we'll do is just delete the application first. Okay, so that one is possibly deleting. Let's go in here. Is anything changing? Can't even tell. We'll go ahead. Oh, can't take that one out. delete application again. If it takes you a couple times, it's not a big deal. It's AWS for you, so there's a lot of moving parts. So it looks like it is terminating the instance, and so we just have to wait for that to complete. Once that is done, we might have to just tear down the environment. So I'll see you back here when it has finished tearing this down, okay? All right, and so after a short little wait here, I think it's been destroyed. We'll just double check by going to the applications, going to the environments. Yeah, and it's all gone. Probably because I initially deleted that environment and then took the application with it. So I probably didn't have to delete the app separately. Yeah, so there you go. And just make sure your Cloud9 environment's gone and you are A-okay. There'll probably be some like lingering S3 buckets. So if you do want to get rid of those, you can. It's not going to hurt anything having those around. But they do tend to stack up after a while, which is kind of annoying. So if you don't like them, you can just empty them out as I am doing here. Whoops. Oh, just permanently delete. Copy that text there. We can go back to here and then just go take out that bucket. Let's delete that there. Oh, if you get this is kind of annoying, but Elastic Beanstalk likes to put in an IAM permission or policy in here. So if you go down here, there's a bucket policy. You just have to delete it out. It prevents it from being deleted. And we'll go back over here, and then we will delete it. Okay. And yeah, there we go. That's it. So let's take a look at serverless services on AWS. And this is not including all of them because we're looking at the most purely serverless services. If we tried to include all the serverless services, it would just be too long of a list. But let's take a look here. So before we do, let's just redefine what is serverless. So when the underlying server's infrastructure and operating system is taken care of by the CSP, serverless is generally by default highly available, scalable, cost-effective. You pay for what you use. The first one is DynamoDB, which is a serverless NoSQL key value and document database. It's designed to scale to billions of records with guaranteed consistent data return in at least a second. You do not have to worry about managing shards. You have Simple Storage Service, S3, which is a serverless object storage service. You can upload very large and unlimited amounts of files. You can pay for what you store. You don't worry about the underlying file system or upgrading the disk size. We have ECS Fargate, which is a serverless orchestration container service. It is the same as ECS, except you pay on demand per running container. With ECS, you have to keep a EC2 server running, even if you have no containers running, where AWS manages the underlying server, so you don't have to scale or upgrade the EC2 server. We have AWS Lambda, which is a serverless function service. You can run code without provisioning or managing servers. You upload a small piece of code, choose how much memory you want, how long you want the function is allowed to run before timing out. You're charged based on the runtime of the service function rounded to the nearest 100 milliseconds. We have step functions. This is the state machine service. It coordinates multiple services into serverless workflows, easily share data among lambdas, have a group of lambdas wait for each other, create logical steps, also work with Fargate tasks. We have Aurora Serverless. This is a serverless on-demand version of Aurora. So when you want most of the benefits of Aurora, but you have to trade off those cold starts or you don't have lots of traffic or demand. So serverless services that we could have put in here as well as like API Gateway, AppSync, AWS Amplify, and those are like the first two are application integrations. You could say SQS, SNS. Those are all serverless services. But, you know, again, we'd be here all day if I listed them all, right? All right, let's take a look at what is serverless. And we did look at it from a server perspective earlier in the course, but let's just try to abstractly define it and talk about the architecture. So serverless architecture generally describes fully managed cloud services, and the classification of a cloud service being serverless is not a Boolean answer. It's not a yes or a no, but an answer on a scale where a cloud service has a degree of serverless. And I do have to point out that this definition might not be accepted by everybody because serverless is one of those terms where we've had a bunch of different cloud service providers define it differently, and then we have thought leaders that have a particular concept of what it is. So, I just do my best to try to make this practical here for you. But a serverless service could have all or most of the following characteristics. And so it could be highly elastic and scalable, highly available, highly durable, secure by default. It abstracts away the underlying infrastructure and are built based on the execution of your business tasks. A lot of times that cost is not always represented as something that is like, I'm paying X for compute. It could be abstracted out into some kind of credit that doesn't necessarily map to something physical. Then we have serverless can scale to zero, meaning when it's not in use, the serverless resources cost nothing. And these two last topics basically pull into pay for value. So you don't pay for idle servers, you're paying for the value that your service provides. And my friend Daniel, who runs the Serverless Toronto group, he likes to describe serverless as being similar to like energy efficient rating. So an analogy of serverless could be similar to energy rating labels, which allows consumers to compare the energy efficiency of a product. So some services are more serverless than others. And again, some people might not agree with that, where there's a definitive yes or no answer, but I think that's the best way to look at it, okay? Hey, it's Andrew Brown from ExamPro, and we're taking a look at Windows on AWS. So AWS has multiple cloud services and tools to make it easy for you to run window workloads on AWS, so let's get to it. So the first is Windows servers on EC2. So you can select from a number of Windows Server versions, including the latest version, like Windows Server 2019. For databases, we have SQL Server on RDS. You can select from a number of SQL Server database versions. Then we have AWS Directory Service, which lets you run Microsoft Active Directory AD as a managed service. We have AWS License Manager, which makes it easier to manage your software licenses from software vendors such as Microsoft. We have Amazon FSx for Windows File Server, which is a fully managed scalable storage built for Windows. We have the AWS SDK, which allows you to write code in your favorite language to interact with AWS API, but it specifically has support for .NET, a language favorite for Windows developers. We have Amazon Workspaces, so this allows you to run a virtual desktop. You can launch a Windows 10 desktop to provide secure and durable workstations that is accessible from wherever you have an internet connection. AWS Lambda supports PowerShell as a programming language to write your serverless functions. And we have AWS Migration Acceleration Program, MAP, for Windows, is a migration methodology for moving large enterprises. AWS has Amazon partners that specialize in providing professional services for MAP. This is not just everything for Windows on AWS. Like if you want to move your SQL Server over to RDS, Postgres, I believe they've created an adapter to do that. But yeah, hopefully that gives you an idea what you can do with Windows on AWS, okay? Hey, this is Andrew Brown from ExamPro, and I want to show you how you can launch a Windows server on AWS. So what you're going to do is go to the top here, and we are going to type in EC2. And from here, what we'll do is we'll go ahead and launch ourselves a new EC2 instance. And we are going to have a selection of instances that we can launch. And so we're looking for the Microsoft Windows server. And this is interesting. There's actually a free tier eligible. That is crazy, because if you go over to Azure, they don't have a free tier Windows server. And AWS does. So that's pretty crazy. And it runs on a T2 micro? No, that can't be right. There's no way it can run a T2 micro. That seems like that's too small. Let's try it. Okay, I just don't believe it, because when you use Azure, you have to choose a particular size of instance by default, and it's a lot more expensive, and there is no free tier. So we'll go here. There are free tiers, just not really for Windows in particular. So we'll go here. This looks good. Security groups. This opens up RDP so we can get into that machine. We're going to go next here and launch this machine. It says, if you plan to use AMI, the benefits, the Microsoft License Mobility, check out this form. That's not something we're worried about today. And I mean, I guess we can create a key pair. I'm not sure what we would use a key pair for here. For Windows AMIs, the private key file is required to obtain the password used to log into the instance. Okay, so I guess we're going to need it. So Windows key. Great, we'll launch that instance. And I'll see you back here when it launches, but I just don't believe that it would launch that fast, you know? All right, so after a short little wait here, the server is ready. And so let's see if we can actually go ahead and connect to this. So I'm going to hit connect here, and we're going to go over to RDB client. So you connect to your Windows instance using a remote desktop client of your choice and downloading and running the RDB shortcut below. So I'm going to go ahead and download this, and you're going to have to be on a Windows machine to be able to do this, or have an RDB client installed. I think there's one for Mac that you can get from the Apple Store. But all I'm going to do is just double click the file. So you probably can't see it here. I'm just going to expand this. Try to, oh, my computer is being silly. But anyway, there we go. We moved it over there. And I'm just going to drag over here and just double click this image so you can see that I'm doing it. I'm saying connect. Okay. And then it's going to ask for a password. So I'm going to hope that I can just click that and get the password. So to decrypt the password, you will need your key pair instance. You'll have to upload that. And I don't know if I remember having to do that before, but it's a great security measure, so I'm fine with it. I'm going to drag my key to my desktop so I can see what's going on there as well. And we're going to go grab that and decrypt the password. And so now, where's our password? Oh, it's right here. Okay, so we're going to grab that password there. We will paste that in. Said okay. Say yes. And see if we can connect to this instance. And if this is running on a T2 micro, I'm going to lose it because that is just cheap. It just doesn't seem possible to me because, again, on Azure, you have to launch an instance with a lot of stuff, and it just seems crazy. What's also interesting is that AWS on Windows launches so fast. It's unbelievable how fast these servers spin up, and it's just very unusual. But yeah, so we are in here. It's not asking me to activate or anything, so I guess there's already a Windows license here. And I'm not sure if there's any kind of games installed. Do we have Minesweeper? Can I play Minesweeper on here? It's a data center server, so I'm assuming not. But yeah, so this is a Windows server, and it's pretty impressive that this works. I'm not sure if this is going to have an outbound connection here, just because we probably would have to configure it. Let's just say okay. I really don't think it's going to go out to the internet by default. Yeah, so you'd probably have to do some stuff, you know. Oh, no, there we go. So, yeah, we got to the internet, so it's totally possible. But, yeah, that's about it. That's all I really wanted to show you. So what I'm going to do is just go back to EC2, and we're going to shut down the server here. Just expand that there. And we will go here, and we will terminate that instance. Good. We'll give that a refresh. That's shutting down, and we are done. Hey, this is Andrew Brown from ExamPro, and we are taking a look at AWS License Manager. And before we do, let's talk about what BYOL, or Bring Your Own License, means. So this is the process of reusing an existing software license to run vendor software on a cloud vendor's computing service. BYOL allows companies to save money since they may have purchased the license in bulk or at a time that provided a greater discount than if purchased again. And so an example of this could be the license mobility provided by Microsoft's volume licensing to customers with eligible server applications covered by the Microsoft Software Assurance Program. And I don't know what I was trying to do there. I guess maybe it's just SA and I missed the parentheses there on the end. No big deal. But AWS License Manager is a service that makes it easier for you to manage your software licenses from software vendors centrally across AWS and your on-premise environments. AWS License Manager software that is licensed based on virtual cores, physical cores, sockets, or a number of machines. This includes a variety of software products for Microsoft, IBM, SAP, Oracle, and other vendors. So that's the idea. You say, what is my license type? It's bound to this amount of CPUs. AWS License Manager works with EC2, with dedicated instances, dedicated hosts, and even spot instances. And for RDS, there's only for Oracle databases, so you can import that license for your Oracle server. Just understand that if you're doing Microsoft Windows servers or Microsoft SQL Server license, you're generally going to need a dedicated host because of the assurance program. And this can really show up on your exam. So even though AWS License Manager works on dedicated instances and spot instances, just try to gravitate towards dedicated hosts on the server or on the exam, okay? All right, let's take a look at the logging services that we have available in AWS. So the first one here is CloudTrail, and this logs all API calls, whether it's SDK or the CLI. So if it's making a call to the API, it's going to get tracked between AWS services. And this is really useful to say, who can we blame? Who was the person that did this? So who created this bucket? Who spun up that expensive EC2 instance? Who launched the SageMaker notebook? And the idea here is you can detect developer misconfigurations, detect malicious actors, or automate responses through the system. Then you have CloudWatch, which is a collection of multiple services. I commonly say this is like an umbrella service because it has so many things underneath it. So we have CloudWatch Logs, which is a centralized place to store your cloud services log data and application logs. Metrics, which represents a time-ordered set of data points, a variable to monitor. Event Bridge, or previously known as CloudWatch Events, triggers an event based on a condition. So every hour, take a snapshot of this server. Alarms triggers notifications based on metrics. Dashboards creates visualizations based on metrics. And that's not all of the things that are under CloudWatch, but those are the core 5 ones you should always know. Absolutely there. Then we have AWS X-Ray. This is for a distributed tracing system, so you can use it to pinpoint issues within your microservices. So you see how data moves from one app to another, how long it took to move, and if it failed to move forward. Okay? Let's take a closer look here at AWS CloudTrail because it's a very important service. So it's a service that enables governance, compliance, operational auditing, and risk auditing of your AWS account. And the idea is that every time you make an API call, it's going to show up as some kind of structured data that you can interact with or read through. So AWS CloudTrail is used to monitor API calls and actions made on the AWS account, easily identify which users and accounts made the call to AWS. So you might have the where, so the source IP address, the when, the event time, the who, the user agent, and the what, the region, resource, and action. So I'm just going to get my pen tool out here for a moment and just notice you have the event time, so when it happened, the source, the name, the region, the source IP address, the user agent, who was doing it. So here was LaForge, the response element. So, it's very clear what is going on here. And then, CloudTrail is already logging by default and will collect logs for the last 90 days via event history. If you need more than 90 days, you need to create a trail, which is very common. You'll go into AWS and make one right away. Trails are outputted to S3 and do not have GUI-like event history. To analyze a trail, you have to use Amazon Athena, and I'm sure there are other ways to analyze it within AWS, but here's just what the event history looks like. So right off the bat, you can already see that there are information there. I'm not sure if they've updated the UI there. They might have, even when I'm recording this, I kind of feel like if we go into the follow along, which we will, I bet they might have updated that. But the idea here is that, you can browse the last 90 days, but anything outside of that, you're gonna have to do a little bit of work yourself, okay? So we're not going to cover all the CloudWatch services. There's just too many, but let's look at the most important ones. And one of those important ones is CloudWatch Alarms. So CloudWatch Alarms monitors a CloudWatch metric based on a defined threshold. So here you can see there's kind of a condition being set there. So if the networking is greater than 300 for one data point within 5 minutes, it's going to breach an alarm. So that's when it goes outside its defined threshold. And so the state's going to either be something like okay, so the metric or expression is within the defined threshold, so do nothing. Alarm, the metric or expression is outside of the defined threshold, so do something. Or insufficient data, the alarm has just started, the metric is not available, not enough data is available. And so when the state has changed, you can define actions that it should take. And so that could be doing a notification, auto-scaling group, or an EC2 action. So CloudWatch alarms are really useful for a variety of reasons. The one that we will come across right away will be setting up a billing alarm. So let's take a look here at the autonomy of an alarm. And so I have this nice graphic here to kind of explain that there. And so the first thing is we have our threshold condition. And so here you can just set a value and say, okay, the value is 1,000 or 100, whatever you want it to be. And this is going to be for a particular metric, the actual data we are measuring. So maybe in this case, we're measuring network in. So the volume of incoming network traffic measured in bytes. So when using 5-minute monitoring, divide by 300, we get bytes per second. If you're trying to figure out that calculation there, you have data points. So these represent the metrics measurement at a given point. Then you have the period, how often it checks to evaluate the alarm. So we could say every 5 minutes. You have the evaluation period, so the number of previous periods. and the data points to alarm. So you can say one data point is breached in an evaluation period going back 4 periods. So this is what triggers the alarm. The thing I just want you to know is that you can set a value, right? And that it's based on a particular metric. And there is a bit of logic here in terms of the alarm. So it's not as simple as just it's breached, but there's this period thing happening, okay? Let's take a look at CloudWatch logs. So to understand that, we have log streams and log groups. So a log stream is a stream that represents a sequence of events from an application or instance being monitored. So imagine you have an EC2 instance running a web application and you want those logs to be streamed to CloudWatch logs. That's what we're talking about here. So you can create log streams manually, but generally this is automatically done by the service you are using, unless you're collecting application logs on an EC2 instance, as I just described. Here is a log group of a Lambda function. You can see the log streams are named after the running instance. Lambda's frequency run on new instances, so the stream contains timestamps. So what I'm trying to say here is that there's a variety of different services, Lambda, RDS, what have you, and they already send their logs to CloudWatch logs, and they're going to vary, okay? So here's a log group of an application log running on EC2. You can see here the log streams are named after the running instance ID. Here is the log group for AWS Glue. You can see that the log streams are named after the Glue jobs. And so, we have the streams, but let's talk about the actual data that's made up of it, the log events. So this represents a single event in a log file. Log events can be seen within the log stream. And so here's an example of, you would open this up in CloudWatch logs and you can actually see what was being reported back by your server. You can filter these events to filter out logs based on simple or pattern matching syntax. So here I'm just typing in saying, give me all those debug stuff. And this isn't very robust, but AWS does have a better way of analyzing your logs, which is log insights, which we'll look at here in a moment. So we're just looking at CloudWatch log events and how those are collected, but there's an easier way to analyze them, and that's with log insights. So you can interactively search and analyze your CloudWatch log data, and it has the following advantages: more robust filtering than using the simple filter in a log stream, less burdensome than having to export logs to S3 and analyze them via Athena. CloudWatch log insights supports all types of logs. So CloudWatch log insights is commonly used via the console to do ad hoc queries against log groups. So that's just kind of an example of someone writing a query, and CloudWatch log insights uses a query syntax. So a single request can query up to 20 logs. Query timeout after 50 minutes if not completed, and queries result are available for 7 days. So AWS provides sample queries that you can get started for common tasks and ease the learning into the query syntax. A good example is filtering VPC flow logs. So you go there, you click it, and then you start to getting some data. You can create and save your own queries to make future repetitive tasks easier. On the Certified Cloud Practitioner, they're not going to ask you all these details about this stuff, but I just conceptually want you to understand that in Log Insights, you can use it to robustly filter your logs based on this query syntax language. You get this kind of visual, and it's really, really useful. Let's take a look here at CloudWatch metrics, which represents a time-ordered set of data points. It's a variable that is monitored over time. So CloudWatch comes with many predefined metrics that are generally namespaced by AWS services. So the idea is that, like, if we were to look at the EC2, it has these particular metrics. So that we have CPU utilization, disk read ops, disk write ops, disk read bytes, disk write bytes, network in, network out, network packet in, network packets out. And the idea is that you can just click there into EC2 and then kind of get that data there. And so CloudWatch metrics are leveraged by other things like CloudWatch events, CloudWatch alarms, CloudWatch dashboards. So just understand that, okay? All right, so what I want to do in this follow along is show you a bit about CloudTrail. So we're going to go to the top here and type in CloudTrail. The great thing about CloudTrail is it's already turned on by default, so it's already kind of collecting some information. And so here it says, now use IAM Access Analyzer on CloudTrail trails. That sounds pretty cool to me. But we shouldn't have to create a trail right off the bat because we'll have some event history. And the event history allows us to see things that are happening within our account in the last 90 days. But the thing is, if you want something beyond 90 days, you're going to have to create a trail. But if we just take a look here, we can kind of see, as we've been doing a lot of things, all the kind of actions that's been happening. So here we have an instance that I terminated. So if I go in here and look at it, I can kind of see more information about it. So we can see when it terminated, who had done that, what access key they had used, the event source, the request ID, the source IP, whether it was read-only, what was the event type that was called, the resource there. And this is the actual raw record. So this is generally how I would look at it, or this is how you had to look at it back in the day. But the idea is that you would have that user identity described, the event time, the source, the event name, the region, the source IP, the agent, all the information there, okay? And so this is a great way to kind of find stuff. So you can go through here and try to debug things this way. So you can go to the event name. And so if you go here, you can kind of get, see a bit of stuff here. So if I was just trying to say like maybe create, I'm just trying to find something that I know that I've been doing, like create access keys. I can see the access keys that have been created within this sandbox account here for the user and things like that. So it's a great way to kind of find things, but generally you're going to always want to turn on or create your own trail. So if you go here and hit create trail, say my new trail, and you're going to need an S3 bucket for that. You'll probably want encryption turned on, which sounds good to me. You'll absolutely want log file validation. And generally, you don't want to store your CloudTrail logs within the existing account. You want to have a isolated, hardened account that is infrequently accessed or only by your cloud security engineers away from here, because you don't want people tampering with it, deleting it, or changing stuff. But let's take an existing one here. I don't want a customer managed. Don't I have one that is managed by AWS here? New custom. Let's choose that one. I don't know which one that is, but we'll just hit next. Usually AWS gives you a managed key there, so I was kind of surprised. You can also include additional data. So if you do data events, this would collect information from S3. But the thing is, you might not want to track everything, because if you tracked everything, it can get very expensive very quickly. But if you don't, you just leave on management events, it'll save you more money. There's insight events. This is new. I haven't seen this yet. So identify unusual activity, errors, users' behavior. That sounds really good. But these could come also at additional charges. But I'm going to hit next anyway for fun. I'm going to create that trail. Okay. And the key policy does not grant sufficient access to, et cetera, et cetera. So I'm going to go turn that off, even though I should really have it turned on. But I just want to be able to show you this. Okay, and so we have this new trail. And so this trail is being dumped to S3. So we might not be able to see anything in here as of yet. But I'm just going to pop over here and just see, right? I probably have one in my other account, but it's not that important. We basically saw what the data would look like. So we go into here. There's a digest. I don't remember there being a digest, so that's nice. So there's no data yet, but when there is, it will pop into there. I'm not sure if we're going to be able to do anything with insights here, at least not in this account. Insights are events that show unusual API activity and things like that. So that's kind of cool. I don't know what CloudWatch Insights looks like. Insight events are shown in the table for 90 days. Okay. So I'm just curious if we can see kind of a screenshot of what that looks like. Whoops. Well, we're at least on the article here. So I guess you kind of get like some kind of graphs or something saying like, hey, this looks unusual, and they might select it. So not pretty clear in terms of what that looks like, but I mean, sounds like a cool feature. And I'm sure when working on my security certification course, I will definitely include it there. But that's pretty much all there is to it. I'm going to go ahead and delete that trail because I just don't really need it in this account. But generally, you always want to go in and create a trail. And what you can do is if you're in your root account, this is actually an account that's part of an organization, but if you're at that organization level, you can create a trail that spans all the regions, that spans all the AWS accounts within an organization. And that's what you should be doing, okay? But that's about it. Hey, this is Andrew Brown from ExamPro. We're looking at ML and AI services on AWS, but let's first just define what is AI, ML, and deep learning. So AI, also known as artificial intelligence, is when machines that perform jobs that mimic human behavior. ML, or machine learning, are machines that get better at a task without explicit programming. And deep learning, or DL, are machines that have an artificial neural network inspired by the human brain to solve complex problems. And a lot of times you'll see this kind of onion where they're showing you that AI can be using ML or deep learning, and then deep learning is definitely using machine learning, but it's using neural networks. And so for AWS, their flagship product here is Amazon SageMaker. It is a fully managed service to build, train, deploy machine learning models at scale. And there's a bunch of different kind of open source frameworks you can use with it, like Apache MXNet on AWS, which is an open source deep learning framework. That is the one that AWS decided to say, hey, we're going to back this one. And so you'll see a lot of example code for that one. We have TensorFlow that you can use, PyTorch, Hugging Face, other things as well, okay? And so there's a lot of services underneath. Some that might be of interest to mention right away is like Amazon SageMaker Ground Truth, which is a data labeling service where you have humans that label a data set that will be used to train machine learning models, or maybe something like Amazon Augmented AI, so human intervention review services. When SageMaker uses machine learning to make a prediction that is not confident, and it has the right answer queue up to the predict for a human review. And these are all about just labeling data, when you're using supervised learning. But there are a lot of services under SageMaker itself and just AI services in general. So we'll look at that next, okay? All right, let's take a look at all the ML and AI services, and there's a lot on AWS. So the first is Amazon Code Guru. This is a machine learning code analysis service, and Code Guru performs code reviews and will suggest to improve the quality of your code. It can show visual code profiles, so show the internals of your code to pinpoint performance. Next, we have Amazon Lex. This is a conversation interface service. With Lex, you can build voice and text chatbots. We have Amazon Personalize. This is a real-time recommendation service. It's the same technology used to make product recommendations to customers shopping on the Amazon platform. Then we have Amazon Poly. This is a text-to-speech service. Upload your text and an audio file spoken by synthesized voice, and that will be generated. You have Amazon Recognition. This is an image and video recognition service. Analyze image and videos to detect and label objects, peoples, and celebrities. Then we have Amazon Transcribe. This is a speech-to-text service, so you upload your audio and that'll be converted into text. We have Amazon Text Extract. This is an OCR tool, so it extracts text from scanned documents. When you have paper forms and you want to digitally extract that data. We have Amazon Translate. This is a neural machine learning translation service. So you use deep learning models to deliver more accurate and natural sounding translations. We have Amazon Comprehend. This is an NLP, so natural language processing service. Find relationships between text to produce insights. Looks at data such as customer email, support tickets, social media, and makes predictions. Then we have Amazon Forecast. This is a time series forecasting service, and it's, technically I guess it's a bit of a database, but the idea here is that it can forecast business outcomes such as product demand, resource needs, or financial performance, and it's powered by ML or AI, if you want to call it. We have AWS Deep Learning AMIs. So these are Amazon EC2 instances. They're pre-installed with popular deep learning frameworks and interfaces such as TensorFlow, PyTorch, Apache MXNet, Chainer, Gluon, Horovod, and Keras. We have AWS Deep Learning Containers, so Docker images instances pre-installed with popular deep learning frameworks and interfaces such as TensorFlow, PyTorch, Apache MXNet. We have AWS Deep Composer. This is machine learning enabled musical keyboard. I don't know many people using this, but it sounds like fun. AWS Deep Lens is a video camera that uses deep learning. It's more of like a learning tool, so again, we don't see many people using this. AWS Deep Racer is a toy race car that can be powered with machine learning to perform autonomous driving. Again, this is another learning tool for learning ML. They like to do these at reInvent to have like these racing competitions. Amazon Elastic Interface. So this allows you to attach low-cost GPU powered acceleration to EC2 instances to reduce the cost of running deep learning interfaces by 75%. We have Amazon Fraud Detector. So this is a fully managed fraud detection as a service. It identifies potentially fraudulent online activities such as online payment fraud and the creation of fake accounts. Amazon Kendra. So this is an enterprise machine learning search engine service. It uses natural language to suggest answers to questions instead of just simple keyword matching. So there you go. Hey, it's Andrew Brown from ExamPro, and we're going to do a quick review here of the big data and analytics services that are on AWS. But before we do, let's just define what big data is. So it's a term used to describe massive volumes of structured or unstructured data that is so large it is difficult to move and process using traditional database and software techniques. So the first here we have is Amazon Athena. This is a serverless interactive query service. It can take a bunch of CSV or JSON files in an S3 bucket and load them into a temporary SQL table. And so you can run SQL queries. So it's when you want to query CSV or JSON files. If you've ever heard of Apache Presto, it's basically that, okay? Then we have Amazon Cloud Search. So this is a fully managed full text search service. So when you want to add search to your website. We have Amazon Elasticsearch Service, commonly abbreviated to ES. And this is a managed Elasticsearch cluster. And Elasticsearch is an open source full text search engine. It is more robust than Cloud Search, but requires more server and operational maintenance. Then we have Amazon Elastic MapReduce, commonly known as EMR. And this is for data processing and analysis. It can be used for creating reports just like Redshift, but is more suited when you need to transform unstructured data into structured data on the fly. And it leverages open source technology, so like Spark, Hive, Pig, things like that. Then we have Kinesis Data Stream. So this is a real-time streaming data service. It creates producers, which sends data to a stream. It has multiple consumers that can consume data within a stream and use it for real-time analytics, click streams, ingestion data from a fleet of IoT devices. Then we have Kinesis Firehose. This is a serverless and a simple version of a data stream. And you pay on demand based on how much data is consumed through the stream, and you don't worry about the underlying servers. Then you have Amazon Kinesis Data Analytics. This allows you to run queries against data that is flowing through your real-time stream, so you can create reports and analysis on emerging data. And last, on the Kinesis side here, we have Amazon Kinesis Video Streams. This allows you to analyze or apply processing on real-time streaming videos. On the second page here, we have Managed Kafka Service, MSK, and it might be MKS now that I'm looking at it here, so just be aware that that might be incorrect. But a fully managed Apache Kafka service. Kafka is an open source platform for building real-time streaming data pipelines and applications. It is similar to Kinesis, but with more robust functionality. Then we have Redshift, which is AWS's flagship big data tool. It's a petabyte-sized data warehouse. The data warehouses are for online analytical processing, OLAP. So data warehouses can be expensive because they are keeping data hot, meaning that we can run a very complex query in a large amount of data and get that data back very fast. But this is great when you need to quickly generate analytics or reports from a large amount of data. We have Amazon QuickSight. This is a business intelligence tool or a business intelligence dashboard, BI for short. You can use it to create business dashboards to power business decisions. It requires little to no programming and connect and ingest to many different types of databases. If you've ever heard of Tableau or Power BI, this is just the AWS equivalent. We have AWS Data Pipelines. This automates the movement of data. You can reliably move data between compute, storage, and services. We have AWS Glue. This is an ETL service, so it allows you to move data from one location to another where you need to perform transformations before the final destination. It's similar to DMS, but it's more robust. We have AWS Lake Formation. This is a centralized, curated, and secured repository that stores all your data. So it's a data lake. It is a storage repository that holds a vast amount of raw data in its native format until it is needed. And then last on here, we have AWS Data Exchange. This is a catalog of third-party data sets that you can download for free or subscribe or purchase data sets. So they might have like the COVID-19 foot traffic data, the IMDb TV, movie data, historical weather data. And sometimes this is really great if you're just trying to learn how to work with these tools, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look here at Amazon QuickSight, which is a business intelligence dashboard or BI dashboard that allows you to ingest data from various AWS storage or database services to quickly visualize business data with minimal programming or data formula knowledge. So here's an example of a QuickSight dashboard. And so the way QuickSight is able to make these dashboards super fast is via Spice, the super fast parallel in-memory calculation engine. And the thing is, you don't have to use Spice, but generally it is good to use it. And there are some caveats when getting your data into QuickSight. Sometimes it can't ingest data directly from a particular data store, so you might have to dump it to S3 first, but it's not too bad because you can use AWS Glue to transform that data over. There are additional features, sometimes marketed as services, but we have QuickSight ML Insights. This detects anomalies, perform accurate forecasting. It can generate natural language narratives, so basically like describe it as if you're going to read it out as a business report, Then there's Amazon QuickSight Q. This allows you to ask questions using natural language on all your data and receive answers in seconds. So there you go. Hey, this is Andrew Brown from ExamPro, and let's go take a look at Amazon QuickSight, which is a business intelligence tool. So when you go here, you have to sign up because it's kind of part of AWS, but on its own separate thing. And then you have to choose what you want. So we have Enterprise and Standard. I do not want to pay that much, so I'm going to go to Standard over here. I'm not really sure what the difference is. It's not really telling me what between Standard and Enterprise. But I'm going to assume Standard is more cost effective. But here it says use IAM federated identities, which is fine. Use IAM federated identities only. We can stick with the top one there. That seems fine to me. We need to enter a name, so we'll just say my QuickSight account. And we probably have to fill something in there. So let's say Andrew at ExamPro.co. And these are the services that are going to integrate with it. Athena, S3, RDS, things like that. I guess we could select some of those buckets. I'm not too worried about doing that right now. The provided account name is not available. That is a terrible UI, but that's AWS for you. So I'm just going to dump some numbers there. I'm going to put my email in here again. We probably want some S3 buckets. I'm going to make a new bucket, because I think that's how we're going to do this. We're going to have to make a bucket here and say QuickSight data. Okay. And we're going to create ourselves a bucket here. I'm going to go back, and hopefully that shows up. It does not. So what I'll have to do is just back out. And I'm just going to give it a hard refresh here. And we're hit sign up for QuickSight again. And we'll choose Standard. And we'll say my QuickSight account, a bunch of numbers there, AndrewExamPro.co. I don't really care about ingesting data from everywhere else. I just want it from S3. There's my data. Sure, we'll give it right permissions, even though I don't plan to do anything with Athena here today. And we'll give it a moment to load. So what I'm thinking is, just making like an Excel spreadsheet here and just filling in some data. So, it says our account is set up here. So we'll go to QuickSight, because I bet I can import like a CSV or something. I'm more of a Tableau or Power BI kind of person, but for the purpose of the Cloud Practitioner, I am going to show you this. Amazon QuickSight lets you easily visualize data and etc. That sounds great. Next, next, next. I know what I'm doing. Oh, do we have some examples? Great. So I don't even have to make a spreadsheet. Okay, so what we'll do is just click on that. And we have stuff. It looks like they've really improved this since the last time I've seen it, which is quite nice. But I could try and make my own. I'm just trying to think, how do we do this again? Yeah, we have the spice there. So it's a lot easier from starting from scratch. I'm just going to say close. And user analysis, we want data sets in here. Oh, we already have some data sets. These are coming from S3, I think. That's the old S3 logo. I'm not sure why they're using that one. We can go here and create a new data set. Oh, we can upload directly, so I don't even have to use S3. That's great. So what I'm going to do is just have some values in here. So I'm going to just say type value. So let's say banana, 125, 123. We'll say apple, 11, orange. Nobody likes oranges. I shouldn't say that. I'm sure it's like lots of people like oranges. Oh, we got to put pears on there. I actually really like pears. People think I like bananas, which is not true. I actually like pears. That's what I like. So I'm going to go ahead and save this, save as. And I'm just going to save this to my desktop here. So just give me a moment. I'm just doing this off screen. And I'm going to save this data set, QuickSight CSV. It can even take an XLS, so I don't have to save it as a, I'll just save it as an XLS. Okay, and so we're going to just upload that. So there is that data set. It's going to scan that file. It's going to see that sheet. You can even preview it. There's the information. We're going to add that data. I get added as a data set. Well, how do I? where do I? It's like it says add the data. I just want to add it as a data set. So data set up here. Maybe save and visualize up here. And is it autographing it? Maybe if I drag in, is it working? Is it thinking? Okay, it's at 100%. So I'm going to just drag that onto there. And it says pear, orange, banana. Just kind of trying to make sense of this here. Is it taking into account the value? Maybe put the value down there. Wow, that's so much easier. I haven't used this for like a year, and I'm going to tell you, this has gotten a lot easier to use. So I'm quite impressed with this. But yeah, I mean, this is pretty much what QuickSight is. If you want to visualize things in different types, you can drag them out. You can probably like click on the wheel here and change it. Again, I'm not sure exactly how all the dials and knobs work here, but I mean, another thing we could do is just drag out like another object and do the same thing. So maybe I'd want a pie chart. So add a visual. Yeah, it's not as nice as Power BI, but like it's still great that it's here, you know, type value. And so we got a nice pie chart there. Let's try something weird. Let's give this one a go. Doesn't color it, which is not very nice. There's probably some kind of way to color it, but focus on banana only. I don't know. I don't know what the point of there. But anyway, that's QuickSight. So I really don't want to pay for this. So what I'm going to do is go up here. You have to deactivate. I'm just trying to remember how. Because they changed the interface again. They change everything on you. So maybe we go. I'm on a trial for 4 days here, maybe. Quantity 4, just the 4. 29-day trial. So if I want to get out of this trial, what do? I don't want to use it anymore. So how to delete AWS QuickSight. Canceling your subscription. So before you can unsubscribe, you're assigned in the IAM account. You're QuickSight administrator. You're the root IAM administrator, sure. You deleted any secondary namespaces to find the existing namespace, etc. So choose your username in the application bar to manage QuickSight. Account settings, unsubscribe. So I was almost there. I thought I was in the right place. This one? No. I was just there. Manage QuickSight. Your subscriptions. Edit. There's no unsubscribe option. So I'm not sure. Can I cancel? Unsubscribe. Button does not appear in QuickSight. And it could just be because we're on trial, and so maybe after the end of the trial, it will vanish there. They are not making this easy for me. Account settings. Delete account. So this is what we probably want to do. Permanently delete the account. Yes. I mean, that has to get rid of the subscription because it gets rid of everything. There we go. We'll say confirm. Delete account. Unless you're using them in the services, blah, 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 blah. Successful. Okay, great. So now I should go back to aws.amazon.com. And just to confirm that it's gone, I'm going to go to QuickSight again and just see if it's trying to ask me to sign up again. So it is. So I've gotten rid of my account, so we're all in good shape. And yeah, that is QuickSight. All right, let's take a look at some more machine learning AI services because AWS won't stop making these things. And basically last time I made the videos, all this generative stuff did not exist, so we need to cover it. The first is Amazon Bedrock. So this uses large language models and makes it a cloud service offering to generate text and images responses. If you know what ChatGPT is, you know what Bedrock is. We have Amazon Code Whisperer. It's an AI code generator that will predict code to meet your use case. So if you've ever heard of GitHub Copilot, it's the same thing basically. It's going to write code for you, or along with you, I should say. We have Amazon DevOps Guru. This uses ML or machine learning to analyze your operational data and application metrics and events to detect operational abnormalities. Imagine if you had kind of like a junior DevOps person digging into your metrics to figure out if there's something wrong. Then we have Amazon Lookout. This is actually 3 different offerings. We have Amazon Lookout for equipment, Amazon Lookout for metrics, and Amazon Lookout for vision. They all seem to have to do something with quality control and performing automated inspections. So vision, of course, would use vision to detect anomalies. One would be for equipment to detect if there's anything wrong with operational equipment. And then metrics would be, with metric data. So something probably more for the hard industries to utilize. And you have Amazon Monotron. So this uses machine learning models to predict unplanned equipment downtime. And so the way they do that is they have these IoT sensors that's going to capture vibrations and sensor data from your hardware. Then we also have AWS Neuron. This is an SDK used to run deep learning workloads on AWS I can't say that word, but I know what it is. It's basically it's machine learning acceleration on GPUs that you can attach, and AWS Trainium. So yeah, I wish the words weren't so hard. There's actually more stuff that AWS has for machine learning. I didn't include them because they were just too far out there. They're definitely not going to show up in your exam. You'll definitely never see them, but we now have better coverage. What I really wanted to show was Bedrock, Code Whisperer, because I feel like those two will show up on future exams. So I'm just trying to get those in front of you now, even if they're not on the exam at the time of this recording, okay? Ciao. All right, so you probably already know what generative AI is, but just in case you don't, I want to just quickly cover it and show a very tiny example. So generative AI, which also can be shortened to Gen AI, though most people don't say that, is a type of artificial intelligence capable of generating new content such as text, images, music, or other forms of media. So an example would be something like a software that I like to use called Midjourney, where you can put in a prompt, and so it will then go ahead and generate out an image. So all the cloud service providers have some kind of offering with both image and text. But yeah, hopefully that makes sense. The idea is that you can plug stuff in and you get stuff out, okay? Let's take a look here at machine learning and deep learning frameworks. And so these are frameworks that can be used with SageMaker or have direct support for them. I just wanted to get you some exposure and to get you some context in terms of these, because machine learning and AI and all this stuff is becoming more popular, so you should at least have heard of these things. So I have all the logos on the left-hand side, and we'll go through them. The first is Apache MXNet. So this is a machine learning framework adopted by AWS. Basically, every single cloud service provider backs their own kind of open source framework, and they try to make that the one that they suggest you to use. But in practice, there's ones that are good and there's ones that people just don't want to use. And Apache MXNet is not fun to use whatsoever. And so you'll see it all over in the marketing and pushed everywhere. But really, people want to use things like Keras TensorFlow. But anyway, I just wanted to point that out, that AWS has a bias because they've invested energy into their team of machine learning frameworks. You got PyTorch, optimized for tensor library for deep learning using GPU and CPU. It's created by Facebook. Facebook does not necessarily have its own cloud service provider offering, so it's kind of out there. And so you'll see good support for PyTorch in all the major providers. The next is TensorFlow. This is made by Google. What's interesting with TensorFlow is Google made their own GPU or TPU, they call it, a tensor processing unit. So tensor is a unit of thing in TensorFlow, and they have optimized hardware for it. I personally find TensorFlow, the easy to use, or I should say Keras. So Keras is a high-level machine learning framework built on top of TensorFlow because these lower-level ones were just really hard to use. And so basically PyTorch came along and it was much easier to use. And then everyone noticed how easier PyTorch was. And so that's where Keras came from, was to be competitive with PyTorch and be easier to use. Then you have Apache Spark, which is a unified analytics engine for large-scale data processing, but they do have ML offerings within it called Spark ML. So there's definitely things you can do there. There's a piece of software called Chainer, and it's a deep learning framework that supports CUDA. Then there's Hugging Face, which is not exactly a framework or tool. It's just a way of accessing a lot of models online and data sets and quickly launching them. For whatever reason, AWS has strong synergies with Hugging Face. I've seen like developer advocates and other folks that worked at AWS go over to Hugging Face. And so there seems to be strong relationships between Hugging Face and AWS for whatever reason. There's a lot of ML frameworks out there, but because ML is just progressively or rapidly innovating, you'll see frameworks come and go. And so I remember when I researched this and I was just trying to understand all the frameworks out there, there was just a lot, and I just kept digging into them and finding, oh, they're not active anymore. They're not active anymore. So I just want to point out that we have all these ones up on screen. If they become inactive tomorrow, I would not be surprised. But for the most part, all of these seem to be very popular and they're being well supported. But yeah, hopefully that gives you an idea of these frameworks. Okay, ciao. All right, let's take a look here at Apache MXNet a little bit more in detail because this is the framework that AWS wants you to use. Whether you want to use it or not is a different story, but you'll see it all over in their marketing pages and things like that. So Apache MXNet is a deep learning machine learning framework which supports many, many different programming languages. So that is one advantage of it. The key features is that it's scalable, it's flexible, it's portable, it supports multiple programming language. AWS has made Apache MXNet their framework of choice, so there's lots of support for it within AWS SageMaker and the AWS ML containers. But I have noticed that they've been increasing support for PyTorch, so maybe they're just trying to meet the customer where they are. But anyway, there is a lot of stuff for MXNet. MXNet has two high-level interfaces. One's called Gluon, and there is Module API. So depending on which one you use, one is imperative programming, one's symbolic programming. This is more of a deeper concept for machine learning, but I'm going to tell you one is really easy, one is really hard. But let's look at a very simple example of some code for using the Gluon API. So it kind of looks like that, and you can see that they are using Python. So hopefully that gives you an idea of MXNet and its offering. The key thing is that it offers it in a lot of different programming languages. Will this appear on your exam? Absolutely not, but should you know it? You absolutely should, just so you have good context with AWS and ML. So there you go. I want to talk a little bit about Intel because I think it's very important to remember the hardware that is running with these cloud service providers, because it really does matter. And there's a couple terms you might see when using compute that you're not aware of, and I want to make sure you know what they are. So let's talk about what is Intel. So Intel is a multinational corporation, is one of the world's largest semiconductor chip manufacturers. Intel is the inventor of the x86 instruction set. So basically, they released this chip back in 1978. This one's called the Intel 8086 chip. And the idea is that they came up with an instruction set. It's basically a bunch of words that you can use to program the chip. And it's a lower level language. So that lower level language would be in assembly, if that makes any sense. So the idea is that you have this instruction set and you have to write an assembly. And so basically most modern programs, like when you use programming languages like C, it will actually compile down to assembly. Or other languages will compile down to assembly because that is what the chip understands, and then assembly is turned into machine code like the zeros and ones. And the reason I'm mentioning this is that when you go and you launch a compute instance, let's say on AWS, you're launching a EC2 instance, you have to choose whether it's x86 or a different instruction set or architecture. And so the other one is ARM. And they're both really, really good. It just depends on whether your stuff can support it. But for the most part, Intel has ARM chips as well. So there is no company that produces ARM chips per se. It's just an architecture. And the way it works is that it just has fewer instruction sets. So there's fewer rules that you can write in. So it's a more limited writing it in assembly. But at the end of the day, it doesn't matter because your programming language is going to compile it down. So you don't have to worry about those fewer instructions. But because it has fewer instructions, it generally results in a better power efficiency. And so it can have better performance or better cost to you, the customer. So when I can, I try to run ARM. And for the most part, it's always great to run ARM, but it really depends on if your software is going to be able to run on ARM and stuff like that. So I just wanted to point out those two things there about at least a bit Intel and then instruction sets, okay? All right, I want to talk about two things that Intel has with AWS, and the first is Intel Xeon Scalable Processor, and the second is Intel Gaudi. So AWS, of course, does work with or purchases hardware from other companies, like they use AMD and NVIDIA. But I think it's worth mentioning Intel in a little bit more detail here because every time I go to reInvent, Intel has a big, giant booth, and you can go scour the AWS website, and it just looks like AWS works more closely with Intel as opposed to the other providers. Not to say that Intel is not being utilized on GCP and Azure and others, but I just noticed something more going on there with AWS. But let's first talk about Intel Xeon Scalable Processors. These are high-performance CPUs designed for enterprise and server applications, commonly used in AWS instances. That scalable part makes them very good for machine learning. So you often are going to be using Intel Xeon processors, whether you know or not, on AWS. The Intel is the Intel Habana Gaudi processor. So this is a processor specialized for AI training. You could say that this is a direct competitor to NVIDIA or a similar competitor because they do something very similar. I believe that Intel Gaudi has their own SDK called Synapse AI that you can use to interact with it. So you could launch up SageMaker and then use that API or SDK in order to best utilize that hardware there. But both of these pieces of hardware are offered on AWS. And I think it's just good to know them, at least in name, what they are, okay? Hey, this is Andrew Brown, and let's talk about GPUs. I'm sure most people know what GPUs are here, but I'm going to talk about it anyway because I want to talk about CUDAs. So a GPU stands for General Processing Unit, and it's a processor that is specialized to quickly render high-resolution images and videos concurrently. If you've ever played video games, you know you need a good GPU because it's all about those images. However, GPUs can perform parallel operations on multiple sets of data, so they can also be used for non-graphical tasks. And this makes it really good for machine learning and scientific computation. So if you're trying to convince your significant other that you need a better graphics card, you can just tell them it's for work. I need it for machine learning and scientific computation. It's not your fault that you can also play video games with it. And so we have like a graphic there on the right-hand side. I think I got that from NVIDIA. And so they're kind of trying to demonstrate the difference between the parallelization with GPU versus serial tasks with CPU. But let's go and just read a little bit more. So CPUs can have an average of 4 to 16 processor cores. GPUs can have thousands of processor cores. How that works, I have no idea, but I just know that that's how it works. So we have 4 to 8 GPUs can provide as many as 40,000 cores. So that is a lot. GPUs are best suited for repetitive and highly parallel computing tasks, such as rendering graphics, cryptocurrency mining, and people are even still doing that, and deep learning and machine learning. So, there you go. That's GPUs. All right, let's take a look here at CUDA, but before we do, let's talk about NVIDIA. So NVIDIA is a company that manufactures graphical processing units for gaming and professional markets. If you have ever played video games and you build your own rig, a lot of people like to choose NVIDIA, but NVIDIA can do things other than video games. And this is due to their framework called CUDA, which stands for Compute Unified Device Architecture. So it's a parallel computing platform and API. I said framework, but I guess it's an API. by NVIDIA that allows developers to use CUDA-enabled GPUs for general-purpose computing GPUs. And it says GPU because it's saying general-purpose GPUs. I know that's a mouthful there. So over on AWS, they have a bunch of instances that can utilize NVIDIA GPUs. So AWS is always changing the instances, so these could be old, but you can see we have a P3, which has the Tesla V100. You have the G3 with the Tesla M60, the G4 with the T4, the P4 with the Tesla A100. So these are probably old ones. There's new instances with newer NVIDIA cards. But my point is that AWS has GPUs that you can utilize. Another thing I want to point out with CUDA is that all major deep learning frameworks are integrated with NVIDIA deep learning SDKs. There's a big fight or war over these companies that make GPUs and CPUs because they really want theirs to be used for machine learning. So you can definitely be sure that AMD probably has some kind of similar offering or something, and definitely Intel as well. But NVIDIA has done a very good job in making sure that theirs is the most popular. So NVIDIA Deep Learning SDK is a collection of NVIDIA libraries for deep learning. So this is the SDK you can use with CUDA to interact with their API. So one of those libraries are called CUDA Deep Neural Network Library. So that's something you can use with it. And it's tuned for a bunch of stuff. If it looks like it's getting a little bit too technical, it's because this slide was for my machine learning AWS specialty, and I didn't do a whole lot to change it and brought it over. So you don't really need to know that last part there, but just understand what CUDA is and that it's very important for working with machine learning. And AWS has good offerings for instances with it, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at the AWS well-architected framework. So this is a white paper created by AWS to help customers build using best practices defined by AWS. You can find this at aws.amazon.com/architecture/well-architected. This idea is not unique to AWS. The other providers have it, but I believe AWS was the first one to define this, and they have a really good approach to this. And this is pretty much essential knowledge that you have to have for certifications when we're looking at the Cloud Practitioner, the Solution Architect Associate, and Professional, because there's a lot of principles here, best practices that AWS uses themselves to architect their infrastructure, okay? So the framework is divided into 5 sections called pillars, which address different aspects or lenses that can be applied to a cloud workload. So imagine you have your cloud workload. You're going to want to adopt the AWS well-architected framework. Some things that people don't consider outside the 5 pillars is that you need to know general definitions, general design principles, and the review process. And then from there, you have your 5 pillars. So you have operational excellence, security, reliability, performance efficiency, and cost optimization. And all of these have major sections in this white paper. But outside of just the main white paper, each of these have their own white papers that go even into farther detail. So if you really want to really focus on security and get a lot more information, they have that as well, okay? Let's take a look at the general definitions for the well-architected framework, starting with the pillars. So the operational excellence pillar is there to run and monitor systems. The security pillar is to protect data and systems to mitigate risk. The reliability pillar is to mitigate and recover from disruptions. The performance efficiency pillar is about using computing resources efficiently or effectively. And the cost optimization pillar is about getting the lowest price. And this is where you're going to find all the business value. And I put an asterisk there because you might obsess saying we need to meet the requirements for all these pillars, and that's not the case. You can trade off pillars based on the business context. So, don't take it as literally implement every single thing, but just consider that, you might have to adapt it based on your workloads. Then we have some general definitions that we will come across. So there's components, so code, configuration, AWS resources against a requirement, a workload, so a set of components that work together to deliver business value, milestones, so key changes of your architecture through the product lifecycle. Then there's architecture itself, so how components work together in a workload. And then we have technology portfolio, so a collection of workloads required for the business to operate, okay? So the well-architected framework is designed around a different kind of team structure. So when you're looking at enterprises, they generally have a centralized team with specific roles, where AWS structures their teams as being distributed with flexible roles. And so this new kind of methodology of distributed teams has some major advantages, but it does come with some risks. And so AWS has baked in some practices or things that they do to mitigate these issues. Okay, so let's compare on-premise enterprise to what AWS is proposing for your team structure. So on-premise, what we'd see is a centralized team consisting of technical architects, solution architects, data architects, network architects, security architects, and you kind of see that they all have a specialized vertical, and they are usually managed by either TOGAF or ZAC-man framework. So those are just ways of structuring your teams. Those are very popular. And so what AWS is proposing here is that you have a distributed team, and the way you're going to make that team work, because obviously just thinking about a distributed team, they're going to be a lot more agile, but to make sure that they effectively work, you have practices like team experts who raise the bar, making sure that, in any areas we can always say, how can we do this better? Then there are mechanisms in place for automated checks for standards. So that's the great thing about cloud. It can all be automated to say, hey, does it meet our regulatory compliance or what have you? And then there's the concept of the Amazon leadership principles, which we will cover on in the next slide in detail. And so, AWS is not obviously using these other frameworks because it has its own, which is this one here. But the mechanism to which they stay organized and up to date is they are supported by a virtual community of subject matter experts, principal engineers, so that what they'll do is they'll engineer things like lunchtime talks and then recycle that into their onboarding material or into this framework itself, okay? So we're taking a look here at Amazon's leadership principles, and these are a set of principles used during the company's decision-making, problem-solving, simple brainstorming, and hiring, all right? And so I can't say that I like all of these, but definitely some of them really stand out as being great, especially the first one, which is customer obsession. So instead of worrying about what your competitors are doing, think about what the customer wants, work your way back, and really focus on the customer's needs. Then there's ownership. So if you're going to go do something, try to be your own mini boss. And take responsibility for whatever it is you're building. Event and simplify. So, always look for the simplest solution. Don't try to engineer something super complicated if it's not necessary. Are right a lot. So, try to be right. Learn and be curious. So that's pretty self-explanatory. Hire and develop the best. Insist on the high standards. AWS always refers to this as raising the bar. Think big, bias for action, frugality, and AWS is really frugal if you didn't know that, but not just for like themselves, but also for their customers. They want customers to spend the least amount of money possible when using their infrastructure. Earn trust, dive deep, have a backbone, disagree and commit, deliver results, strive to be the Earth's best employer, success and scale bring broad responsibility. And if you want to read these in detail, because they have a big block of text for each of these, you can go to amazon.jobs /en/principles and read all about it, okay? All right, let's talk about some general design principles that you should be considering when you are designing your infrastructure, no matter what pillar that you are looking to adopt. The first is stop guessing your capacity needs. So the great thing with cloud computing is you use as little or much based on demand, whereas on-premise, you would have to purchase a machine and you'd have to make sure you'd have additional capacity so that you could grow into it, right? And so here with cloud, you do not have to worry about that. Test systems at production scale. So be able to clone your production environment to testing, tear down testing while not in use to save money. So a lot of people will have a staging server that they run all the time. But the great thing here is that with cloud, you can just spin it up and have it right away and then tear it down and save money. There's automating to make architectural experimentation easier. This is talking about using infrastructure as a code. So for AWS, this would be using CloudFormation, creating change sets, which kind of say exactly what is going to change, stack updates, drift detection to see if your stuff is being changed over time by developers through manual configuration, things like that. Then we have allow for evolutionary architectures. So this is about adapting CI/CD, doing nightly releases, or if you're using serverless, if you adopted Lambdas, they deprecate over time, forcing you to use the latest version. And so that is evolutionary architectures. Then we have drive architectures using data. So when you're using cloud, there's a lot of tooling in there to automatically start collecting data. So CloudWatch will be collecting some things by default, and CloudTrail will as well. So that is another thing. And then improving things through game days. So this is about simulating traffic on production or purposely killing EC2 instances or messing with your services to see how well they recover. All right. Before we jump into each of the pillars, let's go open them up and take a look at what structure we should expect to see. So we have design principles, definition, best practices, and resources. All of the pillars follow this to a T. So let's just talk about what these are. So the design principles are a list of design principles that needs to be considered during implementation. And that's where we're going to focus a lot of our energy. Then you have definition. So this is an overview of the best practice categories. Then you have the best practices themselves. These are detailed information about each practice with various AWS services. And then you have resources. These are additional documentation, white papers, and videos to implement this pillar. And I just want to tell you that if you're doing the Certified Cloud Practitioner, we're really just going to cover the design principles. But for the Solutions Architect Associate or anything that's associate or above, that's where we're going to actually dive deep into the implementation of the best practices, because there is a lot of stuff there. So yeah, there we go. Let's take a look here at the design principles for operational excellence. So the first here is perform operations as code. So apply the same engineering discipline you would to application code to your infrastructure. So by treating your operations as code, you can limit human error and enable consistent responses to events. Generally, we're talking about infrastructure as a code here. So this would probably be like things like CloudFormation. There's other things you could do like policy as a code and a bunch of other ones. Then we have make frequent, small, reversible changes. So design your workloads to allow components to be updated regularly. This could be talking about doing rollbacks, incremental changes, blue-green deployments, having a CI/CD pipeline, refine operations procedures frequently. So look for continuous opportunities to improve your operations. Here you'd use game days to simulate traffic or event failure on your production workloads. Anticipate failure, so perform postmortems on system failures to better improve, write test code, kill production servers. There's a small spelling mistake. It should have an R here. So servers to test recovery, learn from all operational failures. So share lessons learned in a knowledge base for operational events and failures across your entire organization. But if you can just remember these headings here and be able to categorize what would be under operational excellence, you'll be okay, all right? All right, let's take a look at the design principles for the security pillar. So the first here is implement a strong identity foundation. So implement the principle of least privilege, or POLP. That's a very popular concept, meaning giving people only the permissions that they need. Use centralized identity, so that would be using AWS IAM. Avoid long-lived credentials. Then we have enable traceability, so monitor alerts and audit actions and changes to your environment in real time. Integrate log and metric collection and automate investigations and remediation. Then we have apply security at all layers. So take defense in-depth approach with multiple security controls for everything from edge networks, VPCs, load balancing instances, OS, application code. We might have a slide in this course on defense in depth where basically you see like a ring of things, and you can kind of see how like there's layers that go from outward to inward, and that's what they're talking about when they're listing out all these things here. Automate security best practices, protect your data in transit at rest, keep people away from your data. The reason I don't have descriptions there is because those are pretty self-evident. Prepare for security events, so incident management systems and investigation policies and processes, tools to detect, investigate, and recovery from incidences. And there are a lot of security tools out there, and they all have funny initialisms. I didn't put any of them in here, but I'm sure there are some there. But yeah, there you go for security. All right, let's take a look at design principles for reliability. And the first here is automatically recover from failure. So monitor KPIs and trigger automations when the threshold is breached. Test recovery procedures. So test how your workload fails and you validate your recovery procedures. You can use automation to simulate different failures or to recreate scenarios that led to failures before. Scale horizontally to increase aggregate system availability. So replace one large resource with multiple small resources to reduce the impact of a single failure on the overall workload. Distribute requests across multiple smaller resources to ensure that they don't share a common point of failure. So we're talking about multi-AZ, high availability, okay? Stop guessing capacity. We've seen this multiple times. So in on-premise, it takes a lot of guesswork to determine the elasticity of your workload's workload demands. With cloud, you don't need to guess how much you need because you can request the right size of resources on demand. That's going to give you better reliability, okay? Manage change and automation. So making changes via infrastructure as a code will allow for a formal process to track and review infrastructure. And you're going to see IAC show up a lot in this framework, okay? Let's take a look at design principles for performance efficiency. So the first here is democratize advanced technologies. So focus on product development rather than procurement, provisioning, and management of services, because if you're on-prem, you'd have to order those machines, set them up. And so take advantage of advanced technologies, specialize and optimize for your use case with on-demand cloud services. Because again, if you're using on-prem, you might not have the option to have SageMaker, right? It's just going to be a VM, and you're going to have to do all the work yourselves, whereas AWS has all these specialized things so you can move quickly. Go global in minutes. So deploying your workload in multiple AWS regions around the world allows you to provide lower latency and a better experience for your customers at a minimal cost. We have used serverless architecture. So serverless architecture removes the need for you to run and maintain physical servers for traditional computing activities. It removes the operational burden of managing physical servers and can lower transactional costs because managed services operate at cloud scale, and AWS can be a lot better at running them efficiently than you will. Experiment more often. So with virtual and automatable resources, you can quickly carry out comparative testing using different types of instances, storage, or configurations to make the best choice. We call this right sizing, choosing the right size. Consider mechanical sympathy, so understand how cloud services are consumed, and always use technology approach that aligns best with your workload goals. For example, consider data access patterns when you select database or storage approaches. Let's take a look here at design principles for cost optimization. So the first one here is implement cloud financial management. So dedicate time and resources to build capacity via cloud financial management and cost optimization tooling. So AWS is saying, hey, take advantage of all our tooling. That makes it easy for you to know exactly what you're spending. Adopt a consumption model. So pay only for computing resources that you require an increase or decrease using depending on the business requirements. We're talking about on-demand pricing. Measure overall efficiency, so measure the business output of the workload and the costs associated with delivering. Use this measure to know the gains you make from increasing output and reducing costs. So stop spending money on undifferentiated, that's a hard word to say, undifferentiated heavy lifting. So AWS does the heavy lifting of the data center operations like racking, stacking, and power servers. It also removes the operational burden of managing operating systems and applications with managed services. This allows you to focus on your customers and business projects rather than your IT infrastructure. And the last one here is analyze and attribute expenditure. So the cloud makes it easier to accurately identify the usage and cost of systems, which then allow transparent attribution of IT costs to individualized workload owners. This helps measure return on investment and gives workload owners an opportunity to optimize their resources and reduce costs. So there you go. Hey, this is Andrew Brown from ExamPro, and we are taking a look at the AWS well-architected tool. So this is an auditing tool to be used to assess your cloud workloads for alignment with the AWS well-architected framework. And so what it is, it's essentially a checklist, but it also has nearby references. So, as you're reading through it, it will show you information and resources so that it can help you with this checklist here. And the idea is when you're done, you can generate out a report, and then you can provide that report to your executives and key stakeholders to prove, how well architected your workload is on AWS, okay? Hey, this is Andrew Brown from ExamPro, and in this video I want to show you two things, the well-architected framework and the well-architected tool. So first, let's go look for the well-architected framework. So we're going to look up white papers AWS. And so if we go here to AWSAmazon.com white papers, we have a bunch of pages here. And so I'm going to just checkbox on white papers so that we can kind of reduce the amount there. And then I'm going to checkbox well-architected framework. And if we scroll all the way top here, one of these, you think it'd be right at the top, but one of these is the well-architected framework, and here it is. And so if we open it up, it used to just directly open up as a PDF. I'm sure you can still download it as is. But generally, you're going to open up as this HTML page, and you can basically read through it, see all the stuff, see the multiple pillars. We can click into here, see the design principles, read the definitions, and then start reading about the best practices. And they have these things at the bottom of each one. Very boring, very, very boring. But, when you get to the solutions architect and things like that, you're going to need to know this stuff inside and out. It's going to really help you out. The Cloud Practitioner, we only need to know surface level information. But that's the well-architected framework. Let's take a look at the well-architected tool. So we're going to type in well here. We'll get the well-architected tool. And if we go here, you can see that I've created a couple before, probably demos for our videos. And so I'm going to go define a new workload. I'm going to say my workload here, my workload. Whoops, my workload, it is messing up because I probably have Grammarly installed, so it does not like Grammarly. So I'm just going to turn it off for now. So my workload. And it's still not typing correctly, so I have to kill out Grammarly here, which is kind of frustrating. So that's a bug that's not Grammarly's fault, that's AWS's fault for not playing well with Grammarly, and that's something I will definitely report to them because it's very annoying. So I'm going to go ahead and refresh this page. My workload. And this is Andrew Brown. Production or pre-production, doesn't matter. Pick your regions, US East or US East 2, sure. I'm selecting it. There we go. Optional, you go to next. And then you can choose your lens, serverless lens, FTR lens, so that's the foundational technical review, SAS lens. We can go with well-architected framework. And then once that is there, we can start reviewing. Okay, and then we get this big checklist. And so we can go through this and read each one. So we say, Ops 1, how do you determine what your priorities are? And all these things like Ops and stuff like that, these are all the summaries in each of the well-architected framework sections. So you pretty much don't need to really read the doc, you can just go through this. So everyone needs to understand their part in enabling business success, have shared goals in order to set priorities of resources. This will maximize the benefit of your efforts. So select from the following. Evaluate the customer's external customer needs, evaluate internal customer needs. If you click info, it's going to highlight each one here. So involve key stakeholders, including business development, operations teams, this will ensure, etc. And so you just go through this and, once you have that and you save and exit, okay, you'll have the questions that are answered. It'll say what's high risk, what's not, things like that. Very simplistic. It's really just a way of making a very organized report or checklist and proving that you went through it to the executive level or to the management level there. So hopefully that makes sense to you. It's not too complicated, but there you go. Hey, it's Andrew Brown from ExamPro, and we are looking at the AWS Architecture Center. So the Architecture Center is a web portal that contains best practices and reference architectures for a variety of different workloads. And you can find this at aws.amazon.com/architecture. So if you're looking for best practices in terms of security, they have a huge section on that. And they have it for pretty much every kind of category on AWS. Or if you're looking for practical examples, you can view the large library of reference architectures. So here's one to make an AWS Q&A bot, and it will have an architectural diagram, but you can also deploy it via CloudFormation or possibly CDK. And this way you can get a working example and then tweak it for your use case. So this is a really great tool when you are done the AWS well-architected framework and you're saying, okay, how do we apply it? Can we get more concrete examples? And I wouldn't be surprised if a lot of the resources within the well-architected framework white paper are just pointing to this center, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at the concept of total cost of ownership, also known as TCO. So what is TCO? Well, it is a financial estimate intended to help buyers and owners determine the direct and indirect costs of a product or service. So here is an example of, TCO for maybe like a data center. So we have hardware, monitoring, installation, IT personnel, training, software, security, licensing, and taxes. But that's not just the limit of it. It's just kind of the examples we show here. The idea of creating a TCO is useful when your company is looking to migrate from on-prem to cloud. And we will have a better kind of visual here to kind of understand how you would contrast against on-premise to cloud. But let's just talk about how it actually works in practicality, which I think gets kind of overlooked when cloud service providers are selling you on TCO. So the idea is that Gartner, they wrote this article based on this research where an organization had moved 2,500 virtual machines over to Amazon EC2. And so what you're seeing here is that there is an additional cost that we're not considering, which is the migration cost. See this bar up here? So the idea is that the company was paying around $400,000, and so they started to move over. And as you see, their costs initially went up for a short period of time here. But then once that migration cost was over, you can notice that they had a 55% reduction. So it's totally possible to save money, and clearly there is great savings. Now, is it exactly what AWS promises? Probably not, and that could be the reason why they updated their TCO calculator. But let's now just do that contrast against the two. So we have on-premise on the left and AWS on the right, or any cloud service provider. And what I want to do is help you think about what costs do people generally think about, because if we have like iceberg, the idea here is that these are the costs that we always think about above the iceberg. And then there's these hidden costs that we just don't consider when factoring in our move. And that's the idea of TCO, is to consider all the costs, not just the superficial ones. And so people say these look like teeth, and that's why I add penguins and a whale here. And so when we're talking about on-premise, what we generally think are software license fees and subscription fees. But when you compare those against each other, they might look the same. AWS might just look slightly cheaper or even more. And so the idea is you need to then factor in everything. So on-premise, there's implementation, configuration, training, physical security, hardware, IT personnel, maintenance. And on the AWS side, you don't have to do as much of that stuff. So you just have implementation, configuration, and training. And so AWS, with their TCO calculator, their old one, used to make a promise of 75% in savings. Again, this is going to really vary based on what your migration strategy looks like. But it's totally possible you could save 75%, or you could save 50% over a 3-year period, and there's an initial spike. So that's just something you have to consider. But the nice thing, though, is that once you've moved over, all the stuff over here on the left-hand side will be AWS's responsibility, okay? All right, so let's take a look at capital versus operational expenditure. So there's CapEx and OpEx. So on the CapEx side, the idea here is you're spending money upfront on physical infrastructure, deducting that expenses from your tax bill over time. A lot of companies that are running their own data centers or have a lot of on-premise stuff understand what CapEx is, because it's something that a lot of times they get tax breaks on, and that's why we see a lot of people that have a hard time moving away from the cloud, because they keep on thinking about that money they save from the government. But CapEx costs would be things like server costs, storage, network costs, backups and archives, disaster recovery costs, data center costs, technical personnel. So the idea is with capital expenses, you have to guess upfront what you plan to spend, okay? With operational expenditure, the idea here is the cost associated with an on-premise data center that has shifted the cost to the service provider. The customer only has to be concerned with non-physical costs, so leasing software and customizing features, training employees in cloud services, paying for cloud support, billing based on cloud metrics, so compute usage, storage usage. And so the idea here is with operational expenses, you can try a product or service without investing in equipment. So basically, CapEx is what we think about when we think of on-premise, and then OpEx is what we think about, when we're thinking about cloud or AWS, okay? All right, let's ask a very important question about cloud migration. So does cloud make IT personnel redundant? So a company is considering migrating their workloads from on-premise to the cloud to take advantage of the savings. There is a concern among the staff that there will be mass layoffs. Does cloud make IT personnel redundant? And that's a very important question to have an answer to. And this all talks about shifting your IT team into different responsibilities. So a company needs IT personnel during the migration phase, as we saw with that Gartner research report, that there was a period, at least like a year, where they needed that for, depending on the size of your company. So you're still going to need those people around. A company can transition some roles to new cloud roles. So a very traditional example would be you have your traditional networking roles, where people have like their CCNA, and now they're moving over to cloud networking. They have a reduced workload, but there's other things that they could be doing in the cloud. A company may decide to take a hybrid approach, so they'll always need to have a traditional IT team and a cloud IT team. And the last one, and this one you'd actually see on the exam, which is a company can change employees' activities from managing infrastructure to revenue generating activities. Okay, so the idea is that, if you're a company, why would you get rid of all your staff when you can just put them all into revenue generation? I suppose, you could, lay them off, and some companies might do that. Or, you could just retrain them, because if that IT personnel team has technical expertise, I'm sure they can translate that to the cloud. Let's talk about the AWS Pricing Calculator, and this is a free cost estimate tool that can be used within your web browser without the need of an AWS account to estimate the cost of various AWS services. And this is available at calculator.aws. And the reason we're bringing this up is because there used to be a TCO calculator, but now this is the calculator that you use. So the AWS Pricing Calculator contains 100 plus services that you can configure for cost estimate. And so you can just click through a bunch of knobs and boxes to, exactly figure out a very accurate cost. So the idea here is that to calculate your TCO, an organization needs to compare that existing cost against their AWS costs. And so the AWS Pricing Calculator can be used to determine, the AWS costs. And obviously the organization knows its costs, so it can compare it against that. And the way you can get data out of this is you can export it as a final estimate to a CSV, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at the AWS Pricing Calculator. So to get there, it's calculator.aws. What you're going to do is hit Create Estimate, and then here you have a bunch of services. So you just choose what you want. So you type in EC2. We're going to configure that. And from there, we can do a quick estimate or an advanced estimate. So choose this option for fast and easy route to ballpark and estimate. Choose this option for detailed estimate for accounts, workloads, and stuff. So notice down below, very simplistic. We hit advanced, and we get all sorts of stuff, okay? So, it's really up to you. I'm very comfortable with the advanced options. So I might be running a Linux machine. What is my usage? It's going to have daily spikes of traffic because of the use cases. You could say it's not busy on Saturday and Sunday, that it has a baseline of 1, a peak of 2, 8, things like that. Then you can choose what you're using. T4G, I don't even know what that is, but we'll just say like T2 micro, which is not that big, T3 micro. And then you could say we're doing on demand, because a lot of people would be doing that. And you see like $7 a month. It's not a lot of money. Then you're looking at your storage, data in, data out. Okay, so we can add that. Another thing that we might see is something like RDS. So we go to RDS and we add Postgres. And not all of them have the simple and complex. Sometimes they're simple. So production database. We'll have one here, and we're just going to be, let's say, a DB T2 micro, T3 micro. There we go. 100, that's fine. We're not going to have multi-AZ. We'll have single AZ on demand. Show the calculation, $13 a month. Add that to our estimate. So you're kind of getting the idea there, right? And so, we have our summary. That's our monthly, $391. Over 12 months. Our monthly cost is $32. Okay, you can go back there, clone the service, edit it, stuff like that. You can export the estimate. I think it goes out as a CSV. You can also hit share, and then hit agree. And so then you have a public link. And if I have that link, we can just see what happens if I paste it. Okay, and it just brings them to the same estimate. So there you go. Hey, this is Andrew Brown from ExamPro, and we are taking a look at Migration Evaluator. So it was formerly known as TCO Logic, and then AWS acquired the company, and it is an estimate tool used to determine an organization's existing on-premise costs so it can compare it against its AWS costs for planned cloud migration. So the idea is that you can get very, very detailed information, and the way it collects information is via an agentless collector to collect data from your on-premise infrastructure to extract from your own on-premise costs. I don't know if you can see there, but you can see that it works with a lot of different kinds of on-premise technology, like VMware, Microsoft, TSQL, all sorts of things, okay? One migration tool that we can use with AWS is the VM import export, and this allows us to import virtual machines into EC2. So AWS has import instructions for VMware, Citrix, Microsoft Hyper-V, Windows VHD from Azure, and also Linux VHD from Azure. And so the way this works is that you prepare your virtual image for upload, and AWS has a bunch of instructions for that. Once it is ready, you're going to upload that to an S3 bucket. And once it's uploaded to an S3 bucket, then what you can do is use the AWS CLI to import your image. And so that is the CLI command down below. And once it is produced, it will generate out an Amazon machine image. And so from an AMI, you can then go launch your EC2, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at the database migration service, which allows you to quickly and securely migrate one database to another. DMS can be used to migrate your on-premise database to AWS, and that's why we're talking about it. And so here's a general diagram where you have your source database, which connects to a source endpoint, goes through a replication instance. So that's an EC2 instance that's going to replicate the data to the target endpoint onto the target database. And so we have a bunch of possible sources. So we have Oracle database, Microsoft SQL, MySQL, MariaDB, PostgreSQL, MongoDB, SAP ASE, IMDb, DB2, Azure SQL database, Amazon RDS, Amazon S3, and I'm assuming these are database dumps, Amazon Aurora, Amazon Document DB. And so for possible targets, it's very similar. We got Oracle database, Microsoft SQL, MySQL, MariaDB, PostgreSQL, Redis, SAP SE, Amazon Redshift, Amazon RDS, Amazon DynamoDB, Amazon S3, Amazon Aurora, Amazon OpenSearch Service, Amazon Elasticache for Redis, Amazon Document DB, Amazon Neptune, Apache Kafka. I'm just showing you the list to give you an idea of how flexible this service is. But you can tell that these are very different databases. So how can it move them over, right? And so in not all cases can it easily do it. Like it's very easy to go from MySQL to Postgres. But you know, for ones that are like relational to NoSQL, this is where the AWS schema conversion tool comes into play. It's used in many cases to automatically convert a source database schema to a target database schema, or semi-automate it so that you can kind of like figure out how to map the new schema. Each migration path requires a bit of research, since not all combinations of sources and targets are possible. And it really comes down to even versions of these things. So, but I just want you to know about that it's an option as a database migration service. And I've migrated a very large database before, and it's super fast. And it's not that hard to use. So something you definitely want to remember when you're migrating. Hey, this is Andrew Brown from ExamPro, and we are taking a look at the Cloud Adoption Framework. So this is a white paper to help you plan your migration from on-premise to AWS. At the highest level, the AWS CAF organizes guidance into 6 focus areas. We got business, people, governance, platform, security, and operations. And this white paper is pretty high level. So, it doesn't get into granular details on how that migration should work, but gives you kind of a holistic approach. And I believe that probably through the AWS Amazon Partner Network, there's people that specialize in using this particular framework to help organizations move over. And I believe that AWS has professional services through the APN. But let's just kind of break down what these 6 categories are. We're not going to go too deep into this, but let's do it. So the first is the business perspective. So these are business managers, finance managers, budget owners, strategy stakeholders. So it's how to update the staff skills and organizational processes to optimize business value as they move ops to the cloud. You have people perspective, so human resources, staffing, people managers. So how to update the staff skills and organizational processes to optimize and maintain the workforce and ensure competencies are in place at the appropriate time. You have governance perspective, so CIOs, program managers, project managers, enterprise architects, business analysts. So how to update the staff skills and organizational processes that are necessary to ensure business governance in the cloud and manage and measure cloud investments to evaluate the business outcomes. We have platform perspective, so CTOs, IT managers, solution architects. So how to update the staff skills and organizational processes that are necessary to deliver and optimize cloud solutions and services. Security perspective, so CISO, IT security managers, IT security analysts. So how to update the staff skills and organizational processes that are necessary to ensure that the architecture deployed in the cloud aligns to the organization's security control requirements, resilience, and compliance requirements. We have operations perspective, so IT operations managers, IT support managers. So how to update the staff skills and organizational processes that are necessary to ensure system health and reliability during the move of operations to the cloud, and then to operate using agile ongoing cloud computing best practices. So this just taps the surface of what the CAF is. And I think for each of these, they actually have a more detailed breakdown. So, business is going to break down to even more finite things there, okay? So AWS has free services that are free forever, unlike the free tier that are up to a point of usage or time. And so there are a lot here. This is not even the full list. There's definitely more. And we have IAM, Amazon VPC, Autoscaling, CloudFormation, Elastic Beanstalk, OpsWorks, Amplify, AppSync, CodeStar, Organizations Consolidated Billing, AWS Cost Explorer, SageMaker, Systems Manager. There's a lot of them, okay? But the thing is that these services are free, but some of these can spin up other resources. So the services are free themselves. However, ones that provision services may cost you money. So CloudFormation, which is an infrastructure as a code tool, could launch virtual machines. Those virtual machines will cost money, right? OpsWorks can launch servers. That can cost money. Amplify can launch Lambdas. That can cost money. So that's something you just have to consider. Yeah, there you go. Hey, this is Andrew Brown from ExamPro, and we are taking a look at the AWS support plans. So we got basic, developer, business, and enterprise, and you absolutely need to know this stuff inside and out for your exam. They will ask you questions on this, okay? So basic is for email support only, such as billing and accounts. So if you think you got overbilled, and that's something you should do. If you've misconfigured something and you end up with a big bill, just go open up a support ticket under basic for billing, and they're likely to refund you. But if you do have questions about billing accounts, that's what you're going to be using. For everything else, that is for tech support. And so for developer, business, enterprise, you're going to get email support, which they'll roughly reply within 24 hours. I believe this is business hours. So if you message them on Friday, Saturday, you might be waiting till Monday for it, okay? In terms of third-party support, the only one that doesn't have third-party support is developer. So if you are using something like Ruby on Rails or Azure or something that has interoperability between AWS and something else, business enterprise will absolutely help you out with it. Same with enterprise, but the developer one, not so much. If you like to use the phone or you like to chat with people, that's available at the business enterprise tier. This is the way I end up talking to people. If you are, like if you're in North America and you're calling between 9 to 5 on a Monday and Friday, you're likely to get somebody that is within North America. If not, it'll be one of the supports from some other area. So just be aware of that. That can also affect the time they pick up. Sometimes it's 5 minutes. Sometimes it's 30 minutes to an hour. It just depends on what service you're asking for and, what time of day, okay? In terms of responsiveness, for general guidance, everything is 24 hours or less for developer, business, enterprise. If your system is impaired, it's within 12 hours or less. With production system impaired, it's 4 hours or less. With production system down, it's 1 hour or less. And if you're for enterprise, it's going to be business critical system down less than 15 minutes. So just notice who has what for these things. I've definitely waited like 3 days on general guidance before. So just take these with a grain of salt that they're not, they don't really stick to these. That, or maybe I'm just not paying enough for them to care, okay? In terms of getting actual people assigned to you, this only happens at the enterprise level where they have their concierge team. So they help your organization learn how to use AWS. You can ask them any questions personally. And then you have a TAM, a technical account manager. That is somebody that knows AWS inside and out, and they'll help you architect things and make correct choices, or they'll check your bill and help you try to reduce that bill, things like that, okay? In terms of trusted advisor checks, at the basic developer, you get 7 advisor checks. Once you're paying for business, you get all the checks. The cost here for business is $0. For developer, it's starting at $29 a month. For business, it's starting at $100 a month. And then for enterprise, it's $15,000 a month. So I said starting at because it's dependent on your usage, okay? So let's just look at developer, business, and enterprise here because basic's not going to be applicable here. So for developer, it's $29 USD a month, or 3% of the monthly AWS usage, whichever is greater. On the exam, they're only going to ask you, like, is it $2,900? Like, generally, do you know the tier of expensiveness? But they're not going to ask you the percentage of usage, okay? There's not going to be formulas here. When you get into business, it's a little bit different where they have it in different brackets. So it's going to be 10% for the first 10,000, and the next is going to be the next 7,000, stuff like that. Similar for enterprise as well. So let's just do some math so we know that we understand how this works. So if you had a monthly spend of $500 at the developer tier, that's 3% of 500 is $15. So they go, okay, what is greater, $29 or $15? So you're paying $29. If your spend is $1,000, that comes up to $30. So you're going to end up paying $30 because that's greater than 29. Okay. For business, if your monthly spend is $1,000, that's 10% of $1,000, that's $100. If your spend is $5,000, then you're going to be paying $500. If your monthly spend is $12,000, then the first 10% of 10,000 is 1,000, and then the next is 7% of 2,000. So your total bill is 140 USD. We're not going to do a calculation for enterprise because it's the same for business, but hopefully that gives you an idea there. Okay. Hey, it's Andy Brown from ExamPro, and we are taking a look at a technical account manager, also known as a TAM, and these provide both proactive guidance and reactive support to help you succeed with your AWS journey. So what does a TAM do? And this is straight from an AWS job posting. But what they would do is build solutions, provide technical guidance, and advocate for the customer, ensure AWS environments remain operationally healthy while reducing cost and complexity, develop trusting relationships with customers, understanding their business needs and technical challenges. Using your technical acumen and customer obsession, you'll drive technical discussions regarding incidents, trade-offs, risk management, consult with a range of partners from developers through the C-suite executives, collaborate with AWS Solutions Architect, business developers, professional service consultants, and sales account managers, proactively find opportunities for customers to gain additional value from AWS, provide detailed reviews of service disruptions, metrics, detailed pre-launch planning, being part of a wider enterprise support team providing post-scale consultative expertise, solve a variety of problems across different customers as they migrate their workloads to the cloud, uplift customer capabilities by running workshops, brown bag sessions being sessions that occur at lunchtime, something you can learn in 30 minutes to an hour. And so one thing that's really important to understand is that TAMs follow the Amazon leadership principles, especially about being customer obsessed. And we do cover the Amazon leadership principles somewhere in this course. And TAMs are only available at the enterprise support tier. So hopefully that gives you an idea what a TAM does. Hey, this is Andy Brown from ExamPro. In this follow along, I'm going to show you AWS support. And in order to use AWS support or to change your level of support, you're going to need to be logged into the root account. I should say you can use support with IAM users, but if you want to change the support plan, you're going to have to be the root user. So in the top right corner, I'm going to support. And notice here on the left-hand side, right now I have a basic plan. And so before we look at changing our plan, I'm just going to go create a case. And we're going to just take a look at some of the options that are open to us. So we have account billing support, service limit increase, technical support. Notice this is grayed out, so we cannot select anything here. I can go to here and increase our service limit. And this is something that you might have to do pretty soon early in your account. You might say, hey, I need more of something like EC2, or a very common thing is SES. So for SES, you might say, hey, I need to have this amount of emails for etc. Okay, so if we go over to account and billing support, we can go here and ask anything we want. So if it's about the free tier, I could say ask a general question, getting started, and saying what is free on AWS? I want to know what is free on AWS, and you can attach 3 attachments there. You can choose via web and phone, which is really nice. But today I'm just going to do web here and submit that just to kind of show you that as an example. And so what that is going to do is open a case, and then we will see probably respond in 24 hours to 48 hours. Just depends on whether it's the weekend or not, because it's based on business hours, of course. So now that we have an understanding of basic, let's go take a look at what the other tiers look like. So we have basic, developer, business, and enterprise. Enterprise being extremely expensive, developer being affordable, and then business being, affordable for businesses. So I would say developer is okay. It gives you better support, but it's all via email. And so, if you really want good support, you're going to have to pay the business one. And that's the one that I use quite a bit. So if I change my plan, I'm going to go over to business, and this is going to cost me 93 bucks just to do to show you here today. So I'm going to go ahead and click that, and so it's now processing it. And so what's going to happen is I'm going to have to wait for this basic to switch to business, because if I go to the case here, it hasn't happened as of yet. So notice I cannot select this. So I'm going to see you back here in maybe like 4 or 5 minutes, or however long it takes, and we'll take a look then, okay? Great, so after a few minutes, it says my plan is now business, and what I can do is go ahead and create a new case, and so I can go over to technical support and ask a question. So if I was having issues with anything, it doesn't matter what, I could go over to EC2, Linux, and then I could choose my category. So I could say I'm having an issue with Systems Manager, and a lot of times they like you to provide the instance ID. It's going to change based on what service you choose here, but you'll get different information. I'll just say, I need help with logging into my EC2 instance managed by SSM. So I could say, I created an EC2 instance, and I am attempting to access the instance via Sessions Manager, but it is not working. I think I have a role issue. And then I'm just going to go down here and say, this is not a real question. I am filming a demo video or tutorial video on how to use support. Okay, and so once we do that, we have the option of web, chat, and phone. So if you use phone, you're going to enter your phone number in, and they're going to call you back. Usually you will be on hold for anywhere for 5 minutes to an hour. It just depends. Usually it's within 15 minutes, so it's very good. Of course, it depends on the time of day and your location, things like that, and the service, because there's different support engineers for different types of services, and the balance of those are different. But generally, chat is pretty good, so I can go here, and I'm just going to hit submit, and it's going to open a chat box. And so you just wait, okay? And sometimes it's super fast, and sometimes it takes minutes, okay? So we are going to just sit here for a bit, and I'll just pop back here when there is somebody to talk to, okay? Okay, so after waiting a little while, it looks like we've been connected here, so it took a bit of time. So we're just going to say hello. Hi, Umair. This is Andrew Brown. I am recording a video to teach people how to use AWS, and I wanted to show them how AWS support works. So I'm just showing them how the chat system works. Say hello. And hopefully they'll appreciate, or they won't. It just doesn't really matter. We'll give them a moment. There we go. That's it. Thanks for your help. Okay, and so that's pretty much it. There's nothing really special about that, but the idea is when you are typing with them, it will appear in the correspondence there. So I'm just going to end the chat. Okay. And then I'm just going to mark that case as resolved. Sometimes they will ask you to resolve it. If I go to cases, I probably have some previous ones here. And I have a lot, but I don't know why they don't all show up here. So you can see this one is pending. This one is resolved. I go back to this one. You can kind of see that the history of a conversation is kept, and you can go back and forth with the people there. And yeah, that's pretty much it. You can also do screen sharing. So they might send you a request to go on Zoom or download this piece of software that shares your screen. And so that is another option as well. So they can get pretty hands-on to help you with your problems there. But that's pretty much all I wanted to show you with support. I'm going to downgrade this, and I'm not sure if they're going to give me back my money. Sometimes they'll prorate it for you, but I'm going to go here and go back to basic. So we will also refund your credit card directly in the month's remaining fees on your old plan, which you previously paid. You're obligated to pay a minimum of 30 days of support each time you register. So I'm not going to get any money back, which is totally fine. because I just wanted to show you how that works. But business support is definitely worth it. And, that's it. So the AWS Marketplace is a curated digital catalog with thousands of software listings from independent software vendors. Easily find, buy, test, and deploy software that already runs on AWS. The product can be free to use or can have an associated charge. The charge becomes part of your AWS bill, and once you pay, the AWS Market pays the provider. The sales channel for ISV and consulting partners allow you to sell your solutions to other AWS customers. Products can be offered such as AMIs, AWS CloudFormation templates, software as a service offerings, web ACLs, AWS WAF and rules. So it sounds great. If you want to sell here, I think you need like a US bank account to do it. And sometimes AWS Marketplace is just part of AWS. So like when you're using the EC2 Marketplace, you are technically using the AWS Marketplace, but they also have like a dedicated page for it. So it's integrated with some services, and then it's also standalone, okay? Hey, this is Andrew Brown from ExamPro. In this follow along, we're going to take a look at the AWS Marketplace. So what I want you to do is go on the top and type in Marketplace, and that'll bring us over to here. And the Marketplace can be found in a variety of different places on the platform. Here you can see that previously I was using something called Guacamole Bastion Host to launch a server. But the idea is that you can discover products and subscriptions that you might want to utilize. So if I go over here, there's a variety of different things. And so it could be like I want to have something like a firewall. That might be something that we might be interested in. So we could search there. And there's like bring your own license firewall. So maybe you have a license with this and you want to run it on an EC2 instance, something like that. Again, it's not like super complicated what's going on here. But a lot of times, when you're using services, you're accessing the marketplace anyway. So like when I'm launching an EC2 instance, notice on the left-hand side says AWS Marketplace, and so I don't have to go to the marketplace there. I can just kind of like check out the thing I want, and that's pretty much all there really is to it, okay? So, hopefully that makes sense. Well, let's take a look here at consolidated billing. So this is a feature of AWS organizations that allows you to pay for multiple accounts via one bill. So the idea here is we have a master account and we have member accounts. I'm pretty sure that we probably call this root account now. I don't think master account might be a data term, but it's still showing up in the documentation. The idea is that if you have member accounts within your organization, they're all going to be consolidated under this single account. If you have an account outside of your organization, this is not going to give you, this is going to be basically a separate bill as if it's like a standalone organization or what have you, okay? So for billing, AWS treats all accounts in an organization as if they were one account. You can designate one master or root account that pays the charges for all the other member accounts. Consolidated billing is offered at no additional cost. You can use Cost Explorer to visualize usage for consolidated billing, which we can see. I have the icon here. You can combine the usage across all accounts in the organization to share the volume pricing discount, which we did cover in this course separately. If you want an account to be able to leave the organization, you do have to attach it to a new payment method. So if, let's say, you had an account and you want to give it to your friend or whatever, they're going to have to hook up their credit card. But you can totally have an account leave an organization, but you have to deal with that billing aspect, okay? All right, so there's a really cool way to save in AWS, and that's through volume discounts. And it's available for many services. The more you use, the more you save is the idea behind it. And so consolidating billing lets you take advantage of volume discounts. This is a particular feature of AWS organizations. So if you do not have the org turned on, you're not going to be able to take advantage of that, okay? So one example would be something like data transfer, where it is billed for the first 10 terabytes at 17 cents, or sorry, 0.17 cents. And then the next 40 terabytes, it will be at 0.13 cents, okay? So if we had two accounts, such as Odo and Dax, and they're not within an AWS organization, we can calculate those and see what they are unconsolidated. And just so you know, 1 terabyte equals 1024 gigabytes, and that's what you're going to see in these calculations. So for Odo, if he has 4 terabytes, and that is, we calculate the gigabytes there, and we times it by the cent value there, we're going to get $696, okay? For DAX, we're going to end up with about $13.92 there. And so if we were to add those up, the bill would come out to $2,088. Okay, so the idea is that there's an organization and they your company, and they created two accounts, but they're just not within an organization. By having them in the organization, you're going to save about almost $80 there. So that is a reason why you'd want to use volume discounts. Okay. Hey, this is Andrew Brown from ExamPro, and we're taking a look at AWS Trusted Advisor. So Trusted Advisor is a recommendation tool which automatically and actively monitors your AWS accounts to provide actionable recommendations across a series of categories. So this is what it looks like. I personally prefer the older dashboard, but this is what they have now. And you can see along the side we have a bunch of categories, and then we have some checks here saying, what are we meeting, what are we not? And you can go in and read each one, and they'll tell you so much information. They'll even show you what things are not meeting that requirements. In some cases, you can easily remediate by pressing a button. Not in all cases. But the thing with AWS Trusted Advisor is think of AWS Trusted Advisor like an automated checklist of best practices on AWS. And they kind of map to the pillars of the well-architected framework. Not exactly, but pretty close. But there are 5 categories of AWS Trusted Advisor. So we have cost optimization, how much money can we save? Performance, so how can we improve performance? Security, how can we improve security? Fault tolerance, can we prevent a disaster or data loss? And service limits, so are we going to hit the maximum limit for a service? And so the next thing we need to discuss is there's a variation of the amount of checks that are available to you based on your support plan. So, if you're using basic or developer, you have 7 trusted advisor checks. And if you have business enterprise, you have all the trusted advisor checks. So if we're talking about just the ones that are available to you, the ones that come for free is MFA on root account, security groups, specified ports of unrestricted, Amazon S3 bucket permissions, Amazon EBS public snapshots, Amazon RDS public snapshots, IMUs. So this is just about alerting you about discouraging the use of the root account. Service limits. So all service limit checks are free. It's weird because they call it 7 security checks, but if you counted all the service limits, it'd obviously be too large of a number. But notice that 1 through 6 are all security checks. So you're not getting anything from the other tiers, just the security tier. And what I want to do is just go over a bunch of available checks out there. It's probably not the full list because I couldn't even be bothered to update it if they've added more, but it will give you a general idea of what you could expect under each category. So for cost optimization, it could be things like looking at idle load balancers. So, if you have load balancers you're not using, you're paying for them, so get rid of them. Unassociated elastic IP addresses. So for every IP that's not associated, you're paying for as well. Maybe under performance, you have high utilization of Amazon EC2 instances. So maybe you can save money by switching to smaller instances. Under security, we saw MFA on root account, very popular one. Making sure you turn on key rotation could be something as well there. Under fault tolerance, it could be making sure that you're using backups on your Amazon RDS database. Maybe that's turned off. For service limits, there's just a ton of them. And so one that might be pertinent to you is VPCs or EC2 limits. So there you go. Hey, this is Andrew Brown from ExamPro, and we're going to take a look at Trusted Advisor. So what I want you to do is go to the top and type in Trusted Advisor. And once you're there, you're going to notice on the left-hand side, we have cost optimization, performance, security, fault tolerance, and service limits. Right now, there are no recommended actions because there's not much going on this account. And when you have the free level of support, the basic support, you're not going to have all these checks. But if we go in here, we can still see kind of what they do. So we have performance, security, things like that. So these are the ones that we actually can see, and they generally work all the same way. If you expand here, it's going to say Amazon EBS public snapshots. So check the permission settings for the EBS volume snapshots and alert you if any snapshots are marked as public. And so if you scroll on down, if there were ones that were an issue, it would tell you right here. Okay. Then down below here, we see check buckets in Amazon S3 that have open access permissions or allow access to authenticated AWS users. So yellow, the ACL allows list access for everyone. A bucket policy allows for any kind of open access. Bucket policy statements have public grant access. So maybe what we can do is to see if we can get this to trigger. And so what I'm going to do here is go over to S3, and what we're going to do is make a bucket that has full access, okay? So I'm going to create a new bucket, and it'll say my exposed bucket. We'll scroll on down here, and we'll just checkbox that off and create the bucket. We'll say I acknowledge, that is totally fine. Okay, so now I have a bucket that is 100% exposed. If we go back to Trusted Advisor, give this a refresh. I'm not sure how fast it will show up here, but if I expand, so it says the bucket ACL allows upload, delete for everyone. The Trusted Advisor does not have permissions to check the policy. Bucket policy has statements that grant public access. So what we could try to do is make a policy. And try to grant all access here. So I'm not writing these every single day, but I'm sure we could try to figure this out. We'll say S3 bucket policy public access, public read. And so that one might be a good example. So I'm going to go ahead and copy this one. Granting read-only permission to anonymous users. I don't recommend you doing this. I'm just doing this to show you, to see if we can get the Trusted Advisor to check, because I don't want you to do this and forget about it and then have a serious issue. But the principle is set to anybody, so anyone can read it. And here it's saying get object, etc. Then it's saying what particular resource. So this one is going to be for the bucket in question here, which is my exposed bucket. We're going to scroll on down, save the changes. Okay, so this bucket is publicly accessible. We're going to go back over here, refresh, and see what we can see. Okay, so checks buckets in S3, etc. So it should appear under here. And it could be that it's just going to take some time. So what I'm going to do is I'm just going to hang tight for a little bit. Oh, there we go. Okay. So it's showing up, and I guess it just took some time to populate. And so here we can see we have a yellow symbol. It's a warning saying, hey, there's a problem here. If we go back to the dashboard, I wonder if that shows up. So this one's for investigation and recommendation. So, you know, hopefully that kind of makes sense to you. I think in some cases you can do remediation from here, or at least you can go and check box and say, okay, exclude, ignore. I could have swore there was remediation for some of these. But in any case, you know, that's generally what Trusted Advisor does. I think that you probably can have it so that it gives you alerts. So yeah, you could set recipients for particular things. Like if there's a security issue, then I could email a particular person on your team and they could deal with it. But that's pretty much it. So what I'm going to do is go ahead and delete this bucket. I'm all done with it. We'll go delete and say my exposed bucket here to delete it. And that is it, okay? Let's cover the concepts of service level agreements, also known as SLAs. So an SLA is a formal commitment about the expected level of service between a customer and provider. When a service level is not met, and if customer meets its obligation under the SLA, customer will be eligible to receive compensation, so financial or service credits. And so when we talk about SLAs, then we talk about SLIs. So an SLI, service level indicator, is a metric or measurement that indicates what measure of performance the customer is receiving at a given time. A SLI metric could be uptime, performance, availability, throughput, latency, error rate, durability, correctness. And if we're talking about SLIs, then we're talking about SLOs, service level objectives. So the objective that the provider has agreed to meet, SLOs are represented as a specific target percentage over a period of time. And so an example of a target percentage would be something that says an availability SLA of 99.99% in a period of 3 months, all right? And let's just talk about target percentages and the way they can be represented. Very common ones we will see is 99.95%, 99.99%. Then we have 99 followed by 9 nines. And so commonly we just say, we call this 9 nines, okay? And then there's one 9 11s. So if somebody says we have an SLA guaranteeing of 9 11s, it's going to be the 99 followed by 0.911s, all right? Let's take a look at AWS service level agreements. And so there are a lot of them, and I just want to just show you a few services to give you an idea how they work. On the exam, they're not going to ask you like, oh, what's DynamoDB's SLA for global tables? But generally, we should just go through this because it's good practice. So let's take a look at DynamoDB SLA. So AWS will use commercially reasonable efforts to make DynamoDB available with a monthly uptime percentage of each AWS region during any monthly billing cycle. So for A, at least 99.999% if Global Tables SLAs applies, or 99.99% if the standard SLA applies. In the event DynamoDB does not meet the service commitment, you'll be eligible to receive service credits described below. So we have monthly uptime percentage and the service credit percentage we get, global tables, standard tables. So let's take a look here. So if less than 99.999% but equal to or greater than 99.0% is met, so if the service ends up being this, you'll get 10% back of what you spent as service credits. If it drops between 99.0 and 95.0, you get 25% back. If it's less than 95%, then it's 100% back. Okay, and you get the general idea here. SLA is going to be slightly different with their drops. Now let's take a look at compute. So compute is going to apply across a bunch of compute services, probably because they're all using EC2 underneath. So that's probably the reason for it. So we have EC2, EBS, ECS, EKS, and AWS makes 2 SLA commitments for the included services. So we have a region level SLA that governs included services deployed across multiple AZs or regions, and an instance level SLA that governs Amazon EC2 instances individually. And again, we have our monthly uptime percentage, our service credit percentage, region, and instance level. So you can just see the same thing. It's like it's going to change based on what it can meet. Then we'll take a look at one more, like RDS, so a relational database service. So AWS will use commercially reasonable efforts to make multi-AZ instances available with monthly uptime percentage of 99.95% during any monthly billing cycle. And again, you know, if they don't meet those requirements, you're going to get service credits back, which basically equal USD dollars on the platform. And so for this, it looks like that. So just notice that, you know, with compute, it was for a bunch of services. For DynamoDB, it was based on particular features like global standard tables. SLA, it's very straightforward. We didn't do S3 because I just did not want to show you that one. It was just too complicated. But my point is that it's going to vary. So you have to look up per service, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at Amazon's service level agreements. And so the way you find SLAs is you pretty much just type in SLA for whatever it is. So if you're looking for compute, you type in SLA, or you look for a particular service. So maybe you say SageMaker, SLA AWS. I don't think there's like a generic SLA page. At least I don't know where it is. I always just type in SLA to find what it is. And through that, you can just kind of read through and try to find out the things that matter to you for your business, okay? Let's take a look here at the Service Health Dashboard. And so the Service Health Dashboard shows general status of AWS services. And it's really simple. The idea is that you can check based on the geographic area. So you'd say North America, Europe, etc. And what you'll see is an icon that says whether the service is in good standing, and the details, whether the service is operating normally, etc. Notice they also have an RSS feed. The reason I'm talking about service health dashboards is because I want to talk about personal health dashboards. And because they're both called health dashboards, it's confusing. So I wanted to tell you about this one first. So now we'll jump into the AWS personal health dashboard. So we saw the service health dashboard. Now let's take a look at the AWS personal health dashboard. So this is what it looks like. And it provides alerts and guidance for AWS events that might affect your environment. All AWS customers can access the personal health dashboard. The personal health dashboard shows recent events to help you manage active events and show proactive notifications so that you can plan for scheduled activities. You can use these alerts to get notified about changes that can affect your AWS resources, and then follow the guidance to diagnose and resolve the issue. So this is very similar to the service health dashboard, but it's personalized for you. And it's, you know, I don't see it crop up very often, but if you had to create alerts or be reactive to things that are happening within AWS, this is where you'd do it, okay? So there's a team called AWS Trust and Safety that specifically deals with abuses occurring on the AWS platform. And so I'm going to just list of all the cases where you'd want to be contacting them as opposed to support. So the first is spam. So you're receiving unwanted emails from an AWS-owned IP address, or AWS resources are used to spam websites or forms. Port scanning, your logs show that one or more AWS-owned IP addresses are sending packets to multiple ports on your server. You also believe this is an attempt to discover unsecured ports. DOS attacks, so your logs show that one or more AWS-owned IP addresses are used to flood ports on your resources with packets. You also believe this is an attempt to overwhelm or crash your server or the software running on your server. Intrusion attempts, so your logs show that one or more AWS-owned IP addresses are used to attempt to log into your resources. Hosting prohibited content, so you have evidence that AWS resources are used to host or distribute prohibited content, such as illegal content or copyrighted content, without the consent of the copyright holder. Distributing malware, so you have evidence that AWS resources are used to distribute software that was knowingly created to compromise or cause harm to computers, machines that it's installed on. And so in any of these cases, you're not going to AWS support, you're going to open up an abuse ticket. And so you got to contact abuse@amazonaws.com or fill out the Amazon abuse form. So, and this is whether it's coming from an outside AWS account or even your internally, if you think that somehow someone has compromised your account and it's being used in any of these ways, this is what you're going to do, okay? Hey, this is Andrew Brown from ExamPro, and we're looking at AWS abuse. So we were saying that AWS has the AWS Trust and Safety team, and what you'll want to do is if you find that there's an issue, you're going to report it to this email at abuse@amazon.com, or you're going to use this form, which is the report Amazon AWS abuse. So you'll go down here, you'll sign in, you'll put your email in, your first name, last name, org, phone number, the source IP, the details in here. You can even select the type of abuse. So you say if it's this kind or that kind, things like that. It's very straightforward, and that's pretty much it, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at the AWS free tier. And this allows you to use AWS at no cost. And when we say free tier, there's the idea of the first 12 months of sign up. There's going to be special offerings, or it's free usage up to a certain monthly limit forever. And then there's just services that are inherently free, which we have a total separate slide on. But let's talk about just the free tier stuff. And this is absolutely not the full list, but it's a good idea. Like it gives you a good overview of stuff that is free. So for EC2, which you use a web server, you get a T2 micro for 750 hours per month for 1 year. And so there's about 730 hours in a month. And so that means you could have a server running the entire month for free and an additional server for a bit as well. So for RDS, which is a relational database service for either MySQL or Postgres, we can do a T2 DB micro for 750 hours for free. So there we get our free database, and you'd be surprised how far you can get with a T2 DB micro. You know, even for a medium-sized startup, you can run it on a T2 DB micro with no problems. Then you have your Elastic Load Balancer. You get 750 hours per month for 1 year. So that is a really good thing. Load balancers usually cost $15 a month, so that's great. Actually, all of these pretty much cost $15 a month, so that's about $15, $30, $45 month over month for a year. That's free. Then you have Amazon CloudFront. This is where you'd have your homepage, caching your videos, things like that. So you get 50 gigabytes data transfer out for the total year. Then there's Amazon Connect. You get your toll-free number there, 90 minutes of call time per month for 1 month. Or for 1 year, sorry. Amazon Elastic Cache. So you could launch a Redis or Elasticache server. You get 70 hours on a Cache T3 micro for a year. Elastic Search Service, so it's full text search. So again, 50 hours per month for 1 year. Pinpoint campaign marketing email, so you can send out 5,000 targeted users per month for 1 year. SES, so simple email service. So this is for transactional emails. So that you send out from your web app, so 62,000 emails per month forever. AWS Code Pipeline, so 1 pipeline free. AWS Code Build, so this is for building out projects or things like that. So 100 build minutes per month forever. AWS Lambda Service Compute, 1 million free requests per month. 3.2 million seconds of compute time per month for free. And, you know, I like to highlight these ones because for traditional architecture, you're always going to have a web server, a database, a load balancer, and you might even have CloudFront in there as well. But yeah, again, there's a huge list, and this does not even tap the surface of what's free on AWS. Hey, this is Andrew Brown from ExamPro, and we are taking a look at AWS promotional credits. And these are the equivalent to USD dollars on the AWS platform. AWS credits can be earned several ways. This could be joining the AWS Activate Startup program, winning a hackathon, participating in surveys, and any other reason that AWS wants to give credits out. Once you have a promotional code, you click the Redeem Credit button in the billing console, you enter it in, and then your credits will be shown there. You can monitor them via AWS budgets or via Cost Explorer and probably even billing alarms. AWS credits generally have an expiry date attached to them, could be a few months to a year. AWS credits can be used for most services, but there are exceptions where AWS credits cannot be used, like purchasing a domain via Route 53 because that domain costs money outside of AWS's cost, like for their infrastructure and virtual stuff. And so for things like that, you're not going to be able to use credits for that. Okay. The AWS Partner Network, also known as APN, is a global partner program for AWS. So joining the APN will open your organization up to business opportunities and allow exclusive training and marketing events. So when joining the APN, you can either be a consulting partner, so you help companies utilize AWS, or a technology partner. You build technology on top of AWS as a service offering. And a partner belongs to a specific tier, so it's either going to be Select, Advanced, or Premier. When you sign up, it's free to sign up, but you're not going to be able to do much until you start committing to an annual fee. So it's like a certain amount of money to be able to be part of that tier, and it starts in the thousands. Okay, so I think the first tier is like something like $1,000 or $2,000, and it gets more expensive as you go up as a tier. And you also have to have particular knowledge requirements. So this could be holding particular AWS certifications at the foundational level, at the associate level, things like that. Or it could be AWS APN exclusive certifications, so training that it's not AWS certifications, but they're certifications that are only available to partners, saying like it could be like something like how do you talk to customers or communication, things like that. You can get back promotional AWS credits. So, if you say, oh, man, I spent $2,000 on just being able to get into the APN, at least the idea is that you can generally get back that spend on AWS. So it's like you committing, if you give like $2,000, it's like you're going to commit to keep using AWS. I'm not showing the annual fee commitments here and the promotional credits that you get back just because they've changed it a couple times on me, and I just don't want this slide to go stale in case they happen to change it again. So you'll have to look that up to find out what they actually are right now. You can have unique speaking opportunities in the official AWS marketing channels, like the blogs or webinars. Being part of the APN is a requirement to be a sponsor with a vendor booth at AWS events. So when you go to reInvent or any AWS event, all the vendors are part of the APN, all right? So they've paid their fee, and now they paid an additional fee to get their booth. But yeah, the AWS Partner Network is very good for helping you find new business and connecting with other people that are building workloads in AWS. But hopefully that gives you an idea of how that works, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at AWS budgets. So AWS budgets gives you the ability to set up alerts if you exceed or are approaching your defined budget. Create cost, usage, or reservation budgets. It can be tracked at the monthly, quarterly, or yearly levels with customizable start and end dates. Alerts support EC2, RDS, Redshift, Elasticsearch reservations. And so the idea here is you can choose your budget amount. So it could be like $100. It'll even show you what was the last amount if you're resetting the budget. There's something new. You can choose based on a different kind of unit. So if you wanted to be based on running hours on EC2, you could totally do that. AWS budgets can be used to forecast costs, but is limited compared to Cost Explorer or doing your own analysis with AWS cost and usage reports along with business intelligence tools. Budgets based on a fixed cost or you can plan your costs upfront based on your chosen level, can be easily managed from the AWS Budgets dashboard via the AWS Budgets API, get notified by providing email or chatbot, and threshold how close to the current or forecasted budget. So you'd see a list of budgets here, current versus forecasted, the amount used, things like that. You can see your budget history. You can download a CSV. It'll show you the cost history right in line there, which I can't show you. It's hard to see there. You get the first two budgets are free, so there's no reason not to set a budget when you first get into AWS. And each budget costs about 0.02 cents a day, so it's like 60 cents USD per month for a budget, so they're very cheap to use. And you got a limit of 20,000 budgets, so you're going to be in good shape, okay? Let's take a look here at AWS Budget Reports, which is used alongside AWS Budgets to create and send daily, weekly, or monthly reports to monitor the performance of your AWS budgets that will be emailed to specific emails. So it's not too complicated here. You say create the report budget, choose your frequency, the emails you want. And AWS Budget Reports serves as a more convenient way of staying on top of reports since they're delivered to your email instead of logging into the AWS Management Console. So it's just for those people that just can't be bothered to log in, okay? Well, let's take a look here at AWS Costs and Usage Reports. So generate a detailed spreadsheet enabling you to better analyze and understand your AWS costs. So this is kind of what it looks like. And when you turn this feature on, it will place it into an S3 bucket. You could use something like Athena to turn the report into a queryable database since it's very easy to consume S3 CSVs into Athena. You could use QuickSight to visualize your billing data as graphs. So QuickSight is a business intelligence tool similar to Tableau or Power BI. You could also ingest this into Redshift. But the idea here is when you turn it on, you can choose how granular you want the data to be, hourly, daily, or monthly. If you turn on daily, you'll be able to even say spikes of costs for EC2 instances, which is kind of nice. The report will contain cost allocation tags, which I think we have a separate slide on that type of tags. And the data is stored in either a CSV, it'll be zipped, or it will be a Parquet format. It just depends on how you want it for that, okay? Let's talk about cost allocation tags. So these are optional metadata that can be attached to AWS resources. So when you generate out a cost and usage report, you can use that data to better analyze your data. So what you'd have to do is make your way over to cost allocation tags and need to activate the tags you want to show up. There are two types of tags. So we have user defined. So whatever you've previously tagged will show up probably there. You turn it on. So if you made one with project, you turn on project. And there's a lot of AWS generated ones that you can turn on. So there's a huge list there. But yeah, that's particular with cost usage and reports. If it says like cost allocation reports, it's just that's what cost and usage reports used to be called. And some of the documentation is a bit old there. But yep, there you go. So you can create your own alarms in CloudWatch Alarms to monitor spend, and they're commonly called building alarms. And so it's just a regular alarm, but it's just focused on spend. But in order to do this, you have to turn on building alerts first in order to be able to use it. And then you'll go to CloudWatch Alarms, and you can choose billing as your metric, and then you just set your alarm however you'd want. Billing alarms are much more flexible than AWS budgets and are ideal for more complex use cases for monitoring spend and usage in terms of alerting. So you just have to decide what you want to do. Before AWS budgets, this was the only way to do it. And so this is the way I'm used to doing it. And I still do it this way today. But, you know, both options are valid and just have to decide what is your use case, okay? Well, let's take a look at AWS Cost Explorer, which lets you visualize, understand, and manage your AWS costs and usage over time. So here's a big graphic of AWS Cost Explorer. And you can specify time and range and aggregation. And it has a lot of robust filtering. What's really nice is that they have a bunch of default reports for you. So I'm just going to get my pen tool just to show you where that button is. It's over here, if you can see my marker there. But you know, you can look at things like monthly cost by service, monthly cost by linked account, daily cost, AWS Marketplace, R utilization. So there's a bunch there. You can also notice that you can create your own report. So if you do find something that you like, you can save it for later. You can have access to forecasting here, so you get an idea of the future costs and whether it's gone up or down. Just to kind of zoom in on some of those filtration options, you can choose either monthly or daily level of how you want the data to be grouped together. And you have a lot of filter control. So if I want to just have EC2 instances for a particular region, then I can get that filtered information over here. And you can see you have a breakdown of the different types. So it's very detailed. And Cost Explorer shows up in US East 1. I'm pretty sure if you click on Cost Explorer, it will just switch you over to that region, but just understand that's where it lives, okay? Hey, this is Andrew Brown from ExamPro, and in this video, I want to show you AWS Cost Explorer. So what we'll do is go to the top here, and actually on the right-hand side, we're going to click on the right and go to My Billing Dashboard. And from there, on the left-hand side, we're going to look for Cost Explorer, and then click Launch Cost Explorer. And this is where we're going to get to the AWS Cost Management Dashboard, where this is where we find savings plans, reservations, things like that. On the left-hand side, click on Cost Explorer, and you can get this nice chart. And so the idea is you can change it from monthly to daily if you prefer. Okay, you can change the scope here. Maybe we don't need 6 months. We can just go back 3 months here, so there's less data. It is a bit delayed when I'm clicking here, so it also could be just because I'm doing the daily instead of monthly. So you just have to be a little bit patient when using this interface. You can change it to stack, line graph. You can kind of see the details there. It's not always clear like what others is or things like that. And so you can drill down, and there's like ways of applying filters and things like that. I always forget how to do this. It's because it's bringing everything in, so you have to hit clear all first, I think. And oh, you have to click into it. So like if you wanted to click into it and pick a particular service, we could go here and type in EC2 and say EC2 instances, and then apply that filter. So now we can just see exactly that cost, or if we want to choose like maybe just RDS. Okay. So, you know, that could be useful for you to see. But yeah, sometimes it's not always clear. And so what I recommend is just go back to your billing dashboard, and from there, just go to bills. Okay. Bills is really, really useful because here it shows you exactly every single little service that you're being billed for, and you can expand it and see exactly where. And if there you have other accounts, you can go into this side here as well and find spend that way. But Cost Explorer is very useful. Just it's useful in a different way. Okay. So there you go. Hey, this is Andrew Brown from ExamPro, and we are taking a look at the AWS Pricing API. So with AWS, you can programmatically access pricing information to get the latest pricing offerings for services. This makes sense because AWS can change them at any time, and so you might want to know exactly what the current price is. There are two versions of this API. So we have the Query API, known as the Pricing Service API, and you access this via JSON. And then there's the Batch API, also known as the Price List API via HTML. What's odd is that the Batch API returns JSON, but you're accessing it via HTML, so you can literally paste those links in your browser. For the Query API, you're actually sending an application JSON request, so you'd have to use something like Postman or something. You can also subscribe to SNS notifications to get alerts when pricing for the services change. AWS prices change periodically, such as when AWS cuts prices, when new instance types are launched, or when new services are introduced. So there you go. Hey, this is Andrew Brown from ExamPro, and what I want to do here is show you savings plans. And so savings plan is going to be found under the AWS Cost Explorer. So just type in Cost Explorer at the top here, or if you want, you can type in savings plan as well. And once we are here on the left-hand side, we are going to have savings plans options. So we're going to go to the overview. And here it just describes what are savings plans if you want to read through it. But down below, if you have already some spend happening, it's going to make some suggestions. And in this particular account, it's saying that I could save some money on compute. Before we take a look here, I'm just going to go to the form here and see what we can see. So up here, we can say commitment through 3 years. By the way, you have compute savings, which applies to EC2, Fargate, or Lambda. Then you have the EC2 specific one where we can select a very particular type of instance family. And then there's the SageMaker savings plans. But if we go here and we just enter in like $2 all up front, I don't really understand it from here because it doesn't make it clear what the savings are. But what it does make it very easy is probably if we go over here and then click down on the compute. So I kind of feel like here it would auto-fill it in for you. And so here I filled it in. It's filled it in for me. And so here it's saying with a 1-year plan all up front for based on the past 30 days, that it's going to see that I'm going to see a monthly savings of $25.36. And then I can add it to the cart that way. And I kind of feel like that is the easiest way to figure that out, where with how it was going to that form, I just couldn't figure it out myself what the savings were. There are some utilization reports and coverage reports. Honestly, I've never really looked at these before, but I'm just curious, like what we're looking at monthly, daily, let's go a few months here. I've been running stuff in this account for a while, so there should be something. Apply. So nothing of interest, but I mean, I guess you have a lot of use. Then coverage report and utilization report could be interesting, but I imagine it's maybe you have to have a savings plan before you can see this. So that's probably the reason why. But yeah, hopefully that gives you a clear idea that you can just go down to those recommendations and see exactly what you can save, and you just add it to your cart. And then once you want to pay for it, you just choose to submit that order, and you're all good to go. All right, so that's savings plans. Let's take a look here at defense in depth to understand the layers of security AWS has to consider for their data centers, for their virtual workloads, and things that you also have to consider when you are thinking about security for your cloud resources. So in the most interior, we have data. So this is access to business and customer data and encryption to protect your data. Then we have applications. So applications are secure and free of security vulnerabilities. Then you have compute, so access to virtual machines, ports, on-premise, and cloud. You have the network layer, so this limits communication between resources using segmentation and access controls. You have the perimeter itself, so distributed denial of service protection to filter large-scale attacks before they can cause denial of service of users. You could say that's part of the network layer, and that's when I say there are variants on this, but we're just separating it out explicitly there. We have identity and access, so controlling access to infrastructure and change control. And then there's the physical layer, so limiting access to data centers to only authorized personnel. You'll notice I highlighted identity and access in yellow. It's because that is considered the new primary perimeter from the customer's perspective. Of course, AWS has concern about the physical perimeter and things like that. But as a customer, that's what you're going to be thinking about, especially with the zero trust model. And when you see these depths, the idea is that in order to get here, you have to pass through all this stuff. So if this outward one is protected pretty well, then you generally don't have to worry about the interiors, but of course you should. But yeah, there you go. Let's take a look here at confidentiality, integrity, and availability, also known as the CIA triad, is a model describing the foundation to security principles and their trade-off relationships. So here is our triad. So we have confidentiality. So confidentiality is a component of privacy that implements to protect our data from unauthorized viewers. In practice, this can be using cryptographic keys to encrypt our data and using keys to encrypt our keys, so envelope encryption. Then we have integrity, so maintaining and ensuring the accuracy and completeness of data over its entire life cycle. In practice, utilizing ACID-compliant databases for valid transactions, utilizing tamper-evident or tamper-proof hardware security modules, HSMs, availability, so information needs to be available when needed in practice, so high availability, mitigating DDoS, decryption access. So the CIA triad was first mentioned in NIST publication in 1977. There have been efforts to expand and modernize or suggest alternatives to the CIA triad. So one was in 1998 for the 6 atomic elements of information, or in 2004 we have the NIST engineering principles for information technology security. So that's 33 security principles. But this is still a very popular model for security, and it's just to kind of tell you, like, you don't always get everything. You don't get all three of them. Sometimes you have to trade off in your scenario, and hopefully some of the terminology here will resonate as we go through more security content. What I want to do here is just define the term vulnerability. So a vulnerability is a hole or weakness in an application which can be a design flaw or implementation bug that allows an attacker to cause harm to stakeholders or applications. And there's a lot of great definitions of vulnerabilities, but OWASP has a ton of them. And we talked about OWASP when we talk about AWS WAF, but it's an organization that creates security projects that help you know what you should protect, or gives you working examples so that you can understand how to get better at security. And so they have a lot of ones here, but maybe you might notice some here, like using a broken or risky cryptographic algorithm. Maybe there's a memory leak. Least privilege violation, so that's least privilege is something that is a thing that you're always worried about in security. Improper data validation, buffer overflows. So, just to kind of set the tone of what a vulnerability is and things you should be thinking about, okay? Let's understand what encryption is, but before we do, we need to understand what is cryptography. So this is the practice and study of techniques for secure communication in the presence of third parties called adversaries. And encryption is the process of encoding or scrambling information using a key and a cipher to store sensitive data in an unintelligible format as a means of protection. An encryption takes in plain text and produces a cipher text. So here's an example of a very old encryption machine. This is the Enigma machine used during World War II, and it has a different key for each day that it was used to set the position of the rotors, and it relied on simple cipher substitution. And so you might be asking, what is a cipher? And that's what we're going to look at next. So what is a cipher? It is an algorithm that performs encryption or decryption. So cipher is synonymous with code. And the idea is that you use the code to either unlock or lock up the information that you have. So what is a ciphertext? A ciphertext is the result of encryption performed on plain text via an algorithm. So you lock that up, you scramble it, it doesn't make sense, and you need that code to unlock it to get the information. So a good practical example back in the day was a code book, and this was a type of document used for gathering and storing cryptographic codes or ciphers. So the idea is, if we zoomed up on here, notice where we have cannot, so and it would be 00, and then there would be give them authority. So the idea is 00, or if you had the word cannot, it would translate to 00, and then you use 00 to match that up to say, what does that actually mean? And so that is kind of a very practical example of ciphers in action. So we just took a look at encryption, but what are cryptographic keys? So a cryptographic key, an easy way to think of it, is a variable used in conjunction with an encryption algorithm in order to encrypt or decrypt data. And there are different kinds of ones we have. So we have symmetric encryption. So this is where we have the same key that is used for encoding and decoding. And a very popular one, and the one you'll see on AWS, is called Advanced Encryption Standard, AES. So just take a look at that graphic very closely. So we have one key, and it is used to encrypt. So it produces the cipher, and then, or cipher text, we should say, and then it will decrypt, and we will get our plain text. So one single key. Then we have asymmetric encryption. So two keys are used, one to encode and one to decode. And a very popular one here is RSA. If you're wondering what those words are, it's three people's names put together who helped invent this type of algorithm. And so here we have one key for encrypt and one key for decrypt, and they're two different keys. All right. All right, let's look at the concept of hashing and salting. So for hashing, we have a hashing function, and this accepts arbitrary size values and maps it to a fixed size data structure. Hashing can reduce the size of a store value. And hashing is a one-way process and is deterministic. So a deterministic function always returns the same output for the same input. So if we have something like John Smith and we pass it to the hash function, it's going to create something that is not human readable, but it'll say something like 02, FAE, XY, whatever. And it will always produce the same thing if the same key or value is being inputted there. So the reason we use hashing functions or hash in general is to hash passwords. So hash functions are used to store passwords in a database so that the password does not reside in a plain text format. So you've heard about all these data breaches where they've stored the password in plain text. This is the thing that helps us avoid that issue. And the thing again is because it's one way, you can't take that hash and unhash it. Well, there are some conditions to it, but so to authenticate a user, when a user inputs their password, it is then hashed, so the one that was inputted at the time of login, and then that hash is compared to the stored hash in the database, and if they match, the user is successfully logged in. So in that case, we never ever had to know what the original password looked like. Popular hashing functions are MD5, SHA-256, or bcrypt. If an attacker knows the function you are using, and stole your database, they could enumerate a dictionary of passwords to determine the password. So they'll never see it, but they could just keep on going through that. So that's why we salt our passwords. So a salt is a random string not known to the attacker that the hash function accepts to mitigate the deterministic nature of a hashing function. So there you go. let's take a look here at digital signatures and signing. So what is a digital signature? It is a mathematical scheme for verifying the authenticity of digital messages or documents. And a digital signature gives us tamper evidence. So did someone mess or modify the data? Is this data from someone we did not expect it to be? Is it from the actual sender? And so we kind of have this diagram where we have a person who sends or is going to send a message, so they sign it. And then Bob verifies that it was for the person who it's from. So there are 3 algorithms to a digital signature. The key generation, so generates a public and private key. Then there is signing, the process of generating a digital signature with a private key and the inputted value. So signing, which is what is happening up here. Signing verification verifies the authenticity of the message with a public key. So remember, the private key is used for signing and the public key is used for verifying. SSH uses a public and private key to authorize remote access into a remote machine, such as a virtual machine. It is common to use RSA, and we saw that RSA is a type of algorithm earlier. And so SSH-keygen is a well-known command to generate a public and private key on Linux. I know this one off the top of my head. I always know to do this. And so what is code signing? So when you use a digital signature to ensure computer code has not been tampered, and so that's just a subset of digital signaturing. So you can use this as a means to get into a virtual machine, or you can use signing as a means to make sure that the code being committed to your repository is who you expect it to be from. So there you go. Let's talk about in-transit versus at-rest encryption. So encryption in transit, this is data that is secure when moving between locations, and the algorithms here are TLS and SSL. Then you have encryption at rest. So this is data that is secure when residing on storage or within a database. So we're looking at AES or RSA, which we both covered previously, these algorithms. So ones that we did not cover was TLS and SSL, so we'll cover them now. So TLS, Transport Layer Security, is an encryption protocol for data integrity between 2 or more communicating computer applications. So 1.0 and 1.1 are no longer used, but TLS 1.2 and 1.3 is the current best practice. Then we have SSL, Secure Socket Layers, so an encrypted protocol for data integrity between 2 or more communicating computer applications. So 1.0, 2.0, and 3.0 are deprecated. And honestly, I always get these two mixed up, and I always get confused which is being used, but they're always changing on us. But just understand generally what these concepts are and that you're familiar with the terms, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at common compliance programs. So these are a set of internal policies and procedures for a company to comply with laws, rules, and regulations, or to uphold business reputation. So here we have a bunch of different compliance programs, and so some popular ones are like HIPAA or PCI DSS. The question is, should you know these? Yes, you should generally know the most popular ones because you're going to see them throughout your cloud career. And so just getting familiar now is a good time. So let's jump into it, okay? So the first one I want to introduce you to is for ISO, and they have a bunch of different ones. So ISO is the International Organization of Standardization, and their other one called IEC, which is the International Electrotechnical Commission. One deals with, virtual things, the other one deals with hardware things, but they have a lot of overlapping compliance programs, okay? And so the most popular, absolutely most popular one that I know of is the 270-100. I know a lot of organizations that are going for their 27001. So this is for control implementation guidance. You have the 27017. This is enhanced focus on cloud security. The 27018. This is protection of personal data in the cloud. Then you have the 27701. This is Privacy Information Management System, so PIMS framework. This outlines controls and processes to manage data privacy and protect PIIs, so that's personally identifiable information. Then you have System and Organization Controls, SOC, and this is a very popular thing that organizations go for, especially the SOC 2. So SOC 1 is 18 standards and report on the effectiveness of internal controls at the service organization relevant to the client's internal control over financial reporting. We have SOC 2 evaluates internal controls, policies, and procedures that directly relate to the security of the system at a service organization. And SOC 3, a report based on the trust services criteria that can be freely distributed. Then we have PCI DSS, a set of security standards designed to ensure that all companies that accept, process, store, and transmit credit card information maintains in a secure environment. We have Federal Information Procedure Standards, or FIPS, so 140-2. This is U.S. and Canadian government standard that specifies the security requirements for cryptographic modules that protect sensitive information. Then we have PHIPA. This is more relevant to me because I'm actually in Ontario in Canada, but it's also very well-known one out there outside of HIPAA. So this regulates patient protected health information. Then you actually have HIPAA. This is the U.S. federal law that regulates patient procedured health information. Then we have Cloud Security Alliance, so CSA STAR certification, independent third-party assessment of a cloud provider's security posture. If you've never heard of CSA, they have a very well-known fundamental security certification called the CSSK or CCSK. I always get that mixed up. Then we have FedRAMP, which we covered earlier in this course, or in the future, depending on where we put it. But FedRAMP stands for Federal Risk and Authorization Management Program. It's a U.S. government standardization approach to security authorizations for cloud service offerings. If you want to work with the U.S. Government or places that sell the U.S. government, you need FedRAMP. Similar to Criminal Justice Information Services, any U.S. state or local agency that wants to access the FBI's CGIS database is required to adhere to the CGIS security policy. Then we have GDPR, the General Data Protection Regulation. Everyone knows what this is in Europe, maybe not so much in North America or other places. A European privacy law imposes new rules on companies, governments, agencies, nonprofits, and other organizations that offer goods and services to people in the European Union or that collect, analyze data tied to EU residents. There's a lot of compliance programs out there. One that's also very popular is FIPS, but we'll get to that when we talk about KMS. But yeah, there you go. So I just wanted to quickly show you here the AWS Compliance Programs page where they list out all the types of compliance programs that AWS is working with, and that it has different types of certification and attestments, which we can use AWS Artifact or Amazon Artifact, whichever prefix they decide to use for the name there, to ensure that AWS has in order to meet those regulatory compliance. So you can see them all there. And if you want to know a little bit more about any of these, you just go ahead and click them and you can read, and they have additional information so you have a better idea, okay? Well, let's talk about pen testing. So pen testing is an authorized simulated cyber attack on a computer system performed to evaluate the security of the system. And on AWS, you are allowed to perform pen testing, but there are some restrictions. So permitted services are EC2 instances, NAT gateways, ELBs, RDS, so that's Relational Database Service, CloudFront, Aurora, API gateways, Lambda, Lambda Edge functions, Lightsail resources, Elastic Beanstalk environments. Things you cannot do or you should not be doing is DNS zone walking via Route 53 hosted zones. Then there's DDoS simulation testing, so you should not be doing DDoSes, or simulated DOS or simulated DDoS is okay. And that doesn't mean that you can't necessarily do them. Again, there's a lot of exceptions to the pen testing. They have a whole page on this, but generally you're not allowed to do DDoSing. Port flooding, protocol flooding, request flooding, can't do any of those things. For other simulated events, you need to submit a request to AWS. A reply could take up to 7 days. Again, there's a lot of little intricacies here, so you'd have to really read up on it if you're interested in doing this, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at pen testing on the AWS platform. So they have this page here that tells you what you're allowed to do, what you're not allowed to do. And there's some additional things you can read into, like the stress test policy, the DDoS simulation testing policy, which I didn't cover in detail in the course content, but if for whatever reason you're interested in it, I just want you to be aware of that kind of stuff. If you want to simulate events, there is a simulate events form that you have to fill out. So you open it up and you can kind of read about it, and it gives the AWS a heads up of what you're going to be doing: stress tests, phishing, malware analysis, other. So that way that if you are doing it, you're not going to get in trouble. They're aware of what you are doing, okay? So that's pretty much it. Hey, this is Andrew Brown from ExamPro, and we are taking a look at AWS Artifact, which is a self-serve portal for on-demand access to AWS compliance reports. So here's an example of a bunch of different compliance reports that AWS could be meeting. And the idea is that when you go to this portal within the AWS Management Console, you'll have a huge list of reports that you can go and access. So here I'm searching for Canada to get the Government of Canada Partner Package. And then I go ahead and I download that report as a PDF. And then within the PDF, we can click a link to get the downloadable Excel. And that's pretty much what it is. It's just if you want to see that AWS is being compliant for different programs. Hey, this is Andrew Brown from ExamPro, and we're going to take a look at AWS Artifact. So in the top here, we're going to type in Artifact. And not to be confused with Code Artifact, which I guess is a new service. There's just always releasing new services, eh? And so here we have a video and some things, but it's not too hard. All we got to do is go to View Reports. And from here, we have all the types of compliance programs or regulatory compliance programs that AWS is meeting. And we can do is search for something. So we type in Canada, and that's the Government of Canada Partner Package. And I can go ahead and download that report. So when you download it, you really want to open this up in, you're going to really want to open this up in Adobe Acrobat, because if you don't open it up in Adobe Acrobat, you're not going to be able to access the downloadables within it. I know that's kind of odd to say, but that's just what it is. You do have to install Adobe Acrobat Reader. And once you have it open, and I'm just moving it over here, this is what you're going to see. And it's going to say like, hey, oops, no, I don't want to do that. So please scroll to the next page to view the artifact download. And so I think that if we go here, you know, they say scroll to the next page, but I'm pretty sure we can just go here on the left-hand side. And this is what we're looking for, that Excel spreadsheet. So we're going to save that attachment. Or actually, we're just going to open it up. Open this file. Okay, and we'll give it a moment. I have Excel installed. And there we go. There it is. Okay. So I know it's a little bit odd way to get to those certificates or reports, but that's just how it works. But yeah, I mean, that's the idea, is like if you need to prove that AWS is meeting whatever those standards are, you can just type them in, whatever it is. I mean, like maybe there's like FedRAMP, right? Whatever it is, and download those certificate attestments, whatever, and just double check that AWS is meeting those standards, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at AWS Inspector. But before we can answer what it does, let's talk about hardening. So hardening is the act of eliminating as many security risks as possible. Hardening is common for virtual machines where you run a collection of security checks known as a security benchmark. So AWS Inspector runs a security benchmark against specific EC2 instances, and you can run a variety of security benchmarks, and you can perform network and host assessments. And so here's an example of those two checkboxes there, which you'd say which assessments you want to do. So the idea is you have to install the AWS agent on your EC2 instance. You run an assessment for your assessment target. You review your findings and remediate security issues. And one very popular benchmark you can run is the CIS, which has 699 checks. So if you don't know what CIS, it stands for the Center of Internet Security. And so they are this organization that has a bunch of security controls or check marks that are published that they suggest that you should check on your machine. Hey, this is Andrew Brown from ExamPro, and we're looking at DDoS. So DDoS is a type of malicious attack to disrupt normal traffic by flooding a website with a large amount of fake traffic. So the idea is we have an attacker and the victim. The victim is us, and it could be our virtual machines, our cloud services. The idea is that it's some kind of resource which can take in incoming requests over the internet. So the idea is the attacker is utilizing the internet, and so they may control a bunch of virtual machines or servers that are loaded up with malicious software. And the idea is that the attacker is going to tell them all to send a flood of traffic over the internet at your computing resource. And this is where your website is going to either start to stall or it's going to become unavailable for your users. And so the idea here is that, you know, if you want to protect against DDoS, you need some kind of DDoS protection. Traditionally, those used to be like third-party services that you would have to pay for, and it would sit in front of your load balancer or your end server. But now the great thing with cloud service providers is that generally their networks have built-in DDoS protection. So the idea is just by having your compute or your resources on AWS, you're going to get built-in protection for free via AWS Shield, and we'll talk about that next. Hey, this is Andrew Brown from ExamPro, and we are taking a look at AWS Shield, which is a managed DDoS protection service that safeguards applications running on AWS. So when you route your traffic through Route 53 or CloudFront, you are using AWS Shield Standard. So here's a diagram to kind of show you that. It's not just those services, but these are the most common ones where you'll have a point of entry into AWS. So here we could also be including Elastic IP, AWS Global Accelerator. But the idea is that when you go through these services into the AWS network, it has Shield built in. And so you're going to get that protection before that traffic reaches your cloud services. And in this case, we're showing EC2 instances. So AWS Shield protects against layers 3, 4, and 7 attacks. Layer 3, 4, and 7 is based off the OSI model, which is a fundamental networking concept. So 7 is for the application layer, 4 is the transport layer, 3 is the network layer. There are two different types of plans for AWS Shield. We have Shield Standard, which is free, and then Shield Advanced, which starts at $3,000 per year, plus some additional costs based on usage of the size of the attack or what services you're using, how much traffic is moving in and out. So protection against the most common DDoS attacks is what Shield Standard does. You have access to tools and best practices to build DDoS resilient architecture. It's automatically available on all AWS services. For additional protection against larger and more sophisticated attacks, that's where Shield Advanced comes into play. It's available for specific AWS services, so Route 53, CloudFront, ELB, AWS Global Accelerator, Elastic IP, and some notable features here is visibility and reporting on layer 3, 4, and 7. You're only going to get 7 if you are using AWS WAF with it. You have access to team and support, so these are DDoS experts, but you're only going to get it if you're paying for business or enterprise support as you're paying for this as well. You also get DDoS cost protection just to ensure that your bills don't go crazy, and it comes with an SLA, so you have a guarantee that it's going to work. Both plans integrate with AWS Web Application Firewall, so WAF, to give you that layer 7 application protection. So understand that if you're not using WAF, you're not going to be having that layer 7 protection, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at Amazon Guard Duty. So before we look at that, we need to understand what is an IDS IPS. So an intrusion detection system and intrusion protection system is used as a device or software application that monitors a network or systems for malicious activity or policy violations. So Guard Duty is a threat detection service, which is IDS IPS, that continuously monitors for malicious and suspicious activity and unauthorized behavior. It uses machine learning to analyze the following AWS logs: your CloudTrail logs, your VPC flow logs, your DNS logs. And what it will do is report back to you and say, hey, there's this issue here, and this is actually one that's very easy to replicate. It's just saying somebody is using the root credentials, and it's suggesting that you should not be doing that, right? Because you're never supposed to be invoking API calls with the root credentials, or you should be limiting that. You might also notice that if you want to investigate, you can kind of follow up that with Amazon Detective or AWS Detective, whichever prefix they decided to put on that service. It will alert you of findings, which you can automate an incident response via CloudWatch events, which it's been renamed to Event Bridge, just so you know, or third-party services. So you can follow up a remediation action. And here is a graphic of Amazon Guard Duty just a bit up closer, so you can see all the findings, and you can just see you have a lot of detailed information there, okay? Hey, this is Andrew Brown from ExamPro, and we're going to take a look at Guard Duty. So Guard Duty is an intrusion protection and detection service, and so what I've done is I've done some bad practices purposely so that I can show you some information in there. So I'm going to go over to Guard Duty, okay? And you do have to turn Guard Duty on. And so once Guard Duty is on, you're going to start getting reports coming in. So notice here that we have some anomalous behavior 8 days ago. And so that's Bako. He's my co-founder. He's also named Andrew as well. And so we can kind of see some details here about who's accessing what and what they were doing. He's not doing anything malicious, but we can have an idea where they're from. Even shows generally where he is, which he is near Thunder Bay, and his provider would be T-Bay Tel. And you can see that he is making API calls to describe account attributes and things like that. Then the other issue is the root account. So there's MFA. I turned it off so that we can, or maybe it's just usage here. I actually do have it turned on, I suppose. But here we see root credential usage. And so it's saying, hey, you used it 77 times, because sometimes I go in and use the root account for tutorials, but saying you're using this way too much. You've got to stop doing that, okay? So that's something that is pretty interesting with GuardDuty, and it's really cost effective and easy to turn on, so you can turn it on. Looks like they have a new thing for S3. Have not looked at that as of yet, but that's kind of cool. Kind of feels like that would overlap with Amazon Macie, but whatever. And here we get a breakdown of costs. So we see CloudTrail, VPC flow logs, DNS logs, and this is where it would be ingesting data. If you want to use that S3 protection, you'd have to probably be creating a custom CloudWatch trail that has data events to consume that information. So hopefully that gives you kind of an idea of things you can do. And you can also centralize GuardDuty into one account. So you can have one thing that takes care of everything and move all the data across all your accounts into a single place. So that's kind of interesting. And you can set up follow-ups. And it's possible that I'm not seeing this here, but generally it would show you a way of like triggering it into CloudWatch. Probably you could do it pragmatically. This is something interesting, like the list management. You can add trusted IPs or threat lists. So if there's people that you know are fine, you could just whitelist them. Or if there's people that you know that are bad, make sure that they are never allowed to get through. So that's pretty much it with GuardDuty, okay? Well, let's take a look here at Amazon Macie. So Macie is a fully managed service that continuously monitors S3 data access activity for anomalies and generates detailed alerts when it detects risks of unauthorized access or inadvertent data leaks. So Macie works by using machine learning to analyze your CloudTrail logs, and Macie has a variety of alerts. So we have anomalized access, config compliance, credential loss, data compliance, file hosting, identity enumeration, information loss, location anomaly, open permissions, privilege escalation, ransomware, service disruption, suspicious access, and Macie will identify your most at-risk users, which could lead to compromise. So here's just one little kind of tidbit from the app itself, where you have the total users and they categorize them into different risks. I can't remember which flag means what in here. Amazon Macie is an okay service. It's very important if you're storing things in S3, but I don't use it very often, to be honest. Hey, this is Andrew Brown from ExamPro, and we are taking a look at AWS Virtual Private Network, also known as VPN. So AWS VPN lets you establish a secure and private tunnel from your network or device to the AWS Global Network. It's very important to emphasize the word secure here because when you're using Direct Connect, that will establish a private connection, but it's not using any kind of protocol to secure that data in transit, whereas AWS VPN will be using a secure protocol. There are two options here. We have AWS site-to-site VPN, so securely connect on-premise network or branch office site to VPC, and AWS Client VPN, so securely connect users to AWS or on-premises networks. One thing that we need to understand alongside VPNs is IPsec. This stands for Internet Protocol Security, and it is a secure network protocol suite that authenticates and encrypts the packets of data to provide secure encrypted communication between two computers over an Internet Protocol network, and it is used in VPNs, and AWS definitely uses it, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at AWS Web Application Firewall, also known as WAF, which protects your web application from common web exploits. So the idea here is you write your own rules to allow or deny traffic based on the contents of an HTTP requests. You use a rule set from a trusted AWS security partner in the AWS WAF rule marketplace. WAF can be attached to either CloudFront or an application load balancer. So here is that diagram. The idea is you see CloudFront with the WAF or ALB with the WAF. And what it does is it can protect web applications from attacks covered in the OWASP 10 top 10 most dangerous attacks. If you don't know OWASP, they're the Open Web Application Security Project, and they basically have all these security projects, which are things to say, hey, these are things that you should commonly protect against, or they might have like example applications that serve as a means to learn security. So when we look at the top 10, it's injection, broken authentication, sensitive data exposure, XML, external entities, so XXE, broken access control, security misconfigurations, cross-site scripting, so XSS, insecure deserialization, using components with known vulnerabilities, and insufficient logging and monitoring. So there you go. Hey, this is Andrew Brown from ExamPro, and we're going to take a quick look at AWS Web Application Firewall, also known as WAF. And so in this account, I happen to have a WAF running, so we don't have to create one. We already have something we can take a look here. So I'm going to go to WAF and Shield. And then on the left-hand side, you'll notice it's a global service, but on the left-hand side, we're going to be looking for our web ACLs. And so the idea is that when you want a WAF, you create a web ACL. And then within that web ACL, you have the overview, and then it can kind of show you kind of the traffic that's going on here. We can have our rules. And so there's a lot of different kind of managed rule groups that you can use. So these are ones that are provided by AWS. And a lot of these, some of these can be paid, some of these are free. So you see there's these free rule groups where you're like, hey, I don't want any anonymous IPs. You checkbox that on, or I want to protect against SQL injection. Now, the interesting thing is that AWS has this capacity unit, so you can't add all of these. You can add a certain amount of capacity before you have to pay for more or something like that. It's just kind of a way to kind of cap the amount of stuff that you can put in terms of rules. But there's a lot of other rule groups from third-party services like security companies that know what they're doing. So if you like Fortinet's OS Top 10, you can subscribe to that in the marketplace and be able to use it. But yeah, so that's how you apply rules. There's something called bot control. I've never used this before. Get real-time visibility into bot activity on your resource and controllers. What bots allow and block from your resources. That sounds really cool. I cannot stand bots. So I might turn that on myself or take a look at the cost there and see what we can find out. But that's pretty much it with WAF. One thing I would say is that you can block out specific IP addresses or whitelist specific IP addresses. And you might do that through rules. I'm just going to see, yeah, like maybe the bypass here. And so these IP addresses are some of our cloud support engineers where they're using our admit panel, and WAF is being too aggressive in terms of protection. And so sometimes you have to say, hey, allow this IP address and let my, cloud support engineer be able to use the mid panel because they're not malicious. Okay, so that's one little exception there, but that's pretty much it. Okay. Hey, this is Andrew Brown from ExamPro, and we are taking a look at hardware security modules, also known as HSM. And it's a piece of hardware designed to store encryption keys, and it holds keys in memory and never writes on the disk. So the idea is that if the HSM was shut down, that key would be gone, and that would be a guarantee of protection because nobody could, take the drive and steal it. So here is an example of an HSM. These are extremely expensive, so you definitely don't want to have to buy them yourselves. They generally follow FIPS. So FIPS is the Federal Information Processing Standard. So it's a US and Canadian government standard that specifies the security requirements for cryptographic modules that protect sensitive information. FIPS is something you want to definitely remember. And there are two different protocols here. There's actually a bunch of different FIPS versions, but we have FIPS 142 level 2 and then FIPS 143 level 3. So let's talk about the difference here. So HSMs that are multi-tenant are going to be using FIPS 142-2 level 2 compliant, where you have multiple customers virtually isolated on the HSM. And then there are HSMs that are single tenant, And so they're going to be utilizing FIPS 140-2 level 3 compliant, so a single customer on a dedicated HSM. And so the reason why we have these two levels is that when you have multiple tenants, you can say, oh, right, this thing is has tamper evidence, so we can see that somebody was trying to break into it, but there's no guarantee of it being tamper-proof, where level 3 is tamper-proof. There's also FIPS 140-3, which is the newer standard, but not all cloud resources can meet that standard just because of how they offer the service. So again, FIPS 142 is really good, but just understand that there are other ones out there. And it's very easy to get FIPS 142 level 3 mixed up with FIPS 140-3, something that I always had a hard time remembering the distinguishing between those two. So for multi-tenant, this is where we're using AWS Key Management Service. And for single tenant, we're using AWS Cloud HSM. And the only time you're really using Cloud HSM is if you're a large enterprise and you need that regulatory compliance of getting FIPS 140-2 level 3, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at Key Management Service, also known as KMS, and it is a managed service that makes it easy for you to create and control the encryption keys you use to encrypt your data. So KMS is a multi-tenant HSM, so it's a hardware security module, and many AWS services are integrated to use KMS to encrypt your data with a simple checkbox, and KMS uses envelope encryption. So here's that example of a simple checkbox. In this case, it's for RDS. And what you'll do is choose a master key. A lot of times AWS will have a default key for you that's managed by them that is free to use, which is really great. So for KMS, it's using envelope encryption. So when you encrypt your data is protected, but you have to protect your encryption key. When you encrypt your data key with a master key as an additional layer of security, so that's how it works. So just to make this really clear, I have my data. I use this key to encrypt this data, and now I need to protect this key. So I use another key to encrypt this key, which forms an envelope, and then I store this master key in KMS, and this one's considered the data key, all right? Hey, this is Andrew Brown from ExamPro, and we're going to take a look at Key Management Service, also known as KMS. So type in KMS on the top here, and we'll pop over here. And KMS is a way for you to create your own keys, or you can use AWS managed keys. So up here, and not all of these appear right away, but as you use services, AWS will generate out managed keys for you, and these are free. You can create your own keys, and these cost $1 each. So if I go ahead here and create a key, I can choose whether it's symmetric or asymmetric, which we definitely learned in the course, which is nice. For asymmetric, you can make it encrypt and decrypt, sign and verify, and they're just kind of narrowing down the type of key you would use. For this, if I went to symmetric, I go here. I'm just kind of seeing if I can enter the actual material into the key here. So I'm just going to keep clicking through here. My custom key. Generally, you don't really need to do this, but if it's interesting, you can set up administrators to say who is allowed to administer the key, and then you have someone that is allowed to use the key. And you usually want to keep those two accounts separate. You don't want to have the same person administrating and using the key. Okay, keep those two separate. And so we would have a key policy, so you can change this to say the rules that is allowed to use. And then we can go here and hit finish. And so there we now have our own custom key. And one thing we can do is it's possible to rotate out these keys when you need to be. But anyway, when we want to use KMS, it's built into basically everything. And we've seen it multiple times throughout this course. When we've gone over to EC2, we'll just go take a peek at a few different places here. So when we've gone to go launch an EC2 instance, and we go over to storage, so we say select and review, or next, and we go over to storage. Notice that here, this is using encryption, right? So I can choose that, or even my custom key. If you're in DynamoDB or anywhere else, it's always something like a checkbox and you choose your key. So that's pretty much all there really is to KMS. It's very easy to use, and there you go. Hey, this is Andrew Brown from ExamPro, and we are going to take a look here at Cloud HSM. It is a single tenant HSM as a service that automates hardware provisioning, software patching, high availability, and backups. So here's the idea is that you have your AWS Cloud HSM, you have your developers interacting with it, your application interacting with it, you have an HSM client installed in your EC2 instance so that it can access the Cloud HSM keys. So AWS Cloud HSM enables you to generate and use your encryption keys on FIPS 140-2 Level 3 validated hardware. It's built on open HSM industry standards to integrate with things like PKCS 11, Java Cryptography extension, so JCE, Microsoft Crypto and G libraries. You can transfer your keys to other commercial HSM solutions to make it easy for you to migrate keys on or off AWS. Configure AWS KMS to use AWS Cloud HSM cluster as a custom key store rather than the default KMS key store. So Cloud HSM is way more expensive than KMS. KMS is like free or $1 per key, where Cloud HSM is a fixed cost per month because you are getting a dedicated piece of hardware. And there's not a lot of stuff around it. So other than the AWS KMS integration, a lot of times it can be really hard to use this as well. So the only time you're really going to be using Cloud HSM is if you're an enterprise and you need to meet FIPS 140-2 Level 3 compliancy, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at Know Your Initialisms. So a lot of AWS services and concepts and cloud technologies use initialisms to just kind of shorten common things that we need to use on a frequent basis. And it's going to really help if you learn these, because then what you can do is substitute them when you are seeing a service name or something in particular, and that's going to get you through content a lot faster. And in the wild, you're going to see these all over the place because people aren't going to say the full name. They're going to say the initialism. So let's go through them. So for IAM, it's Identity and Access Management. For S3, that's Simple Storage. For SWF, it's SWF, that's Simple Workflow Service. SNS is Simple Notification Service. SQS is Simple Queue Service. SCS is Simple Email Service. SSM is Simple Systems Manager. But, when we see the name, it's usually just Systems Manager, but we still use the initialism SSM. Then there's RDS, Relational Database Service, VPC, Virtual Private Cloud, VPN, Virtual Private Network, CFN, CloudFormation, WAF, Web Application Firewall, and that is a very common initialism, not just in AWS, but outside of it as well. MQ for Amazon Active MQ, ASG for Auto-Scaling Groups, TAM for Technical Account Manager, ELB for Elastic Load Balancer, ALB for the Application Load Balancer, NLB for the Network Load Balancer, GWLB for the Gateway Load Balancer, CLB for the Classic Load Balancer, EC2 for Elastic Cloud Compute, ECS for Elastic Container Service, ECR for Elastic Container Repository, EBS for Elastic Block Storage, EMR for Elastic MapReduce, EFS for Elastic File Store, EB for Elastic Beanstalk, ES for Elasticsearch, EKS for Elastic Kubernetes Service, MSK for Managed Kafka Service. And if you think I got the S and K backwards, I did not. For whatever reason, it's MSK. Then there's AWS Resource Manager, which is known as RAM, ACM for Amazon Certificate Manager, POPL for Principle of Least Privilege, which is a concept, not a service, IoT, Internet of Things. This is not a service, but is a tech concept or cloud concept. RI for reserved instances, and I'm sure there are more, but these are the ones that I know off the top of my head, and they're in my usual use case for what I'm doing day to day. But a lot of times you'll probably just end up needing to remember ASG, ELB, EC2, S3, things like that, okay? All right, let's compare AWS Config and App Config, which both have config in the name, but there are two completely different services. So AWS Config and App Config. So AWS Config is a governance tool for compliance as code. You can create rules that will check to see if resources are configured the way you expect them to be. If a resource drifts from the expected configuration, you are notified, or AWS Config can auto-remediate correct the configuration back to the expected state. For App Config, it is used to automate the process of deploying application configuration variable changes to your web application. You can write a validator to ensure the changed variable will not break your web app. You can monitor deployments and automate integrations to catch errors or rollbacks. So config is for compliance governance. App config is for application configuration variables. So there you go. Well, let us take a look at SNS versus SQS, and these things have something in common, and it's they both connect apps via messages. So they're for application integration. So let's take a look at SNS. So simple notification service and then simple queue service, okay? So SNS is intended to pass along messages via a pub-sub model, whereas SQS queues up messages and has a guaranteed delivery. So the idea with SNS, you send notifications to subscribers of topics via multiple protocols. So it can be HTTP, email, SQS, SMS. And SNS is generally used for sending plain text emails, which is triggered via other AWS services. The best example here is billing alarms. I know we mentioned this, but I like to repeat it so that you absolutely know. It can retry sending in the case of failures of HTTPSs, so it does have a retry attempt, but that doesn't mean there's a guarantee of delivery. It's really good for webhooks, simple internal emails, triggering Lambda functions. If you had to compare these to third-party services, it's similar to Pusher or PubNub. So SQS is, the idea here is that messages are placed into a queue. Applications pull the queue using the AWS SDK. You can retain a message for up to 14 days. You can send them in sequential order or in parallel. You can ensure only one message is sent. You can ensure messages are delivered at least once. It's really good for delayed tasks, queuing up emails. Comparable stuff would be something like RabbitMQ or Ruby on Rails Sidekick, okay? Hey, this is Andy Brown from ExamPro, and we're doing variation study with SNS versus SES versus Pinpoint versus Workmail. And so SNS and SES get confused quite often, but all of these services have something in common. They all send emails, but the utility of email is completely different for each one. So the first one is simple notification service, is for practical and internal emails. So you send notifications to subscribers of topics via multiple protocols. So it's not just for email. It can handle HTTP, it can send to SQS, it can send SMS messages, so messages to your phone. But it does send emails, and so SNS is generally used for sending plain text emails, which is triggered via other AWS services. The best example of this is a billing alarm. So most exam questions are going to be talking about SNS because lots of services can trigger SNS for notifications, and so that's the idea. It's like, oh, you know, did somebody spin up a server, send off an email via SNS? Did we spend too much money here? You know, all sorts of things can go through SNS to send out emails. And you need to know what are topics and subscriptions regarding SNS. Then you have SES, so simple email service, and this is for transactional emails. And when I say transactional emails, I'm talking about emails that should be triggered based on in-app actions, so sign up, reset password, invoices. So a cloud-based email service that is similar to this would be like SendGrid. SES sends HTML emails, SNS cannot. So that is the distinction, is that SES can do HTML and plain text, but SNS just does plain text. And you would not use SNS for transactional emails. SES can receive inbound emails. SES can create email templates, custom domain name emails. So when you use SNS, it's whatever Amazon gives you. It's going to be some weird address, but SES is whatever custom domain you want. You can also monitor email reputation for SES. Then you have Amazon Pinpoint, and so this is for promotional emails. So these, when we say promotional, we're talking about emails for marketing. So you can create email campaigns, you can segment your contacts, you can create customer journeys via emails. It can do A to B email testing. And so SES and Pinpoint get mixed up because a lot of people think, well, can I just use my transactional emails for promotion emails? Absolutely, you can. It's not recommended because you know, Pinpoint has a lot more functionality around promotional emails. They're built differently, and so, you know, just understand that those two have overlapping responsibilities, but generally you should use them for what they're for. Then you have Amazon Workmail, and this is just an email web client. So it's similar to Gmail or Outlook. You can create company emails, read, write, and send emails from a web client within the AWS Management Console. So there you go. Let us compare Amazon Inspector versus AWS Trusted Advisor. So both of these are security tools and they both perform audits, but what they do is slightly different. So Amazon Inspector audits a single EC2 instance that you've selected, or I suppose you could select multiple EC2s. It generates a report from a long list of security checks. And so Trusted Advisor has checks, but the key difference here is that it doesn't generate out a PDF report, though I'm sure you could export CSV data if you wanted to and then turn that into a report. It gives you a holistic view of recommendations across multiple services and best practices. So for example, if you have an open port on the security groups, it can tell you about that. You should enable MFA on your root account when using Trusted Advisor, things like that. One thing, though, is that Trusted Advisor isn't just for security. It does checks across 5 different things, but they both do security and they both technically do checks, okay? So there are a few services that have Connect to the name. You'd think they would be related in some way, but they absolutely are not, and they don't even have similar functionality. But let's take a look here so we know the difference. The first is Direct Connect. It is a dedicated fiber optics connection from your data center to AWS. It's intended for large enterprises with their own data center, and they need an insanely fast and private connection directly to AWS. And you'll notice I give private an emphasis because if you need a secure connection, you need to apply an AWS virtual private network connection on top of Direct Connect. Then you have Amazon Connect. This is a call center as a service. Get a toll-free number, accept inbound and outbound calls, set up automated phone systems. So if you ever heard of an interactive voice system at IVS, this is basically what Amazon Connect is. You have Media Connect. This is the new version of Elastic Transcoder. It converts videos to different video types. So if you have, let's say, 1,000 videos, you need to transcode them into different video formats. Maybe you need to apply watermarks, insert introduction videos in front of each one. This is what you use Media Connect for, okay? Just in case you see Elastic Transcoder as an option, I just want you to know what it is compared to Media Connect. So both these services are used for transcoding, and technically Elastic Transcoder is the old way, and AWS Elemental Media Convert, or just Media Convert, is the new way. So Elastic Transcoder was the original transcoding service. It may still have programmatic APIs or workflows not available in Media Convert. So this could be reasons why we see legacy customers still using it, or it's just too much effort for them to upgrade to the new one. It transcodes videos to streaming formats. Media Convert is more robust transcoding service that can perform various operations during transcoding. So it also transcodes videos to different streaming formats, but it overlays images, it inserts video clips, extracts captions data, it has a robust UI. So generally it's recommended to use the Media Convert. In terms of costs, they're basically the same, so there's no reason not to use Media Convert, okay? So AWS Artifact versus Amazon Inspector get commonly mixed up all the time, but both Artifact and Inspector compile out PDF reports, so that's where the confusion comes from. But let's talk about what is different about the reports. So AWS Artifact and AWS Inspector. So for Artifact, you're answering why should an enterprise trust AWS? It generates a security report that's based on global compliance frameworks such as SOC or PCI or a variety of others, where Amazon Inspector is all about how do we know this EC2 instance is secure? Can you prove it? So it runs a script that analyzes your EC2 instance, then generates a PDF report telling you which security checks had passed. So the idea here is it's an audit tool for security of EC2 instances. So there you go. So let us compare ELB versus ALB versus NLB versus JWLB versus CLB. Because, when I was first learning AWS, I was getting confused because there was Elastic Load Balancer, but then there was these other ones, so what gives, right? So what's happening here is that there is a main service called Elastic Load Balancer, ELB, and it has 4 different types of possible load balancers. So we'll go through all the types. So the first is Application Load Balancer, commonly initialized as ALB. And so this operates on layer 7 for HTTPS. So this makes sense because that is the application layer. And it has some special powers in terms of routing rules. So the idea here is you can create rules to change routing based on information found within the HTTPS request. So let's say you wanted some routes to go that have a particular subdomain to this server and a different subdomain to another one, you could do that. And because it is an application load balancer, you can attach a web application firewall for protection. You can't attach this on the NLB or other ones because they're not application based. So that is just a little caveat there. Then you have network load balancer, commonly abbreviated to NLB. This operates on layer 3 and 4. So we're talking TCP, UDP. This is great for when you have extreme performance that requires TCP and TLS traffic. It's capable of handling millions of requests per second while maintaining ultra low latency. It's optimized for sudden and volatile traffic patterns while using a single static IP address per availability zone. If you're making video games, this is what they like to use, is the network load balancer, but it has other utilities outside of that. Then you have Gateway Load Balancer, GWLB. This is when you need to deploy a fleet of third-party virtual appliances that support, I don't know how to say that in abbreviation, but I'll just say it's GENEVE. And there's not much we need to know outside of that, okay? Then there is the classic load balancer, commonly initialized as CLB. This operates on layer 3, 4, and 7. It's intended for applications that were built within the EC2 classic network. It doesn't support target groups, so ALBs, NLBs use target groups, which is just an easier way of grouping together a bunch of target resources like compute that we're going to load balance to. And with classic load balancer, you just directly assign EC2 instances. And it's going to be retired on August 15th of 2022. So yeah, it looks like it can do a lot of stuff, but it also doesn't have any of the superpowers of these specialized ones. And so there's no reason to keep it around. And generally, you should not be using it. And so yeah, that's about it.